Hello all, welcome to this SD-WAN tutorial. In this tutorial, we will discuss about the challenges that we have in the traditional wide area network and how the SD-WAN will overcome those challenges. Afterwards, we will talk about the controllers and the vANage devices that are components of the SD-WAN. After that, our discussion will be on the deployment of the vANage devices, configuring the templates. We will talk about some policies that we can run in our SD-WAN scenarios. The content that we are going to start is implementing Cisco SD-WAN solution, ENSDWI. Exam code is 300-415, and the version of the exam is currently 1.2. So all the other exams are at 1.1. This SD-WAN exam is currently at 1.2. Earlier, like SD-WAN exam 1.0, it did not have like any security related tasks. Then they went to exam code 1.1, where they added SD-WAN security, and then exam 1.2, they added some new features in the SD-WAN. So currently we are at the exam number or version 1.2. So if you just search ENSDWI 300-415, and you click on the first link, the very first link that we have here, implementing Cisco SD-WAN solution. If you clear this exam, passing this exam earns you the specialist certification, Cisco certified specialist. Remember that you will not become a professional, you will not be a CCNP, you will become Cisco certified specialist if you clear the specialist in the SD-WAN certification. If you clear this particular exam, this is one of the concentration exam that is required for CCNP as well. So if you want to be a CCNP, you have to take a core exam and you have to take a concentration exam. So SD-WAN is one of the concentration exam, and then you can take the core exam and you will become like the CCNP. But until you have taken the core exam, until you have cleared this NCore, enterprise core exam, or simply just the core exam, you will not become the CCNP. You will just become a specialist, the specialist in the SD-WAN technology, for example. So if you want to be a professional, if you want to be a CCNP certified, then alongside with the SD-WAN exam, you will also have to take the NCore exam or enterprise core exam, which will test you on a lot of other things. But our focus is not on the core exam at the moment. The focus is on the SD-WAN exam. You can also use this exam for the certification. Okay, fine. It's a 90-minute exam. It's multiple choice, like MCQs are going to be there. Some sort of like match, like, there will be like two tables and you have to match one part from the other. That kind of questions will be there. So mostly multiple choice questions and these matching questions, these kind of questions are presented in this exam. At the very end of our content, at the very end of our classes, we will also be able to see what type of questions are expected in the exam as well. So we will talk about that, but at the very end. At the moment, just we have to focus on the content that we will have to cover. For example, what are the topics that we have to cover from the exam point of view? So just click on the view ENSDWI exam topics. Just click on this button and it will show you, for example, what topics you have to cover in order to clear the particular exam. So the topic that we have to cover, the entire content of the SD-WAN is divided into these 6 parts: architecture, controller components, controller deployment, router deployment, policies, security, quality of service, and at the very end we have management and operation. So from the architectural point of view, we have to cover a few things. From the controller and the router deployment point of view, we have to know about certain things, then the policies, then the security and quality of service, and then the management and operations. These are the topics that we will have to go through, and then it is expected that you will get the questions in the exam based on the following modules. Once you clear all those, like, then only you will be able to pass the exam. So percentage wise, it's 20% architecture, 15% controller deployment, 20% router deployment, and so on. So overall content is divided into a total 6 parts: architecture, controller deployment, router deployment, and then one of the most important topic of the whole SD-WAN, is going to be this policy. Then security what are the security features available in the SD-WAN natively? Implementing those features will not require like any kind of dedicated firewall, IPS, IDS devices. Or how can we implement the quality of service in the SD-WAN? The management and operation related things, then day 2 operations basically we will talk about as a part of our content. So these are like total 6 units parts that we have. Our content is divided into these 6 parts. If I expand these 6, you can always download this. You can download it and keep it with you so that you can track what topics are covered, what topics are left. Although we will cover everything from the content point of view, but again, it will be your responsibility to cross-check everything. If all the topics are covered or if anything is left, you will inform me, like if anything is left, we will cover it. Although we are going to cover everything that is there in the content. So if I expand it, so first section is going to focus on the SD-WAN architecture. What is SD-WAN? Why we need SD-WAN? What are the components of the SD-WAN? How to design the SD-WAN infrastructure? How to connect the SD-WAN infrastructure to the cloud? What are the routers available that are supported for the SD-WAN platforms and all? What are the technical, what is this control plane? What is this management plane? What is this data plane, orchestration plane? Basically, how the SD-WAN architecture is. And something called multi-region fabric, or in short, like MRF. MRF architecture of the SD-WAN. MRF architecture is something new that they have introduced. It was not available with the earlier version of the SD-WAN exam and in the SD-WAN software as well. So MRF, or multi-region fabric MRF architecture, how it works and all, we'll talk about that as well. So the first unit basically is going to focus on the architecture. Second and third units are going to focus on the deployment of those architectural components. Such as in SD-WAN, we have 2 main components. One component that we have in the SD-WAN is basically the controllers. And the second components that we have are the SD-WAN edge devices, routers basically, that we can connect in our environment and manage from the centralized controller. So what are the SD-WAN edge platforms? How can we deploy them? And what are the SD-WAN controllers and how can we deploy them, manage them, operate on them? So controller deployment and the router deployment, what are different options for the controller deployment? How can we deploy the controllers on the cloud, on premises? Describe, not implement, by the way. So how the controllers are deployed in the cloud, how the controllers are deployed on the premises, installing the controllers on the hypervisor or the cloud platform, scalability, redundancy, configure the certificates. Basically, when the controllers are deployed, we have to install some certificates for the authentication authorization process. So we'll talk about the certificate installation and any issues that we might encounter, we will troubleshoot it from the controller deployment. 15% content, more focused on the theoretical aspect of the SD-WAN controller deployment rather than the practical one. We will talk about the practical deployment on premises as well, but we will focus more on the certificate installation and how each and every device authenticates themselves on the controller. Then the router deployment. What are these SD-WAN routers, for example? What are these vManage devices? What is this vEdge device? What is this cEdge device? What are these like SD-WAN devices, SD-WAN edge devices? We will talk about it. What is this? How the SD-WAN devices are going to secure the communication between 2 branches? What the concepts are used in that, we will talk about that. What is this underlay? What is this overlay? What is this concept of tunnels? What is this TLOC? What is this OMP, TLOC? What are the protocol options that are available with the SD-WAN edge devices? How the multicast is supported? What is this new feature called configuration groups, feature profile and workflows? Basically, router deployment and operating on the router, how to deploy the SD-WAN edge device and how to operate on that SD-WAN edge device, such as, for example, installation of the SD-WAN edge devices and then making them reachable to the rest of the network and configuring protocols such as OSPF, EIGRP, BGP, VRRP, how to do the CLI configuration and all that thing, how to push the configurations using the templates and all those things are basically covered under the router deployment section. By the end of this router deployment in our topology that we are going to work on, we will have like complete end-to-end reachability. We will have a complete end-to-end reachability by the end of these 3 units. By the end of these 3 units, we will have a complete end-to-end reachability in our lab environment, in our lab topology. And you will know about the protocols, templates, and all the things that you should know from the basic operations point. Policies For example, policies are the ways, policies we can deploy, policies we can implement in order to control our traffic flow. If you want to control how the traffic must flow from one point to the point, for that we have this concept called policy. So basic policy is going to control how the data traffic, data policy. Data policy basically means how your data traffic flows. Data policy basically means how the data will flow from one device to the device. Such as we have two transport. One is like internet and one is like MPLS. And we want that for our certain. We want that when the traffic goes from like branch 1 to branch number 2. Here is branch number 2. When the traffic goes from branch number 1 to branch number 2, the data must go via the internet for like certain applications, and the data must go via the MPLS for certain application. So we can, for example, here we can configure various policies to change the way our SD-WAN network is going to work. Our SD-WAN network is going to operate. Things such as like hub and spoke policy, full mesh policy, dynamic tunnels, selecting what transport we have to use, deciding what routes we are going to learn and all. Control policies basically means the policies that we can implement on the control plane, and the data policy basically means the policies that we can implement on the data traffic. Configure end-to-end segmentation, VPN segmentation, topologies and all. Application aware routing, direct internet access. Basically, policies are probably the most important topic of your SD-WAN. The rest like deployment and configuring the templates and all those things is pretty much easy. But when it comes to policies, a few complexities are there. So policies are the topics that we have to focus a lot on. We will cover approximately like, I believe, 20-25 policies, small policies. Rest you can, once you know how to implement the policies in the network, you can decide to implement more and more policies completely up to your requirement. But policies are one topic that we should focus a lot as compared to any other topic in our SD-WAN. In most of the production environment, you will notice that the SD-WAN network might already be running. So you just need to deploy some templates. You just need to deploy some policies in order to change the way your SD-WAN fabric powers the data, learns the routes and everything. So those policies and templates we will focus a lot on. Of course, we'll talk about the deployment and all the other options, PNP, ZTP, whatever. But we will focus a lot on the templates and the policies option. And it's all configure, by the way. It is all configure. So it's all practical. It's completely like practical. I will describe what this policy is going to do, and we are going to implement that policy right now. So it's more focused on the practical rather than the theoretical discussion. Then when SD-WAN came in the market, like Cisco was like one of the few vendors that used to provide the SD-WAN solution. They were more like the leaders in the SD-WAN. But later on, like other vendors also adopted this SD-WAN solution. Versa, VeloCloud, other Citrix, all these other vendors, for example, are also available in the market nowadays. So one of the key challenge for Cisco when it comes to the SD-WAN, proposing the SD-WAN solution to the customer, actually, one of the key challenge, one of the major problem that they were facing, actually, that customer was saying that, okay, you are offering me an SD-WAN solution. Fine. Okay, fine. You are offering me an SD-WAN solution. If I get your SD-WAN solution, I basically get the routing. I mostly get the routing, WAN routing, I mostly get the routing function. But for example, if I opt for the Palo Alto or Fortinet, for example, SD-WAN solution, if I deploy this Palo Alto or Fortinet, for example, the SD-WAN solution, not only we are going to get the routing at the WAN level, whatever amount of functions are available, not only we are going to get the routing at the WAN level, but we are also going to get enhanced security, because Palo Alto firewall that is equipped with the SD-WAN functionality, Fortinet, firewall, for example, equipped with the SD-WAN functionality. Other vendors also there. So they say, why should we deploy your solution if I can go for Palo Alto, where I get the basic routing, which is sufficient for me from the WAN deployment point of view, and we are also going to get a lot of security features. So why should we deploy your routing only SD-WAN solution, where I get the routing along with the SD-WAN from the vendors such as Palo Alto or the Fortinet, for example. Other vendors, other security vendors also. Palo Alto, Fortinet, these solutions became way more popular than Cisco, actually. Then Cisco already had a few security features, but Cisco then announced that what you can do, you can implement some basic security features on your SD-WAN router itself. you can implement some basic security feature on the SD-WAN router itself. So here is your SD-WAN router. In this SD-WAN router, the routing functionalities are going to be there. And you can also implement some security functions with the help of some virtualization concept. You can also implement some security functions such as application-aware firewall, IPS, URL filtering, AMP, SSL, TLS proxy, a trust check, DNS security, SIG. You can implement service insertion and chaining. You can implement these security features right on the box itself. With the help of the SD-WAN controller, you can configure the security policies and you can deploy those security policies on the box. And the box is not only going to then perform the routing, but it is also going to perform the security for your. These features might not be as good as offered by a dedicated firewall. Same of these features like also offered by the normal firewall. I'm saying that these features might not be as good as having a dedicated firewall at your branch. But if you have a small branch where we want to enforce some basic security, or even if you have a medium scale branch and there you want to enforce some basic security based on like URL filtering, advanced malware protection, IPS and all those things, we don't need to purchase like any additional hardware for the same. We can just download a security application image from Cisco website. You can upload that security application image on that SD-WAN router. You can install that security application image on that SD-WAN router, and that SD-WAN router, based on the policy, that SD-WAN router will not only perform the routing now, but will also be able to enforce these securities in the network. So what are these? Although it says describe, but we will implement as many security features as we can in our lab environment. We will be able to implement as many features as we can in our lab environment. For example, we will be able to implement service insertion, application-aware firewall, IPS, URL filtering, AMP, SSL, TLS proxy also. DNS security requires umbrella subscription and all. I will explain the concept. A SIG, where we want to connect our SD-WAN solution with the cloud delivered firewall and all. So what is this SIG and all? I will explain you these features. I will show you how to implement them, but we will not be able to practically implement it. But anyway, so whatever features, as many features as we can implement practically, we will definitely do it in a practical way as well. But most of these features, as per our content, they are only discussed. Then how to better the user experience, how to improve the user experience for different type of application traffic. So how to improve the user experience for the certain application traffic that comes under the quality of service. So since we are talking about the routers, and on the routers we can implement some QoS features. So what quality of service features, what quality of service features are in fact available that we can implement on our SD-WAN device? What are these application quality of experience? What are these features that we can implement to improve the application quality of experience? TCP optimization, DRELs, packet duplication, forward error correction, application and AV. What are these options we will talk about as a part of our content? Again, a few of them we will implement practically as well. Whatever is possible, we will implement practically, such as this, such as this, such as this. We will be able to implement. I guess we will also be able to implement this one as well. So whatever features are possible to implement practically, we will definitely implement them practically, even though it just says this type. But we will have the practical implementation of the same as well. And then at the very end, we are going to go for the management and operation. Here we are going to talk about our day two operations, such as image. If we want to do the image upgrade, REST API, what is this API concept, software image management, AAA authentication, monitoring, reporting, how to configure authentication, how to configure monitoring, reporting, how to configure these things from the vManage, all these things. Basically, some day two operations we will talk about as a part of our SD-WAN. This is the content that we will basically focus on. These are the topics that we will specifically focus on. Apart from that, a few things that are not mentioned here, we will talk about them, such as a few additional concepts, such as tunnel group, such as these feature profiles, such as sub interfaces, a few more things here and there we will talk about. But we will make sure that all the things that are there in this official content tasks are covered first. And then if some time is left, then we will talk about some additional topics that you must know from your content, from your production environment point of view. So this is the content that we will focus on, by the way. There is a dedicated certification exam. So if you cover this content, not only you will be ready for the NRC, not only you will be ready for this ENSDWI exam, but you will also be ready for the CCIE lab exam. CCIE lab exam also, for example, has the same topics. CCIE lab exam, that we have. CCIE lab exam also has the concept like SD-WAN. So if you go through like the CCIE lab exam topics and you just click on it, in the CCIE lab exam also there is a dedicated section called software defined networking. If you click on it, there are two things. One is SDA and one is this SD-WAN. So in SD-WAN, same exact thing. So they do not focus like a lot in the SD-WAN. They don't ask like a lot of things in the SD-WAN. So this content is way more like in detail as compared to this one. So if you go through this ENSDWI content, you will not only cover the SD-WAN from the ENSDWI, but also from the CCIE lab exam, and not to mention the ENCORE exam. In the ENCORE exam, whatever topics of the SD-WAN are, you will also be ready for that. So our content will focus on three certifications. One is going to be like ENCORE, whatever SD-WAN topics are there, those will be covered. Then ENSDWI, the dedicated certification exam, and the CCIE lab exam. So this is like the third certification that our content will focus on. So after completion of the classes, they will neither require the dedicated classes for the ENCORE, nor we will require for the CCIE lab exam as the topics. You will not require like any further more classes dedicatedly for the ENCORE or the CCIE lab exam from the SD-WAN point of view. This is a topic that we are going to go. These are the topics that we are going to. So any doubts, any questions that we have in the content, what content we are going to cover, or any doubts, anything you want to ask, you can ask. Let me know. Doubts so far.
Hey, I have a quick question. Can you hear me?
Yeah, I can.
So what is the prerequisite for this course?
Yes. Okay. So for the SD-WAN, since it's not an associate level of certifications, a few things you must already know before you begin your SD-WAN classes. One of the very basic thing that you must already know is like the basic routing. You must know, for example, like what is routing, why we use routing, what is an IP address, all the basic fundamentals regarding what is a router, for example, what is this iOS, all these like basic things you must know. And you must also know about the routing protocols, such as what is this OSPF, what is this static routing, what is this EIGRP, what is this border gateway protocol. It's not like you should know about all these things in very much detail, but at least like a basic to intermediate level of knowledge will be required. For example, I am not going to tell you what is border gateway protocol, why we use border gateway protocol, what is this concept of AS number, why we use AS number in BGP, EIGRP, those basic concepts, basic fundamentals of the routing. I should already know. What is EIGRP, where to use EIGRP, where to use BGP, basic fundamentals about the routing, very first thing that you should. It's not like you have to go through the MPLS and the internet and in very much detail about the DMVPN and all those things. No, just the basic understanding means like the beginner to intermediate level of understanding. If you have about the routing topics, then it will be like okay.
Perfect. Thank you.
Second thing that you must know, for example, security. When it comes to security, our content specifically says that we have to implement the security. We have to, although we will talk about like what is this intrusion prevention system, what is this URL filtering. But if you have the knowledge of security before you reach out to this part of SD-WAN security, then it will be an advantage, because then you will just be able to deploy all those features without any problem. Else for the detailed, we will talk about this content in a little bit in theoretical, but for the detailed discussion, actually, you will have to cover these topics from a dedicated security content. In whatever module of security these topics are covered in detail, you can cover it from there. And then you can see how the SD-WAN basically implements these things using the templates, using the policies. So a little bit understanding of the security terminologies you should also have. Same goes for quality of service. Our content says implement quality of service. Although we will talk about what is this policing, shaping, and all those things, but we are not going to discuss the quality of service in detail. It is part of our CCIE curriculum. So we are, of course, not going to discuss like the topic of quality of service in detail, like what is this giving, shaping. Quality of service requires like 4 to 5 days, a dedicated, content like is there for the quality of service, which is typically covered in the CCIE routing curriculum. So here you should be familiar with the basic terminologies of the quality of service, like what is giving, what is shaping. Rest we are going to talk about it, and rest we are going to practically implement in our content as well. So, but the basic understanding, if you already have, then it will be beneficial.
Perfect. Thanks. I do not have that, but I believe you are going to cover in CCI routing.
Correct. I will do it, but I will explain the basic things about this policing, shaping, giving. What I can do just when we start over this topic before the classes, you can just before like one day before the class, you can just remind me. I will provide you with some videos of on YouTube or some portal, so that you can at least quickly like revise about the or know about the terminologies, and then whenever dedicated content of the routing starts, then we will focus in detail about these. Same thing can be done for the security. Same things can be done for the other topics that you might not be that much familiar.
Okay, makes sense. Thank you.
Also, like for example, when we are talking about the controller deployment on the cloud, and if you want to deploy the controller on the cloud, actually, then of course you will have to have the knowledge of the cloud itself. Like what is this AWS? What is this Azure? What is this concept of VPC? What is this concept of VNet? What is this availability zone? What is this reason? If you want to actually deploy the controllers on the cloud, we expect, or I expect, that you will at least have the understanding of the cloud terminologies and how the cloud works, and then it will be easier for you to deploy those things, deploy the controllers on the cloud. So the point basically remains that if you want to deploy the controllers on GCP, for example, Google Cloud Platform, then you will have to have the understanding of the GCP and its terminology to deploy the things on the cloud respectively. So point remains the same. Point is basically, if you want to deploy the controllers on the cloud, you must have the understanding of the cloud. As pure SD-WAN content point of view, it's not required. It's not required like to know about cloud terminologies, AWS, Azure, because a little bit we will talk about, and rest like we will focus more on the on-premises deployment. But if you want to, again, if you are managing the SD-WAN services in your production environment, and if they say that we have to deploy the controllers on the cloud, then of course either you will have to find a cloud engineer, otherwise you will have to learn about the cloud deployment respectively.
Yeah, control deployment is a day one activity, right? So
yes, the very basics. Correct. Very basics.
So policy is a day two activity where the support
Correct.
teams.
Once everything is up and running and we want to influence our SD-WAN architecture as per our requirement, there we are going to deploy the policies. Correct. Similarly, I'm going to tell you right here that if you plan to deploy the controllers on your premises, if you are planning to deploy the controllers on the premises, controllers are basically just the softwares that we will have to install on some virtualized environments, such as, for example, ESXi, basically on server. Controller is just the software that we will have to download from Cisco website once we have purchased the solution, and we will have to install it. If you want to go for the on-premises deployment, then you will have to deploy that on the server. Server is basically a hardware device that can provide you various services. A hardware device that is equipped with a lot of resources, RAM, CPU, storage, and all. So basically on server, we have to deploy these controllers. And on the servers, we have server operating systems. We have these things called hypervisors, such as ESXi, we have KVM, Hyper-V, we have different hypervisors. So if you again want to deploy the controllers on the premises, then also you will have to have the understanding of the servers. Server virtualization, you will have to have a little bit understanding of the server virtualization. You have to know what exactly is a server. What is this concept called virtual machine? What is this concept called, what is that vSwitch? What is this concept called port group? How to basically map the virtual interfaces, the virtual network interfaces with the vSwitch, and how to connect the vSwitch with the physical switch and all. So you will have to have the understanding of the server side or server virtualization, just in case if you want to deploy the controllers on the premises. Else, you will need to find someone who knows about the server virtualization, who knows about like ESXi or the KVM or the Hyper-V, and then you can ask them to create a virtual machine where you can deploy the controllers in a virtualized environment on your premises. Again, does not concern us, not the part of our curriculum. But again, if you are the network administrator and if you are someone who is responsible to deploy the controllers on the premises for the customer or for your organization, then you will also need to learn a little bit about the server virtualization. So that topic you will also need to go. It's not very hard actually. Whatever things are relevant in our content from the server side of server virtualization point of view, it's very easy. So if you spend like 1 or 2 days exploring the options available in the server, you will be able to understand each and everything properly. But dedicated, for example, training or dedicated, for example, you will have to study dedicatedly. You will have to study for that part, like server virtualization. Again, you will find plenty of YouTube videos on the server virtualization. You will find plenty of videos for security, quality of service, and all those things. So it is not going to be like very hard, but these things you must know if you are going to deploy and manage the infrastructure of the customer or even your organization by yourself. These are the prerequisites that we have before we begin our SD-WAN content. Most of them are just like when we have to do the deployment, when we have to enforce the security policies and everything ourselves. But if we have a dedicated security team, we can have a discussion with them like what kind of security feature will be beneficial, and then you can just follow some videos or documentation to deploy those security policies or quality of service without any problem. But still, at least like these are the things at least you should know before we begin our basic. Medium, I will say like beginner to intermediate level of knowledge is required for these kind of topics. The rest, like you don't require the very detailed knowledge of MPLS, DMVPN, GRE, IPsec. You don't require like a very detailed understanding of these things. All you need to know is that MPLS, internet, these are just the transport. All you need to know is that IPsec is just a protocol that is required for a secure communication between two endpoints over in secure network such as internet. From these topics point of view, you will not require like a lot of detailed discussion on the same. So beginner to intermediate level of knowledge is sufficient.
Is this only VIPTELA like this?
Yes. We will focus. Yes, we will focus specifically on the Catalyst SD-WAN, which is based on like VIPTELA. So we will not talk about the other solution that the Cisco offers, which is Meraki based SD-WAN. We will have a little bit discussion about the Meraki based SD-WAN, but we are not going to go in detail of it. Meraki SD-WAN is mostly like completely cloud delivered, so we can't practice anyways. So I will brief you on this Meraki based SD-WAN solution, but our content is specifically going to focus on the Catalyst SD-WAN based on VIPTELA. Other vendors also we're not going to talk about, such as Versa.
Hardware involved, is it? Everything is VM only?
Everything is
VMs only, virtual machines, or do we have any hardware?
No. It's going to be like completely virtualized environment. That is why if you want to build your own lab at your home environment, it is possible to. So if you want to build your own lab, then let's say there are two ways that you can take to do the lab. Either you can get the lab access from here, like online lab access. So you can drop a message to your account handler whenever our lab content starts. You can drop a message to your account handler, and you can ask them that you want the lab access for this particular time period. So it is like 4 hours per day, 4 hours per day, whatever time slot you choose. It is going to be like 4 hours per day. On 4 hours per day basis, you can do the practice of your SD-WAN topics. So you can get the online lab from here. However, in the online lab, you will face a few challenges since it's all virtualized a few challenges will be there. We will talk about those challenges. If you can manage the resources, you can build an offline lab as well, but that will require like a lot of resources. If you do not have that much amount of resources, then you will have to rely on the online lab and the challenges that you might face. But if you have sufficient amount of resources, you can build the SD-WAN lab offline as well in the ENG platform, for example, PNet. You can build the online lab here in these virtualized platform as well. But the resource requirement is going to be a little bit on the high side. Minimum for a smooth operation, if you are going to deploy the SD-WAN solution in a virtualized environment, minimum for a smooth operation, you will require at least 64 GB of RAM. At least you should have a total of 16 virtual CPUs and at least like 500 GB SSD. SSD is needed if it is NVMe, if it is M.2 or NVMe, that is going to be better. But minimum this much amount of resources will be required for a smooth operation. You can practice on the older versions, like with less amount of resources, like for example, 32 GB RAM, 16 total like CPUs, and 500 GB like SSD. So you can practice on the lower version of the SD-WAN, even if you have like 32 GB RAM. But you can see if you refer to this. If you refer to that document, here is a document from the ENG website. Here is the document from the ENG website that describes, like, for example, how much amount of resources are required for each and every version. So, for example, if you are going to deploy the SD-WAN version 19 point something, then 16 GB RAM you will have to dedicate for the one controller, then 2 GB RAM you will have to dedicate for the second controller, and 1 GB RAM you will have to dedicate for the third controller. So, minimum, if you see like 16 plus 2 is 18 and plus 19 GB minimum, 19 GB RAM is required for the controllers, and you will require like additional 5-6 GB RAM for the SD-WAN devices, vManage routers. So approximately in 32 GB, things might still work properly if you are practicing on the older version. But if you are working on the newer version, if you are working on the 20 point version, then you will require at least 24 GB of RAM, at least 20 point version if you are practicing on, which is what is used in the production environment, 20.9, 20.10, for example, the stable release, 20.12 has become the stable release now. So these versions require at least 24 GB RAM here. So one of the controller will require minimum 24 GB. So 32 GB might not be sufficient. However, you can still build a small topology and practice on the same. But if you are going to go for the 20.12 or beyond, then you will require at least 32 GB RAM for one single node. So having only 32 GB RAM will not be of any. That's why I said, like, if you want to deploy the lab in your home environment, then minimum for a smooth operation, minimum you will have to have the 64 GB, minimum 64 GB RAM, a total of like 16 virtual CPUs, and if 500 GB NVMe or like M.2 SSD is there, then it is going to work properly without any. If you can manage that much amount of resources in your desktop, or maybe you might have a server, you might get the server from your company, organization, whatever, like, if you can manage a virtual machine, if you can manage an ENG with that much amount of resources, you can deploy the lab at your home environment. You can ask your account handler, they will connect you to the lab admin. Lab admin will take the remote access and they will deploy the lab in your, for example, environment for you. So you don't have to do anything. If you are familiar with like ENG, how to do the deployment and all, then you can just ask them for the images and then they will do that as well. Otherwise, you can just ask the lab admin and then they will take the remote access and deploy the lab for you in your home. And I will recommend that if you can manage, I'm not saying that you have to, I'm saying that if you can manage at least for 15, 20 days, 30 days, for example, at least for 30 days, if you can manage this kind of like machine with this much amount of resources, I will say it will be much more better learning experience, because you can do the lab at whatever time. There will not be any time foundation or anything. You can do the lab at whatever time you want to. There is a WhatsApp group for the SD-WAN where you all will join, and you can ask your question in that group and all. So plenty of things can be done regarding that. So if you can manage this much amount of resources, then I will say that you must actually, so that you can have a better learning experience from the lab point of view. Else, you will be provided with the lab access from here. Online lab access will be there. That will be limited to 4 hours per day throughout the time period of our classes. And even after that, after the class ends, I guess 1 month, 2 months is there. You can get the confirmation from your account handler that for how many days after our class ends, the lab access is there. So they will let you know on the timings and all. So you can have all these kind of discussion with the management, with your account handler. But I will recommend personally, if you can manage the laptop, desktop, or any kind of server for that, so 30 days maximum, it will be better. If not, then you can just get the lab access from here as well. Both the options are. One will be time bounded. One is going to be if you deploy things at your own environment, then it's not going to be there will not be any time limit. Right. So regarding the lab, you can decide which one you want to opt for. Let me know. Any doubts in the lab section? Any doubts, any questions so far in the lab point? Anything you did not understand or any point that needs to be discussed? Let me know. Now, what is the lab? How will you get the lab file and all that? That I will let you know. I will tell you how to get the lab and all that thing. So when we start our lab content, we will, since it's completely virtualized, since the lab is completely virtualized, so we do not need to worry about purchasing any hardware also. We will not require to purchase any kind of hardware or anything, since the lab is completely virtualized, since all the controllers and, for example, the vManage devices and everything, since it's completely virtualized, we do not need to purchase or download or any hardware for the same. So this is our content that we will focus on. Whatever things say describe, we will describe. Whatever things say implement or troubleshoot, we will do the practical implementation and troubleshooting of that as well. Also, a few things that they say, for example, only describe, we will also do the practical implementation of those things as well. As much as possible, we will do the practical labs for these topics as well. So this is the content that we will follow, which will cover 2 more contents, N4 and the CCIE lab exam. The lab access, you will get the lab access when our lab starts, basically, which will take, I guess, at least 2 weeks before we start our lab. For 2 weeks, we will have our technical discussion, theoretical discussion about the topics, and then we will start our lab afterwards, starting from the controller deployment, going all the way to the policies and everything. And then apart from that, all the documentation, workbook, PDF, PPT, everything you will get on the portal, the Trainonic portal from where you have joined the classes. There you will have various links on that portal. You will have various links from where you can download all kind of resources that are required for the completion of our training. So, for example, if you visit your course, under your course, you can just click on it and you can just download it directly. So you can just download it. This is the SD-WAN deployment getting started guide. It is officially from Cisco. So this is SD-WAN getting started guide that you can download and have it with you. So all the kind of documentation and everything is already available with you on the portal. SD-WAN content. Approximately, it will take 24 to 25 classes. Approximately, I expect 24, 25 classes will be there for our content. To be very honest, I have not taken the SD-WAN batch in the weekdays for a very long time. So generally, it's in the weekend, I do take the SD-WAN classes. So generally, it's 10, 12 weekend training. So basically 24, we will be able to complete the content in 24, 25 classes here. Accordingly, in the weekend, it takes approximately 8 to 10 weekends. 10 weekends approximately it takes. So we will be able to complete it approximately in 24, 25 classes. 2 hours per day, 8 to 10. 2 hours per day, approximately 24, 25 classes. I'm not saying days, by the way. I'm saying classes. Monday to Thursday. Friday, Saturday, and Sunday is going to be off. You can do the labs on Friday, Saturday. You can enjoy your Sunday, for example. So whatever things we do in these 4 days, you can do it in the weekdays as well. And then you can dedicate a dedicated day for the study, and then you can spend the weekend as per your choice. So Monday to Thursday classes will be there 4 days a week, 2 hours a day, and we will be able to complete it approximately in 24-25. I believe. Do we have any holidays meanwhile? Just to give you a heads up, I will let you know on any
the traditional networking is working, and
that
what is
that is from where we will start actually. That is what we will start, like, what is SD-WAN, why we need SD-WAN, how it is different from the traditional network, what are the traditional solutions. We'll talk about that in our technical content that will start like in just 5 minutes. We'll begin with that.
Oh, okay.
Yeah. Right. So so far, what we have covered, what we have discussed like what topics we are going to cover. This is again from the official Cisco website. These are the topics that we are going to cover. Then this is the lab environment that we will have. It is completely virtualized. Either you will get the lab access online from here, or you can just get the files and you can deploy it at your home environment. We will talk about the lab environment when we start the lab. But this is the lab topology that we will be working on, completely virtualized. We will have to only touch the traditional. We'll only have to touch the software-defined part here, not the traditional part that we will discuss in our lab session. These are the labs that we are going to cover: creating the SD-WAN overlay underlay network, interconnecting SD-WAN components, installing the root certificate, initializing the controller, whatever, vManage, vBond, vSmart, whatever. Then WAN as devices, initializing the WAN as devices, registering the WAN as devices on the vManage, performing the initial configurations on the devices, then deploying various templates, system, banner, VPN, AAA, BFD, configuring various basic templates, configuring routing templates, TLOC extension, whatever basically routing, whatever things we needed to do to make the reachability, we will talk about in all these small labs. Then the policies, different types of policies such as hub and spoke, traffic engineering, service insertion and chaining, route filtering, TLOC filtering, route leaking, VPN membership, preferred transport, application aware policy, NAT, DIA, CFLOT, QS, packet loss mitigation, application aware firewall, IPS IDS, URL filtering, AMP, DNS familiar security, cloud on ramp, whatever. So these are all the different types of policies that we will be implementing throughout our content. Then we will have a mix of policies. We will deploy a mix of policies to do multiple tasks at the same time. We will basically talk a lot about the policies in our content, the normal control policies, data policies, security policies, how security policies are implemented and all, we'll talk about all that as a part of our content. And then we will begin with then we will start our day 2 operation. Day 2 operation basically means the management part. We will talk about at the beginning.
Sorry, you uploaded the topology in the portal?
No, the topology is not uploaded on the portal. Topology you can get from the lab.
Okay. Is it going to be single topology throughout the course?
No. It is just going to be a normal topology. This topology, and in this composite topology, you are going to practice everything one by one.
So it's like one topology for the entire lab, right?
Oh. Here all the traditional devices. Here all the traditional devices are pre-configured, and you will only need to focus on the SD-WAN devices and their deployment. The software version that we will be using, we will decide on the software version ourselves. There are a few challenges when choosing the correct software version to practice on. We will decide, together, like which version we will have to practice on. I recommend 20.12 to practice on, but we will decide what are the challenges in that version. How should we choose the correct version to practice on? We will decide that later on, but just to be very brief, we will practice on 20.12 version of the SD-WAN.
This for the lab, it's like the CCIE lab.
CCIE lab has 20.9 actually. CCIE lab has version 20.9, but from the graphical user point of view, there are not many differences in 20.9 and 20.12. So Cisco basically, they changed the naming convention. Cisco completed the acquisition of the Viptela. There was a company called Viptela that used to provide the SD-WAN solution. So Cisco completed the acquisition of the Viptela around in August 2017. And then in June 2023, they rebranded the SD-WAN solution offered by Viptela to suit their portfolio. So from 20.12 release, they started calling the Viptela SD-WAN. They started calling the Viptela SD-WAN as the Catalyst SD-WAN. In one of the Cisco live event, Cisco is now connecting the power and flexibility of the Catalyst brand across the entire enterprise networking stack with the Catalyst Center, formerly the DNS Center, Catalyst Software Licensing, formerly the DNS Software Licensing, Catalyst Wireless, Catalyst Switching, Catalyst Routing, and Catalyst SD-WAN. So formerly it was known as Cisco SD-WAN or Viptela SD-WAN. So they just changed the naming convention to Catalyst SD-WAN, and they made it effective with the release of SD-WAN version, software version 20.12. So they changed the name. They changed the name of the controller to a different name. They changed the name of the controller. They changed the name of the controller. Everything else remains the same. Just the naming convention they have changed. They have just changed the names. Rest everything, like how the SD-WAN solution operates and all that thing remains as it is. Remember that in the slides, if you see vManage automatically understand its SD-WAN manager, if you see like vMon automatically understand that it is validator, if you see vSmart automatically understand that it is controller. Consider the naming of the controllers in the slides being used interchangeably. So just the name has changed, nothing else. In the user interface, they have just changed the name. In a lot of places, you will still see the vManage, vBond, vSmart, but the naming convention has changed. The rest of everything remains exactly the same with no changes at all. So why I recommend 20.12? Because you will get yourself familiar with the latest terminologies that they have. Effective 20.12, like all the other releases have the same. All the other releases have the same exact name and all. So I will recommend 20.12, even though in exam they have 20.9. And the latest version is 20.15. 16 is also there. So 20.12, 20.9, 20.15, or maybe 16. Which version you will want to practice on, that needs to be decided. This is 20.12 is also now the recommended release for the production environment. 20.16, 15, they are still now not the recommended release. 20.9 is the one that we have in the exam. So conceptually, practically speaking, we should either go for 20.9 or 20.12. Since 20.9 and 20.12 they have almost similar user interface. With a lot of things being used interchangeably. So they almost have the similar user interface. So I will say this using this 20.12 will be very much okay. But the major you will see that in 20.12 and 20.13 and beyond, there is a major change in the user interface. The user interface of 20.12 and the user interface of 20.13 is completely different. So which gives us a challenge, like which version we should practice on. Should we practice on the version that is there in the CCIE lab exam? Should we practice on the version that is recommended by Cisco for the production environment? Or should we practice on the version that is the latest version, or from where the user interface has started completely getting changed, 20.15, 20. So from 20.13, the user interface has changed completely. So we have like these three choices. So we will fix this issue. We will talk about the solution of this problem. But just to give you a heads up, we will practice on the 20. This is what we are going to use in our lab. Since 20.9, 20.12 has similar user interface, so you will not require the practice on 20.9. Once you have done practice on 20.12, then you can make yourself familiar by practicing on the upgraded version. Or I will give you one more solution. I will ask you to go to the dcloud and see the differences between the releases 20.12 and later. And you can just navigate through the user interface from the dcloud to see what option has been moved where and all. So that will also be sufficient, which we will talk about in our lab section, not here. But just to give you an idea, we will be practicing on 20, which will require a minimum 32 GB RAM for one of the controller. So minimum 64 GB RAM for overall operation. Minimum 64 GB RAM you will require for overall operation. overall SD-WAN. If you can manage that much amount of resources at your home, it's good. If not, then you can get the lab access from here. You can drop a message to your account handler, and then they will connect you to the lab admin, and then they will ask you about the slots and all, and then you will get the lab access based on that as well. This is how we are going to do things. This is how we are going to cover our way. So traditionally, when we talk about like the traditional environment, we are talking about the WAN. WAN stands for like, wide area network. WAN is basically how we connect. Wide area network, or WAN, is basically how we connect our campus network with the rest of the branches, headquarters, data center. Assuming that we have here like BR1, here we have BR2, here we have some, for example, headquarter, here we have such as, for example, some data center, some small offices and all. So WAN typically defines how we are going to connect, how are we going to connect all these data center, headquarter, branches all together with the help of the transport. So we can provide the connectivity from the edge router that we have in our infrastructure. We can provide the connectivity with the help of the edge routers that we have in our infrastructure. We can have either one edge router, we can have multiple edge router. Some edge routers can be connected on the multiple transports, such as like internet, such as like MPLS. Some of the devices might be connected with only one of the transport. So we can have different options for this reachability. Once the reachability is there, once like this IP address is reachable with this IP address and this IP address and this IP address, once the reachability is there between all these devices, then we can decide to implement additional configuration commands. We can decide to implement the additional technology, such as, for example, we might implement this VPN technology, for example, to secure the communication over the public network, such as internet. We can go for things such as VPN, we can go for GRE, we can go for like IPsec and whatnot. We can basically decide to implement different types of like protocols, configurations to secure the communication over insecure networks such as internet. WAN traditionally was focused more on connectivity, connecting basically different branches, headquarters, data centers, all together. WAN was more focused on connectivity. WAN was more focused on connecting all the WAN edge devices together so that the reachability can be provided from one location to other. To provide the reachability, we can use the concept of like GRE, VPN, IPsec, and other technologies as well to provide the connectivity from the LAN to the LAN, from the LAN to the LAN. We also had the option of using a private WAN transport such as MPLS. Internet is more like categorized as a public WAN transport. MPLS is categorized more like a private WAN services, private WAN transport. The main reason we call this MPLS transport as a private WAN transport is the reason because this MPLS transport internet is basically shared with everyone. Anyone who basically pays for the internet services can be connected to that public network, and they can use that network to send and receive the data. Internet is most probably the biggest network that you can ever find. So internet is more like a public network. Anyone can connect to the internet and they can start sending and receiving the data. All you need to do is just a capable device, and you can connect yourself with the internet services, and then you can start sending and receiving data. However, the use of MPLS or multi-protocol label switching, using the MPLS technology also, we can provide the connectivity between these IP addresses that are available on our WAN edges. So using the MPLS transport, which is more like a private transport. Not everyone gets their hands on the MPLS transport. It's more like private to those who have subscribed, who have opted for this kind of solution. It's like the MPLS service providers, they have their own set of wires, cables that can provide the connectivity between all these locations over some sort of like private way, in more like a private way, rather than having accessible to everyone. Only those who have more like subscribed, only those who have, for example, opted for the MPLS solution can get this kind of connectivity also. The objective was to provide the reachability. The objective of the WAN was to provide the reachability between all these IP addresses Once the reachability was there, then we can use various protocols to exchange our routes from one location to the location. And once the route exchange process was done, we can use the transport such as MPLS or internet to send and receive our traffic over insecure public network, over a private network that people used to consider a little bit more secure as compared to internet. By the way, there is no security in MPLS. There is no security in MPLS. The only reason why they say that MPLS is much more secure as compared to the internet is basically the fact that it's not shared with anyone. It's not like shared with every. It's not shared with every. Only those who have subscribed for this MPLS connection, they only get their hands on the MPLS technology. Not everyone can just come and then start sending the data over this MPLS. But that's why in an essence, that's why this MPLS is more like a private WAN transport rather than a public WAN transport. Connectivity between different devices can be done over a public WAN transport such as internet, and connectivity between the devices of different locations can be done over a private transport such as MPLS. The major difference between them is the this sense of security. MPLS is considered more secure as compared to the internet in sense that it is not shared with everyone like internet. But still, whatever data we send and receive over the MPLS transport, it's not encrypted. It is not encrypted. It is not secured by default. So there are still very much possibilities that when you send some data over the MPLS service provider, chances of attacks, chances of data theft can still be there. It's not encrypted. It's more reliable than internet. It is It is costlier than internet as well. It is more costly than internet as well. So there are a lot of things associated with the MPLS transport, such as cost, such as the availability, such as reliability, such as security. There are a lot of things based on which because of which based on in the traditional environment people used to prefer. In the traditional environment, people used to prefer this MPLS as their primary transport to send and receive. If you want to enforce the security, by the way, we do have the option. In the MPLS, we can implement the VPN such as get a VPN. Group encrypted transport virtual private network designed specifically to secure the communication over the MPLS network. Some additional configurations might be required for the same. But even if you don't configure this get VPN, since it's more like a private WAN transport, sense of security is there as compared to the public transport such as internet. What people used to do in case of public transport such as internet, they used to build these secure communication channel over this transport. People used to build the secure communication channel over these over this internet transport. People used to build tunnels, GRE, DMVPN, these kind of tunnels people used to build over this insecure transport such as internet, and then they used to secure the communication. They used to secure the communication over these tunnels with the help of a protocol called IPsec. Requires manual configuration of these tunnels, require manual configuration of our security protocol so that we can send our private data from one point to the other. So basically MPLS was your preferred transport. MPLS was your preferred transport by multi-protocol label switching. MPLS was your primary transport, and internet we used to use as a DMVPN. Internet we used to use as a VPN. Internet we used to use as a secondary. Just because that it gives you a sense of security in some sense, we used to use MPLS as a primary transport based on reliability, availability. In a way, it's private WAN transport. So because of a lot of reasons, we used to use MPLS as our primary transport and internet as a secondary transport. Then we also have this concept called 4G LTE. Nowadays, we have 4G long-term evolution, 4G LTE. Nowadays, we also have this concept called Metro Ethernet. Metro Ethernet is where the connectivity in the metropolitan city is provided solely based on the Ethernet technology. So companies can install their fiber optical cables from one end of the city to the other end of the city, and they can provide the connectivity everywhere. So metro Ethernet concept is also there. There are different types of WAN transports that are available nowadays. But again, the traditional WAN was focused more on interconnecting multiple devices. The traditional WAN was more focused on interconnecting all the devices together. Then came the concept of cloud. Then came the concept of the software-defined networking. There came like a lot of additional things in the market. IoT devices, for example. Humans were no longer only user of the network. We now have like the IoT devices. We have different types of like sensors, cameras, and all that. They also became the users of the network actually. So basically, one of the biggest challenge was adoption of these new things that were coming in the market, such as IoT, such as cloud, for example, such as IoT, such as cloud, and these kind of things. So addition of these, made WAN a little bit more complicated to handle. Moreover, like things started moving. Moreover, things started moving to the cloud. Earlier, applications were deployed. Earlier, applications were deployed onto the premises. But nowadays, like applications are hosted on the cloud. Nowadays, applications are hosted on the cloud. So how the traditional WAN is going to address the challenges, latency, drops, and all these things, how the traditional WAN is going to address the challenges regarding these things. Those things might require manual configuration. Companies started moving their infrastructure to the cloud. Companies started deploying cloud-delivered firewalls, cloud-delivered data center. How are we going to extend the connectivity of our branches to these cloud-delivered solutions, such as firewall, such as data center? How the user experience can be improved for those? How can we deploy the policies on the cloud-delivered firewall and redirect our traffic of branch 1 to branch 2 via that cloud-delivered firewall, and then to this point? Let's say you have to deploy like a new branch. In that new branch, let's say you have to deploy 2 vNS devices. And both the vNS devices needs the connectivity with the internet and the MPLS transport. So we will have to do certain configurations on this vNS router, provide the connectivity with the internet to the MPLS, configure the policies, configure the VPN settings and all those things. When we have to deploy a few new devices in a few new branches, then the configurations are needed to be done manually. Even though you might use tools, you might copy and paste the configurations from one of your branch to the new branch, but that will also have a risk of pasting the same configurations without changing the values. If you accidentally paste the same configuration that we have done on one of the branch on this newly added branch without changing the expected values, then also there might be issues. All the traffic that must have gone to this branch will now somehow started going to that branch maybe. There could be like various challenges even if you do the copy paste, then also like deploying a new device will add like a lot of challenges. Let's not even talk about the troubleshooting. Let's say, for example, a few branch users are experiencing packet loss. A few branch devices are experiencing the packet loss, and for the other branch devices, everything is working as expected. For a few branch devices, they are experiencing the packet loss, and for the rest of the branches, everything is working as expected. So we need to log into the vNS devices that are connected onto that branch to run some commands. And after running those commands, we will be able to understand. We will be able to see what exactly, we will have to execute some commands basically. And then after we will be able to find out the issues and all. And then we will be able to resolve it. Basically, the issue resolution will take like some time as well. The issue resolution will also take like first when the issue was reported versus when the issue was resolved could take a significant amount of time. Basically, overall, then you will need to spend money on various troubleshooting tools, various management tools, so that you can manage your entire WAN network from, for example, one centralized point. Total cost of operating the network was higher. Total cost of operating the network was higher. The operations to manage the traditional network was complicated. We need to configure like configurations regarding the VPN, DMVPN, IPsec, get VPN, XYZ, do the configuration here, then here, then here, then here, so that the connectivity can be there. Manual configurations are complex to manage. There are always chances of some issues. If you add like a few more transport, then it will be hard. It will be difficult to manage those multiple transports. Define priority of one transport over another. Define that some traffic must go via this transport. However, some traffic must go via this transport. Configuring the policy on n number of devices, one by one, to prefer one transport over another to address the loss or address the latency issues on the transport will be difficult to manage as well. When we have to provide the internet connectivity, earlier in the traditional WAN environment, we are not going to deploy a security appliance on every branch. I am not going to deploy a security appliance on every branch. Instead, what I am going to do, instead of that, I am going to deploy my security appliances. Instead of that, I'm going to deploy the security appliances in the data center. Instead of that, I am going to deploy the security appliances on the data center. And then we are going to redirect all the traffic. We are going to redirect all the traffic from the branch to the data center. Even if the user wants to access the internet, user wants to access those applications delivered on the, deployed on the internet, infrastructure as a service, software as a service, the infra that is deployed on the cloud, the software that are deployed on the cloud. Even if the user wants to access these infrastructure as services or software as services, it has to send all the traffic to the data center, where the inspection will happen based on the security appliances that we have deployed. And then the traffic will go to the internet, then the traffic will go to the infra that is delivered on the cloud, then the traffic will go to the softwares that are deployed on the cloud. Basically, the user experience will be very poor because all the traffic is getting delivered via the data center. So some latency, even though the security is there, but since we are redirecting all the traffic to the data center, which was our priority, and there the inspection and everything will happen, and then the traffic will reach out to those cloud delivered infrastructure, cloud delivered applications, or even the internet. It will result in a poor user experience. Managing all these n number of devices that are deployed in n number of branches in n number of geographical locations, doing the SSH on all these branches over the internet, and then running the configuration commands and all, managing each and every device like one by one, it is also going to add it will also add an additional challenge in the management. If we have like way too many, like for example, branches, then it might not even be very scalable to manage all those devices one by one locally by doing the telnet SSH. So localized management we are going to have here in the traditional or legacy wide area. We will need to involve in the routing process with the service providers, like such as we are going to run BGP, we are going to run OSPF. In the LAN, we are running like OSPF. In the LAN, we are running like EIGRP. So we will need to redistribute EIGRP into OSPF, OSPF into EIGRP, XYZ. We will need to perform complex routing operations so that like our routes can be advertised from like the branch to the data center, from the data center to the branch, so that the reachability can be ensured. In protocols such as BGP, you might need to perform path manipulation, traffic engineering, which is going to add an additional layer of challenge. Traditional WAN is not application aware, or it has a limited application awareness. So for example, if I want to configure a policy in such a way that our business critical application traffic must go over the transport that has a low loss, latency, and jitter, we will need to either use some tools to observe out of these multiple transport, which of the transport has lowest packet loss, delay, latency, and jitter. And then based on that, we can configure this device to prefer one path over another. Traditional WAN is not that much application aware. Traditional WAN, legacy WAN, lacks the application visibility. It has limited app awareness. So it might not be possible that, or it might be complicated to manage the policies based on your certain applications, such as business critical applications, must follow like one path over another. That kind of policy, if you want to implement, it will be hard to implement that kind of policy in the traditional or legacy wide area network. Apart from that, other challenges are there also, which we will talk about, but connecting the users to the data center was the priority. So all the traffic used to go via the data center in order to access the internet, in order to access those cloud delivered application infrastructure and the application, which added additional like latency, delay, resulting in poor user experience. Traditional WAN was not aware of the application. So if you want to deploy a policy around your business critical application, it might not be possible to deploy because your traditional WAN is not even aware about that, aware of that application. We might need to advertise our routes using some routing protocols over the WAN, so that like everyone learns those routes and then we'll be able to send and receive the data. So routing might get a little bit complicated. Performing the routing between the branches, data center, headquarter, and all might get a little bit complicated. Each and every device needs to be managed locally, which is not a very scalable solution. In a large WAN environment, in a big WAN environment, it might not even be possible to deploy, or manage all these vManage devices one by one. If you have multiple transports, preferring one transport over another based on various characteristics is also going to be difficult. How to like prefer one transport over another, that is also going to be a challenging part. Basically, overall WAN operation is complicated, complex, and total cost to operate the overall legacy WAN is going to be very high. Apart from these general challenges, we also have a few more challenges that we will talk about. We'll talk about a few more challenges, and then we will see what has changed. So we were talking about different challenges that we had in the traditional network, such as in the traditional network, our priority was to connect the users to the data center, because typically we used to place our security appliances at the data center. All the traffic will be redirected towards the data center, where it will be inspected via those security appliances, and then based on the policies, either they will be allowed to reach to the internet, they will not be allowed to reach to the internet. Then they will be allowed or not allowed to access those cloud delivered applications, cloud delivered infrastructure. Every device, peer-to-peer, forget about it. Lack of application visibility. The traditional WAN, the legacy WAN that we have, it is not application aware. So not application aware basically means that, or limited application visibility basically means that the modern day applications that we deploy on the clouds or the applications that we are running in the data center, the legacy WAN, the traditional WAN is not aware of those application services, meaning to say that if I want to prioritize like one transport over another transport for certain application traffic, that might not be possible when it comes to the legacy WAN until we run some dedicated additional commands to match the traffic based on the port numbers and all. So the traditional WAN or the legacy WAN is not like application aware. It lacks application visibility. We need to involve ourselves in the routing process with the service provider or with the other branches, with the data center. We might choose to use routing protocols such as OSPF, GRP, or maybe border gateway protocol. Based on that, based on that, we are going to form the EIGRP, OSPF, BGP neighborship. Then we are going to exchange the routes, and then the traffic will start flowing. All the device needs to be managed one by one, which might not be a very scalable solution. If you have multiple transport, supporting the multiple transport, giving some sort of preference to one transport over another is going to be a challenging task. Overall, basically the legacy WAN operation was complex, and total cost to operate the network was actually very. Traditionally, basically, when we talk about these traditional devices, the functionality of a device can be broken down into three parts. One is like the control plane functions, one is the data plane function, and one is the management plane. From the architectural point of view, I can divide the functionality of the device into three major architectural planes. Three major architectural components are there. One is the control plane, one is the data plane, one is the management plane. Control plane, data plane, and the management plane. Control plane functions, data plane functions, and the management plane functions are performed by the device. Whatever operations device perform, whether it's forming the EIGRP OSPF neighborship, exchanging the routes, performing encapsulation, decapsulation, allowing the user to access the device via telnet, SSH, all these functions that the device performs, they can be categorized as the control plane functions, data plane functions, or the management plane function. Management plane functions or management plane of the device. Management plane of the device is responsible to provide the management level of access, how the device is being managed. How are we managing the device? Are we using telnet, SSH, console, auxiliary? Are we using like SNMP? What kind of, what approach we are using to actually manage that particular device? That is handled by the management plane of the device. The part of the device that handles management function is referred to as the management plane of the device. Essentially, when we set up the console password, when we set up the VTY password, when we set up the auxiliary password, when we set up the credentials for the SNMP and all, eventually like what we are doing, we are securing our management plane. We are securing that not everyone can get the access of the device. Only the authorized, authenticated users are allowed to get the access of the things such as encapsulation, decapsulation. When the data arrives, the data will be decapsulated. Then the routing table lookup will happen. Based on that, the router will determine what is the exit interface, and it will place the data onto that interface. Then while placing the data, encapsulation will perform. So things such as encapsulation, decapsulation, routing table lookup, MAC table lookup, ARP cache table lookup, all these kind of functions, all these functions that are involved in order to perform the data forwarding. All these functions are called data plane functions. All of these functions are referred to as the data plane functions. Data plane functions are those functions. Data plane is the part of the device which is responsible to perform things such as encapsulation, decapsulation, and various table lookups, so that it can decide like where to forward the data. So when the packet arrives on the interface and the packet is decapsulated, typically it is the data plane functionality to decapsulate the packet. Then when the routing table lookup happens, it is the data plane functionality to perform the routing table lookup. And when the packet is placed onto a certain exit interface, while the packet is getting placed, encapsulation needs to happen again. So that functionality is all of these functions are the data plane functions. And who is responsible to maintain these tables? Who is going to create these tables, such as routing table, ARP cache, such as, for example, your STP, spanning tree database, and all those different types of tables that the device can maintain in order to perform the data forwarding. It is the responsibility of the control plane. It is the responsibility of the control plane to create various tables, such as routing tables, such as ARP cache, such as the MAC address table, for example. All these kind of tables that are used by the data plane to perform the packet forwarding. Control plane controls the data plane. Control plane is the one that is responsible to instruct the data plane about like how to forward the data. Control plane creates the tables. Those are referred. Those are checked by the data plane. So eventually, like if there is an entry in the routing table, the packet will be forwarded. If there is no entry in the routing table, then the packet will not be forwarded. So control plane controls what packet can be forwarded out of what interface and all, by creating, by populating, by making various entries in some sort of tables. When we say that two routers are going to form the OSPF EIGRP adjacencies, they are going to exchange the routes and all, topology database, BGP update, STP messages, OSPF messages, all these messages are created and sent by the control plane of the device. Control plane basically means, eventually the control plane basically means the CPU, the brain of the device responsible to perform maintain, create like all these different types of table. So every device has the control plane functions, which is responsible to create various tables that will be referred by the data plane in order to perform the actual data forwarding. And then the management functions can be performed by the management. Control plane, data plane, and management plane. These are three functions that we have here. These are three functions that we have here. And these three functions are in fact performed. These three functions are in fact performed by the legacy devices. Now in the traditional architecture, whether we are talking about LAN or WAN, in the traditional architecture, we have distributed control plane, data plane, and management plane architecture. Every device has its own set of control plane, data plane, and management. So if two devices are supposed to perform the data forwarding, these two devices first must, for example, run some sort of routing protocol. Then they will exchange the routes. Then they will update their routing table with those new routes, and then the forwarding basically will happen. So routing process and then the forwarding process. Routing process is basically responsible to create those various tables that can be referred to by the data plane in order to forward the data. And forwarding plane is actually responsible to forward that. So this device has its own set of management plane. This device has its own set of management planes. So if you want to access this device, you can use telnet, SSH, console, auxiliary, and you can then access this device either like locally or via remote. Once you are done doing the configuration on this device, then you will disconnect your console, terminate your SSH session, and then you are going to connect yourself to the second device. Basically, if you want to configure all these devices, since every device has its own set of management plane, we will need to take the access of each and every device individually, and we are going to configure those devices one by one, box by box basis. Since every device has distributed management plane, which means basically every device has its own management plane, means that if we want to configure the device, then you will have to take the access of the device like one by one and do the configuration on each and every configuration, such as we are going to configure OSPF here, we are going to configure OSPF here. So we will take the access of the device first, configure OSPF, then we will take the access of the device, and then we will do the OSPF configuration. And then OSPF messages will pass between the devices. OSPF messages will pass between the devices. Those control plane messages, OSPF control plane is going to generate some OSPF messages. Those messages will pass between the devices. They will form the OSPF neighborship. They will exchange the database, and then they will calculate the routing table. They will basically update their routing table, and then the data forwarding between the two devices will happen. Every device has its own set of control plane, management plane, and the data plane. That is why each and every device must be configured manually, one by one, box by box basis. On each and every device, we will have to configure a protocol, control plane protocol, such as OSPF. Each and every device must maintain their own set of tables that can be looked up by the data plane when the forwarding needs to take place. Yes, let me know.
Yeah, as a quick question. So when we are talking about the control plane, data plane, and management plane, in which part of the routing and switching this happen? I mean, it's RAM, disk, where it's happen?
No, it's basically like, for example, the control plane operations are CPU-centric operations. So when we talk about the control plane, eventually we are talking about the CPU of the device. When we are talking about the data plane, a data plane basically refers to the process of performing things such as decapsulation, encapsulation, routing table lookup. Now, routing table, ARP cache, all these tables are populated in the RAM of the device. So management plane functions are basically the functions that are performed by the device to provide the management level of access. So, both like RAM and CPUs will be involved of the device to perform these control plane, data plane, and the management plane functions.
So when we set up the switch or router, so do we need to specify the amount of space they have to use?
No.
Particular? No. Okay, is a random.
You will just set up the telnet SSH. You will just set up the routing protocol such as EIGRP, OSPF. The devices will form the EIGRP, OSPF neighborship adjacencies, and then they will use whatever amount of bandwidth CPU resources are available. We can limit in some protocols. We can limit the amount of resources they can consume, but other than that, we do not define these kind of things. We let the device choose automatically how much resources they can consume in order to make things work.
Okay. So it's a combination of RAM and CPU.
Correct. RAM, CPU, the mostly like the information is maintained in the whatever things are running on the device is maintained in the RAM. The instructions are given by the CPU. So yeah, things are performed by the RAM and CPU of the device.
So once we have some performance issue on the switches, routers, do we need to check these three components, or how we are going to troubleshoot? I just need to correlate with the with the utilizations of these
those things are more like from the monitoring point of view. So if you are experiencing like high CPU utilization or high memory utilization on the device, you can execute the commands to find out like which process of the device is consuming like more CPU, more RAM, and then you can either terminate that process or maybe optimize that process accordingly. You can do it with the help of the commands, or you can do it with the help of some monitoring tools that your company might be using.
Okay, thanks.
Show processes CPU, for example, is one of the commands. Show processes CPU history, for example, show processes CPU utilization. A few commands are there that you can use to check these utilization. But these things are more like from the routing point of view, or maybe the switching point of view. These are more like the hardware specific.
I got it. Thanks.
So basically, in the traditional network architecture, every device has its own set of like control plane, data plane, and the management. Since every device has its own set of management plane, if we want to perform the management of the device, you will need to take the access of this device, do the configuration, then you will need to take the access of this device, then do the configuration. Those things you will need to do one by. So management plane functions are the functions performed by the device to provide the access of the device to the user, so that the user can perform the configuration of, for example, protocol OSPF, so that OSPF can form the neighbor table, database table, routing table, updates the information in the forwarding table so that the data plane can decide how to forward the data. Key point here, we are not going to talk about the routing. The key point here is that every device has its own set of management plane, control plane, and the data plane. So each and every device needs to be configured, accessed, managed one by one, box by box basis. On every device, we have to configure a protocol so that the information about the subnets can be exchanged, and every device will take a look at their own table to decide how to forward the packet respectively. So if you have like a lot of devices, if you have, let's say, for example, a lot of devices, accessing and managing all those devices, one by one is going to be a complicated task. So overall, like if you have many branches, in many branches, you have many branches in many networks, many geographical locations. And, in every branch, you have at least like, for example, 1 or 2 vManage devices, accessing all those vManage devices one by one, managing all those devices one by one. It is going to be complex to operate. It is going to be difficult to secure, and overall user experience is going to be poor because every traffic needs to be forwarded. Every traffic needs to be forwarded to the data center. So security related challenges are there, limited app awareness, no cloud ready WAN, high cost, complex operation. The modern day applications are consuming the modern day applications that we have. Let's take a very basic example, like for example, Chrome, or any other your business critical application or any kind of application which can consume a lot of bandwidth. So the bandwidth might not be sufficient for all. The bandwidth might not be sufficient for all the applications. They decided to use some sort of approach to manage all these things in more like an automated fashion. In the data center network, however, this concept, called software-defined networking, where the administrator, instead of accessing all the devices one by one, administrator will interact with the application with the help of a software. Where a piece of software actually, in case of software-defined networking, what happens? A piece of software will configure the network in an automated fashion. So if we have n number of devices in n number of geographical location, and you want to manage all those devices, instead of managing all those devices one by one, we can use some software that will configure, and we'll interact with that software. We will define our intent, what exactly we want to achieve from the network, rather than configuring the network on per device basis. There was a concept called intent-based networking, where the administrator, intent-based networking basically means where the administrator will define its intent, what exactly they want to do, what exactly they want to achieve with the help of some software. And the software is going to configure, software is going to take that intent, software is going to convert that intent into some configuration, and the software is going to push all the necessary configurations on those devices. And this thing was not new actually. In the data center environment, in the DC environment, in the data center environment, this thing was very popular in earlier days as well. The concept of WAN will be there in the data center, in the service provider, in the like, enterprise. So the concept of WAN, wide area network, will remain like common in all the locations. So what has changed actually, the enterprise network has now a greater demand for mobile, Internet of Things, IoT traffic, SaaS application, infra as a service, cloud adoption, security requirements. Application requires priority optimization. The problem is that as compared to the traditional wide area network, current WAN is evolving to manage these challenging application landscape. There are more user requirements nowadays in modern day WAN as compared to the older or legacy WAN. Not only more user, but more types of user. Earlier, humans were the only users of the network, but nowadays we have like IoT devices such as CCTV camera, we have smart home devices, appliances, and all that thing. So not only humans, but we nowadays have the devices communicating with the devices. Devices also have become the user of the network. Earlier, humans were the only users of the network, but nowadays devices also have become the users of the network. An application might want to communicate with another application. An IoT device which is supposed to export the traffic, or which is supposed to generate some sort of like alerts when certain thing happens. So the device needs to be connected to the network as well. And if the device connects to the network, it will get an IP address, subnet mask, default gateway. If it is part of the network, then we will also have to manage the traffic sent by that particular device. So not only more users, but more types of users. Different types of users also have come in the network. Not only the users, but different types of users also are there in the network. And we should do some configurations in order to separate our, for example, corporate user traffic with the guest user traffic, and with these like IoT or different types of devices. We will need to do something to achieve clear separation, so that the corporate users cannot communicate with the guest users cannot communicate with the IoT users. So we will need to enforce some sort of security in order to provide proper communication between the different types of devices, different types of users. Applications that we used to deploy on the premises, on the laptop, desktop, they are moving to the cloud. For example, like Office, Microsoft Office. Earlier, we used to purchase and install the Microsoft Office on our local machine, but nowadays we do have the concept called Office 365, where we can take all the benefits of the Office from the cloud. We don't need to install this on our premises. We can just use the Office services. We can use this Office software as a service from the cloud. Of course, we need to subscribe. We need to pay a certain amount of money, but we can do it. Google Drive, for example, Dropbox, for example, CRM application, for example, that your company might be using. Applications that we used to install on our devices, or maybe our like data center headquarters, the applications are moving into the cloud. More and more applications are moving into the cloud. In fact, there is a concept called born in cloud. There is a concept called, someday when you study like cloud networking, you will see there is a concept called born in cloud. Basically, an application is completely like developed, completely like created in the cloud infrastructure itself. It is supposed to be deployed only on the cloud, not on the premises, for example. SaaS, software as a service, basically. Softwares that we used to run on our machines, they are running as a service on the cloud. Companies are moving their infrastructure to the cloud instead of having like a big infrastructure on their premises, like having to purchase like different routers, switches, like servers and all. They can just get the subscription from the from these providers that can run all these things on the cloud. So infra as a service. Infra as a service basically means companies are running their infrastructure on the cloud nowadays. Cloud delivered firewalls are there. Cloud delivered security appliances are there. Cloud delivered routers are there. Cloud delivered security, cloud delivered firewall. These are very common concepts that we see. Cloud delivered data center, where we can store things, store or provide the services to the users from the cloud. So applications are moving to the cloud, and also not only one cloud, multiple clouds. Some applications companies deploy on the AWS, some applications they deploy on Azure, some applications they deploy on GCP. Not only one cloud. If it was one cloud, candidate can learn one cloud and get to know about it. But companies are deploying their services, infrastructure, and all that thing on multiple clouds, whatever fits their business needs. They are deploying the services, applications on multiple clouds, not one, multi-cloud. Companies have their own data center also. So in that data center, they might be running some business critical applications. But for other general applications, they might use the public cloud services provided by AWS, Azure, GCP, or any other cloud service provider. SaaS, software as a service, infra as a service, these are very popular trends nowadays that we have. Softwares are moving to the cloud, infra is moving to the cloud. Branches no longer needs to send all the traffic to the data center and from there access the internet. The concept of regional or central breakout, regional internet access or central breakout. Central breakout basically means from a centralized location, we are providing the internet reachability. That concept is going away as well. Branches are getting nowadays called DIA. DIA stands for direct internet access. Why? So that when the branch user sends some traffic for those cloud delivered application or cloud delivered infrastructure, the traffic exits the branch locally instead of going all the way to the data center and getting the access. The branches can now access those cloud delivered, for example, applications and infrastructure locally as well. Reducing the latency loss, improving the user experience. Actually, improving the user experience was the objective. So in some branches, you might have this concept called DIA. However, in the other branches, you will still have that central breakout or regional internet access. Applications are moving to not one but many cloud. Earlier, we used to go to the office and access our office infrastructure, or we used to access the applications from the office itself. But nowadays, we have this concept, very popular concept called work from home, where candidates can access their resources from anywhere at any time, from anywhere or any time they can access the company resources. Users of the network are not supposed to go to the office always. They can do things such as work from home and all. Basically, now how your traditional wide area network is going to address all these challenges, how your traditional WAN is going to address the challenges of different types of user, how the traditional WAN is going to address the challenge of applications moving to the cloud, how the traditional WAN is going to improve the user experience for those applications that are getting deployed in the cloud, how the traditional WAN can be connected to those SaaS applications or infra as a service, infrastructure as a service, how the traditional WAN is going to enforce the security when we provide the direct internet access, how it is possible that we can access the network anywhere, anytime we want, and still be able to have proper security, have the access of the network, how the traditional WAN is going to, connect to those different cloud service providers, AWS, Azure, and all, and how can it improve the user experience for the infra or software deployed on those clouds. There were a lot of challenges. Earlier, when the objective was WAN was just to connect multiple branches at quarter all together, it was easy, but things have changed rapidly. Different types of user came in the market. The concept of the smart city, smart home, CCTV cameras, and all these smart appliances and all these things came in the market. Cloud came in the market. So different technology, since the network is ever evolving, because of these different types of challenges, the traditional WAN also needs to evolve, or traditional WAN needs to address at least all these challenges that we are facing. Our traditional WAN must be ready to face all these challenges. Our traditional WAN must be configured in such a way that it can address all these challenges at minimum. Same challenge that we were facing from the WAN point of view, same challenge we were also facing from the LAN point of view. In the company, in the enterprise local area network, we have a lot of devices, and managing all these devices one by one is also going to be a time-consuming task. Configuring all these devices one by one, enforcing the policy, security, and everything one by one, it is also going to add additional challenges. In the data center environment, that is the data center, which is centric to certain applications that are running in that data center. Data centers are those facilities that provide different types of services to the user. Service such as storage, or maybe some business critical applications might be running in that data center. Data centers are built around certain applications that they serve, hence the name application-centric infrastructure. How are we going to manage the data center infrastructure? How are we going to manage the WAN infrastructure? How are we going to manage the LAN infrastructure? If we have to do all these things one by one, if my company has all these three things, LAN, WAN, and the data center, my company has like 10, 20 branches. In every branch, we have 2 WAN devices. Then like we have some LAN devices. Then we have 2 data centers, 1 main data center, 1 recovery data center. So managing all the devices one by one is going to consume a lot of time. Configurations might be prone to error. Even if you just copy and paste, the configurations from one device to the other device, the configurations still will be prone to errors. You might unknowingly copy and paste incorrect configuration from one device to the other device. So in the data center network, everyone then came up with the idea, why don't we introduce, we are already using different types of software in our organization to manage our network. We might also be using the softwares to configure the network. So they thought like, why don't we create some software? Why don't we create some softwares that will be responsible to manage the campus local area network? Why don't we create some software that will be responsible to manage the wide area network? And why don't we create some software that will be responsible to manage the data center infrastructure? So the engineer, they don't need to interact with all these LAN, WAN, or data center devices one by one. The engineer will need to interact with the software. The engineer need to define their intent on the software, and the software is going to program. The software is going to do whatever configurations that are needed to be pushed onto the devices to make your intent work. And then we will deploy this software on some sort of hardware. Of course, like in order to run this software, we will require some hardware. So we will deploy this software on some sort of hardware. This hardware will run that software, which is responsible to manage, configure our campus LAN, WAN, and the data center network. And this hardware is what we are going to refer to as the network controller, or simply controller. Network controller. Network controller is basically a device that is responsible to manage the network infrastructure, manage the campus LAN, campus WAN, and campus maybe the data center network as well. So a hardware that is running some sort of software responsible to manage the campus LAN, WAN, and data center network is what they refer to as the control. How much control? What things can be controlled? How much control is our data plane, control plane, management plane? What degree of control? What degree of control we will get? That depends. What degree of control that we get? Will we be able to do like everything from the controller? Or we will be able to just do the management and rest of the things we will need to do like manually on the devices? What degree of control we will get? That is completely dependent on what controller we are talking about. In the data center network, they created, to overcome these challenges, they decided to use software-defined approach to manage the network, where the engineer will not interact with the devices. The engineer will configure its intent, and the software will automatically configure the devices based on what intent the engineer has configured. Basically, network-wide configuration rather than per device basis configuration. Configure the network rather than configuring all the devices. Different vendors they used to offer different solution. Nowadays, also different vendors are there, and they offer different software-defined networking solution, SDN. Different SDN solutions are offered by by other vendors. When it comes to Cisco offers three main like SDN solution to manage the campus network, data center infrastructure, and all. So they offer like three automation. They offer three software-defined networking solution. Open Daylight Controller based on Open Daylight Controller based on Cisco Open SDN model. So Open SDN controller or Open Daylight controller, they used to sell this controller earlier. Nowadays, it has gone obsolete. So you will not see the use of this controller, Open Daylight controller, or it was based on the Open Network Foundation. So, Cisco added some specific commands or specific things to this solution, and then they started selling it. But sooner, like they removed this, they no longer sell this Open Daylight controller based on like OpenSDN solution. So it has gone obsolete completely. So you will not see the use of this. In the data center infrastructure, ACIE, application centric infrastructure for DC, ACIE for data center. Application centric infrastructure, ACIE data center. Build the data center around the application that they serve. Configure the data center around the application that they serve. Application centric infrastructure for the data center network. And the controller that is responsible to manage the ACIE data center was named as APIC. APIC stands for Application Policy Infrastructure Controller. Application Policy Infrastructure Controller, APIC. APIC, ACIE, APIC. ACIE is the data center solution, and APIC is the name of the controller, Application Policy Infrastructure Controller. It is still used in the Cisco data. It is still used in the Cisco data center environment. You will still see the use of ACIE and APIC in the data center network in order to manage the data center network in a software-defined approach, rather than configuring all these things one by one. Maybe someday when you go for the data center track, you will learn about the ACIE APIC concept. Not here, of course, but the ACIE data center, the data center can be managed in a software-defined way, in a software-defined approach with the help of this APIC, Application Policy Infrastructure Controller. This APIC became very popular. This APIC controller actually became very popular. More and more like companies started adopting this APIC, Application Policy Infrastructure Controller, for their data center infrastructure, for their data center environment, and it became like very, very popular. It's still in a modern day network. Still, if you are building the Cisco data center, you will see the use of ACIE data center, ACIE and APIC. In modern day network also, this solution still remains well. In fact, it became so popular that they decided to create an enterprise version of the same controller. They decided to create the enterprise version of the same controller, and they called it like APIC EM, Application Policy Infrastructure Controller Enterprise Module. EM stands for Enterprise Module. So for the enterprise network, they did create this APIC EM. Just give me a second, guys. Just give me a second. Application policy, the APIC EM, Application Policy Infrastructure Controller, based, inspired from the APIC, inspired from Application Policy Infrastructure Controller. They created an enterprise version. They created an enterprise module. This was a different controller. APIC was a different controller, and APIC EM was a different controller. Unfortunately, this APIC EM could not gain that much popularity, and they no longer sell this controller as well. So the only controller that you see for the data center infrastructure is the ACIE APIC. APIC EM, the enterprise module of the same controller, is no longer present in the network. They redesigned it, or they repurposed it, and they launched it with the name of like later on when the software-defined networking became popular around in like 17, 18, 19, then they rebranded it, they repurposed it, and they added a few features in this APIC EM, and they created a new controller called DNA Center, Digital Network Architecture DNA Center, also known as nowadays Catalyst Center, which is used in Cisco SD-LAN or SD Access, whatever you call SD software-defined local area network. Cisco calls it as the access. Other vendors call it as the LAN. So when we want to manage our LAN devices or local area network devices such as switches with the help of the software-defined approach, we are going to purchase and install this controller known as the DNS Center or the Catalyst Center. Again, it is gaining a little bit popularity nowadays. A lot of companies are using this controller in their production environment. They are adding new features in this DNS Center or Catalyst Center controller. The base of this controller still remains APIC, and they added a few more functionalities in this APIC when they rebranded, repurposed this APIC with the name of like DNS Center or Catalyst Center, which is a very popular solution for the SD access or campus local area network. For a CAN, for the campus area network, it is very. So for the data center, we have APIC, Application Policy Infrastructure Controller, which works based on ACI, Application Centric Infrastructure. Then we have DNS Center, the controller that is designed for as the LAN solution or as the access solution for our campus area network. And then in both LAN and data center, both in the LAN and the data center, we are going to have some devices at the edge of our network responsible to connect our data center, responsible to connect our branches with the rest of the network, with the wide area network. So in both data center and the branches, we will have these devices called WAN edge devices. The devices that sit at the edge of the edge of your network, responsible to connect your network to the wide area network. So if you want to manage these devices from a centralized point, Cisco offers a product called SD-WAN, software-defined wide area network for next generation. So there are 3 products now: SD-WAN for the WAN network for both data center and the enterprise. For the campus LAN, we have the SDA solution, and for the data center, the internals of the data center from the LAN side of the data center, we do have this concept of ACIE. You want to have full-fledged SDN solution, you need to purchase these 3 things. If you want to have complete SDN solution in your infrastructure, then considering the point that your company has branches, your company has the data center, and they are all connected with the help of various transport. If you want to achieve full SDN capabilities, if you want to take the benefits of the complete SDN capabilities, then you will need to go for SDA, you will need to go for the ACI data center, and you are going to connect the WAN devices with the help of the SD-WAN solution. Software-defined approach to manage the campus LAN is called SD access or SD-LAN. Software-defined approach to manage the data center is called ACI APIC. The software-defined approach to manage the WAN is called software-defined wide area network. Software-defined data center, software-defined WAN, software-defined LAN. At the moment, unfortunately, we have 3 different controllers for these 3 tasks. DNS Center, also known as Catalyst Center nowadays. For the ACI, we have APIC, Application Policy Infrastructure Controller, and for the SD-WAN, we have a dedicated controller referred to as vManage. We have multiple controllers, but we have a controller called vManage. vManage, we have a different name for it now, but vManage. We have a different name for this now, but we have a controller called vManage. There are multiple controllers, by the way. vManage, vSmart, vBond, multiple controllers are there. They also have now been renamed. So manager, controller, orchestrator, or validator, we have different names for them. But eventually in the SD-WAN, we are going to have 3 controllers. This is the overall picture of the software-defined networking SDN solution offered by Cisco. Other vendors might also provide same type of services, but since our content is Cisco specific, these are the services provided by Cisco.
Surendra, I have a quick question. I'm sorry.
Yeah.
So if you see that diagram, so ACI data center and those 2 routers are connected with the ACI data center, ACI,
Yes.
right? So those router are managed by the ACI, or the same router are connected to the SD-WAN? So
SD-WAN. So
which
ACI
one
is
is
for the LAN. ACI is for the LAN environment, and these routers are, since the WAN routers, these are managed by the SD-WAN. These are managed by the SD-WAN.
So those router which are connected with the ACI are managed by the SD-WAN, right?
Yes, correct.
Okay,
Correct.
and those
Routers that sit at the boundary that are responsible to connect your network to the WAN are managed by the SD.
So how these router are connected with the ACI? I'm a little confused because from
No,
the
no,
SD-WAN.
we will not be discussing that. That is part of the data center certification. Just to give you the idea, just like in our traditional environment, we have like some switches. For example, these are the access layer switches. Then we have the distribution layer switches. Then they are all connected like that. And then we have connected a few routers so that we can connect our network with the rest of the network. So this is what we refer to as like LAN. This is what we call WAN. Similar to that, the ACI data center follows a different type of topology. In that topology, we are going to have some devices connected. In that topology, the routers that we will connect will be responsible to connect that data center with the rest of the network. But for that, you will have to understand the topology that is there in the data center environment, how it is built, how the connections are there. So that is specific to the data center. All we need to know at this point, all we need to know that there are a few routers in the data center environment which are responsible to connect our data center with the WAN. And these routers are managed by the SD-WAN solution provided by, offered by like Cisco. What exactly is the LAN side, how the connect is in the LAN side, we don't care. That is all in the data center. It is going to be very much similar. It is going to be very much similar as our campus local area network, but that completely depends like how the company has created their data center topology and how they have or where they have placed the routers responsible to connect the data center with the rest of the. So for that, you will have to have the understanding of the data center technology. Same goes for LAN. We are not going to talk about the campus local area network. No matter how the connectivity is there in the LAN side, we really do not care about it. All we care is that we have two, for example, or one maybe device sitting at the edge of our enterprise network, connecting our enterprise network with the wide area network with the service providers, ISPs, and all. And these routers are managed by the SD-WAN solution offered by it. Internal connectivity can be in whatever way they choose to connect. We really do not care about the internal connectivity. It is part of the campus area network. It is part of the data center network. When you study in the switching section, if you want to know about the software-defined access, you will study that in the SDA curriculum. And if you want to know about the data center infrastructure, how the topology is built and how the connectivity and everything is there is a dedicated content for the same. Our LAN is connected with the WAN edge router. WAN edge routers are responsible to provide the connectivity of our campus LAN with the rest of the network. That is all we need to focus on. And these routers will be managed by the SD-WAN. Basically, these routers might learn the routes from the LAN, advertise it to the other sites and all. So we don't need to focus on the LAN part. We just need to focus on the WAN. We don't need to worry about the LAN side of the network. We just need to worry about the WAN side of the network. LAN side of discussion is done dedicatedly in the other. Right. So this is like the overall picture of the SDN solution offered by Cisco. Other vendors also provide these kind of solutions, but this is the solution offered by Cisco when it comes to software-defined network. And we were already using like technologies such as DMVPN and all. We were already using these kind of technologies such as DMVPN, where like the devices will form some sort of like VPN tunnel. Devices will form some sort of like VPN tunnel, like from here to here. From for example here to here, from here for example to here, some here to here, some here to here, here to here. So over a public network such as internet, we were already using this technology called a DMVPN, where the devices are supposed to form various VPN tunnels, and using those VPN tunnels, they are supposed to send and receive the data from one network to the other. Before this SD-WAN came in the market, Cisco also had one more technology. Like before this SD-WAN came in the market, before Cisco acquired this viptela, and all, Cisco also had this thing called I-WAN. If you ever came across this term, I-WAN stands for Intelligent WAN. Cisco Intelligent WAN technology. It was initial SD-WAN offering from Cisco. Initially, Cisco used to offer the SD-WAN functionalities based on this thing called I-WAN, Intelligent WAN. It works around the principles of the DMVPN. So one of the key things that this I-WAN uses is this concept called DMVPN. It works on DMVPN. It will use your existing DMVPN infrastructure, and it will use this protocol referred to as the performance routing. PFR version 3 is the latest version of the performance routing protocol. So using the performance routing over the DMVPN in the I-WAN technology will allow to have a little bit features of the software-defined wide area network that we have nowadays, such as transport independent, application optimization. We can optimize our certain application traffic to go from one path over another path, secure communication. It will reduce the overall operational cost in doing the troubleshooting, managing the network. So I-WAN was also a technology which was initially offered by Cisco when it comes to software-defined network. And in some places, we still see this I-WAN technology. In some companies, in some organizations, you might still see this I-WAN technology in use. It is a very old technology, by the way, works on the DMVPN and the concept of performance routing. But nowadays, like most of the companies have gone to the software-defined networking based on viptela or Meraki. But this is like this I-WAN technology they can also go for, which is based on this thing called DMVPN and PFR. PFR stands for performance routing. There are official documentations from Cisco that you can refer to find out like how to deploy this I-WAN network, how to operate on this I-WAN network, how to deploy this PFR and all those things. There are plenty of documentation, and you might still see companies using these I-WAN devices. The companies still using these like I-WAN technology. Companies might still be using this I-WAN technology actually for say. It is not needed for you to know, but just in case if you want to know, you can refer to this blog. I am sending you a link just in case if you want to read about it. What was this initial offering from the Intel? What is this I-WAN and all? This is one blog from Cisco. I am sending the link in the chat. You can just click on it, and here you can just read about the I-WAN technology, read about the official documentation from the Cisco, regarding how does I-WAN works, what are the advantages we get in the I-WAN. There's no need of it, but just in case if you want to get an understanding, you can refer to these documentation, Cisco validated design. So Cisco validated design deployment guide. So you will at least, if you are aware with the DMVPN, you will be very easily able to understand how this I-WAN technology actually works. Again, not part of our content. It was just for your knowledge that you can learn about this I-WAN technology as well. Intelligent WAN or I-WAN was the initial offering by Cisco when it comes to SD-WAN solution. Then they purchased, then they acquired viptela. Viptela was a company who was creating the software-defined WAN solution. So Cisco acquired viptela, and their SD-WAN offering became Cisco SD-WAN offering. So Cisco SD-WAN, viptela came in the market. So these are the solutions that we get. These are the things that we get when it comes to a full-fledged SDN solution. These are the three offerings from Cisco. In this also, Cisco offers two SD-WAN solutions. One SD-WAN solution that we have is like Meraki-based SD-WAN. One SD-WAN solution that we have is Meraki-based SD-WAN. Meraki. And one is like the viptela or Catalyst nowadays called Catalyst SD. We have Meraki-based SD-WAN, and one is like Catalyst SD-WAN. There are two SD-WAN offerings still, as Cisco offers like two SD-WAN offerings. One is like Meraki-based SD-WAN, and one is like the viptela-based SD-WAN. Targeted for small users, like where the number of users are not very much. They have specific devices. They have specific security appliances. They have a specific like switches. They have a specific like access points. They have cellular devices, for example, under the Meraki dashboard, under the Meraki portfolio, under the Meraki product line. If you go through the Meraki products, if you search like what products Cisco offers when it comes to like Meraki, so Meraki is the technology that Cisco basically offers, and in this technology they have like different devices. Like we have like wireless access point, we have security appliances, we have different. They have different types of devices. They have different types of devices. They have like wireless devices, switching devices, MDM devices, different types of say SD-WAN devices, gateways. They have different types of devices under the Meraki portfolio. You can just purchase these devices, install these devices in your infrastructure, install the access point, install the switches, install the routers, cellular gateways, install these devices in the infrastructure, and you can just manage all these devices directly from the Meraki cloud. So they give you a cloud-based dashboard. They give you like a cloud-based dashboard. From that dashboard, you will be able to manage the particular device from a centralized point. Just like if you are aware, just like the wireless LAN controller, just like the WLC is responsible to manage all the APs, similar to that, this Meraki dashboard will be responsible to manage all the Meraki devices from one centralized. They have different products for the same, different switching products, different access points. They have different products for the same. You can purchase these products, install it in your infrastructure, and you will be able to manage all these devices from directly cloud. Easy to deploy, easy to manage, maintain, but more targeted for the small users, where we do not need to enforce like very complex policies and all. We don't need to be involved in a very complex routing and all. So, we can manage our basic like medium to small infrastructure just based on these Meraki. It's completely cloud based. You will access all these devices from the cloud. You will have to purchase the Meraki compatible devices and manage all these devices from the cloud.
So that is the major difference between these two technologies, sir, because
yes, correct.
They
One is completely cloud-based, targeted for medium to small organizations. Different products are there. You can purchase those products, install it, and those products register themselves on the Meraki cloud. And then from the Meraki cloud, you will be able to manage the functionalities of them. So very simple setup, cloud-based, like, you get like different options. It's basically like completely like cloud-based solution. It's more like we are going to manage all the devices from a centralized point. So for that purpose, we are going to go for our Meraki-based solution. However, SD-WAN solution that we have in the market, SD-WAN solution is more targeted for those people. vManage, I'm talking about the Catalyst SD-WAN solution or vManage SD-WAN solution. It is targeted for that audience who have like many branches, headquarters, data center, connected all of them over some sort of WAN transport, who want to enforce proper routing policies, templates, all those kind of things, security, quality of service, for example, all those things they want to enforce from a centralized point. So for a medium to large or very large network, as the Catalyst SD-WAN solution is going to be much more beneficial. But for that, we will need to deploy the controllers. We will need to make things reachable. We will need to do some more like additional things, which we don't need to do in the Meraki-based SD-WAN solution. Meraki is completely cloud-based. In the vManage one, we will need to do certain deployments of the controllers and all, and we will then be able to manage everything from centralized. vManage SD-WAN or Catalyst SD-WAN is more robust. It gives you more control over the network as compared to Meraki, which just provides you a basic dashboard from where you can do various things. Basically, Meraki SD-WAN does not offer like a lot of functions as compared to the Catalyst SD-WAN. Catalyst SD-WAN offers like a lot of functions such as templates, policies, quality of service, security, routing, basic to advanced routing, multicast, and plenty of functions. vManage or Catalyst SD-WAN basically. Meraki, however, is more easy to deploy, more easy to maintain. We don't need to deploy any like controllers also. Just purchase the Meraki devices, install it in the network, and just manage those devices directly from the cloud. Basically, for the small network, simple networks, the Meraki-based SD-WAN might be much more beneficial. And for the large enterprises or the complex network, for example, where the requirement of policy, requirement of routing, requirement of security is there. For the large enterprises, typically the viptela SD-WAN solution or Catalyst SD-WAN solution is much more. Meraki SD-WAN solution is completely cloud managed. You don't need to deploy. You do not need to deploy like any controllers. You can just purchase the devices, register those devices on the Meraki cloud, and do various things from the cloud itself. Here, in case of viptela SD-WAN or Catalyst SD-WAN, we will need to deploy the controllers. We will need to make them reachable to the routers, and then we will be able to configure the routers from a centralized point. More complex, but gives you more control as well. So different requirements are there. A lot of companies still prefer using Meraki SD-WAN rather than viptela-based SD-WAN. Of course, costing is going to be different as well for the Meraki-based SD-WAN and the viptela-based SD-WAN. So the costing will be different as well. So some medium to small businesses, they still prefer to use like Meraki-based SD-WAN instead of using the viptela-based SD-WAN solution. But the large enterprises having different branches with different requirements of policy and segmentation, they still prefer to use viptela-based SD-WAN solution. If you search like Meraki dashboard, if you just search like Meraki dashboard, you will see that, let me show you. If you just search like Meraki dashboard, you can just log into this Meraki dashboard with the credentials that are provided to you. And from here, you can just manage everything from a centralized. It gives you, if I go to the images, it gives you like this kind of access. So this kind of access you will be, this kind of user interface you will be provided from where you can manage, like all the devices in a centralized way. You can also do the monitoring from a centralized way. So for small to medium businesses, Meraki is open. The large enterprises, viptela SD-WAN or the Catalyst SD-WAN is much better choice. I am giving you a link in the chat again. It is a YouTube video that you can watch to know more about like how the Meraki dashboard actually is there. Just a random YouTube video. You can take a look at that video and see how the Meraki basically dashboard works, how the registration and everything is being done and everything. So you can, for example, purchase these devices. You can purchase these Meraki-based devices. It is 100% centralized cloud management for security networking application. Purchase the devices, register them into the cloud, and then you can manage everything from the Meraki cloud. Everything, you can manage all these things from the cloud itself. See, this is like the dashboard. This is more like the Meraki dashboard, and from here you can manage the things like security, users, and all these things. So just watch a video and know what options of configurations and everything is provided by the Meraki dashboard. It will not give you like same level of access as the same level of control as the viptela SD-WAN, but still it is going to give you like plenty of like functionalities of the software defined wide area. Like I said, what degree of control we get is completely dependent on the solution. How much control we get on the control plane, how much control we get on the data plane, how much control we get on the management plane is completely dependent on the solution that we are. So in case of Meraki, it's more like we are doing the management from the centralized point, and we are pushing certain configurations from the centralized. All the devices still needs to do the data forwarding. All the devices still needs to perform the control plane functions by themselves. These are the overall offering from the Cisco so far. Any questions, any doubts? If you have whatever content we have covered so far, if you have like any doubts, any questions.
One quick question regarding suppose. Sorry. Yeah, so suppose I have an existing setup with a viptela, and tomorrow we acquire a company. They are on Meraki. Can it be integrated between the viptela and Meraki?
No. Either the device will be like managed by the viptela-based SD-WAN solution or by the this Meraki-based SD-WAN solution. So your audio is very low. Like, what exactly?
I mean, we cannot integrate, but we have to migrate them.
You can migrate from like one solution is possible. You might face the connectivity issue. You might face the loss of connectivity a little bit, but it is possible.
Okay, all right. Thank you. And what about the integration between like viptela and other third-party vendors SD-WAN solution?
That is also not there. The viptela SD-WAN solution will be responsible to manage the viptela SD-WAN devices only. So when it comes to integration, you will not have a direct way to integrate it with the other vendors. Somehow via the data center, you might need to redirect your traffic. So not direct integration is basically not applicable, not at least yet.
Okay.
What is then this software-defined networking? Software-defined networking is basically an approach of managing the network infrastructure with the help of some software. SDN or software-defined networking is an approach to physically abstract the control plane from the data plane and to be able to manage all the infrastructure from a centralized point. SDN is the approach to physically abstract the network control plane. SDN provides us the ability to abstract or separate the control plane from the data plane, and we will be able to manage the entire infrastructure from a centralized. So earlier, every device has their own set of control plane, data plane, control plane, data plane, also the management plane. That's why each and every device needs to be managed individually. Control plane functions, data plane functions needs to be managed individually. Distributed control plane, distributed data plane, distributed management plane is there. But when it comes to software defined, in case of SDN or software defined networking, completely depends. But the control plane functions and the management plane functions can be centralized, and the devices will be left only with the functionalities of the data plane. Things such as encapsulation, decapsulation will be performed. The data forwarding will be done by these devices, but their control plane and management plane functions are going to be centralized. But again, repeating the same exact thing, what level of centralized control we will get completely depends on the SDN solution that we are. So we have the now in the software defined networking, we have this infrastructure layer. In the infrastructure layer, we have infrastructure devices, routers, switches, different types of devices that we have placed, connected together and make them reachable. Then we are going to use some SDN control software. The software that is responsible to manage all these devices from a centralized point, configure all these devices from a centralized point. With the help of various protocols, this software is going to interact with these networking devices. And we are going to interact, we can interact with this, for example, software with the help of like applications. We can use various applications. We can navigate through the user interface, like graphical user interface or web user interface. We can also navigate through the user interface, or we can use certain application to interact with that SDN software. We will define our intent, and based on our intent, the SDN software is going to configure or control all these devices from a centralized point. What degree of control we get, what level of control we get, that completely depends on the SDN solution. The software-defined approach to abstract the control plane from the data plane and to be able to manage all the devices from a centralized point is what we refer to as the software-defined networking, or SDN. Multiple offerings are there: SD-WAN, SD-LAN, or SD-Access, and the CCIE data center. Focusing only on the SD-WAN solution, a software-defined wide area network SD-WAN solution provides all these functions. We are talking about, by the way, Cisco Catalyst SD-WAN. So Cisco Catalyst SD-WAN provides all these functions: transport independent WAN fabric, different routing, security, segmentation, quality of service, multicast, survivability, service insertion, and different like functions are provided. We can also enforce different types of policies, such as application visibility and SLA, per VPN segmentation, and whatever. So we have different applications policies that we can deploy in our SD-WAN. So we can operate, we can monitor, and we can analyze the entire WAN network from one centralized point. From one place, we can manage, we can operate the entire managed devices, we can monitor those managed devices, we can analyze, we can see the utilization of various things from a common dashboard. Following the concept of zero trust workspace. None of the devices in the workspace are trusted. Each and every device, zero trust, zero touch. There are possibilities. There is a possibility that the vanish device that we want to deploy, we do not even need to touch that device. The device can be deployed automatically with the help of this process called ZTP or PNP. And until the devices get authenticated, authorized, they will not be allowed to join. So zero touch, zero trust workspace we get in our Catalyst SD-WAN infrastructure. Everything that you see here, all these things that you see here, all these functions that you see here, these are provided by the Cisco Catalyst SD-WAN solution. One by one, we will discuss about it. But these are all the these are all the options. These are all the things provided by the Catalyst SD-WAN solution. The very first function that the Catalyst SD-WAN provides is transport independent WAN. The responsibility of WAN will now be just to connect two devices. You can use whatever WAN technology. You can use any WAN technology as per the amount of money your company allows. You can use any WAN technology, such as, for example, internet, maybe 4G LTE, maybe, for example, MPLS. You can use any WAN technology that you want to in order to provide the connectivity between the WAN edge devices. The WAN edge devices will be just responsible. The WAN edge devices will just be responsible to provide the connectivity between the two devices. The WAN technology that you will be using, the WAN technology will be responsible just to provide the connectivity between the two devices. You don't need to go for costly MPLS solution. In order to connect two WAN edge devices, you can utilize, for example, one service provider, and you can utilize the second service provider, ISP1 and ISP2. Instead of going for a costly MPLS solution, we can go for two service providers, or we can go for 4G LTE, or we can go for like cellular. We can use whatever type of technology we want to use to provide the connectivity between the WAN edge. Security is not going to be a challenge. Deployment is not going to be a challenge. You can use whatever WAN technology. No need to be dependent on MPLS as your primary transport, public internet as your secondary transport, DMVPN, IPsec, all those things you don't need to do. Just make sure that the devices are reachable. Just make sure that these two devices are reachable. Transport independent WAN. You can use whatever transport you want to use, as simple as a broadband connection, MPLS, cellular, internet, whatever kind of transport you want to use. You can use any kind of transport. You can use any kind of transport. Transport independent WAN fabric. And since now the customers have the choice not to use a costly MPLS transport, but utilize like multiple ISPs like ISP1 and ISP2, the customers can completely remove the MPLS transport from their network and just go for two ISP connections, maybe go for the broadband connection, maybe go for 4G LTE. That is why some people started saying that SD-WAN is going to replace the MPLS, which is completely like it's not going to happen, not at least anytime soon. So if you know about the service provider network, if you have ever worked on the service provider network, or you have completed the routing content that we talk about, then you will know the use case of the MPLS technology, and you will know that the MPLS technology cannot be replaced that sooner as they say that SD-WAN is going to replace the MPLS. It's not. From the customer point of view, they might be true, but that thing is completely subjective on the understanding. From the customer point of view, now earlier I used to connect my vanish devices with the MPLS and the internet. From the customer point of view, now what I can do instead of using a plus solution, I can go for like different internet connection or maybe 4G LTE, or I can use a less costly transport. So from the customer point of view, that might be true that the M+ technology we don't need anymore. We can use simple public internet, simple like 4G LTE or these kind of transports to provide the connectivity. But is it going to like eliminate the M+ from the world? It's not going to happen, because go ahead and learn about the service provider, go ahead and go through the concept of MPLS as a in our routing content, and you will know the use case of the MPLS within the service provider network. It's not going to be, it will not be gone until like every device in the service provider network decided to use some other technology, some other path to forward the traffic. So that's not going to happen anytime soon. From the customer point of view, customers now have a choice. Customers, they now have a choice to either go for a costly MPLS solution or maybe go for a less costly 4G LTE or these kind of. Second advantage that we get in our SD-WAN is that from a centralized point, I can do all the things. Everything that we want to do, we can do from a centralized point. We can use any WAN technology to connect multiple devices, and we get complete visibility from a single pane of glass, which basically means that we can manage, we can configure, we can monitor, we can troubleshoot, we can do all the things from a centralized point. We have a centralized management plane concept. From a centralized point, we can manage all the networking devices. Not only manage, we can also do the configuration on those devices. We can also do the troubleshooting on those devices. For that, they have a controller. Centralized management plane. Centralized management plane. For a centralized management plane, they created a software and they call that software vManage, also known as Catalyst SD-WAN Manager nowadays. This is the software you will download. You will install it in some virtualized environment such as ESXi. You will configure it. You will configure this with some IP address and all, and you can open that IP address in your web browser, and you will get the web user interface, just like you get the web user interface of your wireless LAN controller, just like identity services engine, such as, for example, your DNA center. Similar to that, you will get the web user interface of the particular controller. And from here, you can do all the monitoring, you can do all the troubleshooting, you can do all the configuration, you can do the software upgrades, you can do plenty of things from this centralized dashboard. If you want to explore it right now, if you want to explore it, what you can do, you can just log in. You can just search Cisco D-Cloud. You can just search Cisco D-Cloud here. You can just search Cisco D-Cloud here. And on the Cisco D-Cloud, you can look up, you can search for, on the D-Cloud, you can just search for, first of all, click on it. And here you will have to log in with your Cisco credentials. So I'm going to log in with my Cisco credentials. Let me log in with my Cisco credentials here. Once you have logged in with your Cisco credential in on the Cisco D-Cloud, from here, you can go to this option at the very top, referred to as catalog. Right here, at the very top, you will have this option called catalog. So under the catalog, you will click on this. This is how the D-Cloud page will open. So here you can go to the catalog right here. And here you are going to check D-Cloud and instant demo. Click on this instant demo button. And here, these are some instant demo available for different products offered by Cisco. What we are interested in is the SD-WAN. So either you can scroll down, and you can just search where is your SD-WAN. Scroll down, keep scrolling until you see the SD-WAN right here. For example, 20.10 instant demo right here. 20.10, for example, instant demo. You can check it, click on this view button. And then here we have the latest version as well, 20.11 we have. We have also 20.14 instant demo. So you can click on these buttons and you can see here. This is like completely on cloud based. Like you can just get the idea about like the user interface provided by the Cisco SD-WAN solutions. Either you can search it, otherwise at the very top you can just right here you can search the catalog. You can search this catalog right here, and you can search for like SD-WAN, for example. At the very top, for example, you can search like here at the very top here you can search like SD-WAN, and once you search the SD-WAN, it will show you all the SD-WAN 20.10, 20.11, 20.14. So intro to Cisco Meraki also, this is some sort of Meraki dashboard. So you get like a few demos here. Cisco Catalyst SD-WAN view, Cisco Catalyst SD-WAN 20.14 view. Click on this view button and you will be brought up to this page. You will be brought up to this page, and here you are going to see the user interface of your vManage. This is the user interface of vManage, Cisco SD. This is the user interface from where we are going to manage everything. Here we can do monitoring, configuration, maintenance, some tools like taking the SSH access and everything. We can analyze our network as well. Basically, we get our hands on every aspect. Like this is the monitor dashboard. This is monitor dashboard. From here, we can monitor our different sites, devices, tunnels. These are all the devices that we have in our SD-WAN network. In this demo, for example, I can click on any device. I can click on any device to get more information about that particular device. If I click on the device, it will open this kind of page. From here, we can observe things such as how many times the device got rebooted, crashed, any extra module that we have installed, the CPU utilization, the memory utilization, all the events like all the things that have happened in the background, the logs and everything. We get our monitoring level of things. Here is what version. What version is this? This is 20.11, by the way. This was 20.10. Username password is demo. If it asks you the username password is going to be demo, and the password is going to be demo 1234 exclamation mark. The username password, just in case if it asks, the username is going to be demo and the password is going to be demo 1234 exclamation mark. And just log in and you will be brought up to this home page, from where you can see you have the option of monitoring, you have the option of configuration, you have the option of the maintenance, such as software upgrades and all. You can do like plenty of things about the WAN right from here. Under the configuration, you have the cloud on ramp feature for SaaS application, infra as a service, multi-cloud, security, policies, templates. We have different options available here. This is the dashboard that you will be exploring throughout the content, and what things we can do from this dashboard. All those things we will explore throughout our content. This is the only dashboard you will get your hands on. This is the only dashboard that you will get your hands on. There are other controllers as well, but those other controllers, they do not provide any dashboard to you. They just sit there, perform basic functions. This is the vManage dashboard that you basically take a look at the difference between the version 20.11, 20.12, and the 20.14. Starting from the version 20.13, they started changing their dashboard. This is the look and feel of the up to 20.12. From 20.13, they have a different kind of dashboard here. With all the same options, by the way, but just the user interface is a little bit different. We call manager, controller, validator. Here we used to call them like vBond, vSmart, and vManage. Then the managed devices, licensing, certificate status, and all these things. So, the options are pretty much same, like overview devices, tunnel application, It's pretty much same, just the user interface a little bit they have. When it comes to configuration, more options are added, configuration groups, policy groups, all these things, more options are added here. But the other options such as cloud on ramp, all those things, policies, templates, everything remains the same. So SSH terminal, software repository. Basically, you might need to explore what option they have moved where, But overall, like this dashboard remains pretty much same as this dashboard. This is just the theme they have changed. I will say there's the theme they have changed, and they have moved option like in a few places. Apart from that, everything is exactly. Apart from that, like you will see exactly the same. So if you want to explore this dashboard before we begin with our content, you can just log into the dCloud and just take a look at this demo and explore various options that we have. This is read only. You will not have your hands on the configuration part. So you will not be able to configure anything, but still you will be able to explore various functions that are, at least to take a look at the user interface, at least to take a look at the options available in this Cisco SD-WAN solution, so that you know what options, what things we can do from here, what things we cannot. So, we can just explore a few options later on, like in our content. We will go through like most of these options anyway. So if you don't want to do it right now, you will do it later on anyway. So just explore this option, by the way. Right. So dCloud provides you various demos from where you can take a look at what things we can do, what things we cannot do from a dashboard. Here is a Meraki dashboard, by the way. Here is how the Meraki dashboard looks like. So under the Meraki dashboard, we can also see the devices. We can also see like a little bit information about the devices, the security SD-WAN. We can configure these following things. Just go and compare the options available. Compare the options available in the Meraki dashboard and compare the options available in the Catalyst SD-WAN dashboard, and you will know the routing functions, what routing functions are possible for us to configure. BGP routing, for example, we can enable, we can configure. The limited options are there. What functions are for the SD-WAN? So you can just explore the options available for the SD-WAN. This is the option for the SD-WAN. Optimizing the WAN link utilization, some traffic rules. These are the options available here. Just compare. Monitoring, assurance basically means monitoring. Just compare, for example, what options we have in the Meraki dashboard versus what options we have in the Catalyst SD-WAN dashboard, and you will know the difference between. So this is like complete visibility from a single pane of any WAN technology we can use, and complete visibility from a single pane of glass. A single dashboard is there, a web user interface is there, from where we can manage all the things from a centralized. It is available for both Meraki, and it is available for both Catalyst-based SD-WAN solution. Right.
So one quick question: you were mentioning that it is any WAN technology. It is compared like it can support any transport. Either it is 5G or whatever the wireless one, or it is
all that matters. Anything. All that matters is the reachability. We can use any technology. All that matters is the reachability.
It doesn't matter also, correct? So for this SD-WAN solution, whatever technology transport we are using doesn't matter, because it is not touching those technology. It is just overlay concept, right?
But the point is that you will have to do the configuration to make this device reachable with this device. For example, if you are using a technology such as MPLS, you might still need to run protocols such as OSPF BGP so that you can make the reachability between the two. So even though we are not touching that, of course, but the choice of transport is completely on. If you are using like internet, you could have just given a default route here, just a default route here, and things will make the reachability accordingly. So
okay,
reachability you will have to make. How are you going to make the reachability from this device to this device? That will be completely on you. The choice of transport you use for that purpose is completely on. Reachability has to be there between the devices, and of course, from the devices to the controller. If the reachability is not there, centralized management, control, all those things will not be there. How are you going to make the reachability? Using what technology? What WAN technology? Completely. Zero-touch deployment. Zero-touch deployment basically means I can just unbox the vManage router. I can just provide it the connectivity with the network, and that's it. I just have to unbox it, connect the cable onto this vManage, and power it on. Just supply some power to it, let the device boot up. The concept called zero-touch provisioning, or the concept of plug and play, PNP, the concept of ZTP or PNP allows us to onboard. It allows us to onboard these vManage devices without any human interaction. Like we just need to unbox the device, place it in the network, and all the rest of the things will be done in a complete automated way. Concept of ZTP and PNP we will talk about in detail later on. At the moment, this information is sufficient that we can deploy the vManage devices with zero touch provisioning or plug and play concept. There is also one thing called one touch provisioning, but zero touch provisioning is like, one of the key things that we are going to. Application aware. Our SD-WAN is application aware. We can redirect, we can configure the policies in such a way in a few minutes. We can create policies in such a way that our business critical application will be redirected over the transport that is having low loss, latency, and jitter. Application awareness. Our SD-WAN is application aware. Application aware basically means like I can redirect our business critical application traffic. This is some business critical application. Our SD-WAN can be made aware of that business critical application. So the SD-WAN devices, they choose the transport that has low loss, latency, and jitter in order to forward that business critical application traffic. Application awareness is there in our SD-WAN. It recognizes, it uses a concept called NBAR, Network-Based Application Recognition version 2, NBAR, which recognizes like a lot of application traffic. Deep packet inspection. There are technologies basically in our SD-WAN that allows the devices to recognize the application based on the content and then decide what path we have to take based on the configured SLA, service level agreement. Option of application aware routing is also available. Cloud ready WAN features such as cloud on ramp. Okay, I close that. Features such as, for example, cloud on ramp. Features such as cloud on ramp, they allow you to extend your SD-WAN solution to the cloud, the infrastructure that you have deployed on the cloud, and the software applications that you have deployed on the cloud, so that your user experience can be improved. To improve the user experience, the SD-WAN can be connected SD-WAN in Catalyst SD-WAN. We can use a few features to improve the user experience for cloud delivered applications and cloud delivered infrastructure. So cloud ready WAN, we have the concept called cloud ready WAN. So if you have deployed certain applications onto the cloud and you have deployed some sort of infrastructure on the cloud, we can extend the capabilities of our SD-WAN to those cloud delivered infrastructure and cloud delivered applications, so that the user experience can be improved for those cloud delivered infrastructure and cloud delivered. A feature called cloud on ramp, also known as Cloud Express. When we configure this feature in our SD-WAN, it allows us to have better user experience for those cloud delivered infrastructure and cloud delivered softwares, SaaS applications. How? Not a part of our discussion but our SD-WAN capabilities can be extended to the cloud with the help of this feature called cloud on ramp to improve the user experience for those cloud delivered infra and cloud delivered applications.
So the cloud deployment will be just a router, correct? Deploying the router, the edge device.
Cloud delivered. I did not get it.
Deployed on premise that will manage those devices.
Yeah, like how we are going to do that, we will talk about it later on. But basically, the SD-WAN is going to push certain configuration on those managed devices so that the user experience can be improved for those cloud delivered infra and cloud delivered softwares.
But from the same what do you call it, the controller?
vManage, yes, correct.
vManage.
From the same vManage. We saw that there was a feature called cloud on ramp for infra as service, for software as service, for a multi-cloud. There was an option. If you just explore the D-Cloud dashboard, you will see in the configuration, you will have the option called cloud on ramp. So from the same dashboard, we will be able to do all these things. Correct. So these are a few benefits that we get in our SD-WAN. These are the few advantages of using our SD-WAN solution. To explore the D-Cloud SD-WAN solution, you can just explore the D-Cloud vManage and explore what options are available, what is the difference between the Meraki-based SD-WAN and the Catalyst-based SD-WAN, what options are there. From the D-Cloud, you can take a look at the dashboards of both of the SD-WAN solution and get to know more. Let's talk about a few more benefits, a few more functions, a few more advantages that we get when we choose this Catalyst SD-WAN solution. Already we have covered we can use any WAN technology. We can, from a single point, we can do all the configuration management monitoring. SD-WAN application aware, we can redirect critical application traffic over a certain transport cloud on ramp to reach to the cloud services in an optimal way. Zero touch provisioning, ZTP or PNP. These are like a few benefits. These are a few things things that we already discussed. Now let's talk about the other functions, other advantages that we get in the Catalyst SD-WAN. The next advantage that we get is the separation of the management plane, control plane, and the data plane for scalability purpose. With a traditional architecture, a device is going to have control plane functionality, management plane functionality, and data plane functionality are all on the same box. All on the same box, all on the same device. The device will have the control plane functions, management plane functions, and the data plane functions. However, when it comes to SD-WAN solution, especially we are talking about Catalyst SD-WAN, Cisco SD-WAN solution, here the functionalities of the control plane, the functionalities of the data plane, and the functionalities of the management plane have been separated. There is a concept called centralize the control plane, centralize the management plane. The control plane has been centralized and the management plane has been centralized so that all the devices that we have, such as this is vManage 1, this is vManage 2, this is like vManage 3, this is like vManage 4. Since we have a centralized management plane, I can manage all these vManage devices from the centralized point. I can manage all these vManage devices from the centralized point. And since we have a centralized control plane, that means the routing functions, control plane functions, the policies and everything can be managed from a centralized point as well. Centralized control plane basically means all the routing related tasks, all the policies implementation and all those things will be managed from the centralized point. And centralized management plane basically means like all these devices can be managed from the centralized point as well. Centralize the control plane, centralize the management plane. So these devices are now just the data plane devices. These devices will now just have the data plane functionality from the SD-WAN point of view. These devices will be responsible to receive the data and forward the data, perform things such as encapsulation, decapsulation, those real-time functions these devices will perform, but their management will be done from the centralized point, and all the routing, policy implementation, and everything will be managed from a centralized point. So they have separated the control plane, management plane functions from the data plane. They have separated the control plane, management plane functions from the data plane, and they created these controllers. Centralized management plane is what they refer to as vManage. Centralized the control plane is what they refer to as the vSmart. Nowadays, we call this vManage as Cisco Catalyst SD-WAN Manager, and we call this vSmart nowadays Cisco Catalyst SD-WAN Controller. Centralized control plane of our SD-WAN solution is vSmart, also nowadays known as Cisco Catalyst SD-WAN Controller, and the centralized management plane of our SD-WAN, also known as Cisco Catalyst SD-WAN Manager. Earlier, it was known as the vManage. And these devices, all these vManage devices that we have, these vManage devices will have the data plane functionality. These devices will receive the data, decapsulate it, check the routing table, forward the data, real-time functions like encapsulation, decapsulation, a routing table lookup and everything. All those functions will be performed by these vManage devices so that they can forward the data from one point to other. We can manage all these devices from a centralized point, and we can enforce all the policies. We can influence the route learning process and everything from the centralized point as well. So we have centralized the management plane and the centralized control plane by the name of vSmart and vManage. So there is a separation now. The control plane and the management plane functions have been separated from the data plane functions. So these vManage devices are just now the data plane devices, and the control plane and management plane functions are managed by controllers called vManage and vSmart. Advantage is that if the vManage goes down or if the vSmart goes down, your devices will still keep forwarding the data from one side to other side without having any problem. Even if your centralized control plane goes down, even if the centralized management plane goes down, meaning to say if the SD-WAN controller goes down or if the SD-WAN manager goes down, if your management plane is down, you are not able to take the GUI access of the vManage. There is some reachability issue or whatever is the reason. Maybe the vManage has restarted, maybe your vSmart or the controller has restarted, or whatever it is. If your control plane or management plane goes down, these devices will still keep forwarding the data. The data plane will still remain functional. These devices will still keep forwarding the data based on whatever information they have for a predefined time period, like not for forever, for a certain time period, which we will talk about. They will keep forwarding the data for a certain time period, not forever, by the way. They will keep forwarding the data for a certain time period. And then, after that time period, then of course the reachability might go down. But during that time period, we can of course try to fix the issues that we are having, and our data plane functions will, idealistically speaking, like if you are able to resolve the issues, the data plane functions, the data plane will not go down in the meantime. What will happen? You will not be able to manage the devices from a centralized point. What will happen? You will not be able to learn the new route. What will happen? You will not be able to add a new policies or whatever. You will not be able to do the control plane management plane function. But whatever information is already there on the devices, based on that information, the devices will still keep forwarding the data for a predefined time period. For that time period, like there will not be any loss of connectivity, the data will still be forwarded. And during that time period, you can also fix the issues with your vSmart, with the vManage. And if the issue gets fixed, then of course you will not have the downtime. You will not have like any downtime in your network, which is very different than the traditional architecture. In the traditional architecture, if the control plane functions goes down, because everything is on the same device, if the CPU goes down, then all the tables populated by the CPUs will also go down. As a result, the data plane functionalities will also be affected. Here, that's not the case, which is also, I will say, like one of the biggest advantage that we get in our Catalyst SD-WAN solution, that there is a separation between the control plane, management plane, and data plane. So if the control plane or management plane goes down, our data plane will still operate based on the predefined, based on the previous information that it has learned. This is also one advantage. Since we get the GUI, since we get the graphical user interface, I also showed you the graphical user interface GUI or web UI access of your vManage. From the vManage, we can navigate through those different options that we have, and we once like our vManage or manager. Once our Cisco Catalyst SD-WAN manager, once that manager is managing all the devices, and if let's say, for example, we want to create a hub and spoke type of topology, we want to create a full mesh kind of topology, we want to create a partial mesh kind of topology, as per our requirement, just with a single click, just with a few clicks, just with a few point and clicks, we can create different types of topology. We will not need to log in on each and every device to do all these configurations manually. If you want to create a hub and spoke policy, you can log into your vManage. You can create a hub and spoke topology from the web user interface, from the graphical user interface, whatever you want to call it, and you can just click on the deploy button or apply button. Once you deploy that policy, all the devices that we have in the network will start acting as a hub and spoke kind of network based on what device we have configured as hub, based on what device we have configured as the spoke. It will hardly take, I will say, it will hardly take like 2 minutes or maybe like 1 minute. All you need to define is who is the hub, what site is the hub site, and what site is the spoke site, and you can just apply that. You can just deploy that. With a few point and clicks, you will be able to create different types of policies, such as hub and spoke, full mesh, partial mesh. You can create different types of policies as per, you can create different types of topologies as per your requirement. You will not need to log into each and every device. You will not need to log in to each and every device and do the configurations by yourself. You will just stay on the vManage, and here you are going to create the policies regarding the type of topology that you want. And when you apply that policy, the vManage will push all the configurations on the devices, and based on the configuration that is pushed on the devices will start acting in a hub and spoke kind of way. So we don't need to do the interface tunnel and IP and HRP or whatever, whatever those things we used to configure regarding the DMBPM, regarding the hub and spoke kind of topology. We will not require to do all those things manually. Can be done with the help of the vManage graphical user interface with a few pointers, which is also one of the advantages that with the help of a few clicks, we can create and activate different types of policies in different types of topologies in our network, not to mention different types of policies as well. We want to control what routes can be learned. We want to control what kind of data can be forwarded and all. We can create different types of policies, and with just one click, we can apply those policies. And based on the policies that we have applied, the route learning process and the data forwarding process can be influenced. This is also, and all of this we are going to do with the help of the graphical user interface or web user interface of our vManage controller. vManage manager. With the help of this concept, in the very last class, we talked about that nowadays we have different types of devices. We have some corporate users, we have some IoT devices, we have some guest users. But I want to have some clear separation between the three. I want to have the separation between the corp users and the, for example, IoT devices and our guest users. To achieve the separation in SD-WAN, we can use the concept of VRF, also known as VPN. VPN stands for Virtual Private Network. VRF stands for Virtual Routing and Forwarding, or VPN Routing and Forwarding. So we can perform segmentation. We can separate. We can have the segmentation capabilities. We can separate the corporate user traffic from the IoT or the guest user traffic. We can separate that traffic. We can achieve the separation between the corporate, guest, and IoT devices with the help of this concept called VRF, or with the concept of VPN. VPN, Virtual Private Network, or VRF stands for Virtual Routing and Forwarding. With the help of this concept called VPN or VRF, we can achieve the separation between the corporate users, IoT devices, and, for example, the guest user.
I have one doubt. Then here, actually, you told vManage vSmart, it is not reachable. Still, we have reachability via vEdge devices, which we have data plane, right? So you told after some time, still we are not able to reach vManage vSmart. Then that period after that period of time, it will not reachable.
Correct.
That how many hours or days, maximum how many hours or days we can
will be covered later on. Will be covered later on when we talk about the data plane operations. Will be covered later on. It is, just to give you an idea, approximately 12 hours.
Okay.
So it will be covered in the data plane operations, but the whole point was that even if your control plane and the management plane goes down, your data plane will still keep functioning based on what information it has. So it will keep operating without any problem for a fixed amount of time. And after that time, the data plane connection will go down as well, and you will need to fix the reachability. But during that time period, everything will keep working like, as is. We will also test it in the lab environment, and we will talk in detail about it in our data plane operation, but it will keep operating.
Okay, maximum 12 hours only we can configure it. More than that, we can't able to do it.
We can't configure, can we configure it? Can we not? It depends on one factor. Again, which we will talk about like in detail in our data plane operation when we talk about this concept called IPsec. There it will make much more sense.
Okay. Thank you.
Right. So what I said, that we can create the VPNs. VPN is a terminology that viptela used to use when which was very synonymous. It was exactly same as the VRF concept that the Cisco devices were using. So when Cisco acquired viptela, they did not change that VPN terminology to VRF. So with context to in this SD-WAN context, you will notice that the concept of VPN is equal to VRF. When we say VPN, we mean VRF. A VPN or VRF gives us the ability to achieve the separation between the different types of devices, such as like corp, such as IoT, such as like guest users. I can put the corp user in a different VPN. I can put the IoT devices in a different VPN, and I can put the guest users in a different VPN or VRF. And of course, there will not be any communication between them, because that is the whole point of virtual routing and forwarding, or VPN. And how are we going to create the VPNs on those thousands of devices? I'm not going to configure the VPNs on those thousands of devices like manually. I will again stay on my vManage. I will stay on my Catalyst SD-WAN manager dashboard. And from there, we are going to create the VPN template, and I'm going to push that VPN template on 1,000 devices. So on all the 1,000 devices, 500 devices, 600 devices, the VPN 10, VPN 20, and VPN 30 will be created. And then we can put the interfaces in those VPNs. That also I'm going to do from the vManage. I'm going to create the interface template, and I'm going to configure what interface belongs to what VPN from the vManage. I'm not going to do it like manually on all the devices. All these things can be done from the dashboard, from the vManage dashboard. We can definitely configure the policies that, okay, VPN 10 should be able to communicate with VPN 20. If that is your requirement, we can configure the policies in such a way that VPN 10 can communicate with VPN 20. By default, VPN 10 will not be able to communicate with VPN 20. By default, IoT devices will not communicate with the corporate users. But if there is such requirement, then we can do something about it. We can configure a policy to allow the communication between the two VPNs as completely our choice. That also I'm going to do from the vManage.
But this is not in much in use, correct? This is SD-WAN we are talking about, the WAN router.
This is not what use?
Like in the LAN side, we can mostly use this one, correct? That policies and all. This is just allowing the devices to communicate to the WAN side, correct?
Not the WAN side. WAN side is basically like the underlay side, like, the reachability point we are not talking about. We are talking about like the user's point of view. We are talking about from the user's point of view. The use of the WAN already discussed in the previous class. The only use of the WAN is going to be now provide the reachability. So assuming that the reachability is done between these devices, and we have in the LAN side of the network, in the internal network, we have different types of users such as corp, such as guest, such as IoT. So we can achieve the separation between them. We can achieve the separation between them with the help of this concept called VPN or.
So on the remote side also, we will have this capabilities to segregate, correct? That's
same thing here. These concepts are applicable on the vManages. So on all the vManages, we can configure this concept called VPN or VRF to achieve the separation between different types of users. And if we have, let's say, two vManages, here on this vManage, we have configured 3 VPNs. One is like the corp, one is like the guest, one is like the IoT. This is VPN 10, this is VPN 20, this is VPN 30. Here also, we have configured, let's say, for example, 3 VPNs. One is corp, one is guest, one is IoT. Corp is 10, guest is 20, IoT is 30. So if we, and there is a connectivity, there is a reachability between the two VNS devices over some sort of transport. So by default, corp devices will be able to communicate with the corp devices, guest with guest, IoT with IoT. The communication from the corp to the guest, corp to the IoT will not happen unless we are specifically allowed. So end-to-end segmentation is there. End-to-end segmentation is there. End-to-end, like 2 devices that are located at 2 different geographical locations. End-to-end, we will be able to achieve the separation, segmentation between these different types of devices. Of course, we can create the policies to allow the communication between the 2 VPNs, 2 VRF. Just like in the traditional network, we can configure these concepts called route, target, import, export. We can choose like what VRFs can communicate with what VRFs and all in the traditional network. Here also we can do the same, but by default it will not. So end-to-end segmentation can be achieved in the SD-WAN with the help of this concept called VPN or VRF. The term VPN and VRF is synonymous with context to SD-WAN. It is the exact same term. It has the exact same meaning, no differences at all. One more thing to understand here, when it comes to the vManage, vSmart deployment, you have to understand that these are just softwares. These are just softwares that we can download from Cisco website, and we have to either deploy it on our premises in a virtualized environment such as ESXi, or maybe we want to deploy in the cloud such as like AWS, Azure, or whatever. So these are like vManage, vSmart, like the manager and the controller. These are just, I'm just going to call them like control components. Control, I'm going to just call them control components. Control components basically means like the controllers, like vManage and the vSmart controller. We call that vManage as the manager. We call the vSmart as the controller nowadays. So the vSmart and vSmart, and vManage, these are just softwares. These are just softwares that we can download. These are just softwares that we can download, and we can install these in a virtualized environment such as ESXi on our premises, or we can deploy them in the cloud for better redundancy, better availability, and all. So we can do that on the cloud as well. There's no hardware for the controllers. That's what I'm trying to say, is that there is no hardware for the controller. You will have to download these softwares from the Cisco website. And once you download these, you can choose to deploy it on premises, or you can choose to deploy it on the cloud, completely up to you. If you have a well-equipped data center, you have the servers available in your premises. then you can choose to deploy the controllers on your own environment. But in that case, you will have to have the understanding of server-side engineering, server virtualization. You have to understand in that case. And if you do not understand the server virtualization, then you can deploy the things on the cloud. But for that, you need to be aware of the cloud services such as Azure or AWS. You have to have the familiarity with one of the clouds such as AWS or Azure. You have to know what is this AWS, what is this Azure, how can we deploy the controllers on the cloud and all. So you have to have the understanding of the cloud services, and then you will be able to deploy the controllers on the cloud. And if you have neither, if you don't know about the servers, you don't know about the cloud, then you can of course contact these managed service providers, MSPs, or you can contact Cisco. They will deploy the controllers in their cloud. They will deploy your controllers, they will deploy your manager, they will deploy your SD-WAN, Catalyst SD-WAN controller. We call that vSmart. So we call the vManage. So they will deploy the vManage and vSmart on their cloud, and they will provide you the access on some subscription basis. You need to pay them some amount of money, and you don't need to worry about the deployment anymore. You can just contact these MSPs or even Cisco. They can deploy the controllers in their cloud, and they will provide you the access respectively. All the options are there. All the options are there. Whatever suits your requirement, all the options are there. It's just a software that you have to download and either install it on your premises or on the cloud by yourself, or maybe contact some service provider that can deploy these controllers on the cloud for you, and then they will provide you the access over the internet. They will provide you the access of the vManage, vSmart over the internet to you as well. So this point, this is all. Assuming that we have deployed the controllers, here is our vManage, here is our vSmart. Where we have deployed it? We have deployed it in our data center. Maybe we have deployed that in a cloud. At the moment, like we no need to focus on that part. Assuming that we have deployed our controller on the cloud, or maybe we have deployed our controller on the data center. We have downloaded the software and we have deployed that controller software on the cloud, or maybe on my own data center. We have configured it with some IP address such as 100.1.1.1, such as 100.1.1.2, for example. Now I will have to make these control components reachable over the transport to our WAN edge devices as well. So we have like multiple WAN edge devices. We have one of the WAN edge device. It is in like Pune location. We have a second WAN edge device, maybe for example, in Delhi location. We have the third WAN edge device, maybe in other country, for example. We will have to make, here will be an IP address, here will be an IP address, here is an IP address, here is an IP address. We will have to make the reachability. We will have to make the reachability with the help of this WAN transport. We will have to make the reachability between all these control components and these WAN edge devices. As simple as a default route, if you are using the concept of public transport, public IPs, then as simple as a default route will just do the trick. So just the default route will just be sufficient, because it's a public IP, public IP, public IP, public IP. Public IPs are reachable over the transport such as internet. So just the default route will be fine. And you will, of course, be able to ping from one device to other device. But if you are using a private WAN transport such as MPLS and all, then you might need to be involved in the routing. You will need to advertise. You will need to contact the MPLS service providers to make the reachability from these IP addresses in different locations. So you will ask them that, okay, we have a few branches, a few data centers. We want them to make reachable. We want them to be reachable. So here is like you can do some routing. You can do some routing from Delhi to Pune to like Mumbai or whatever. So you can just ask the MPLS service provider to provide the routing capabilities for you. In short, basically the reachability has to be there. How you are going to make the reachability is your problem. What transport you use, it's your problem. Public transport, private transport, default route, any routing protocol such as OSPF, BGP with the service provider, it's completely your problem. Whatever option you go for, at the end of the day, the reachability has to be there between the WAN devices and with the controllers.
I have one doubt regarding implementing the vManage. We will have two vManage. whether we can keep it one vManage in cloud, one vManage in our data center like that.
There comes a concept of redundancy where we have like active model and active standby model. Both the options are available. Some might require like clustering, some might require like no clustering at all. So it is possible to have a set of vManage on the cloud, and it is possible to have a set of vManage on the premises. So we can have a mixed environment as well. Again, you will have to make sure that they are reachable to each other, and ensuring the reachability is again going to be with the help of some transports and all. So as long as they are reachable, things will work.
Okay, only reachability we need to make it.
Correct. Some latency considerations, some bandwidth considerations will be there, which will be covered in our HA chapter later on. But it is possible.
Okay.
Assuming that we have made the reachability, assuming that the reachability is there, assuming that the control components such as vManage, vSmart, they are reachable over the transport to the vNS devices, Assuming that the reachability is, assuming that we have formed the reachability between all these IP addresses, either by using a public transport such as internet or using a private transport such as MPLS, Metro Ethernet, or whatever. Assuming that the reachability is there. I said that from the vManage, we can do the centralized management. I said that from the vSmart, we can deploy various like policies and everything. Route learning process is going to be with the help of the vSmart as well. So whatever information is passing between the devices, whatever information is passing from the vEdge to the vManage, all this information that is passing from these devices to the devices, all that information that is passing between the devices must be secured as well. Whatever messages, whatever information is passing between the devices regarding routes, regarding policies, regarding management, whatever information is passing over this public transport such as internet, from the vNS to the vManage, vManage to the vManage, vSmart to the vManage, vSmart to the vManage, vManage to the vSmart, whatever information is passing between all these control components and the vNS devices, all that information must be properly secure. Otherwise, anyone from the internet, they might try to attack on your network. They might try to, just eavesdrop like on the data that we are sending, and they will just be able to get the routes. They will just be able to get the information that you are sending and receiving. So whatever communication has to happen, whatever messages have to pass between the control components and the vNS devices to the control components, whatever messages need to pass between the devices, they will be completely secured. The data will be completely secured. The data is going to be completely secured, and the security will be provided by this concept called DTLS or TLS. DTLS, TLS. Datagram Transport Layer Security, Basically, as soon as these devices become reachable to each other, there will be a secure communication channel from the vSmart to the vManage, from the vManage to the vManage. There will be a secure communication channel. Basically, a tunnel will be built. From the vSmart to the vManage, from the vManage to the vSmart, and that tunnel will be built based on the protocol called DTLS, Datagram Transport Layer Security, or Transport Layer Security. Between the devices as well, the secure communication channel, a secure communication channel will be established with the help of this protocol referred to as DTLS, Datagram Transport Layer Security, or TLS. We can choose, but typically it's going to be DTLS, but we can choose to use TLS as per the requirement. But between all these control components and vManages to the control components, you will have this secure communication channel established based on DTLS, TLS, and then whatever messages needs to pass, those messages will pass within the protection of the secure communication channel, and those messages will be completely secured. So the intermediate like attackers, they will not be able to see those data or those messages, and the security will be. It's very much similar to we have the web page and the web server we have the web client and web server communication. So you open the browser, you type google.com. So your browser creates a secure communication channel with the Google server, and then whatever data you send, that data is basically completely secured and all. Similar to that, like these control components and these control components and the VANS devices, they will create a secure communication channel. And within the protection of that secure communication channel, they will send data, which is going to enforce the security for the data as well. And the best part, all we need to do is to make sure that the reachability is there. This DTLS, TLS, these tunnels will be created completely automatically. Just like when we have to access a web page, I do not go and form a tunnel first and then access the web page. It happens automatically. Similar to that here also, things will happen automatically. Automatically, a secure communication channel will be established between the devices. I will not need to do the configurations. Not to tell you that the data traffic that passes from the vanish to vanish. Not to tell you, this is okay. The communication between the control components and the vanish device is completely secured, and not to tell you that the data that passes from the vanish to the vanish, the data that is passing over this transport, the data traffic that passes from the vanish device to the vanish device, that data traffic is also completely secured. VPN 10 traffic is passing, VPN 20 traffic is passing, VPN 30 traffic is passing. Whatever data passes from the vanish to the vanish, that data is also completely secured. So VPN 10 can communicate with VPN 10, 20 can communicate with 20, 30 can communicate with 30 over a secure communication channel. And that secure communication channel will be provided, it will be created automatically. And the protocol that will be used for this purpose is called IPsec. Without doing any configurations, these vanish devices will create a secure communication channel between each other. Like these devices will create an IPsec tunnel. These vanish devices will create the IPsec tunnel. These vanish devices will create the IPsec tunnels, and a secure communication channel will be established, and then the data will pass. There will be one tunnel, and within that tunnel, the VPN 10, VPN 20, VPN 30 traffic will pass, and still there will be a clear segmentation. There will be a clear separation between the three VPNs. No configurations of the IPsec. In fact, I can tell you, it's not the traditional IPsec as well. It is not that ISACAMP IPsec. Basically, it is the IPsec responsible to provide all the CIE functions, confidentiality, integrity, authentication, anti-reply, all those functions is provided by the IPsec here. But the way the IPsec is implemented is a little bit different. We will, of course, talk about it. At the moment, it is just okay to understand that the communication is completely secure, whether we are talking about the control plane communication or we are talking about the data plane communication. Everything is completely secured, completely automatically with the help of protocols such as IPsec, DTLS. All we need to do is to make sure that the reachability is there. No configurations of DTLS, no configurations of the TLS, no configurations of the IPsec. We don't need to do any kind of configuration. All these configurations regarding DTLS, TLS, IPsec, all these configurations will be pushed automatically, and the secure communication channel will be established between the devices, and then your data to the control plane, to the control components, and the data to the vanish will pass. Oh, by the way, if we have these vanish devices reachable, this is one vanish device, this is one vanish router, this is the second vanish router, and it is connected via this transport. So there will be an IPsec tunnel between the two. And if they are connected via another transport, then there will be an IPsec tunnel between the two as well. Multiple IPsec tunnels you will be able to see. If your vanish devices are connected via multiple transport, the vanish device 1 is connected with the vanish device 2 via multiple transports such as ISP1 and MPLS, for example, like this. So there will be an IPsec tunnel and there will be an IPsec tunnel. And the data will be load balanced. The data will be load balanced among these IPsec tunnels. Some data will pass from here and some data will pass from. We can influence it, but by default, full mesh tunnels will be established between the vanish devices, and the load balancing will take place over the different tunnels. By the way, this device will also try to establish an IPsec tunnel with this device. Like it will try to establish an IPsec tunnel. It will try to establish an IPsec tunnel between these IPs as well. The problem is that this is a public IP. This is a public IP, and maybe this is a private IP. Maybe this is a private IP. This is a public IP. This is a public IP. Maybe this is a private IP. So the problem is that this public IP is not reachable with the private IP. This private IP is not reachable with the public IP. So there is no tunnel. There is no tunnel between the two. Else, if let's say, for example, you are using internet transport, this is ISP1, ISP2, and it is also a public IP, 100.1.2.1, 100.1.3.1, and 100.1.4.1. So if it's a public IP, public IP, public IP, public IP, in that case, you will notice 4 tunnels, not 2 tunnels. You will notice 4 tunnels actually here. You will notice a tunnel. You will notice a tunnel from here to here, of course. There will be this tunnel, and there will be this tunnel. And since these IPs are also reachable, there will be a tunnel between the 2 IPs, like here. And since these 2 IPs are reachable as well, there will be a tunnel between the IPs as well. Full mesh IPsec tunnels will be there, and the load balancing will take place over all those 4. This is a default behavior, by the way. All we need to do is to make sure that the reachability is there. Else, everything other, like all the rest of the things, will happen in a complete automated fashion. The only reason in the previous example the full mesh tunnels were not there is because of the reachability. The private IPs were not reachable with the public IP. That's why the full mesh tunnels were not there. But here in this case, the full mesh tunnels will be there because everything is completely reachable. So the point I'm trying to make is that we don't need to worry about security. Why should we go for a costly M+ connection? Replace your existing M+ connection with a cost-effective internet services. Business internet maybe. SLA-based internet, for example. Go for some SLA-based internet. Go for like business internet services and ensure that the reachability between the 2 devices is there over multiple ISP connections. And you don't need to worry. The major concern about for like sending the data over the internet was the security. The major concern, the major issue was security. And that has now been resolved. That has now been resolved by the SD-WAN because the data is already secured with the help of IPsec concept. That's why they are saying that, okay, SD-WAN will replace MPLS because no one is going to use MPLS. Everyone is going to use these ISPs, internet service providers, business internet, 4G LTE, these kind of like public internet services they will use. Maybe as simple as a broadband connection. Maybe a broadband connection at our home, and we have deployed our router behind it. We have done some sort of netting here, so we can still have the secure communication channel. So that's why people have been saying that M+ will replace the SD-WAN, but that's not going to be the case. The use case of M+ is very different as compared to the SD-WAN here. So that's not going to happen anytime soon. Customers now have a choice. Customers now have a choice to not use a costly M+ solution, but to use internet. Maybe. In short, basically, there is a complete security. There is, in short, complete security. There is complete security between the devices. In short, there is complete security between the devices. From the control plane point of view, from the data plane point of view, complete security is there between the devices. Okay. So this is done. The responsibility of the WAN, will just be responsible. It is just going to be to provide the connectivity between this IP, and this IP. The responsibility of this transport, the MPLS transport or the internet transport, the responsibility of the transport is going to be to provide the connectivity between the devices. Once the connectivity is there, like I said, there will be a secure communication channel between these devices, and that secure communication channel will be with the help of this concept called IPsec. IPsec is going to create an overlay network on the top of this underlying infrastructure. The IPsec protocol is going to create an overlay network. IPsec is going to create an overlay network on the top of this underlying infrastructure. On the top of this underlying infrastructure, the IPsec is going to create a logical network and overlay network. and our data will pass. Our data will pass from here to here over that logical network, over that overlay network. So the responsibility of the transport is just now to provide the reachability. Once the reachability is there, then the overlay tunnels will be built. And the data will start passing from those tunnels. Once the reachability is there with the vSmart controller, for example, there will be some tunnels built. The DTLS tunnels, for example, will be built, right? So the DTLS tunnel, within the protection of the DTLS tunnel, the control plane messages will pass, and those control plane messages will carry the routes and other information. The route information and the other information, those control plane messages will basically carry. The concept of overlay is used here, in our SD-WAN scenarios. We have the concept called underlay, we have the concept called overlay. Underlay is the underlying infrastructure on the top of which a logical network is built, and that logical network is known as the overlay network. The underlying infrastructure is responsible to provide the reachability. The underlying infrastructure is responsible to provide the reachability. The wires, the IPs, everything that we have connected, the transport, for example, that we are using, all that is responsible to provide the reachability. Once the reachability is there, a logical network will be built on the top of it. And once this logical network is built on the top of that underlying infrastructure, then our data can start passing from that logical. Enhanced routing functionalities with overlay. The routings and everything will happen, the data forwarding will happen with the help of the overlay concept. Underlay will just be responsible to provide the reachability between the devices, and the logical network overlay will be built on the top of it, and then the data will start passing via that logical network. The concept of underlay and overlay is used. The similar kind of concept was there in the DMVP and in the GRE as well. We make the routers reachable over public transport, such as, for example, internet. And then once the reachability is there, we do some configurations about tunnels, interface tunnel, tunnel mode, tunnel source, tunnel destination, which forms a logical tunnel from one end of the network to the other end of the network, and then our data passes via that tunnel. Similar kind of concept is here as well. Here, just we are not using the concept called GRE or DMVPN. Here we are using the concept called IPsec. Here we are going to use the concept called IPsec. So the concept of underlay overlay still remains in our Catalyst SD-WAN. The concept of underlay overlay still will be used in our Catalyst SD-WAN solution. And the final point, just like our controllers are softwares, we can deploy them in a virtualized environment such as ESXi, or maybe Linux-based kernel virtual machine, Hyper-V, or maybe in the cloud such as AWS, Azure, XYZ. Routers, they come in two form factor: physical devices, physical routers that we are going to purchase, and install on our premises. We can onboard them with the help of this concept called ZTP, or we can do the manual configuration to make them part of our SD-WAN network, completely your choice. Either you can do it, or we can download the image for the routers as well. We can download the software, we can download the iOS image for the router as well, and we can then install that in a virtualized environment such as ESXi, or maybe we can run it on the cloud, and we can then we get all the functions of the SD-WAN, a secure communication channel with the control component, secure communication channel for the data forwarding. We get all those routing functionalities here as well. CSR, for example, CSR 1000V, for example, C8TV, for example, these are a few cloud service router. These are some virtualized router that we can download and we can install in a server, and then we can configure it with the IP address and make them reachable to the rest of the network. And then we get the functionality of a normal router on these devices as well. Eventually, like a router, when we talk about a router, ultimately a router is just a hardware where we have some RAM, some CPU, some hard disk. We have all those things basically. All those things are available on my server as well. So I can just download the image and upload it onto the server, and we get the full functionalities of the routing from that device itself in a virtualized environment as well. However, the use of these virtual routers, is actually a little bit different. We will talk about it, but it is completely possible that we can download these router softwares. We can download these router softwares and we can install it in a virtualized environment on our premises in a servers and all, and then we will take the benefits of the router from there. We don't need to purchase that. And not to tell you secure router. What do we mean by secure router? Secure communication channel with the control component and secure data plane connections with the rest of the devices. So these are the benefits that we get. These are the advantages that we get when we deploy the Catalyst SD-WAN solution in our network, which is, like we covered in the last class, very different than the Meraki-based SD-WAN solution that Cisco provides. We don't need to deploy the controllers. We don't need to do all these kind of things. We just need to purchase those Meraki-based devices, connect them with the internet. They will register themselves on the Meraki cloud. And then from the cloud itself, from the Meraki dashboard, we will be able to manage plenty of things about those devices. But we will not get that much control as we are getting here in the Catalyst SD-WAN, the templates, the policies, the securities and all. So you can choose to use either the Meraki-based SD-WAN for small to medium businesses, and you can choose to use like Catalyst SD-WAN for the large or very large enterprise networks. But both the options are there.
Regarding this, as you mentioned, the virtual routers, everything is available virtually, can be deployed virtually. In that case, why most of the company during this pandemic and this crisis, why most of the company are struggling with this supply chain issue? This is the
because
case
like I said, the use of those virtual routers is different. It's not exactly the same as like the physical devices. So the use of those virtual routers, like where should we use, what is the use case of those virtual routers, is a little bit different, which we will talk about. So they still want to have the physical appliances on their network. Companies will anyway need to purchase some hardware such as servers if they want to deploy those routers. So if not like routers, then they will have a shortage of the servers. So if they can't purchase a physical router and they try to go for the virtualized environment, then still they will need to purchase a well-equipped server where they can create those routers they can deploy the routers in a virtualized environment, and then they have to get the licensing and everything, and then they will have to make the reachability. So plenty of challenges still there. Like it's not like they can just download and install it in a computer. No, there is a specific requirement for these routers to be deployed. Some connectivity options, some like networking has to be there. So the proper environment where we have to deploy these routers are going to be like these servers. So if your company has a server, they can definitely go for it. If your company has a server and someone is responsible to manage those server resources in your organization, you can definitely ask them to create a virtual machine, and you can deploy those cloud-based routers, CSR 1000V or C8KV, on that virtualized environment. You can get the licensing, you can get the license, and then you will definitely be able to use it. Your company's choice. But someone has to have the understanding of the server-side engineering. Someone has to have the understanding of the virtualization. You will not get the exact same functions as like the routers. Some limitations might be there. So maybe based on those factors, the companies have still preferred to deploy the physical devices. But it's not very uncommon to see these virtual routers in a production environment as well. The major challenge is the connectivity. The major challenge is the licensing. Those kind of challenges you will still face. But apart from that, if it is possible, if it is feasible, I will say, your company can still go for the virtualized solution. You can just spin up a Catalyst 1000V on a CSR 1000V on a VM, and then you can make it reachable to rest of the network, and you will notice that all the things will work exactly as the normal router. But server has to be, and cost of purchasing a server, a well-equipped server with that can handle deployment of a few routers, for example, and cost of purchasing a dedicated router, a few factors might be there because of which the companies might have chosen to go still for the physical devices. Security could be another reason. Although like CSR 1000 V or C8 kV, they come with a lot of security features, but security could also be one reason. Maybe they want a dedicated device. So could be like various reasons based on which the companies have opted for the physical device rather than for a virtual solution. And at that time, when we are talking about like 2020, approximately 1920, at that time on pandemic, companies might not have explored these options of deployment like that much. A lot of like issues might be there, some bugs might be there when we deploy these devices in a virtualized environment. So that could be also one reason. But overall, we nowadays we have like the option to deploy this in a virtualized environment as well, and it works pretty well. In fact, we will do all the deployment in our lab in a virtualized environment itself. So you will notice the advantages. You will notice the things that we can do in a virtualized environment, and you will be able to do like everything that you can do on the physical devices. So it's their choice. It's company's choice to opt for one over. And however, more use cases we will study about these virtual router deployment later on. We will study about more use cases about these virtual router. But these are some generic benefits that we get in our Catalyst SD-WAN. Deploying the Catalyst SD-WAN is going to provide first of all, we have end-to-end segmentation based on the VPN, end-to-end security is there. We can purchase a physical router, or we can deploy the router in a virtualized environment based on our requirement of rich services or the light services. Based on we want to deploy the router on the branch, on the cloud, on the aggregation point like service providers and all. So based on like where we want to deploy the router, we can choose to go for a physical appliance, or we can go for a virtual appliance. So endpoint flexibility is there. We can choose whatever transport we want to use. Transport does not matter anymore, because no matter if you are using a public transport such as internet, the entire communication will be secured by the IPsec. So transport independent WAN fabric. Superior security architecture. There are some built-in security features on these WAN devices. So in a small branch where you want to enforce some basic security, you do not need to purchase a dedicated firewall or a dedicated security appliance. You can, for example, get those native security features available on the devices. So from that point of view, security is also there. And the communication from the vManage devices to the control components to the vManage devices, vManage to the vManage, control component to the control component, all that is completely secured with the help of like DTLS, TLS, IPsec. So a complete sense of security is also there. To improve the application quality of experience, to improve the user experience for the application, there are plenty of features as well. Cloud on ramp, for example, feature is there to address the cloud delivered applications, cloud delivered infrastructure. Application aware routing feature, for example, is available to better the user experience for certain applications. That kind of thing is there. SD-WAN basically offers a few features to improve the application quality of experience. We can deploy these controllers and all in the cloud. We can deploy the controllers in our premises. Deploying the controllers in the cloud is going to simplify the operations of deployment, and also either we can deploy those controllers on the cloud by ourselves, or we can maybe contact these managed service providers and get the things deployed there in their cloud and all. We have plenty of options from the deployment point of view. Yes, we get all these. So WAN has evolved to address all these previous challenges that we talked about. So our modern day WAN is both cloud ready and secure. So we have secure now WAN solution with minimum human interaction, with minimum configurations that we need to do on the devices. All we need to do is to make sure that the reachability is there between the vManage to vManage, vManage to the control components, no matter if they are deployed on the premises or on the cloud, does not matter. As long as the reachability is there, the communication is going to be secured, and most of the things will happen in a complete automated fashion. Automatic DTLS tunnel, automatic TLS tunnel, automatic IPsec tunnels, zero touch provisioning, ZTP, the concept of ZTP to deploy the vManage devices in without human intervention. The cloud delivered applications, cloud delivered infrastructure to address those IaaS and SaaS services, for example, cloud on RAM feature, plenty of benefits we get in our Catalyst based SD-WAN. This is all the things that we need to know about why we need SD-WAN, What are the benefits of the SD-WAN? How it is different from the traditional wide area network. What are the advantages we get? How the WAN has evolved and all. These are all the things that we have to talk about before we move on to the technical aspect of architecture of our SD-WAN. So this basic part is now complete. Chapter number 1 from, you can say, the official book, which says that why we need SD-WAN, what are the benefits and all. That part is now done. You also now have the idea that there are two components in the SD-WAN. One is like control components and one is like the routers, WAN edges. Control components such as vSmart, vManage, also known as controller and manager. There is also one more component. We will talk about it later on. But then the WAN devices, Viptela based WAN devices and Cisco based WAN devices. Viptela operating system based WAN devices called VS devices and Cisco IOS XE based SD-WAN devices called cEdge devices, known as normally WAN devices. We do not use the new schema that we have, the new naming convention that we have does not mention Viptela anymore. So controller, manager, WAN devices. Later on in detail, now we will talk about each and every component from the architectural point of view. Now we will talk about each and every component one by one. But why part is now done. Any doubts, any questions? If you guys have any point you need to ask, we can discuss. Else we can continue with the architecture part. So any doubts, any questions, if you guys have, let me know. Any point you need to discuss so far. Remember that we are focusing only on the WAN side. We are not talking about the LAN side. Our focus is only on the WAN edge devices. What things we can do on these WAN edge devices, we are focusing more on that. LAN part is covered in software-defined access, and the data center part is covered in the, like we covered the ACIE APIC.
So this branch router, we can also consider this as a fusion router also, correct?
From the SDA point of view, can be considered as a fusion router. Otherwise, from the SD-WAN point of view, it is just a managed router.
And it can be managed by both?
No, it cannot. If you go through the SDA classes, we do not have the, when it comes to SD-WAN and SDA integration, we have the integrated domain and, different domains. So we do not follow the concept of integrated domain anymore. The option is no longer available. So these WAN devices will now be managed by the vManage, and the LAN side will be managed by the SD-WAN. SDSO. So we do not have that concept anymore. It was there earlier, but nowadays there is a concept called integrated domain and independent domain. Nowadays we follow the concept of independent domain, not the integrated domain. So the functionalities of the WAN devices will be managed by the SD-WAN, and the LAN side will be managed by the SD. Any more questions? Anyone? Any doubts so far? This is a chapter number 1. You can read through the chapter number 1 now, which explains like why we need SD-WAN, what are the benefits of the SD-WAN, what are the challenges in the traditional WAN and all. You can go through that first chapter of your official certification guide. I already uploaded on the portal, so that thing you can now read. So from the architectural point of view, we have now two things. One is control components, and the second one is the WAN edge devices. Control components, in short, controllers, and WAN edge devices, those Viptela operating system based S devices and Cisco operating system based S devices, vEdge or cEdge devices. So we have centralized the control plane with the help of a controller called vSmart, also known as controller. Centralized the management plane with the help of a controller called vManage, also known as manager. Nowadays, we have the data plane devices. These devices will have the data plane functions performing things such as encapsulation, decapsulation, all that thing, routing table lookup and all. So they will do the data plane functions. Apart from that, we have this concept called analytics. Earlier, we used to call it like vAnalytics. Now we call just like analytics. This is a cloud delivered analytics engine. You do not get like any software to install it. It's completely cloud delivered, which is there to give you better insights of your network. We will see later on. vAnalytics basically gives you a better insight of your network, things such as like link utilization, circuit utilization, the sites information, the client information, and also it gives you better insights of the network. It is completely cloud delivered. Customers can choose to opt in either like they can choose to use it, they choose not to use it, completely on them. So it is more like an optional element if you want to use it. And then we have the third-party automation. A third-party automation basically means that it is possible to integrate our SD-WAN solution with the third-party automation tools, such as, for example, Postman or scripting tool, Python scripting tool. Basically, if you do not want to navigate through the user interface, the GUI or the web UI, if you do not want to navigate through the user interface of the vManage, what you can do actually, you can create scripts, you can write scripts, you can run those scripts using the concept of API, application programming interfaces. Those scripts will be able to send the instructions to the vManage, and the vManage will be able to configure the devices based on the instructions. So not necessarily that we need to navigate through the user interface. If you are good with the scripting, if you know about like automation programming, then you can also integrate your SD-WAN solution with the automation programming tools and do everything that we can do from the vManage user interface. You can do all those things from the automation tools as well. Completely your choice if you want to do it like from the user interface or you want to do it from the automation tools, scripting, programming, all those things. One more control component is there called validator, which is referred to as the orchestration plane. Earlier, it was known as the vBond, but nowadays we call it like validator, and it is part of the orchestration plane. It is the orchestration plane of the SD-WAN. So from the architectural point of view, we have the management plane, we have the orchestration plane, we have the control plane, we have the data plane, we have the option of analytics, cloud-delivered analytics engine to get the better insights of our network. And we can also integrate our SD-WAN solution with third-party automation tools. And we will require some certain transports to connect all these controllers and the managed devices together. So from the architectural point of view, these are all the things that we require to build an SD-WAN. In order to build an SD-WAN network, these are the things that we require. The very first component that we have in our SD-WAN architecture is the centralized management plane. Centralized management plane, the management plane functionalities of the devices can be managed from a centralized point, a single pane of glass for day 0, day 1, and day 2 operation. We can do everything all the way from the deployment to the monitoring and day 2 operations, such as like software upgrades, troubleshooting, and all. Everything we can do from the centralized management plane called Cisco Catalyst SD-WAN Manager, earlier known as the vManage. It is a single pane of glass for day 0, day 1, and day 2 operation. We can perform everything. We can do everything. We can do everything all the way from the device deployment to the monitoring, initial planning and the understanding of the network, deployment and verification, maintenance and troubleshooting. All these things we can do from centralized point from the vManage or Cisco Catalyst SD-WAN Manage. Single pane of glass. What do we mean by single pane of glass? Already we discussed this, that we can always, meanwhile, since we start, till we start our lab, we can go to the D Cloud, Cisco D Cloud, just search D Cloud and go to this Cisco D Cloud. And here you can log in with your cisco.com credentials from the very top. You can log in with your cisco.com credentials. And once you log in with your cisco.com credentials, you can take a look at the demo actually. You can take a look at the demo, instant demo provided by the Cisco D Cloud on the SD-WAN solution. So once you log in here, go to the catalog right at the top, catalog. And from here, you can click on the instant demo button on the left side of the page here. You can click on the instant demo, and then either you can scroll down to find the SD-WAN, or you can search at the top. You can search in this catalog. You can search the SD-WAN right here in the catalog. You can search here like SD-WAN, click on the search button, and it will show you only the SD-WAN demo, 20.10, 20.11, 20.14, these are basically, for example, demos that we can take a look at. So I will just click on view button here if you want to open the 20.11, and I will click on the view button here if I want to see how the look and feel is for the SD-WAN solution 20.14. So click on it. It will open in the cloud itself a dashboard, which is your vManage dashboard, and you can explore various options that we have under this vManage. So this centralized management plane. This is centralized management plane. From here, we can do all sort of like monitoring, configuration, maintenance, administration. We can generate different types of reports. We can have tools to take the SSH access and raise a tag case, maybe rediscover. We have different basically options available here, which we will explore throughout our content. The main point is that from a centralized point, we can do all these things that we want. Single pane of glass, right from one dashboard, we can do plenty of things. From one single dashboard, we can do all sort of like configuration, monitoring, troubleshooting. I can do all those sort of things right from here. For example, I can go to the devices. I can click on any device, such as, for example, this one. It will give me details of that particular device. And I can then scroll down at the very end. And there, I will be able to do the troubleshooting. I will be able to do the ping and trace from this dashboard itself. I don't need to log in to that particular device. Same if you go for like, same, for example, if you go for like, it will not allow me, I guess, to go. Let me see here. So for example, here we have all these devices. I can click on any device. I can click on any device, such as, for example, this one, any device. You can click on any device, such as this one. And at the very end, you can go to the troubleshooting. You can go to the real time. From here, for example, you can execute the commands. From here, you can do all the troubleshooting, basic troubleshooting, such as like packet capture, such as simulate flows. Let's say I want to go to the 8.8.8.8, for example. How can I go to 8.8.8.8, for example? So we can simulate the traffic flow from that device point of view, or right on the same dashboard. I don't need to log into that device for the purpose. The point is that we can do all sort of troubleshooting. We can do like management, monitoring. We can do plenty of things right from here itself. We do not need to, for example, log into the device to do all these kind of ping, trace, troubleshooting, monitoring, deployment. We can do all those things right from the SD-WAN dashboard itself. We can do plenty of things from the SD-WAN dashboard itself. The look and feel of the latest version is a little bit different than the older version that you will have to be aware of. That's why in the dCloud, we have both the demos. You can explore both of the options to know. You can explore both of the options to know about the user interface, how it looks in the new version, how it looks in the old version. So just the theme they have changed, the rest of the options remains exactly the same. A few new features might have been added. Those new features you can explore. But apart from that, just the theme has been changed and the rest of the concept looks pretty much the same. Single pane of glass for day 0, day 1, and day 2 operations. From a centralized point, we can do all these things. Single pane of glass for day 0, day 1, and day 2. From a centralized point, we can do the device provisioning, configuration, troubleshooting, monitoring. We can do all those sort of things from a centralized. As we can see in the dashboard itself, we have plenty of options here. We can do all those things from the centralized. We can create the users right here. We can create the users. We can create the users. We can create the users user group right here. We can create what different types of user groups can be there and what are different users part of different groups. Role-based access control. A role-based access control basically means that we can provide the access of the vManage to different users, different administrators based on their privilege level. Some administrators will have a read-only access. Some administrator will have read-write both the access, for example. We can create the user groups. We can create the user groups from here. We can assign the users in those groups such as demo. Demo users, they do not have any write access. They will just have the read access. NetAdmin, for example, operator, for example. We can define what things we want to permit, deny, what things must have the read-only access, read-write access. We can do the role-based access control. Role-based access control we can do from the vManage itself. And with the help of this concept called API, Application Programming Interfaces, we get programmatic control over every aspect of vManage administration. We can do all the things that we can do from here. We can do all those things with the help of the APIs as well. So this vManage can get the instructions with the help of the API using these third-party automation tools. Whatever tools your company might be using, the company automation engineer might create some scripts in order to change the network. It will run that script. The script will instruct the vManage to do certain changes. and the vManage is going to push the configuration on the devices respectively. So if you are aware with automation programming, you can get the programmatic control over all the aspects of the vManage administration with the help of this concept called API. And all the documentations regarding the API is also available on the internet. All the documentations that you require, all the documentation that you require is also going to be available on the internet. You can refer to that documentation. You can refer to the documentation and, such as you can just search SD-WAN API. And here is like from the Cisco DevNet, Cisco Catalyst SD-WAN Manager, and you can just click on it. And there will be plenty of like APIs. The APIs, what APIs are basically available. These are all the things that we can do with the help of the API. For example, you want to do some sort of monitoring, you can click on this. It will show you the API format. If you understand, for example, the automation programming, you can refer to this documentation available. You can refer to the documentation available here for the same. So we get programmatic control over all the aspects of the vManage administration with the help of the API. What else? When it comes to deployment, we can download this software. When it comes to deployment, we can download the software. When it comes to the deployment, we can download the software of the vManage from the Cisco website, and we can install it in our premises. You can download the software image from the Cisco itself. So software.cisco.com, you can visit software.cisco.com. You can visit software.cisco.com. Here you can log in with your credentials. Here you can log in with your credentials. And then let me quickly log in. So you can log in with your cisco.com credentials here, and then you can wait. Let me log in. So now I'm logged in here. You can go to the downloads and upgrade option. You can click on this access download button. You can search here. You can either search here SD-WAN or you can browse all. You can browse all. You can go to the routers. You can go to the software-defined wide area network. You can go to the SD-WAN, and you can download this software. You can download this SD-WAN software for the vManage and the vSmart. Click on the vManage, and you can download the software as per your requirement. You can either download the latest version, 20.16, or you can download the recommended suggested release as per your company's policies. As per the version that you want to choose, you can just click on the version. This is mid deployment. This is early deployment. So star release is the recommended release. So you can download this like OA file. You can download this OA file and deploy it in a virtualized environment such as ESXi, or you can download this QCOW file and you can deploy this in a KVM, in a Linux-based kernel virtual machine.
Can you go back? Is there a vBond also here or no? You can download?
No, there is no vBond. There's no v. So just vManage, and you can download the vManage software and install it in a virtualized environment such as ESXi. You can download it and install it in a Linux-based kernel virtual machine, or you can install it in the cloud.
Then how will get the vBond?
When we talk about the vBond, we will talk about it. So currently you can just download the vManage image and you can deploy it. When we reach to the vBond point, we will talk. Now, when we deploy this in our premises, it's okay. When we deploy this vManage in our premises, it's fine. We can choose to deploy this in our premises. We can choose to deploy this vManage software in a virtualized environment such as ESXi on our premises. It's fine. But if you go to any managed service provider, MSP, Cisco, and you ask them to deploy the controller onto the cloud, basically in their data center, if you ask them to deploy the controllers in the cloud, they will ask you, or maybe even you are doing the deployment. Let's say you are the managed service provider company, and there are a few clients. There are a few clients that want to get the SD-WAN solution. You can ask them, do you want to deploy the controller in a single tenant environment or a multi-tenant environment? We can deploy the vManage in a single tenant and multi-tenant environment. Single tenant means there will be a dedicated set of resource. There will be a dedicated set of resource for you and you only. That resource is not shared. That resource is not shared with anyone. Single tenant, of course, is going to be a little bit more costly, but single tenant means there is a dedicated set of vManage resource only and only for you. In a multi-tenant, we can also deploy the vManage in a multi-tenant environment. In the case of a multi-tenant vManage, a single vManage can manage the devices of multiple clients. The same vManage resource is going to manage the devices of the client one. Client one has like 10 devices, 100 devices. There is a client number two. Client two has like approximately 50 devices. There is a client number three that has like 150 devices. So, and we ask these clients that, do you want to go for single tenant or multi-tenant deployment? They said, okay, we are okay with the multi-tenant deployment. So there will be a single vManage instance, and the single vManage resource will be responsible to manage three, for example, tenants. Of course, client number two will not be able to see the client number one, client number three devices, of course. There will be a clear separation between the two, of course, between the three as well. When you log in, when the provider gives you the login, when you log in on the vManage, you will get your own dashboard. Your own client dashboard will be visible. You will not be able to see the other client dashboard, of course. You will be able to manage only your devices, not the other, for example, like, client devices. That is, of course, there. But it is possible that we can deploy the vManage in a multi-tenant deployment where a single vManage can manage the devices of multiple tenants, multiple clients. How many clients? Depends on the deployment. Single tenant deployment and multi-tenant deployment is done in a different way. The different concept is there for the single tenant deployment, and there is a different concept for multi-tenant deployment. Single tenant deployment is done in a different way, and a multi-tenant deployment is done in a different way. Some concept of cluster, domain ID, domain thing is basically used. So single tenant deployment and multi-tenant deployment, it is done in a different way. So, when we deploy the vManage, it will ask me, when we deploy the vManage, it will ask me that, do you want to deploy the vManage in a single tenant or a multi-tenant environment? Tenancy mode, either single tenant or multi-tenant. Single tenant means there is a dedicated set of resource for the customer. That resource is not shared with anyone. This vManage will be responsible to manage only that customer device, If for the second customer, I will have to deploy a second set of resources. For the third customer, I will have to deploy a third set of resources. There are three different resources, maybe on three different VMs, three different like servers, three different clouds and all. So single tenant means a dedicated set of resources for every tenant. And multi-tenant means that the devices of multiple tenants can be managed by the same vManage instance. Rest, when we talk about the controller deployment, we will see the details about it. But here is the software. You can download this software and install it in a virtualized environment. There is no hardware for it. You can download this software and install it in a virtualized environment. Similarly, you can download the software for the vSmart. vSmart is the centralized control plane of the SD-WAN fabric. We have to download the software image of the vSmart. Once we download the image, we can deploy that in a virtualized environment, such as, for example, ESXi, such as Linux-based kernel virtual machine, or maybe like in a virtualized environment in the cloud. We can do also all those sort of deployment actually. And once we have deployed it, we will go to the vManage, and we are going to add our under the devices, under the configuration devices. I'm going to add my vSmart controller, here. I'm going to add my vSmart controller here. I'm going to tell my vManage who is the vSmart controller, what is its username and password, and are you going to use DTLS or TLS for the secure communication check. We can add more than one vSmart controllers as well for added redundancy. We can do that as well, completely our requirement, but minimum one, at least one we will require. We can add more than one as well. We will talk about the deployment configurations of the controller later on, but we can have one or more than one vSmart controllers as per our requirement in our SD-WAN network. So we will deploy the controller. By the way, controller, I mean vSmart controller. And then you are going to go to the vManage dashboard. Here you will go to the configuration devices, and here you are going to add your SD-WAN controller. By the controller, I mean the vSmart controller. Same exact option. If you go for the new version, same exact option is here under the configuration, under the devices. And here we have this concept called control components. They call it now control components. Instead of calling it controller, they now call it control components. And here we can add a controller, or here we can add the validator. So I can click on the controller, add controller, and under the add controller, we can add the controller here, or we can add the validator. They just change the name. Rest of the concept remains exactly the same. So we can add like one or more than one vSmart controllers in our network. What is a vSmart controller? vSmart controller is the centralized control plane, which is responsible to implement control plane policies, such as like what routes can be learned by the devices, what, for example, like policies should be implemented by the devices, control plane policies, like what routes can be learned, how the data must be forwarded, control plane policies, data plane policies. We can implement with the help of the control plane component, which is called vSmart, or in simple terms, it's called controller. Basically, to dissimulate or to distribute the control plane information, such as routes policies between the vManage devices, whatever routes I learn, I will advertise that route to the other vManage devices. Whatever routes I learn, I will advertise those routes to other vManage devices. I will inform about one vManage device to other vManage device. So this vManage device information will be given to this vManage device, and that is how this vManage device will know about this vManage device. That is also part of the SD-WAN controller. It is the responsibility of the SD-WAN controller, the vSmart controller, to tell one vManage device about the other vManage. That is how one vManage comes to know about the other WAN and one other vManage, and they establish a secure communication channel, IPsec tunnels, IPsec encryption keys, policies, plenty of things. Basically, everything that is regarding the control plane is implemented by this centralized controller called vSmart controller. We are talking about the routes, we are talking about the policies, we are talking about the vManage device information, we are talking about the IPsec encryption keys. A lot of things is basically distributed by the centralized control plane of your. So I will learn the routes, I will learn the route, I will advertise those routes to the vSmart, and vSmart will advertise those routes to the other vManage devices by default to everyone, unless we control it with the help of some policies. Centralize the control plane. Centralized control plane basically means the vSmart controller is a centralized control plane that is responsible to manage all the things from the centralized. Control plane functions are managed from the centralized point, referred to as the vSmart, also known as the Cisco Catalyst SD-WAN controller. This is also a software that we can download. This is also a software that you can download from the Cisco website, install it in a virtualized environment, make it reachable with the rest of the components, such as vManage, vManages, and then once the reachability is there, secure communication channel, tunnels, and everything will be established. So for the device to be completely functional, so devices are now just having the data plane functionality. So the devices to be completely functional, they must know about the management plane, and they must know about the control. The devices must know who is their centralized management plane. They must know the IP address of the centralized control plane. They must be able to connect. They must be able to connect to the centralized control plane. They must be able to connect to the centralized management plane of the network, and then only the device will be considered fully functional. When the device connects to the control plane, then it will be able to learn the routes, from the other side. It will be able to learn the IPsec encryption keys, form the secure communication channel, and also policies and all. So these data plane devices must connect to the control plane and the management plane in order to be completely functional. So we have to go to the data plane device, and we will have to inform who is the control plane, who is the management plane of the network. So we will basically, I'm trying to say is that we will need to log into the devices, and somehow we need to tell these devices who is the vManage, who is the vSmart of the network. Go and connect to the vManage, go and connect to the vSmart, go and connect to the controller, go and connect to the manager and controller, so that you get the management plane functions and the control plane functions. Fortunately, we are not going to do it manually. We are not going to log in on each and every device and provide the information about my management plane and the control plane manually. It will be done by a third controller that we have, also known as validator, which we will talk about next in our upcoming class. In our next class, we will talk about what is this vBond? What is this validator? What are the functionalities of the validator? What things it can do? How can we deploy it? How can we download it? All those things we will talk about in our next class. But our control plane functions and the management plane functions, the centralized control plane and the centralized management plane part is now complete. The rest we will talk about in the deployment section, how to deploy them. But what these components do, that part is now complete. We will talk about the centralized, what is this validator, what is this vBond, and how these data plane devices, what are these data plane devices, software, hardware, and all these things. We will talk about them. When it comes to the vManage redundancy, vManage HA, vManage high availability or redundancy, they're like, why will we want to have the vManage redundancy? Even though we have like less than 2000 number of devices, we do not have that much number of devices. We have less than 2000 number of devices. But what we want to do actually, what exactly we want to do, there are multiple services running on the vManage. Like there are different services running on the vManage. And we want to do some sort of like load balancing. We want to do some load balancing. We want to load balance the services on multiple vManages so that the load can be distributed on those multiple vManage devices. For that purpose, we are going to use multiple vManages, such as 3 vManages, and we are going to deploy them in a cluster. We are going to deploy them so we will deploy the first vManage, and then we are going to add the second vManage, then the third vManage. And then we are going to choose, we can choose then what services we want to run on the one vManage, what services we want to run on the second vManage. Else, like if you have to manage more than 2000 number of devices, just in case, if you want to manage more than 2000 number of devices, in that case also you are going to have the multiple vManage deployed in an HA environment. But in that case, you can also have this thing called disaster recovery. In the disaster recovery, we are going to deploy a cluster of vManage in one data center and a cluster of vManage in another data center, and we are going to connect them with the help of some wires. So when we want to load balance the services like configuration database, statistics database, network configuration system, when we want to load balance those services, we are going to deploy the vManage in a cluster. In order to do it, we already have connected like VPN 0 as a transport interface. We have already connected VPN 512. We have already connected VPN 512 for the management purpose, and VPN 0 right here we have the VPN 0 that we have here. We are going to connect one more interface, one additional interface we are going to connect, and that additional interface that we are going to connect, it is going to connect to the VPN 0, and this interface will be used as a message bus. So within the cluster, intra-cluster communication, like in between the devices, when the communication has to take place, that will happen with the help of this wire, with the help of this dedicated wire. The condition for this dedicated interface, the condition for this dedicated wire, that minimum 1 Gbps bandwidth we need to have, and less than 5 millisecond latency we need to have between the cluster member, meaning to say that all these 3 devices will have to place in the same geographical area. We have to place all these devices in the same geographical area. When we do it, when we place those devices within the same geographical area, when we have configured like the devices into the same geographical area with the maybe like fiber wires, or maybe like 10 gig interfaces or 10 gig interfaces, gig links basically, and we have achieved like less than 5 millisecond latency, in that case like there we are going to basically, then the cluster will work properly. It's not for geo redundancy. This clustering concept is for high availability only. It's not for geo redundancy. So when it comes to geo redundancy, we'll have to have the active standby model. So this kind of deployment is not for the geo redundancy. So we will need to have a dedicated interface called message bus. That interface is going to be the third interface. We have to put it in VPN 0. We'll have to configure it with some IP address, and we are going to use that interface in order to have the communication between the cluster devices. So if you want to achieve high availability and redundancy for fault tolerance, or if you want to manage more than 2000 number of devices, or if you want to distribute the NMS service load, for that purpose, we are going to have the vManage cluster. But remember, it is not for the geo redundancy. Minimum 3 vManage devices we will require for the same. Minimum 3 vManage devices we will require. We can have 3, 5, 7, like that. Minimum 3 vManage devices we need to have, and there will be a dedicated interface for the cluster communication, for the communication between the devices in the cluster. So vManage servers form a cluster for redundancy and high availability. All the devices in the cluster, they act as active nodes. Basically, all the members of the cluster must be in the same data center in the metro area. It is not for geo redundancy. If we want geo redundancy, in that case, you have to deploy the vManage in active standby model. In that case, it's not going to be cluster, and the database will be replicated between the active and standby vManage devices. So it's this clustering concept is not for the geo redundancy. For geo redundancy, we have this concept called disaster recovery. For geo redundancy, we have this option called disaster recovery. So when we deploy one set of vManagers in a cluster on one metro location, then we have deployed another set of vManagers in another location, and we have connected them with the help of the wire. The database, we have enabled the disaster recovery, then the database replication between the sites will happen. And if one vManage goes down, or maybe like all the vManages goes down, it will not have any impact on the fabric operation. Maximum to maximum, you will not be able to do any administrative changes. You will not be able to do any statistics collection, but you will not be able to. The loss of the vManage servers has no impact on the fabric. Data plane will keep operating even if your vManage goes down, even if your vSmart goes down, or even if your vBond goes down, does not matter. If all these controllers go down, does not matter, your data plane will still keep operating. Maximum to maximum, you will not be able to manage all those devices from the centralized point. You might not be able to post the templates, policies, all those things. No new device can join the fabric if just in case your validator has gone down. But your existing devices, all the existing devices, they will keep operating based on what information they have, and for of course a predefined time period. It's not like permanent. They will work for a specific time period, and then after once it's done, then after they are going to then the IPsec tunnels will go down and the reachability will not be there.
Even vManage goes down, it will going to work up to 12 hours only?
No, if the vManage goes down, then you will not be able to do this. Only when the vSmart goes down, then IPsec encryption keys will not be able to refresh, so OMP peering will go down. Routes will be considered as invalid. So it's for the vSmart, not for the vManage. vManage is just for the management. So you will have to log into your vManage. You will have to log in to the vManage, and you will have to go to that cluster management option. We are not going to do it, just for your reference. I'm going to show you how it is done. You have to log into the vManage dashboard. You have to log into your vManage, and you are going to, once you log into the vManage, then you are going to go to this option called cluster management. There is an option within the vManage dashboard. There is an option called cluster management. So you are going to go to that cluster management option, and from there you are going to do clustering concept. So you go here on the vManage dashboard. You go to the vManage dashboard, and you are going to go to here, administration, and there is this option called cluster management. Click on it. Here at the moment we only have one vManage, like we covered in the last class. The vManage is being used for the compute and data both. All the services are running on the particular vManage. If you want to see how many number of devices this vManage is managing, so you can click on the vManage. You will be able to see all the backend services running, and you will be able to see manage the devices. You will be able to see what are the devices being managed by this particular vManage network management station. So first of all, under the vManage detail, it shows you like what are the services running on that particular vManage. And under the, you can see under the managed devices, you can see what are the devices being managed by this particular vManage. Details along with the details. So if you want to manage, if you want to add another vManage, the very first thing you will have to do, you will have to click on these three dots. You will have to edit, and you will have to change the manager IP. You will have to configure the IP address on the vManage. So it's already there, but here, right here, under the cluster configuration, it says localhost. So we are going to change it, edit it, and here we are going to provide the IP address. Here we are going to provide the IP address of the third interface that we have. Whatever interface we are using for the cluster management, in the drop down, we are going to select that particular interface. That interface is also part of the VPN 0. So when you boot up, when you configure the IP address on that interface will also show here. You will be able to, in that case, you will be able to select that third interface IP here. And once you select that third interface IP here, then you can click update. Remember that when we do it, like you'll have to provide the username and password. When you click update, then the application services will go down and they will come up again. And then after once it's done, then once it's done, then you will be able to see the IP address on this particular interface. So first of all, you will have to set up the IP address on the interface. The very first thing is that the cluster interface that we have, we will have to set up the IP address onto that interface. Same steps we are going to repeat on the second vManage. Same steps we are going to repeat on the third vManage. We are going to repeat the same steps on all the vManages, and then I will go to my primary vManage. I will click on the Add vManage button. I'm going to click on here the Add vManage, and from here I'm going to add. First of all, it will ask me to configure the IP address on the local interface. Once done, then I'm going to select. Then I'm going to provide the information about the second vManages from here. Here we are going to write down the IP address of the second vManage, then the third vManage, and then once we are done adding it, then you will notice that the devices will boot in a cluster. Just to show you, I will show you document actually. Let me show you if some sort of cluster they have created. Right. So here is one video. There are plenty of videos available on the internet that you can look up, but this is one of the video that you can look up. So just follow the steps if you want to. So first of all, what they are doing, they have deployed like multiple vManages. This is vManage, like this is one of the vManage, then the second vManage, then the third vManage. Then they are connecting it, they are configuring it. They are doing the configuration from the scratch. They are setting up the first vManage. So once they are done doing it, so it comes up, everything is okay. Right, so they will configure the third interface. So third interface, second interface, whatever it is. So they are going to configure the interface, configure it with some IP address, and then they are going to configure the IP address on the second vManage, configure the IP address on the third vManage. As you can see, they are doing the IP address configuration on all the vManages. So the IP address that they have configured is 20.1.1.1, 2, and 3 respectively. And then they have configured the route to reach to the outside network. And then we are going to go to the vManage. This is the vManage dashboard. Here they will go to the administration. Same point, they will go to the administration, cluster management, and they are going to select the IP address of that interface here on the first vManage. Provide the username, password, and then once they save it, the application services will stop, and it will the vManage will start again after some time. Then they will take the access, they will configure. We'll have to wait basically for the vManage to enable the application services again. So 20.1.1.1 is now up, and now they are going to add the vManage. Click on Add vManage button, and here we are going to provide the IP address of the vManage, whatever is the IP address of the vManage, and the username and password of that vManage. So you go to the primary one, and node is being added to the cluster. Operation may take up to 30 minutes and may cause application services to restart in between. Once the application server is back online, post-cluster operation, progress can be viewed under the task list. Right, so once it happens, once it's done, once all the application services are running, you can see now we have two vManages, and we are now going to add the third vManage here as well. Same step, same process. So basically configure the IP address on that interface and provide the IP address here on the device, and you will be able to add all those three vManages in a clustered format. And then you want to add 5 while adding it, you can choose the persona. Maybe out of these 3 vManages, you can choose one vManage specifically for computations, one vManage specifically for the data storage. That you can do as well. So of course that you will have to do. You have to install the certificates and all those things. No need to tell you about the certificate process and all. So you will still need to install the certificates and also all that process. So this is how the clustering is formed. Not a very difficult process. This is how the vManage cluster is basically formed. Clustering concept is pretty much like easy, but when it comes to like disaster recovery, that is a different kind of thing. When it comes to disaster recovery, That is a different kind of thing. For the clustering, it's okay. For the cluster, it's okay. The steps are very simple. But when it comes to disaster recovery, that is some different thing. For disaster recovery, you are going to go to the same point, but here we are going to go to the disaster recovery option. So make sure that we have deployed a cluster of a 3 vManage at one location. We have deployed a cluster of 3 vManage on a second location. So here is the active cluster. Here is the standby cluster. Here is the DC. Here is the DR. So we have deployed it respectively, and we are going to click on administration disaster recovery, and we are going to click on the manage disaster recovery button right here. And here we are going to provide the IP address of the active cluster. Here we are going to provide the IP address of the secondary cluster. The IP address of the primary cluster, the IP address of the secondary cluster, the username and password. Then what is the validator? Who is the validator? We are going to provide the information about the validator as well. Then recovery mode, either manual or automatic. Recovery mode we have to provide here. Do we want to have like automatic recovery, or do we want to have the manual recovery? That we will need to provide here. And then replication schedule, because in case of like active standby mode, the database will be replicated from like one active cluster to the standby cluster. So for that, the replication schedule, like when do you want to replicate the data, at what time you want to replicate the data between the devices, that we will need to configure here. Once you fill up all these information and click on submit button, then you will start seeing the active cluster here. You will start seeing the standby cluster here. And once all that thing is done, right here in this diagram, the information will be shown. You can refer to again, I'm sending you one more video for the same. If you want to take a look at that, you can check here. There's a one more video for the same. So here you can see, if I refer to this video, here you can see that it's an old version, by the way, but the steps remains pretty much the same. So here, like first of all, they are configuring. They are configuring like a cluster. They have configured the IP address on the third interface. We'll have to configure the IP address on the third interface. So they are doing that. And then so this is the primary node. Then they went on the secondary node. They took the access of the secondary vManage, and there also they configured the IP address. And then click on the manage disaster recovery. Provide the information about the active cluster. Provide the information about the standby cluster. So you are going to give the IP address of the primary and secondary cluster respectively. So 192.168.254.2 username password. The secondary IP is whatever it is. So that IP address, username password, and then who is the vBond? The vBond information, the vBond that we have, that information we will need to provide along with the username and password. And the recovery mode is going to be either manual or automatic. If you are going to have the manual recovery mode, that means like when the active cluster goes down, it is your responsibility to switch over. It will be your responsibility to switch over to the next active cluster. Automatic failover or automatic recovery. Automatic recovery basically allows you to detect the failure in an automatic way and inform the standby cluster to become the active cluster respective. So for that purpose, if you want to go for automatic recovery, you will need to deploy something called an arbitrator. If you want to go for like automatic recovery, then you will have to deploy this thing called an arbitrator. So if you go for automatic option, you will have to deploy this thing called arbitrator. What is an arbitrator? Arbitrator is just another vManage. Arbitrator is just a vManage that we have deployed in a third location and made it reachable with the active and made it reachable with the standby device. So this the topology will become something like that. So here is the DC, here is the DR, here we have like an active cluster, here we have like the standby cluster, and in between we have an arbitrator, something like that. The reachability will be something like that. So in this case, the arbitrator is responsible to detect. The arbitrator is basically responsible to detect if the active cluster is up or not. If the active cluster, for example, goes down, it is the responsibility of the arbitrator. To send some API call and make this standby cluster as the active cluster. So both kind of recovery is there. Both kind of recovery, both the types of recovery, I will say, both the types of recovery is there. We have the recovery mode as automatic, or we have the recovery mode as manual. In the manual recovery, when the active cluster tool goes down, it is your responsibility to switch over to the the standby one. And in case of automatic recovery, the arbitrator is going to do it for you. So configurations are needed for the same as well. 3-node cluster at one location, 3-node cluster at second location, and then in between arbitrator, so that like the failure can be detected and failover can happen respectively. So the point is that both like active and active standby, both the models are available. Both the types of recovery are there, and both of the recoveries can be managed via the vManage GUI itself, the administration, cluster management, and the disaster recovery. vManage the only device in the set of these controllers. vManage is the only device that supports this kind of thing. vManage supports this kind of thing. The vSmart and the vBond, they do not support this kind of deployment. By the way, if you see that the devices are not reachable, just restart the devices. Power it off. We did not onboard it, so no need to worry. But power it off and just power it off. If you see that the devices have gone unreachable, then just power off and power on. Just power off and power on the device, and you will see that the reachability will again. This lab is running continuously 24/7. I'm not powering it off, so sometimes that happens that the devices, the VHs, they go down automatically. So you just need to stop it and start it. Then once they boot up, the reachability will be there, and you will be able to see all the 3 vManage devices reachable here again. So this was the overall HA part. That we will have to cover, that we had to cover theoretically. We did not need to do it like practically. So HA part, we did like as much as we can. For example, like in the vSmart, we can have the controller group ID, controller group list. We have the FQDN. We have talked about all that. As much as practical we had to do, we have done it. And for the vManage, of course, we will not be able to do it. It requires a lot of resources. One single vManage requires at least like 32 GB RAM. So if you deploy like 3 vManages, 32. If you deploy disaster recovery, then multiply 32 by 6 total. So this is from the controller recovery. This is the controller HA. This is the controller HA part. The vManage devices also. The vManage devices that we have in the network, the WAN edge devices that we have in the network, there also is a problem associated with those vManage devices. The number of concurrent data plane tunnels supported by the vManage devices are also limited. It varies hardware to hardware. For example, if you are using a VH100 series device, the concurrent IPsec tunnels that can be created is 250. When we configure the VH1000, then the concurrent IPsec tunnels that can be established is 1500. VS2000, 5000 have a limit of 6000 number of concurrent IPsec tunnels. So number of concurrent data plane tunnels supported on the vManage hardware platform varies actually. The problem is that if a vManage device is connected via multiple transport, if the vManage device is connected via multiple transport to other vManage device, by default it will try to establish the connectivity. Over all the available transports. So here, and here. If this IP is reachable with this IP via 3 transport, then the problem is that too many number of IPsec tunnels will be there. Too many number of IPsec tunnels will be there. By default, full mesh, if you remember, full mesh IPsec tunnels are there. So every vManage device is supposed to establish the tunnel with every vManage device over all the available transports. So if you have n number of transport, n number of IPsec tunnels with every vManage device will be established. So if you have n number of vManage devices connected over n number of transport, then we will have like a lot of IPsec tunnels. The limit of the hardware might reach and the device will not be able to establish more tunnels afterwards. So we will have to take care of that as well. We will have to make sure that the limit of the maximum number of IPsec tunnels does not reach on these data plane devices as well. So instead of having a full mesh topology, what we can do, here, we can in fact configure partial mesh topology. Instead of full mesh topology, we have the concept of like partial mesh topology. We can configure some policies in such a way. Let's say we have different WAN devices in different regions. What we can do, we can create some policies in such a way that, for example, the devices in the region 1 are supposed to form the IPsec tunnels with each other. The devices in the region 2 are supposed to form the IPsec tunnels with each other. The devices in the region M are the n number of devices that we have in the region M, they are supposed to form the IPsec tunnels with each other over all the available transports, but the devices in the region 1 cannot establish the tunnels with the other regions, limiting the total number of IPsec tunnels that can be formed on a particular vManage device. The problem in this kind of topology actually is that how the reachability will be there in that case. If you are limiting who can establish the IPsec tunnel with whom, how the reachability will be there. How the devices in the region 1 are supposed to communicate with the devices in the region 2, region 3, region 4, and respectively. Again, we are going to configure the topology in such a way that internal devices, all the internal devices of the region are supposed to form the neighborship with each other, but the border devices, we have some devices, as you can see in the topology, we have some devices acting as a border device. We have some devices acting as the border device. And these border devices are supposed to form the IPsec tunnels with the other region border nodes. We have identified in our topology, what devices are the border devices, and we have allowed them in the policy that we have deployed. In the policy, we have allowed them to form the IPsec tunnel with all the other border devices of the other region over all the available transports. So whenever the data has to pass from this device to this device, or maybe this device to this device will send the traffic to the border will send to the border, and from the border the traffic will be sent to the internal device. So you have to think carefully, and you will have to create the policy in such a way that all the internal devices will form the BGP neighborship with each other. They are not allowed to form the BGP. They are not allowed to form the IPsec neighborship, not the BGP. They are not allowed to form the IPsec neighborship with the other region devices. Only the border devices that we have in the region, they are supposed to form the IPsec neighborship, IPsec tunnels with the other region devices. And whenever any device wants to send some traffic, they will send it to the border, from the border to the border, then the border to the device. Regional mesh. Within the region, I have a mesh topology. Regional mesh. But we have the regional mesh topology, but the borders are kind of like in a full mesh format. We are connected with the other full mesh tunnels between the border vManage devices. Full mesh tunnels between the SD-WAN devices in the same regions. No direct IPsec tunnels from the internal devices to the other region devices. So if you have like n number of devices in this region, the maximum number of tunnels that we have to form is going to be just n-1, where n is the number of vManage devices, assuming that there is only one device on the site. Better than this, instead of having the regional mesh, I can have some sort of like hub and spoke type of policy as well. I can designate these devices as the hub devices of this region, and all of these devices are supposed to form the IPsec tunnels only with the hub device. They are not supposed to form the IPsec tunnels directly, thus limiting the number of IPsec tunnels that can be formed within the region as well. Same thing I can do here as well. Same thing I can do in other regions, for example, as here, all these things we can do. Regional hub and spoke kind of topology we can also have, So when this device sends the traffic, the device will send the traffic to the hub will send the traffic to other hub, and from here the traffic will go here. The traffic within the region can move from here to here via the hub router, or we can have the concept of dynamic tunnels, where we can have the concept of dynamic tunnels where the IPsec tunnels will be built on demand basis, where the IPsec tunnel will be built on demand basis. Basically, plenty of options are there. What kind of topology you want to have? Plenty of options are there. We have regional mesh, we have full mesh, we have hub and spoke. A new concept is there also. A new concept is there also as well in the SD-WAN nowadays. Not nowadays, like it has been there for quite a long time, but there is a new concept, there is a new way to deploy the SD-WAN in a large scale network. In a very large scale network, we do have the option to deploy the SD-WAN in a different way. They call it like, read about it. They call it like multi-region fabric. They call it like multi-region fabric architecture of the SD-WAN, or MRF architecture of the SD-WAN. This architecture explains like how can we deploy the SD-WAN in a very large network where we have like multiple regions, In every region we have a few number of devices, and we want to limit the IPsec tunnels between the WAN devices, and we want to have complete communication from the one region to other. MRF, if you study like MRF architecture in the MRF SD-WAN, just search the MRF architecture in the SD-WAN, and you see Cisco SD-WAN multi-region fabric. Multi-region fabric using multi-cloud. So multi-region fabric, how the multi-region fabric is there, how the multi-region fabric is configured. This is specifically, I believe, for the cloud. There is a normal multi-region fabric as well. Implementing and troubleshooting multi-region fabric here. This is one of the documentation from the Cisco itself, where they have described like how to deploy the MRF architecture in the SD-WAN when it comes to deploying the SD-WAN in multiple geographical regions. How the connectivity will be there. Some routers will be designated as the border routers. Some routers will be designated as the edge routers. So basically, they came up with the idea of this thing when people started asking like the Fortinet firewall is giving both SD-WAN and firewall capabilities. What are you giving actually? So the Palo Alto firewall is giving firewall and the SD-WAN capability. What are you giving? So they came up with the idea of this multi-region fabric where we can deploy the SD-WAN in a very large network with the help of this concept of MRF architecture. So the configuration happens in a different way, but you can go through it if you want. Then they came up with the idea of SD routing. Learn about that as well. Not part of our content, not at least yet. Maybe they might add it later on. But then they came up with the idea of SD routing. One of the biggest challenge for the SD-WAN was like iOS XE SD-WAN, for example, the compatible devices needs to be there. But with the feature of SD routing, the traditional devices that we have, with the help of the feature called SD routing, it allows the vManage can also manage some non-SD-WAN devices as well, where we have not configured the SD-WAN functionality. There we have not configured the SD-WAN. The devices are not configured for the SD-WAN, but we can still manage those devices somewhat like from the vManage itself. So SD routing, they also came up with the idea of SD routing. Just search about SD routing and you will know about it as well. So device lifecycle management, monitoring and assurance, software-defined security policy, software-defined multi-cloud integration. Some benefits are there. The major point of the SD-WAN deployment is that we need to have all these controllers like control plane, controller, manager, validator. But when it comes to SD-WAN routing, in SD-WAN routing, we do not need to deploy a controller. The control plane operation still remains on the devices itself. There's no such concept of centralized control plane, just the validator and the manager. Basically, it's a different kind of architecture. It is majorly used for these purposes. If you want to, like, for example, do the software upgrade on the multiple devices, you want to monitor the application devices, stats, and all that thing, configure support for all the features in WAN branch and aggregation use case, enforce the security, secure internet gateway integration, cloud integration, migration. So more features on upcoming release. So these are some features available in the current SD routing option. Later on, they might add more and more feature. The major difference between the SD router and the SD-WAN is like in the SD-WAN, there is a concept called centralized control plane with the help of the vSmart controller. But in SD routing, the control plane remains on the device itself. Only the centralized management is done from the vManage device. So we don't need the support of OMP protocol. We do not need the support of like OMP protocol. The Catalyst SD-WAN Catalyst SD-WAN manager can now manage the traditional WAN as well as the software-defined wide area. Read about it as well. You might encounter the MRF architecture and you might encounter the SD routing in your production environment sooner or later. If just in case your company is working on a large-scale network, then you might encounter these options in your production environment. Not all the devices might support it. So software version, you will need to cross-check. You will need to cross-check the software version. So in future, they are adding like more and more releases. But up to August 2024, multiple options are basically now available in the SD routing. There are a few videos as well if you want to go through it. You can just search on the YouTube about the routing and you will see a few videos there as well. Overall point was that in order to limit the number of IPsec tunnels between the managed devices, we can have this concept of regional mesh, hub and spoke, partial mesh, or we can have like full mesh. We have different options available with this. The HA part from the high availability part from the controller point of view is now done. So everything is now okay. Now we have like all the devices here. We have the devices here. And now we are going to deploy. We are now going to configure the devices with the help of this concept called template. We are now going to configure the devices with the help of this thing called a template. When we want to configure n number of devices, how can we deploy those n number of devices? How can we configure those n number of devices at once? How can we do it? That we are going to now talk about with the help of templates. We can do it. We can do it with the help of the templates. So now we are going to focus on the template configuration. So if you want to manage multiple devices, if you have to configure multiple WAN edge devices, if you want to configure multiple routers, let's say, for example, you want to configure OSPF. Let's assume that we want to configure OSPF on the LAN side. And we want to configure OSPF not only on one, but we want to configure the OSPF on multiple routers. I want to configure OSPF on the router 1. I want to configure OSPF on the router 2. And I also want to configure the OSPF on the router 3. Some routers belong to one location. Some routers belong to other location. Either we can log in to the device and configure the OSPF manually, or we can configure this thing called a template. We can go to the vManage dashboard, and from there we can configure templates right here. We can configure this thing called a template, and we can configure a device template. Under the device template, I'm going to define the device configuration. I'm going to configure here. I'm going to define what do we want to configure, what I exactly want to configure, what exactly I want to configure. I want to configure OSPF, maybe EIGRP, maybe some other things. What exactly do I want to configure? That I'm going to define in this device template, and I am going to attach that device template with multiple devices. I can attach that device template with n number of devices. Once I do it, whatever configurations we have defined here will be pushed on all these devices. In this configuration, we can have fixed values and we can have variables as well. Some configurations that might change based on the device specific configuration, for example. The configurations that are device specific, such as host name, such as system IP, those configurations that are device specific to the device, that we can define in the template that these configurations are device specific. They need to change actually. That these configurations are device specific, so we need to change these configurations actually. When we push the configuration, when we push that template onto the devices, vManage will ask us what configuration, what are these device specific things, device specific values that you want to fill, device specific values that you want to fill, the device specific values that you want to. And then once we fill all that thing, when we push it, then only the configuration will be delivered onto the devices. Device templates are attached to the devices. Simple. Device templates are attached to the devices. In the device template, we define the device's working configuration and we push those configurations onto the devices. Those configurations, some of those configurations might be like fixed, like such as, for example, maybe the same time zone, maybe, for example, same time zone, for example, same syslog server, same DHCP server, for example. But some configurations might also vary. Some options, some configurations might also vary based on the device to device. So in the template, we are going to define what configurations are fixed, what configurations are delivered, what configurations we'll have to deliver on all the devices like as it is, and what are these variable values. And then we are going to push the template onto the respective devices. When we push it, it will ask, when we push it, it will ask what are the variable values that you want to push? What are the variable values that you want to push? When we define all that, once we define all that, then only the configuration will be delivered on the. So device template. Device template defines the device's complete working configuration. Device template defines the device's complete working configuration, and then we configure the model specific device template. By default, there is no device template. We configure model specific device template by going to the dashboard. For example, here, device template, create template, and we are going to create the device template either with the help of the feature template or with the help of the CLI template. So what is this CLI template? I want to create a device template with the help of the CLI template. I want to create a device template with the help of a CLI template. So I will click on device template, I will click on create template, I will click on the CLI template, and then we have to specify the device. For what device? I can create the templates for different models available in our production environment, and I can create a template for our controllers as well, such as vSmart in the vManage. So let's say we have multiple vSmarts. Let's say we have 3 vSmart controllers, vSmart 1, vSmart 2, and vSmart 3. And what I want to do, I want to push, I have configured first vSmart, and I want to take those configurations that I have done as a reference, and I want to configure the second and third vSmart as well. So I will select here that I want to configure a template for the vSmart. The name is like generic, for example, template, whatever you want to for vSmart, you can just give it a name. And right here, you can give it a description, whatever. I'm going to copy and paste the same. And since we are configuring the template for the vSmart, I am going to fetch. We already have onboarded one of the vSmart, so I'm going to fetch the running configuration from the vSmart controller. I have fetched the running configuration from the vSmart controller, and now whatever fields I want to mark as variable, because I am going to push this template on 3 vSmart, and on those 3 vSmarts, for example, the host name is going to be different. So I'm going to select it, and I'm going to click on create a variable, and I'm going to say the variable name, for example, is a host name, and create variable. So now this value is now substituted with a variable. The host name that we configured is now substituted. It is now substituted with a variable. For example, system IP. System IP, of course, cannot be same, so I can mark it as variable. For example, the IP address. It cannot be same, so I can select it and I can create variable. I'm going to say IP address, for example. The next hop maybe, for example, it might be different, so I can select it and create like the variable, such as, for example, next hop, and create variable. Whatever fields in this configuration you think are variable, whatever fields in this configuration you think are variable, select and mark those values. Select and mark those values as variable. Select and mark those values as variable. Add. So we have configured a device template with the help of the CLI template. This is what we were using in earlier days. In earlier days, this is what we were using. Nowadays, we have the option of feature templates, but in earlier days, we were using this CLI templates very heavily. Then I'm going to click on these 3 dots, and I'm going to click on attach device button, and here I am going to attach my controllers. So we have 3 controllers. I'm going to select all these 3 controllers, and I'm going to click on the attach button. Then whatever values, whatever things you have marked as variable, so you can see the cross. Cross basically means that the configurations are not proper. So whatever things we have marked as variable, we will have to edit it. And we are going to fill the things such as, like, for example, the host name, the IP address was 100.1.1.2, by the way. The next hop was 100.1.1.100, by the way. So whatever information we marked as variable, we have to fill that information here and then click on the update button. Now you can see that status okay, and now you can click on the next button. So while configuring the templates, we can mark the values either as variable or we can mark the values as fixed. Fixed basically means the values that do not change, and the variable basically means the values that change. The values that basically change based on the device to device configuration. And when we attach the device, it will ask. When we attach the device, it will ask us to fill those values. It will ask us to fill those values that we have marked as variable. So we are done doing it, then we can push that template onto the particular device. I can see, click on this device. I can preview the configurations before we deliver them. So config preview button. Config preview basically means like preview the configurations before you deliver them. So config preview. This is the configuration. This is the configuration that is going to be delivered, by the way. You can see the config div. You can see the side-by-side differences. You can see the differences between the configuration. You can see the differences, inline difference. You can see the inline difference. You can see the side-by-side difference. You can preview the configuration, the configurations that are going to be pushed onto the device, config div, side-by-side div, inline differences. You can see all that thing. Intent, you can click on the intent button as well to get some info as well, and just click on the configure button. So it will push the configuration on that particular. It will push the configuration. It will do some checks, and then it will push the configuration on the vSmarts controller. If you have configured multiple vSmarts, it will validate the basic things, and then right here it will push the configuration on the device. Click on this action button and see what is going on in the backend. If there is some error, the error will be shown right here. Read the error and correct it. If there is some error, then the error will be shown right here. You will have to read the error. You should know how to read that error, and you should know how to correct that error. So read the error, correct it, and push the template again. Fortunately, at the moment we did not get any error, so things are now okay. The device done. So the device, the vSmart controller has now been configured with a template. I can check it. I can cross-check it. I can check if the template is there or not. So I can click here. I can go to the configure. I can go to the template, and I can see that with this template, we have one device attached, and the device is the vSmart controller. Very easy. Create template, CLI template, select the model, for example, vManage, define the name for the template, define the name for the template, description for the template, fetch the configuration from a reachable vManage, just in case if we have any. So fetch the configuration from a reachable vManage and mark whatever fields you want to mark as variable, mark whatever fields you want to mark as fixed. Once done, click on the add button. So we have added a generic template for the vManage. I can edit it, by the way. I can edit it before we push it. I can just edit this, like, I can edit the name, for example. I can edit the description, for example. I can still mark the values as variable, for example. I can update it. I can edit it if I want to. And then just click on here and just attach the device. And what device we want to attach? Here we want to attach our vManages. We have different vManages. We are attaching the vManages here. So select it, attach, and before we push the configuration, we can validate what configurations are being delivered. We can cross-check what configurations are being delivered. We can check the differences between the current configurations and the configurations that are being pushed. We can check the side-by-side difference. We can see the inline difference. We can do all that. And once we are satisfied, then we can click on the configure device button so that the vManage pushes the template onto the particular device. It will do some checks. Once it's done, then it will push the template. Once the basic checks are done, then it will start pushing the configurations. It will start pushing the configs with the help of the template on the device. So now if you go to the templates option, now you see we have the device template. We have two templates, one for the vSmart, one for the vManage, and we have one device attached here and one device attached. The problem with this actually is when we attach the template on the device. The problem is we can't now do local changes. Anything you want to change now, even if you want to just do a even if like you want to do just a basic shutdown onto the interface, you cannot do it. You can go on the vManage vSmart, for example, and you can cross check that you can't do any local configurations anymore. Even if you just want to do a configure terminal, VPN 512, interface ETH0, all I wanted to do is to just do the shutdown, and it will not allow us to do it. Device is being managed by the vManage. Configuration through the CLI is not allowed. So we can't do the configurations. Since the device is now vManaged, the device operational mode, the device can be in the either CLI mode, or the device can be in the vManage mode. If the device is in the CLI mode, we can do all sorts of changes. But if the device is in the vManage mode, then we cannot. If the device is in the vManage, then we unfortunately cannot do the changes locally. The only case when you will be able to do the local changes is when you break the reachability with the vManage. If you break the reachability with the vManage, then only you will be able to have the local, you will be able to do the local changes, else not.
Actually, I hear that if you are configuring into CLI mode, then device it will change it into vManage mode into CLI mode, like that someone told. Is that true, or we can't able to do any changes in
We cannot do any
CLI?
We cannot do any changes. The device is in the vManage mode. We cannot do any changes via the CLI. Only verification commands you can do. Show version, show clock, and all those things. Those verification commands you can execute, but you can't do any configuration changes via the CLI now.
Even vEdge everything, right?
Whatever devices we have configured with template on those devices, you cannot do any changes via CLI.
Okay, understand. Thanks.
The only case when the changes will be allowed locally is basically when the reachability goes down. If let's say, for example, your vSmart loses the reachability to the vManage, the vSmart was managed, the vSmart was attached with the template, and your vSmart loses the reachability to the vManage somehow. The control connections have gone down. Show control connections, the control connections have gone down. Then, of course, you can do. Then VPN 512, interface ETH0, shut, commit. Then you can do. If the reachability, if the control connections have gone down, if you are no longer reachable to the vManage, then it is allowed to do the local changes. But when you do the changes, it will throw up a warning. It says that device is being vManaged. This device is being managed by the vManage. Any configuration changes that you will do via CLI, will be overwritten by the vManage after the control connections are up. So even if I do the changes, I have shut down that interface, by the way. You can confirm show interface description pipe tab. You can see that I have shut down that interface, by the way. And as soon as my control connections are back up again, you can see when the control connections come up, just to wait for the control connections to come up. Once the control connections come up, the template configuration will be pushed, the configurations will be pushed by the vManage again, and you will notice the interface that we shut down. Once the control connections are up, wait and see. You will see that the interface will again come up. So wait for the control connections to come up with the vManage. Once it comes up, it's up almost. And let's see. Wait. Let the vManage push the template onto the device, and you will notice that this interface, VPN 512 interface that we shut down, you will notice that the interface will come up again. See, I did not do anything, and it came up. Point is, the template configurations are final. Whatever configurations whatever configurations we have done via CLI after our control connection has gone down will be overwritten when the vManage comes up. So make sure that if you really want to do some changes, if let's say, for example, you want to do the changes via CLI and you know very well that the changes will not be there once the control connections come up, then better to do those changes. It is better to do those changes in the template first and then do the changes in the CLI. Let's say when you push the template, when you push the template onto the device, because of the template push, let's say the reachability has gone down. And you have identified the problem is that the IP address is incorrect. You are supposed to configure the IP address like 100.1.1.2 and accidentally you configured the IP 10.1.1.2, which is incorrect. So when you push that template, when you push the configuration with incorrect, for example, IP address, the reachability will break. If the reachability breaks, then the vSmart will allow you, for example, Smart will allow you to do the local changes. You will do the command, you will run the command, show interface description pipe tab, and you will come to know that, oh, IP address is incorrect. Then since the local changes are allowed, you will go under the VPN 0 interface ETH1 and you will configure the IP address and everything. You will correct the IP. And as soon as you correct the IP, the reachability will be up. And as soon as the reachability is up, the vManage will again push the template. So again, the IP will change. Again, the IP will change. By the way, just in case if you want to see, just do the changes. Just edit this template, and in the template, just the IP address that we have configured is variable. So just to change the device value and change the device value accidentally from 100, change the device value from 100 to accidentally 10, and see what happens. Next, configure. So now the configuration changes will be delivered. Now the configuration changes will be pushed to the vManage. The configuration changes will now be pushed to the vManage, and the IP address that is 100.1.1.2, it will now change to 10.1.1.2. Wait, let the configuration go to the vSmart. You see, what does it say? It says incorrect. It says failure. Okay, what is the failure? Generating the device, sending the configuration to the device, the configurations have failed. So it's not device failed to process the request. Device failed to process the request. What is the error actually? What is the error? Learn how to read the error. So here, right here, read this error. The error is device failed to process the request. Error is where? In the VPN instance, like in VPN 0, interface, ETH1, IP address. The IP address and system IP cannot be in the same VPN 0. See, this is the error. Now read the error and correct it. So no problem. I will push a different IP address. No problem. I will push a different IP address. Maybe I'm going to push the IP address, let's say, accidentally like 100. Instead of 100, I accidentally put like 200. Understand when the IP address was delivered. Understand that when the IP address, when it is delivered onto this device, if the vManage is able to successfully deliver the IP address on here, the reachability will break. And once the reachability breaks, you see the IP has changed. The IP address has changed. The IP address has changed. The template configuration push was successful. This was successful, no, but it will stuck here. It will stuck here. Why it will stuck here? Because now the reachability has broken. Show control connections. The reachability has broken. Once the reachability is broken, you will of course not be able to have any control connection with the controller, with the managed devices. You can do the local changes, right? So VPN 0 interface ETH1. You saw that the IP was incorrect. So what you did, you tried to correct it. IP address 100.1.1.2/24 and commit. You tried to commit the IP addresses. It says that we can't do it. Why we cannot do it? Because the vManage still is pushing the templates configuration. So now wait until this process is complete. Once this process is complete, then you will be able to see that you will be able to do the local changes. But as soon as you correct it, as soon as you correct the IP, the reachability will be there again, And as soon as the reachability is there, the vManage will push the same template configuration again, and the IP will change right away. IP will change again. So if you really wanted to do the changes, what you should have done, if you really wanted to do the changes, it will stuck here, by the way, because the reachability has broken. It will stuck here. If you really want to do the changes, in that case, you first must have edited the template and then have done the changes via the CLI. So even when the reachability comes up, the IP address and everything is still correct, and the ping and every process will work accordingly. This is stuck now. This task is stuck now. This task is now stuck. This task is stuck. Why it is stuck? Because when the vManage pushed the configuration, the IP address of the vSmart controller changed, and since the IP has now changed, the reachability is not there. So vManage is not able to confirm if the changes are really done on the device or not. So it's stuck here. How to clear this process? If you want to clear this process, you can clear this process with the help of an API. HTTPS 192.168.10.71, which is the IP address. It is the IP address of our vManage, and I can go here and I can execute the command data service /device /action /status/tasks. This is the API call that we have to this is the API call that you will have to do. The API call I'm sending in the chat itself. So the API call is like the IP address of the vManage, data service, device action status task, enter, and it will show you all the pending tasks. If the URL is correct, it will show you all the pending tasks that are currently going on. HTTPS 192.168 actually, not 169. 192.168.10.71 data service device task, and you see this is one of the ongoing tasks that is going on. This is one of the ongoing tasks that is going on. The task is to push the template onto the device, and it is in progress. Then I want to clear it. So URL data service device action status task, and I'm going to say /clean. And what do I want to clean? I want to clean the task with the process ID PROCESS ID is equal to, and the process ID is right here. This is the process ID. Enter. Success, and you see here, done. It's gone, cleared, basically. Very handy, I will say, API call that we can use to see what processes, our tasks are ongoing tasks, and we can clear it just in case if we get stuck somewhere. Link I have already pasted in the chat. By the way, so the reachability has gone. Down. So we validated that the reachability has gone down, and we found out that the reachability has gone down because of the incorrect IP address. So we corrected the IP, we did commit was complete, show interface description. Now the interface is basically up, show control connections. The control connections will also now come up. You can see the control connections have come up, and now once we push the template again, once we push the template from the vManage again, once the vManage pushes the template configuration again, the IP will change again to the incorrect IP address, and the reachability will break again. So we might need to wait, but once it happens, you will notice that the reachability will break again. So make sure that the values that we have is correct. Here.
So we have cleared that task, right? If in case we have
your audio is cutting off like a lot. You're not audible properly. Your audio is breaking up actually. You can put the question in the chat, by the way. Make sure that the values are not incorrect. Else you will lose the reachability. CLI template. These are called CLI template. We can create the device templates with the help of the CLI template, where any text can be replaced with a variable, and we can deploy these CLI templates with the help of the device template as it is. These are heavily used in the past before the introduction of the feature template. How to apply this? Click on the attach device button, select what device you want to apply to, and just apply that onto the respective devices. The mode will be converted into the vManage mode. The mode will be converted once we attach the template onto the device. The mode will be converted into the vManage mode. And remember that if the device is in the vManage mode, we cannot do the local changes.
Sir, how can we check if a device is in local mode or vManage mode?
You can take a look at the device itself. So here, you can go right here. You can go to the monitor. You can go to the devices, or maybe configuration devices. You can go to the configuration devices, and right here you can cross-check if some sort of template is attached onto the device or not. If the template is attached onto the device, then it means that the device is in the vManage mode. If the template is not attached onto the device, right here mode. So right here mode is by default off, so mode, and you can see somewhere, if I scroll down, so you see CLI, so CLI. So at the moment all of these are CLI mode, but if I go to the controller, you can see that we have attached the template, managed by this template, or we can just select here, that is managed by right here, or mode, for example. So it will show you that it's a CLI mode, it's a vManage mode.
Sorry, in between I have got disconnected due to internet issue. Actually, I asked that if we have cleared the task, in between, if you are running more than 2 or 3 tasks, how we can identify this task is belong to this?
It was written right there. It was written in the task itself. You can refer to the recordings. It was written in the task itself that what task is going on. Every task is identified by a number, process ID. So you can click on the pending task, whatever tasks were going on, you can click on it. You can see like whatever task we were pushing. This was the task, for example, that we pushed earlier. Here is one of the tasks, and when we do that API call, right here in that API call, it will be written there. You can take a look at the API call. You can see the process ID, you can see the name, you can see the start time and time and all that thing. You can read this and come to know like what task is this.
Okay, thank you.
Yeah. CLI template. These are called CLI templates. Very easy to deploy, very easy to push onto the devices. What are the challenges in this? Like not a lot, but we have to at least configure one of the device to get the CLI configuration, or maybe we can write down all the CLI configuration, then replace the values with variable and all that. So not a lot of issues actually, but not a very efficient way, I would say not a very efficient way to configure the templates and all. We are going to configure a new way to push all these templates. We are going to use a new way to push all these templates onto the devices, and that is with the help of feature templates. Feature templates define feature templates that we have. Feature templates, they define individual building blocks of the device. Individual configurations of the device can be defined with the help of the feature template. We can use CLI templates if you want to attach the templates on a few devices, like 1 or 2 devices. It's okay to use the CLI template. For example, I wanted to attach the template on the vSmart. Why? So that we can push the policies. Later on, when we cover the policy, we will know that if you want to push the centralized policies in your SD-WAN network, the vSmart must be in the vManage mode. It is mandatory actually. So we will have to create a template for the vSmart and attach it there. But the problem is that if I want to create a template for the vSmart and I create a few feature templates, then attach, it will take a lot. Better just create. It's better that you just create the CLI template and attach it on the device. But we want to do the configurations on these vManage devices, these routers that we have. We want to push the configurations on the site 1 VH1, site 1 VH2, site 2 VH1. I want to pre-provision, I want to pre-configure like some configurations for this vManage, so that then when this vManage comes up, the vManage is able to push the configuration onto that particular device. So I can go to the monitor, I can go to the vManage, and on the vManage dashboard, I will go to the same option like template, configuration template, and I'm going to create a device template. But this time I'm not going to create a device template with the help of the CLI template. I'm going to do it with the help of the feature template. But before that, I will need to create a few feature templates. I will need to create a few feature templates. So click on the feature template, and here some feature templates will be there by default. There is no device template by default. Here you can see like all the templates, they say that there is no device template by default, but when we change it to from the default to like all, we see that there are plenty of like default device templates available, but they are more like hidden. By default there is no by default there are some device templates available. By default there are some feature templates available. By default some templates are generated by the system. So by default this option is under the non-default. Here by default it's under the non-default, so it only shows you the templates that we have created, not the one that are there by default. So that line basically is not truly correct nowadays. Like this line is not truly correct, that by default there is no device template. So there is in fact there are some device templates by default nowadays which we can use for our devices if you do not want to create the templates from the scratch. At the moment we are not going to do it. We can go to the feature template, and first of all I am going to create various feature templates for my site 1 vh1, site 1 vh2, and site 2 vh1. So I'm going to configure here some feature templates now. I'm going to configure some feature templates here now. Feature templates are going to define the device's individual building blocks. So I'm going to configure some feature templates now. Click on add a template, select the model. So we are working on the vManage cloud, VH cloud. So I'm going to select the VH cloud, the platform for which we want to create the template. And here are the individual building blocks of configuration available for that particular device. These are the things that we can configure on that VH cloud device. These are the things that we can configure on that VH cloud device. Some basic information, some VPN information, some other templates. We have these configurations available for that vManage or VH cloud router. So let's create a few basic templates, such as I will create a system template. In the system template, I'm going to say, I'm going to give it a name, system template. It is for VR1 and 2. It is for site 1 and site 2. This is like a system template for site 1 and site 2. You can put whatever description you want to. I'm just going to copy and paste it. And here, site ID. Site ID, either we can have global or we can have device specific. Remember that this template will be pushed on 3 devices, these 2 and this one. So site ID here is 1 and site ID here is 2. Site ID here is 1 and the site ID here is basically 2. So we cannot set the site ID to global. Global basically means whatever number we write here will be pushed on all the devices attached with this particular template. We can't do it because this system template will be pushed on here, here, and here. Here the site ID is 1 and here the site ID is 2. So here we are going to configure the site ID as device specific. And you can put a description as per your requirement. You can put a description as per your requirement if you want to. So I'm going to just put a description as per my requirement, site ID. So site ID is device specific. Why it is device specific? Because we are going to push this template on 2 sites, site 1 and site 2. So I cannot have a global value there. It is device specific. System IP is always device specific. We can never have the same system IP. So system IP is always device specific. Overlay ID, we don't care. Time zone, both of these sites are in India. So time zone is common. Time zone is global. Asia, Calcutta, for example. Asia and Calcutta. Time zone is global. Time zone I want to push on all the devices same. Same time zone I want to configure on all the devices. The time zone is going to be Asia, Kolkata, because all of these devices, they belong to the same geolocation. Host name can never be the same. The host name is different. Group, device group, controller group, we don't need to define description. Global description is like devices. These are the devices in India. WAN edge devices in India. This checkbox that you see, it means default. This checkbox that you see it means default. By default, there is no location name. By default, there is no device group, controller group. So this checkbox means default. This means device specific, and this means basically global. So global means whatever we fill here will be delivered on all the devices. Device specific means that the value is device specific. We will need to provide this value while pushing the template, and the default one is the last one. Default means like the default parameters will be baud rate 9600 bits per second, max OMP session, I don't care, longitude, latitude, I don't care, tracker, I don't know, advanced, I don't know what is this. I don't know what are these configuration. I'm going to set only the required configurations here. MTU port hop is enabled, port offset if you want to configure, DNS cache timeout. Do you want to, since remember that the image for the vManage and the vBond is same, so is it the vBond? No. Allow same site tunnel. Remember that if two devices have the same site ID, they will not form the IPsec tunnel. So if you want to allow the same site tunnel, then you can check this box and say yes. It means that allow the same site tunnel. Or no, I don't want to allow the same site. Idle timeout basically means how many minutes in, like 5 minutes. If the devices go idle for 5 minutes, timeout. On-demand tunnel, the on-demand tunnel timeout. I'm not going to enable any of these things. So the basic configurations, whatever I knew, we filled up here in the system template, and then I just saved it.
Latitude, longitude is not mandatory, or
no, it's not mandatory. Okay. It's optional. So if you want to track the devices based on the geolocation, then you can provide the longitude, latitude, else it's not mandatory. Okay. Then again, add a template. Again, the same cloud. What else? System template is done. Now maybe we want to configure some NTP template. Okay. So NTP. I want to configure NTP on the devices. NTP site 1 and site 2. Who is the NTP server? The NTP server is 0.in.pool.0.in.pool.ntp.org. This is the NTP server. This is the global NTP server that we are configuring. We can have NTP server in our organization as well. If we have it, then we can provide the host name. We can provide the authentication and everything. But here we are configuring a global NTP server, a public NTP server, 0.in.pool.ntp.org. Via what VPN it is reachable? It is reachable via the VPN 0. What NTP version we are going to use? 4. Do you want to use a particular interface as the source interface for the NTP messages? No. Like if we had like multiple interfaces, I can select a particular interface as the source interface for the NTP message. I'm not going to use it. Do you want to prefer this NTP server? Yes. Add it. You have more than one NTP server, add new server. So, 1.in.pool.ntp.org. Hopefully you now understand. So we can configure more than one NTP server as per our requirement on the devices. If in your company we have some NTP server, you can add that server information as well. Maybe you have also configured the authentication. So what authentication key you have configured, such as 12345. What is the password that we have configured for the NTP authentication? Cisco @123, for example. And we can configure multiple authentication keys, and we can choose what key we are going to use as the trusted key, like 12345, for example. We can choose here also the authentication key while doing the configuration. The point here is that we are going to configure the NTP authentication or NTP as per our requirement. Not a lot of options are there. whatever options are there, they are in front of you, and save it. Keep doing it until you have set enough template, until you have configured enough templates, such as security. Do you want to change the IPsec encryption time? Do you want to change the rekey timer? This is 86,424 hours by default. Do you want to change the rekey timer? Do you want to change the type of like authentication and all that? Basically, the security, the IPsec tunnel. Do you want to change any parameters? Do you want to enable the pairwise keying maybe? Do you want to do some changes regarding the IPsec security? So if you want, then here are the options that you can do. Here are the options that you can change actually. Here are the options that you can change actually. Yeah. So what I was saying, that select the required options and just save it. If you want to do some changes about the IPsec, then select the required options and just save it. So you will need to create the templates. You will need to create the templates. You will need to create, keeping the templates, like creating the templates, add template, create the template like cloud, for example, click on the cloud, then create a template for maybe OMP, overlay management protocol, create a template for BFD, bidirectional forwarding detection. So for example, you want to change some BFD multiplier and color and whatnot. So you can keep creating those templates until you have created enough templates here. AAA, archive, BFD, NTP, OMP, security, system, all these things. You create all the basic templates that you know. Create all the basic templates that you know. Once done, then now we will have to create the templates for the VPN and the VPN interface. We'll have to create a template for the VPN and the VPN interface. Minimum, like we have to create 1, 2, 3 VPN 0, LAN side VPN 10, which is for our corporate user, maybe VPN 20, which is for our guest user, and the VPN 512 for management purpose. Then we have multiple interfaces. ETH0, for example, in VPN 512, gigabit 0 by 0 in the VPN 0, the gigabit 0 by 1 in the VPN 10, the gigabit 0 by 2 in the VPN 20. We will have to create at least 1, 2, 3, 4 VPN interface template. We will do it later on, but we will have to do this. Then additionally, if you want to, like these are the VPN and VPN interfaces, then additionally, if you want to, you can create a template, for example, the banner template. Banner, site 1 and site 2. The banner template. Banner template basically like login banner. Warning, do not use this device if not authorized. Whatever, warning you want to give. Some sort of warning message we want to give. So warning, for example, or maybe like message of the day banner, like scheduled down time is at 1 a.m. IST, whatever, whatever message, whatever the banner you want to display, you can display the banner here. These are the additional templates. At the very end, we have the additional templates, and these additional templates that we have, such as banner template, such as logging, syslog template. We have like syslog server somewhere in our network. So syslog site 1 and site 2, maybe, for example. So we have a syslog server. Where is the syslog server? This one is maybe our syslog server, 192.168.100.3. This is our syslog server. So disk logging, like log messages are stored in the disk as well. And where is our syslog server? The syslog server is here. It is at 192.168.100.3, and it is reachable via VPN number 10. We will configure VPN 10 later on, but here is our syslog server, and it is reachable via VPN 10. And this interface, by the way, this interface that we have, this interface we are going to use, interface gigabit 0 by 2, we are going to put it into VPN 10. So that interface I'm going to use as the source interface for my syslog messages. So we can select the proper interface. Maybe I will fill it later on. Maybe we have different interfaces here. So I'm going to select the interface device specific. What log messages do you want to deliver? You want to deliver what severity, what importance level, what log messages do you want to deliver? Do you want to deliver the log messages of all the severity, or do you want to deliver the log messages of the specific severity? So that you can choose. By default, it's all. Configure it. If you have multiple syslog servers, add them again, keep doing it. You want to configure SNMP? You want to configure SNMP, for example, just select it, go to the very end, and additional features such as, for example, SNMP. You can configure the SNMP. SNMP communities, for example, SNMP version 1, version 2, version 3. Version 2 and version 3 supported basically. So if you know about SNMP, you can explore the options and configure the SNMP on the devices as well. What I'm trying to say is that you need to explore these options available. These options vary based on the device to device. So if you select, like, for example, in the cloud, in the vEdge router, take a look at the routing protocol. BGP, IGMP, OSPF, whatever. You can see these are the routing protocols supported. What about the vEdge 100 device? What about the vEdge 100 device? We have the similar routing protocol support here. But what about the cEdge device? cEdge, like ISR, some ISR series router. What about this router? You can see that here we have like OSPF version 3, we have EIGRP, some additional protocols are also there which are not available on vEdge platforms, right? So point I'm trying to make is that functions of the devices vary. The functions of the devices vary. So you will have to create the templates based on the same. Once done, once you have created enough feature templates, we will do it. We will create the VPN templates, VPN interface templates. Once done, then I will go to the device template and I will create a device template, now this time with the help of the feature template. And I will select for what model? Same, vEdge Cloud. And I am going to assemble. I'm going to assemble all those templates that I have configured. All those templates that I have configured, I will assemble them here. I will assemble them here. All those templates that we have configured, I am going to assemble them here. And then I'm going to attach it. Then I'm going to attach it onto the device, which we will do later on. But once we have created the feature templates, once we have created these various feature templates, then we are going to assemble them in the device template, and then we are going to attach the device template with the devices. So still some templates are left. We will talk about them, such as VPN template, VPN interface templates, and then we will attach them with the device template. So far, you can explore the options yourself on your vManage router. Whatever options are available, you can explore them yourself. For the moment, tomorrow we'll continue from here. We will create the other templates, VPN interface templates, and then we are going to attach all those templates with the device template, and we will push it on the respective devices. And tomorrow itself, I will show you the concept of ZTP, not completely, but I will try to onboard this device with the help of the zero touch provisioning as well. And once all done, then we will onboard the cEdge router. The cEdge router onboarding we have not done. I will onboard it and I will attach the template right away, so that the problem that we discussed earlier, sometimes the interfaces change, that problem might not arise, right? Revisit the class from the recording, try to configure the same things in the lab environment. So some basic templates we created for our Site 1 and Site 2 devices. So configuration under the templates. So we configured some feature templates, like we configured banner template, NTP template, syslog template, system template. A few more templates let's create, like VPN template and VPN interface template. And then we are going to push all those templates onto the devices, right? So same steps, go to the configuration, go to the templates, go to the feature template, create add template, and here select your model of the device, that is cEdge, vEdge Cloud, and scroll down. And first of all, we need to create a few VPN templates. So click on the VPN, and here under the VPN, I will say VPN 0. This is VPN 0 template. This is VPN 0 template. So VPN 0, Site 1, Site 2. Here the VPN number is 0. Name, maybe I want to provide, so transport VPN. Then do you want to change the AD value for routes that you learn via OMP? By default, it's 250, 251. There are two AD values for the routes that you learn via OMP. One is like 250, one is 251. 250 is on the VS devices and 251 is on the CS devices. So we'll talk about it in the routing section. So VPN number 0, name we can provide if we want to, AD value we can configure. Do you want to configure the DNS in the VPN 0? Of course, like DNS is like 8.8.8.8. The secondary DNS is basically primary DNS IP address is like 8.8.8.8, and secondary DNS is maybe like 1.1.1.1 or whatever, primary DNS, secondary DNS. Do you want to perform the host mapping? Of course, yes. Like, remember that vbond.imedita.com is like at 100.1.1.3, that kind of mapping we want to perform. So remember that in VPN 0, VPN 0 will be used to reach out to the controller. And if you have configured the name for the vBond, if you have configured the name for the controller, in that case, you will have to provide, this mapping IP to like name mapping you have to do. So that thing we set up. Route we will have to add. We have to add a new route. On all the routers, we have a default route pointing towards the internet. So I will have to add a new IPv4 route, and the route is going to be 0.0.0.0/0. And the next hop is going to be device specific. The next hop is going to be device specific. Internet next hop. The next hop is going to be device specific. Why? Because the next hop IP for this router is going to be different. The next hop IP for this router is going to be different. The next hop IP for this router is going to be different. So next hop is going to be device specific. You can change the AD value. We can also track that interface by configuring a tracker. Since we have not configured any tracker, we don't even know what is tracker, so forget about it. Add it. Click on the add button, which means that we have added a default route in VPN 0. In the VPN 0, we have added a default route pointing towards the next hop, and the next hop is device specific. IPv6 route, we don't have. Service routes, we don't have. Service routes, service route, we don't have. GRE route, we don't have. IPsec route, we don't have. NAT, we don't have. Route leaking. Do you want to leak some routes from global to the service VPN, from service to the global VPN? No, of course not. I don't want to leak any routes or anything. So forget about it. Then I'm just going to save it. Basic thing. Whatever things we have configured so far, very basic things we are going to configure here. So we have configured a template for our VPN, the VPN 0 template we have configured here. Then I'm going to copy this. And I'm going to create a VPN 10 template. VPN 10 is for the LAN site, by the way. So I'm going to create a VPN 10 template. VPN 10 is for the LAN site, by the way. So VPN 10 template. VPN 10 is for the LAN site, and it is for our corporate, for example, users. So I have just copied it. And now I'm going to edit it. Edit the settings of that VPN. So I'm going to say that it's VPN 10, by the way. It's corp VPN. It's do you want to provide the DNS information? Yeah, we need to provide the DNS information for the VPN 10 users so that they can reach to the internet. We don't, however, want to have any host mapping, so I'm going to delete the host mapping from here. Advertise OMP, no. Any route, no. We will run the routing protocol later on, so I don't need to add any route. I don't need to add any V6 route, any service route, nothing. Everything apart from that, nothing. We don't need to do anything extra. Again, copy this. Copy this. This is going to be, let's say, for example, VPN 20. VPN 20 is our guest VPN users. So VPN 20. I'm going to copy the VPN 20, edit it, and this is going to be our VPN 20. VPN 20 is basically our VPN 20 is basically, let's say, for example, guest users. The guest users belong to the VPN 20. So VPN 20 maybe. Guest users also wants to access the internet, so DNS information I also need to give there. What else? Yeah, all good. Then one more VPN 512. Keep doing it. Copy VPN 512. Copy, and the VPN 512. Edit. Oh, sorry, not this one. So VPN 0, VPN 10, VPN 20, VPN 512 is right here. So edit, and edit it to configure the VPN 512 for our management users. Keep doing it. First time you will have to do all these things. Management VPN, I do not have like any DNS in that management VPN or all. So you can configure these things there. Update. So VPN templates we have configured. We have configured various VPN templates, by the way. So we have configured like banner template, NTP, syslog, system, VPN 0, VPN 10, VPN 20, VPN 512. We have configured various templates here. Now we will configure the template for the interface. Now we will configure the template for the interface coming in the VPN. So there are various interfaces part of the VPN. So I'm going to now configure the template for the VPN interface. So go ahead, add template, cloud, and the VPN is done. Now the VPN is done. So VPN interface Ethernet. VPN interface Ethernet I am going to add here. VPN interface Ethernet I'm going to add here. So this is like VPN 0 interface. It is going to be GE 0 by 0. Some sort of description I have given. This is VPN 0 interface GE 0 by 0. Or I'm going to do one better. GE 0 VPN 0. And now fortunately, the interface name is same everywhere, right? Interface name is same. So the same interface is going towards internet on site 1 VH1, site 1 VH2, site 2 VH1, So not a very big problem. I can just, do you want to shut down the interface? Of course not. And I can put the interface name right here, GE 0 by 0. I can put the interface name right here, GE 0 by 0. Why? Because on all the devices, the interface name is same. The same interface actually on all the devices, the same interface is in fact going towards the internet. Since the same interface is going towards the internet, I can provide the name. If let's say, for example, it was a different interface, then I will just say device specific, and I'm going to say internet, for example, interface, something like that. I don't need to do it, but let's do it. Let's configure the interface as a variable, like, considering the fact that maybe the interface going towards the internet is different on all the VNS devices. In our topology, it's same actually, so we don't need to do it, but let's assume that it's different. Then you can provide the description. You can add some description there. Description like this is the internet interface or whatever, I'm going to add the description like internet interface. What IP you want to configure? I want to configure the IP to be device specific. So internet interface IP address. Internet interface IP address. Something like that. Then yeah, nothing, bandwidth, nothing. I am not going to, let's assume here we had the DHCP server. Or here we had the DHCP server, and I want to relay the DHCP message towards the DHCP server, then the helper address and all, but I don't have any such thing. So is it a tunnel interface? Of course, yes, it's a tunnel interface. What color? Color is public internet. It is in fact a tunnel interface, and the color that we have configured there is going to be public internet. The color settings that we have to configure there is public internet. Like I said, you can configure whatever color you want to, but since the interface is going towards the internet interface, so I'm just setting the color as public internet. Restrict. Do you want to form the IPsec tunnel with the same color only? Of course not. In case of multi-region fabric, is this a border T-lock? No. Max control connection. We can define out of the interface how many maximum number of control connections can be created. A vManage connection preference. Okay, we'll talk about it. Just keep this in mind that there is some option called vManage connection preference. Okay, fine. Port hop. Okay. Allow service all. We can allow whatever service we want to allow. So allow service all. Advanced option. Encapsulation like IPsec. We can set things such as preference weight and all those things, but at the moment, hello interval, IPsec hello interval is basically like 1000 milliseconds and all. So we can change a few parameters regarding IPsec, but I'm not going to do it. No NAT, no VRRP, nothing, no QS, no ARP, no .1x, no duplex, no MAC address, path MTU discovery is off. So TCP MSS you can adjust, the speed you can adjust, ARP timeout you can adjust. We have plenty of options here available. You can go through the option, and if something is useful for your production environment, you can implement it. I'm not going to do any additional configuration. Just save it. Then the second interface, GE0 is done. Copy this and GE1. GE1 is the second interface. It is going towards MPLS. So copy this and edit it, then edit it. Interface name is going to be device specific, MPLS interface. IP4 address is going to be device specific, MPLS interface. Tunnel, yes. Color, MPLS. Allow service, all. Encapsulation, IPsec. Rest, we don't need to do anything extra. We do not need to change any other parameter. That is it actually, and just update it. So VPN 0 has two interfaces, so both are set up. Again copy. This is gig 0 by 2, GE2. GE2 actually, GE2 is part of VPN 10. GE2 is part of VPN 10. GE2 is part of VPN 10. We don't have GE3, not at least attached, but let's consider GE3 is part of VPN 20. So GE2 is part of VPN 10, GE2 VPN 10, copy, and I'm going to edit it. GE2, edit this gigabit 2 template, which is part of VPN 10. So edit it. This is going to be corp interface, corp VPN interface. Then IP address is going to be device specific as well, corp interface IP address. Tunnel, no. It's the LAN side, it's service side interface, so no tunnel. OVRRP, no ACL, nothing extra, no .1x, nothing. So all good. Rest, update. Keep doing it. G2, copy this. G3, VPN 20. Edit it. This is the guest interface. This is like the guest VPN interface. This is like guest interface. There's no guest interface. I'm just setting it up like that. So no additional thing. All good. And then finally, the last VPN that we have, copy. That is going to be ETH0, which is VPN 512. Copy. And edit it. It is MGMT, management interface. It is ETH0. So I can put the interface right at that point. No need to set everything to device specific. I can set it as per my requirement to global as well. IP, someday like when you connect that interface with some management switch, it might get the IP from the DHCP. So that thing, no tunnel, no NAT, nothing. So we have configured various VPN interface templates. I guess these are sufficient. Now I can assemble all these under the device template. Under the device template, I can create a template from the feature template, and I'm going to assemble all these. I'm going to assemble all these templates for this is site 1, site 2, a generic template, So something like that. What system template we want to use? The one that we configured. What log template we want to use? The one that we configured. What NTP template we want to use? The one that we configured. What OMP template, what BFD template, what security template, what AAA template we want to use, default ones. What VPN template we want to use, the one that we configured. VPN interface. There are two interfaces in the VPN 0. One interface is gig 0, one interface is gig 1. In the VPN 512, we have one interface which is ETH0, by the way. So keep assembling those things. Keep assembling all those templates that we have configured. And then add a service VPN. We have configured 2 service VPNs. We can choose what service VPNs, what client-side VPNs we are going to add. We can add both of them, or we can add just one of them. Completely your choice, completely your requirement. So I can add both of them. So we have VPN 10, VPN 20 on site 1 and site 2, for example. Next, under this, we have interfaces. We have the interfaces. We have interfaces such as what interface we have? We have gig 2 in the VPN 10, and we have gig 3 in VPN 20, for example. Now, since we do not have like VPN 20, so I'm just going to remove it. You know how to remove it? Just click on it and just say, click on it and click here. That means VPN 20 template is there, but it does not exist onto that particular site. And I'm just going to add one template here, gig 2. So I was just telling you that I just showed you that if you have multiple VPNs on the LAN side, you can add them under the VPNs, and then you can just select the interfaces under that. You can add another VPN, by the way. You can always add another VPN, no need to tell you. You can add another VPN, click on the interface, and add the last interface. You can do it like completely your choice. Completely your choice. Since we have only one VPN, I'm going to remove it. Banner template, yes. SNMP template, no. Security template, no. So, and you want to, let's say, for example, you want to create a template, you could have created a template right from here itself. For example, you want to create a BFD template. So click on it and click on create template button. It will redirect you to the page where we can configure the BFD, and then we can select it. Then we can select it under here, or we can click on create template for OMP. It will redirect you towards the page where you can create this, where you can create like OMP site 1 and site 2, and then you can just set whatever parameters you want to set for the OMP, overlay management protocol. And once you have set all those parameters, just click on the save button. So maybe you forgot to create a template on the feature template. You can do it right from here as well. I guess all the necessary things I have assembled. I'm going to click on create template, and it will create a device template, which is a composition of various feature templates. 15, in fact, feature templates. 15 feature templates we have attached here. We have configured a total of 15 feature templates here. I'm going to attach the device. And I'm going to attach site 1 VH1, site 2 VH1, these 2 devices, and I'm going to pre-provision. This device. This device I'm going to pre-provision. I'm going to say when the device with the chassis ID and serial number, this chassis ID and serial number comes up, attach it with the template as well. I am pre-provisioning that particular device so that when the device comes up, it can be attached with the template respectively. So attach, and now we'll have to fill all the values. All the things that we have marked as variable, now we will have to fill all those values. Here, right here, I will just click on these 3 dots and I will say edit device template. And then from here, whatever fields we have marked as variable, we are going to fill all those values here. Go to the interfaces. I have the description I have mentioned properly. That's why I can easily fill all these values. If we did not put proper description, then some issues might be. Anyway, I am going to say one by one. Interface name. What is the corp interface? By the way, if you mouse over it, it will show you the path actually. You can see it says, if you mouse over it and you see at the very end, it says /10. /10 means it's for VPN 10. and the interface is corp interface name. Just in case if you accidentally put the same description on multiple interfaces, just mouse over it and it will show you the exact thing about that particular interface. So it's GE 0 by 2. This is 0 by 2, by the way. This is 0 by 2. 0 by 2. 0 by 2. What device is this? This is site 2 VH1, by the way. This is site 2 VH1. This one. So GE is 0 by 2. Okay. What is the IP address on that interface? 192.168.20.1/30. The IP address on that interface is 192.168.20.1/30. The next hop, internet next hop. The next hop basically means like this one. It is 2.2.3.2. It is going to be 2.2.3.2. The internet next hop, the next hop IP for the internet route that we have configured 0000000000, it is 2.2.3.2. This is 2.2.1. This is 2.2.1.1, 2.1, 3.1, so 3.2. MPLS interface name is, by the way, 0 by 1. The internet interface name is, by the way, 0 by 0. The IP address on the internet MPLS interface, this interface is going to be 3.3.3.1. 3.3.3.1. 3.3.3.1. I already have done the same exact thing in one of the previous class on the Firefox itself. So it's suggesting me the, when I click on it, it's suggesting me. Of course, you will not get that. So be very careful while filling up the interfaces. So internet interface IP, this interface IP is 2.2.3.1. 2.2.3. Host name is going to be this one. Location is in Delhi, maybe. System IP is going to be this one. Site ID is going to be 2. Source interface for the syslog. If you want to specify the source interface for the syslog, it is basically 0 by 2, this one. I might get the error, but 0 by 2. Update. So we'll fill that value from site 2 VH1 point of view. Now I will need to fill the value, same exact thing from the site 1 VH1 point of view. So again, edit it. The same exact thing. This is name is basically this one. The location is in Pune, maybe, for example. The system IP is 10.1.11.10.1.11.1. This is site 1 VH1, by the way. So 10.1.11.1 site ID GE 0 by 2 is the source interface for syslog server. Corp interface is 0 by 2. The MPLS interface is 0 by 1. The internet interface is 0 by 0. The IP address is 2.2.1.1/30. The IP address here is 3.3.1.1/30. And here the IP is going to be 2.2.1.2. And corp interface 192.168.10. So corp interface is the LAN interface, by the way. Interface 0 by 2. The IP address, the internet next hop 2.2.2.1.2. Then the MPLS interface 0 by 1. The IP address, the internet interface 0 by 0. The IP address, the host name, location, system IP, site ID, and the interface for the syslog server. And I'm going to fill this one as well. The corp interface is same, actually, 0 by 2. The IP address is 192.168.10.2/29. This is, by the way, this is this device. This is this device. I am pre-provisioning that device. Then the IP address 2.2.2.2 interface MPLS is like GE 0 by 1, and just it is going to be 3.3.3.2.1/30. Then GE 0 by 0, it is 2.2.2.1/30, and this is going to be site 1 VH2. Location is going to be Pune, and the system IP I'm going to configure as 2, and site ID is going to be 1, and the VPN 0 interface is going to be. So we'll have to fill all the values. Be very careful while filling the values. You have to be very careful while filling the values. If you accidentally put something like incorrect, in that case there will be issues. What I could have done, instead of doing all that, what I could have done here, I could have downloaded. I could have, like here, I could have downloaded that file. I could have here downloaded it like in the format of CSV, and from here, from this button right on the top, if you have like a lot of devices here, if you have many devices here, then I can just click on this button here, right here. The button is basically download button. So click on it. So it will download a CSV file. Here, now I can fill all the values. Since we have already filled the values, it shows all those values here. But what we could have done, we could have filled the values right here on all those multiple devices. And then I could have just uploaded it. Once we have done filling, I could have just uploaded this Excel sheet, Excel file, this CSV file. I could have uploaded it on the device. Take a look at the serial number of the device and just start filling the values one by one. Start filling the values one by one. And once you are done, then just click on the upload button and browse the file and just upload it. I will advise you that whenever you fill the values, whenever you are done filling the values, always keep a copy with you. Always. I will advise you that when you are done filling the values, if you have like multiple devices and you have filled the values on those multiple devices, I will always advise you that you download a copy of it. Reason is that if, let's say, for example, you get some error, let's say when you are pushing the templates, let's say you are pushing the template, and while pushing the template, let's say you get some error, then the template push will not be successful. And when you correct the error and you push the template again, then you will have to fill all the values again. So it will be a good idea. It will be a good idea that you download it. And let's say, for example, due to some error, you need to push the template again, then you can just upload the same file with the correct value. So that can be done, but completely your choice. I always do that. I always just, once I am done filling all these values, I will download it. And then I will just upload it later on if the template push is not successful. Click on the next button. Do you want to see what configurations are going to be delivered? You can click on the device and you can preview the configurations that are going to be delivered. So config preview, you can see here the configs that are going to be delivered onto the device, the config preview. You can see the differences between the configurations that are being delivered. So here is the configuration that will be delivered onto the devices. Config diff, the side-by-side difference. You can see the side-by-side difference, the information that is going to be delivered on all those devices. Not necessarily that you have to check it, but you can check it. Also, if you push the configuration and due to some configuration mistake, let's say the device becomes unreachable. Let's say due to some configuration mistake, the device becomes unreachable. So by default, without doing anything, by default, there is a rollback timer. The default rollback timer actually is 5 minutes. Device rollback timer. The default rollback timer is 5 minutes, which means that if your device becomes unreachable due to like some misconfigurations from the templates and all, the device will roll back to the previous configuration in 5 minutes. Like after 5 minutes, it will roll back to the previous configuration. It is by default enabled. We can adjust the timer, and we can also like set the timer for specific devices. We can add exception. We can do all that sort of thing. So it's by default there. If the devices become unreachable due to template push, it will roll back to the previous configuration. Configure it, confirm changes on 3 devices. Just for the sake of what happens, like I told you, sometimes these devices, they go unreachable. So what you just do, just restart it once. I am just starting the devices right here. Here. And then once the control connections are there, then I'm going to 192.168.10.71. Once the control connections are there, then I will push these templates. Right. So I will just wait for the device to boot up. It was showing me unreachable, by the way. It was showing me unreachable, So I have just restarted the devices, and then it's a problem from the iOS point of view itself. Like the versions, sometimes the version that you use, those versions come with some issues. So the version that we are using looks to me that that version basically has some issue in the software code that after some time the devices go unreachable, the interface goes down actually. So I have just restarted the device. And I will just wait for the device to become reachable. Then I will do the template push so that like everything is delivered successfully. And by the way, if you get any problem, if you get any error, you will see the error right at the point of template push, and then you will have to read the error. You must know how to read that error. You must know how to correct that error, and then again you are going to push that template. Let the devices come up, let the devices boot up, and let the devices establish the connection with the controller. Then we are going to push that configuration template. Wait, let me refresh. Wait for the devices to come up. Just restart the devices if the connections are not up. Okay, so 2 have become reachable. Site 1 VH1, site 2 VH1 are now reachable. It's fine now. I'm just going to now push the template on the device. Right, so it's done. So the devices are reachable now. So I'm just going to push the template right now. So I'm going to go here and I'm going to click on confirm. Let the vManage push the configuration towards the devices. You can see that all the devices have become reachable. I did not do anything extra. It happened automatically, by the way. So just restart the device if it becomes unreachable. The validation successful. Template push is now active. So, okay, let's see. If you get some error, the error will be displayed right here. If you get some error, the error will be written right here. Done. Looks like no errors were there. So the configuration was pushed. The template was successfully attached to the devices, and the template will be attached to the device when the device comes up. The device became unreachable. Configuration template scheduled to be attached to the device when it comes up. So this device we did not set up this device. So it says that when the device comes up, then the template push will be there. Apart from that, you can click on the site 1 VH1 and you can cross check that the template push was successful. You can see that the configuration was delivered there. So you can see the banner admin. Now the funny thing is that the username password is now reset. The username password is no longer Cisco@123. The username password has now been reset. It's like now admin and admin. The password has been reset to admin. The password has been reset to admin. I will tell you why, but the password has now been reset to admin. And now you can just see by doing the show running config, you can see that all the provision, the configuration, the idle timeout, the description, the host name, the location, the site ID. Then after, we have the syslog, we have the NTP, we have the OMP, we have the banner, the VPN 0. On the VPN 0, we have now two interfaces. So VPN 0, gigabit 0 by 0, VPN 10, VPN 512, everything is now delivered there. Everything is also delivered there. Here also everything is delivered. Just one thing that I'm noticing here is that the configuration, when we push the configuration, the password has changed actually. One thing that I'm noticing here, that the password has changed. Apart from that, everything looks okay to me. So first of all, let's see why the password has changed. The password has changed because in this template that you have attached, you have not configured the AAA template. The passwords are part of AAA configuration. The username password is part of AAA configuration. The username password is part of AAA configuration. So AAA, like configuration is the default one, and as per the default AAA configuration, the username password is admin. That's why when we push this template, actually, remember that in the previous class, I told you that the template configurations are considered as the final configurations. So the default template, when the AAA template was delivered, the username password became admin. You want to correct it? Edit this template or create a new template. Create a new template for AAA site 1 and site 2. Create a AAA template. Here you can configure the AAA. If you know about AAA server, you know what is AAA, how to configure the AAA. So you can configure under the AAA, you can configure the authentication order, first local, then radius, then TACACS, authentication fallback, admin authentication order, disable the logs. You can set up the authentication rules, you can set up the authorization rule, you can set up the accounting rules. You can do all that. If you know about the AAA, you can set up the AAA configurations from here. You can set up who is the radius server. You can set up who is the TACAX server. You can add the radius server information. You can add the TACAX server information. But for that purpose, you must know what exactly is AAA, what is radius, what is TACAX. We are actually not interested in that. We are interested in the username. I am going to edit it, and I'm going to edit the password to be Cisco@123. Save it, update it, and push the template on the tree. It automatically selects that. I believe it has already selected it. So I'm going to now configure the device again. So the reason why the username password got reset, because the username password comes under the AAA configuration, and we unfortunately did not create any template for AAA. Since we did not create any template for AAA, AAA authentication, authorization, accounting, that is why actually the configuration was delivered with the default username and password. Done. So now when I log into the device, now it will show me the correct username password, by the way. So now if I log in there, if you exit, and now if you log in, admin and Cisco@123, now it will log in with that username. Be careful. A point I was trying to make is that template configurations are the final configuration. So whatever configurations we have done in the template will be considered as the final configurations, and they will be delivered respectively on the device. So we will have to be careful with that. We will have to be careful with the configuration that we are going to deliver on the devices. Actually, later on, if you plan to add more, if you plan to do more changes, that you can also do. If you plan to do like more changes, you plan to add more templates and all, it's fine. But it's done now. This is done now. So this site 1 VH1, site 2 VH1 is now attached with the template. Site 1 VH2, however, we did not onboard. So I am going to do the basic configurations here. Remember, let me revise the ZTP process, zero touch provisioning process. Device bootstrap interface is already configured for the ZTP. So this interface will get the IP address, subnet mask, default gateway, DNS server, all that from the DHCP. Once it gets the DNS information, it will ask who is ztp.viptela.com. The provider, the DNS server will respond that ztp.viptela.com is like this. So the device will reach to that cloud delivered ZTP server. There it will present its chassis ID, serial number, and the cloud delivered ZTP server will validate that chassis ID, serial number, find out the device belongs to the organization I-MEDITA, and the organizational vBond is 100.1.1.3, and it will provide that information to the site 1 VS2. Unfortunately, this process we can't do because we do not have a ZTP server, neither do we have the reachability to the internet. So I am going to do that configuration manually. I am going to do some basic configuration manually, such as system. I will set it about the vBond 100.1.1.3. I'm going to set up the org name, which is I-MEDITA, and I am considering that the VPN 0 interface GE0/0 and the IP address is 2.2.2.1/30 no shut tunnel interface and allow service, all encapsulation and all those things I am not going to set, and just give a default route. Just bare minimum configuration I have configured here. I have configured the vBond and org name. Then I have configured like the VPN 0 interface, and then the tunnel interface, and then configured the IP address. Bare minimum configuration I have done, and I will make sure that I am able to reach 200.1.1.1. Make sure that you are able to reach 200.1.1.2. Make sure that you are able to reach 200.1.1.3. Then do not forget, since we are using the enterprise root CA, since we are using the enterprise root CA, we will have to download that root certificate. Remember that since we are using the enterprise root CA, we have to download that root certificate from the CA server, which is vManage, and we have to install that certificate. We have to install that certificate on the VS device, root cert chain, install home admin and root ca.pem. And we need to activate it, by the way. Request VH Cloud activate, since it's a software-based managed device. We need to activate it. And while activating, remember, this device, remember what exactly, what chassis ID you have attached with the template. We have attached, I believe, this one, if I'm not wrong. If I'm not wrong, we believe that it is this one, if I'm not wrong. Let me just cross-check the template. What device have I attached with the template? It is, which one? It is C55F or C5F, this one. So copy, and request VH Cloud activate chassis ID, and token is going to be, what is the token? Token is going to be this one. So request VH Cloud activate the chassis ID and the token we have configured. Since it's a software-based managed device, we will have to activate this device. In the hardware-based managed devices, we already have the chassis ID and serial number, so we do not need to do it. Process will happen. The process will happen. The process, make sure that you have also validated that device. Make sure that you have sent the device to all the controller. Make sure that all the controllers know about that chassis ID and serial number. So those steps remain exactly the same. That once the device is received at the branch location, then I'm going to mark that device as the valid device, and I'm going to add it in the controller. So now wait. Now just keep waiting. Now wait to see if the ZTP process. Now what will happen? Now what process will happen? The device will take its chassis ID serial number. It will reach out to the vBond. vBond will check the chassis ID and serial number. It will authenticate it. Once it authenticates, it will provide the information about the vManage. The device will reach to the vManage and see the configuration push was successful. See, 3 devices are now attached with the template. You see the certificates. You see. So half of the part we can't mimic, by the way. The half of the part we cannot mimic. The half of the part where the device gets the information, the device gets this information from the ZTP server. We can't mimic it. Rest I just showed you. We cannot like simulate that. Apart from that, you can now you now understand the process of the ZTP. So first the device will reach out to the ZTP server to get the information about the vBond and the org. Then the device will be validated by the vBond. Then the vBond will provide the information about the vManage. The device will reach to the vManage, get the system IP, and all the rest of the process that we discussed in the previous class has now happened, and you can see all the information presented there. See, now all the devices are actually in upper state. There are 3 devices that are now completely reachable. The devices that are reachable are like site 3 VS2 is not reachable. Site 3 VS2 is not reachable. Apart from that, all these devices are reachable. So I will just restart that device, so it will become reachable again. But apart from that, all the devices, you can see, all the devices have become up, site ID, system IP, all good here now. So you see, so all the devices are now completely up, and so this was how we can onboard the WAN edge devices, and we can attach them with the help of some templates as well. I also tried to show you the ZTP process. The first half of the ZTP process we can't actually mimic, but the second half of the ZTP process we have mimicked successfully. This is now done. When this device boots up, it will also become reachable. So all the 4 devices will be reachable. You can check the information based on site to site. You can see on site 1 what devices we have. You can see on site 2 what devices we have. On site 1 we have site 1 VH1, site 1 VH2. You can see the site specific information from here as well. If you want to see the site specific information, you can check it from here as well. And global basically means show me all the information. All the devices, by the way, no need to tell you that all the devices also have established once the vManage device comes to know about other vManage device. All the vManage devices also have established the IPsec tunnel. You can go anywhere. You can go anywhere and you can see the IPsec tunnel getting established on all the devices by executing the command show. By executing that command, show IPsec inbound connection or show IPsec, IPsec outbound connection, show BFD sessions. You can execute these various commands to see that the tunnel is in fact established. So site 1 VH1 has established the tunnel with 10.1.12, which is site 2, and 10.1.13, which is site 3. It's at the moment down. Once the device comes up, the tunnel will also come up. Remember that between the same site, the tunnel is not allowed, by the way. Between the same site, tunnel is not allowed. Go to the system configuration, go to the system template, and execute the command allow same site tunnel. Go to the system template and allow the command, run the command allow same site tunnel. Then only, even if the devices belong to the same site, they will be able to form the IPsec tunnels. You can validate all the rest of the things from the command point of view. The IPsec tunnel, the BFD sessions, the control connections, all those things you can then validate based on your technical understanding, based on the configuration commands. You can validate all those things. Everything is now up and running, and you can just confirm that the tunnel is up from. This is how the vEdge devices are on. This is how the WAN edge, this is how the vEdge, not the cEdge. This is how the vEdge devices are onboarded. And now we will talk about the cEdge device onboarding. Here the CS device that we have, it is like C8000V, 1000V, whatever. You can see that the device has hanged. We can see that the device has hanged. And we unfortunately cannot do anything about it. Like, it has hanged basically. So I will just power it off. And I will just restart it again. So this device has booted up, by the way. Admin and Cisco@123 is the username password. Yeah, so Cisco@123 and Cisco@122. So I have configured the device, like the CS device that we have. The CS device is booted up. It could be a C8KV or C1KV, 1000V, 8000V, whatever it is. Does not matter. Just take a look at the show version command. Execute the command show version and find out if it is a 8000V or if it's a 1000V. So what is this? Is this 8KV or 1KV? What device it is? It's actually, what is... screen is already shared. I did not stop the screen sharing. Screen just no. I'm just booting up the device. Yeah, that one I'm just booting up. Just wait. I will just. Yeah, now it's there. So just execute the command show version. Just execute the command show version and find out like what device it is. Show version. This is, by the way, what device it is? 8KV. It is C8KV. This is CSR or C8KV device basically. C8KV device it is. So no problem. Remember to, like, when the device boots up, remember that you have to execute the command controller mode enable. Once you enable the controller mode, then only the device will boot in the controller mode. So already we have covered this in the previous classes. So make sure that the device is in controller mode. So you can see that the device is, if it is in controller mode or the autonomous mode, you can check if the device is in controller mode or the autonomous mode. We already have executed the command when the device booted up. Previously, like in the previous class, we executed the command controller mode enable. That means the device is now in the controller. And then the onboarding of this CS device is a little bit different. So watch carefully. How can you onboard the CS device? Before you do it, use the command swipe interface brief to cross-check the interfaces. If it is not 1, 2, 3, 4, then restart. If it is not 1, 2, 3, 4, then restart this CS device. If after restarting it's not 1, 2, 3, 4, then restart again, keep restarting until you see the correct interfaces 1, 2, 3, 4. Else you can just wipe that node. You can wipe that device. You can wipe that node and start again. Set the configurations from the scratch again. You will not need to do it. You just restart. Just keep restarting the device until you get the correct interfaces. I already have briefed you on the issues that you might face in the CS device onboarding. One of the very common issue is the incorrect interfaces. So if the device boots up with the incorrect interfaces, you will need to restart the device again and again until you get the correct interface, by the way. So at the moment it's fine. So I am going to do the same basic configuration, configure terminal. I am going to do bare minimum configuration because I am going to attach this device with the template anyway. So I will push the templates from, I will push the configs from the template. So I will just do bare minimum configuration. Like configure terminal command is not running. So configure transaction command is config transaction. Configure terminal command runs in the autonomous mode, and config transaction command, it runs in the SD-WAN mode. So the command is config transaction. I'm going to go under the system. I can configure the host name and all those things, but I am not going to do it. I will do it from the template. So I'm just going to do some bare minimum configuration, some basic configuration. I will do some basic configurations here, and rest of the configuration I will push from the templates actually. So under the system, I will configure the vBond. I will configure the org name, organization name, I-MEDITA. Then I can also configure things such as site ID if you want to. You can configure system IP if you want to. Like, you know, although like we can also push these configurations from the vManage, but while doing the initial configurations, we can do all that, right? Then commit these changes actually. So the CLI, the command line interface remains very much similar to the vEdge. Like we have system, then the vBond, then the org name. By the way, the host name is configured here. The host name is configured outside of the system configuration. So this is site, this is DC, cEdge 1, something like that. The host name is configured outside the system configuration. In the vEdge, the host name is configured inside the system configuration. And I'm going to disable the log, no logging console. I'm going to disable the log. I do not want any log on the console, so I am just disabling the logs for the moment. I don't want these log messages on the console. All right, so I did the configuration. I did the configurations of system. I did system configuration. I did the system configurations here. I did the basic system configurations here. I did the configuration like you know, we configured like the vBond, org name, site ID, system IP. Then we exit, and then we set the host name. You know, we set no logging console. Some basic things we did. I will configure the IP on the interface gigabit 1. So show IP interface brief. The interface is gigabit Ethernet 1. So config transaction. The command is interface, and interface is gigabit Ethernet 1. Then no shut. Then the IP address is 100.1.2.1 to 55255.255.252. Then I'm going to say IP route 000 and 000. I will configure the default route as well, 100.1.2.2. So basically, the way we configure the IP address on the normal interface, we have configured the IP address here on the gigabit 1 interface. IP address 100.1.2.1 to 55255.255.252, and the default route I have configured pointing towards the data center firewall, which is 100.1.2.2. This must have made me reachable with the 100.1.1.1, 100.1.1.2. This must have made me reachable to the controllers. So the reachability is now there. I did bare minimum configuration. Basic things, the very basic things I configured under the system, and the basic thing I configured under the interface. The interface, no shut, IP address, and those things. Problem is, we do not have VPN 0 here. We do not have the configuration of VPN 0 here. We cannot configure like VPN 0. I cannot configure the VPN 0 interface and put that interface gig 1 in the VPN 0. I cannot do it. Just like we do on the vEdge devices, we cannot do it on the cEdge devices. Instead, what I have to do, I will have to create, instead of using the command tunnel interface and all, I will have to create a tunnel interface, config transaction. The command is configure terminal, interface tunnel. I will have to create the tunnel interface. The command is interface tunnel, and tunnel 1 to whatever interface tunnel I will have to create. Interface tunnel we will have to create. Instead of saying like interface gig, and that instead of saying that this interface is a tunnel interface, I will actually need to create the tunnel interface. On the CS devices, when we do the onboarding, I will need to create the tunnel interface by the command interface tunnel, and then the tunnel interface number 1, then it is going to be tunnel IP and the numbered gigabit Ethernet 1, which means whatever IP we have configured on the interface gigabit 1, the same IP will be used on this interface, and tunnel source is going to be gigabit 1 and tunnel mode is going to be SD-WAN. This is the difference between the vEdge and the cEdge onboarding. On the vEdge, we don't need to do all these things. We can just go under the interface. I can just go under the interface and then I can configure the tunnel interface command. Here we can't do it. Here we unfortunately cannot do it. Here we have to say interface tunnel, the interface number, then IP and number. This command means like whatever IP we have configured on the gig 1 will be used as the IP on the tunnel 1, and tunnel source is the gig 1 and tunnel mode SD-WAN. If we had 2 interfaces, if we had 3 interfaces, the interface tunnel 1, interface tunnel 2, interface tunnel 3, tunnel source, tunnel destination, tunnel mode, basically all those things you will need to configure one by one for all those WAN interfaces. And then you go to the SD-WAN configuration. Since the tunnel mode is SD-WAN, you will go to the SD-WAN configuration, you will put your interface there, the interface gigabit 1, and here you are going to say allow service, tunnel interface, allow service, encapsulation. Here you are going to execute all those commands, color, red, whatever. Commands become something like that. Let me repeat the commands, by the way. The commands become something like that. The very first thing, you will go under the physical interface. This is your physical interface. The physical interface you will configure with the IP address. You will do the no shut on the physical interface. You will also configure a default route pointing towards the edge, the data center, edge, the firewall, for example. Then you will configure an interface tunnel, T capital, interface tunnel, the number of the interface tunnel, then the IP address on the tunnel interface is going to be the same IP on the gig 1. So IP unnumbered. Unnumbered is a technique to borrow the IP from one interface to other. So IP unnumbered, then the tunnel source and the tunnel mode. This means that this tunnel will be used for SD-WAN. Then go under the SD-WAN and configure those commands such as interface gig 1 is the SD-WAN interface. It is the tunnel interface, allow service, color, and all those things we will need to configure. These steps are different than the steps that we take for the vEdge device. These steps are different than those interfaces. Same certificate installation process. This part is done. Now, like the certificate installation process. This is the basic part that we had to do. Now the certificate installation process. Remember that we do not have the vShell here. We do not have the vShell here. We do not have the vShell here. So there are two ways. There are 2 ways by which we can copy the certificate from the CA onto the cEdge device. There are 2 ways. I will show you both of the ways just for your reference. Whatever suits you, you can use that option. One way is very simple. One way is just to use the copy command. Since we already have the reachability from here to here, one way is to use the copy command. We can use the copy command in order to copy the root certificate from the vManage onto the CA server onto the cEdge, by the way. So we can use the copy command. Simply the command goes like this. The command is copy. I want to copy using SCP protocol. From where? From admin 100.1.1, then rootca.pem. This is the file that I want to copy. Copy using SCP. Using the SCP, copy the file from this source rootca.pem file and paste it in the boot flash. In the flash memory, paste the file, copy the file in the flash memory with the name same rootca.pem. Command is copy SCP admin @100.1.1.1 rootca.pem and boot. So copy command, the command that we already have in our iOS, we can execute that command and we can copy that command. We can use the copy command to copy that certificate like that. You can see that the file was copied. You can see show boot flash, and here you can see at the very end you must have that root certificate. At the very end or somewhere in between maybe you will have that root certificate. Here, right here we have the root ca.pem. So copy command. I'm going to use the copy command to copy. I'm going to use the copy command to copy the root certificate from the CA server onto the device, and then I will install it. Request platform software SD-WAN root search chain install. There the command was request root search chain install. Here the command is request platform software SD-WAN. This command, this thing will be added in between. So request the platform software SD-WAN root search chain install, and the root certificate is in the flash memory. Root search chain install, and it is in the flash memory with the name rootca.pen. So it will install the root certificate. This command will install the root certificate from the boot flash into the device. So SD-WAN certificate, root CA certificate. Command is there. The command was show certificate. Here the command is show SD-WAN certificate. Show SD-WAN certificate, root CA certificate, and you execute this command, and you will see the root certificate that we just installed. You see the org name is SD-WAN test lab and all that thing. You can see that the root certificate which is installed. Root certificate is now installed. So we executed the copy command. And then we executed the installation command for that root certificate and activate it. Request platform software SD-WAN VH cloud activate chassis number, and I can take any chassis number from here. Configuration, certificates, any cEdge router, yeah, C8 KB. I'm going to say, I'm going to first of all copy, and I'm going to paste it here, and token is going to be this one. Copy and paste it here. And do not forget that you have to validate the device, and you will have to send the device to the controller. You will have to validate the device, and then you will have to send the device to the controller. Then only all the controllers will know about that particular device. Then only you can activate the device with the correct chassis ID and token number. So wait now, go to the certificates, and wait now and see the certificate installation process for this managed router. It will also happen automatically. The certificate installation for that cEdge router will also happen automatically, just like it happened for the VH devices. It will also happen for the cEdge devices. So this token generated, the certificate installation for this one, it will happen automatically, just like it happened for the rest of the devices. This one. Make sure that we have configured all the things properly. Make sure that show like vBond information, show SD-WAN, running configuration. So you just make sure that we have configured all the basic configurations correctly, such as system IP, such as site ID, such as vBond, such as org name. Make sure that we have done all those basic configurations properly. Make sure that we have configured the IP. Make sure that we have configured the route. Make sure that the tunnel interface is created. Make sure that the SD-WAN allow service command and all that thing is running properly. When everything is okay, we must see the certificate installation process. You see, CSR is generated, and it will install the certificate there in a moment. Yeah, so C8 KB, you can see the certificate installation was done for that device as well. That device is also now onboarded. Just go to the Catalyst SD-WAN, the main dashboard, and here you can also validate the commands like show SD-WAN control connections. You can see the control connections are established or not. So you can see the control connections are up. Show SD-WAN control, then local properties. Every command is same. Just add the keyword SD-WAN in between. Just add the keyword SD-WAN in between, and you will see. Just add the keyword SD-WAN in between, and you will see the exact output as you were seeing earlier as well. So everything else is basically same. The onboarding of the cEdge device is pretty much similar to that of the VS device. Just a few steps are different, like the tunnel interface, and those things are a little bit different. Apart from that, like things remain pretty much exactly the same. The concept remains the same. I will say that the concept remains very much the same. It's just we are going to, it is just that we are going to use different steps for the onboarding purpose. Now I will advise you that as soon as you are done doing the basic onboarding, I will advise you right away configure the template immediately, because otherwise, there are very good chances that if you power off this device and power on the device, there are very good chances that the device will boot with incorrect interface. So that might create the problems. So I will advise you that you do the cEdge onboarding process in one dedicated day. And once you are done doing all that onboarding, just right away configure the template, which we will do just in a moment. But first, let me tell you the second process. The second way, if you're not able to copy the root certificate, via this command, if it shows 0 byte copied, if it shows you that 0 bytes copied, when you execute that command, if it shows you 0 bytes copied, that means the certificate was not copied. Then you have another way. You have another way to in fact do the onboarding, to copy that certificate. Actually, you have another way to actually onboard or copy that root certificate. All these things are documented, so you already have these things in your documented format in the portal. But the other way is to use TCL scripting. So TCL sh, the command is TCL sh. So you have to go to the config transaction mode, and then here you will have to execute the command like TCL sh. But remember that this command, once we execute the TCL sh command, it might not work in the controller mode, so do it before onboarding. So on the C8K device, 8 KB device, it does not work. In the CSR 1000V, when the device is in the controller mode, it accepts that TCL sh command. So we can use the command TCL sh. The command is TCL sh. We are going to enter, and then we are going to execute the command in this format. The command is TCL sh, enter, and then just copy this command. Copy this thing and paste it here, and then just enter. When you press enter, it will ask you to paste the root certificate. So you will copy the root certificate from the vManage. You will copy the root certificate from the vManage here. You will copy the root certificate from the vManage vshell. You will say cat rootca.pem. You will say cat. You will copy this certificate, and you are going to paste that certificate here. You are going to paste that certificate right here. Once you enter in the new line, you are just going to do the right click. You are just going to paste the certificate. Once you paste the certificate, enter and close these brackets. Close these brackets, enter, and TCL quit. So this is the command. When you execute, it will create a file on your cEdge router with the name rootca.pem. Unfortunately, that command does not work on the C8KV, but the command will successfully work on the 1000V. Actually, you can try that if that thing is not successful. By the way, if that copy command is not successful, you can execute the command like this as well. TCL sh command you can execute, but mostly like the copy command will work fine. If it doesn't, then you can use the TCL command. Once done, once all the control connections show SD-WAN control connections, once all the control connections are established, just right away push the template. Do not wait, just right away push the template. Create the template here. Go ahead and create the templates here. Template, and create a template from the feature template for your cEdge router, C8KV. Or CSR 1000V, whichever device you are working on. Either you are working on C8KV or you are working on C1000V, CSR 1000V, whatever. Select it. It is SD-WAN edge router and DC cEdge template, something like that. I have executed. Then I'm going to create some basic templates from here. So such as system template. I'm going to create a system template quickly, like DC system Site ID. Site ID is 100, by the way. System IP is device specific. Site type, time zone. Time zone we can specify like some time zone as per your requirement. You can specify. I'm going to do the bare minimum configuration. Like location, for example, Australia. So this device is in Australia, maybe. Description like device in DC. Baud rate. Then apart from that, nothing extra that we have to configure. So click on the save button. So I've configured a system template. I am not going to configure the logging template and TP template. I am not going to do it. I'm just going to do very basic template push here. No AAA template, no BFD, nothing. If you want to add the AAA templates because you want to change the username, you can create a template. So AAA template, AAA for DC. Then just scroll down and change the username password to Cisco @123. The password is Cisco @123. So add it. Please fill in the required field. One fields are required. What field? What fields are required? Server group priority. Okay. Local. Okay, fine. What else? No OMP, no BFD, no security. VPN 0, yes. VPN 0, I will create a template. VPN 0, this interface. VPN 0, I will create a template, by the way. VPN 0, DC. This is VPN 0. Name and everything, I'm not going to configure this time. Do it yourself. In the VPN 0, do you want to provide the DNS information? Yeah. So 8888 is my DNS server. Secondary DNS, if you want to provide, yes, 1111 is my secondary DNS, whatever. You can also do the host mapping here as well if you want to. No need to do it, just IP route I will need to provide. 0.0.0.0/0, and the next hop is going to be 100.1.2.2. So 100.1.2.2. No V6 route, no service route, no extra service, no NAT, nothing. Save it. VPN 0 template we have configured. Then what? VPN interface template. Okay. There is one interface, gigabit Ethernet 1. So GI1 DC. And interface, I don't want to do shutdown. The interface name is gigabit Ethernet 1. The interface name is gigabit Ethernet 1. The IP address is, by the way, 100.1.2.1/30. Sorry, /30. 100.1.2.1, 100.1.2.1/30. Since I'm going to push this device template only on one device, I can put as many values as global, not the device specific, so that we have to fill less and less values on the template push time. Whatever. I'm doing the exact same thing. I am repeating all the exact same thing that we did for the vEdges. I'm doing the exact same thing for the cEdge devices as well. VPN 512 template. This is VPN 512, by the way. VPN 512 and DC. VPN 512, name, DNS, nothing, no route, nothing. Save. Then the VPN interface template. Okay. Gigabit Ethernet 3. I'm going to bind gig 3 for our VPN 512. Gigabit Ethernet 3. Gigabit Ethernet 1 is here, 2 here, and 3 I am going to consider for the management actually. That interface I'm going to put shutdown. That interface is Gigabit Ethernet 3, by the way. I can say no shut to that interface if I want to, and the IP address and everything we will get from the DHCP later on whenever we connect whenever we connect a management switch out of that interface. I am binding a dedicated interface for the management purpose, that is gigabit Ethernet 3 or maybe 4 or maybe 5 or whatever. No tunnel interface, no NAT, nothing. Save it. Then a service side VPN, yes. So we have a service side VPN. Create a new VPN. The service side VPN is going to be VPN 10. Here we are going to have a VPN 10 here. So VPN 10 data center. VPN number is 10. Name and everything up to you if you want to configure the name and all. The DNS 8.8.8.8. Secondary DNS maybe 1.1.1.1, whatever. Route, no V6 route, no service, no GRE, no IPsec, nothing. Just configure the VPN number. Maybe you want to configure a name if you want to. That is corp VPN, and then just DNS and all that thing. So save it. Here is the VPN 10 template that I just configured, and I'm going to configure one interface there, VPN interface Ethernet. So the interface template I'm going to create as well. This is going to be gigabit Ethernet 2, GE2, IP address 192.168.100.1/29, 192.168.100.1/29, and just tunnel interface, no NAT, no VRRP, no ACL, no quality of service, no ARP, no TrustSec, nothing else. Just save it, add it. Anything else? Nah. So nothing else. Banner, if you want to, like, if you want to configure a banner. So banner, for example, DC. I can configure the banner for the data center, and the login banner is stay away if not authorized. You can configure whatever banner you configure. I'm just configuring it. You can do the configurations. You can do the configurations like that as well. We can configure things such as banner, SNMP, and whatnot. We can configure various things from here. Click on create. We have configured various feature templates, and we assemble them in the device template. And I'm going to attach now. Attach device, the DC device, the cEdge device I am going to attach. Whatever things are variable, you will need to fill those fields. Unfortunately, we do not have a lot of things as variable. We have set most of the things as global. So we will not need to fill up a lot of things. Just next and just configure. Do it on the same day. Whenever you are configuring the cEdge device, once you do the basic configuration on the cEdge device, just push the template right away. Do not wait. Just push the template right away. Do not wait actually for the for the next day, and also don't wait. Because again, repeating the same thing, if you, let's say, for example, set up the cEdge device, and then you power up the cEdge device, then you try to attach the template on the next class, there are very good possibilities that the cEdge device will boot with incorrect interface. And then you will have to either restart the device, keep restarting it again and again and again until you get the correct interface. Else you will need to wipe the node and do all the steps again. So I will advise you that you do it. You do both of the things, configuring the device and attaching it with the template right on the same time. So things are happening here. The device has pulled the configuration. The device has pulled the configuration with the feature template and everything. The device has pulled the configuration. So the configuration must have been delivered onto this particular. So you can see admin, password, you can see enable, you can see show IP interface brief, you can see the IP address on the interface, you can see the IP address on the interface, system interface, some loopbacks it has created automatically, some tunnel interface, basically whatever things we configured, we can see show SD-WAN running configuration. We can see all those configurations right from all these configurations. You see the color and whatever like you. What I'm trying to say is that do it on the same day so that you do not get the issues. So now that device is also attached with the template. That device is also attached with a cEdge device. We also have attached with the template. We have attached the vEdge device and we have attached the cEdge device with the template as well. One device is unreachable. It must be the site 3 device actually. Site 2 reachable. Okay. I will just restart it and it will become reachable, but no need to do it right now. It's just now the template attachment process. The template attachment part is also now complete. So things are now working as expected. No need to tell you that this CS device also has established the IPsec tunnel with the other devices. You can validate, show SD-WAN, IPsec inbound connections, show SD-WAN IPsec outbound connection, so SD-WAN IPsec outbound connections, show SD-WAN, show SD-WAN BFD sessions. You can validate all the same commands, same exact thing, just the difference actually, just the difference is the keyword SD-WAN in the middle. The difference is just the SD-WAN keyword in the middle. The rest, everything is pretty much the same. This is done now. This part is now done. The reachability and everything is there. The tunnels are established. Everything is now working as expected. So we are done with the template configuration part of the vEdge, cEdge, and the CLI templates and everything as well. The template part is now done. We have centralized policy, we have localized policy, we have centralized control policy, centralized data policy, localized control policy, localized data policy. Control policies affect the control plane. Control plane is based on OMP. OMP carries two types of information. One is like routes, like OMP routes, and one is TLOC routes. So we can influence both OMP routes and TLOC routes with the help of the control policies. And the data policies that we have, data policy is there, data policy that we have here. It is to carry the data traffic. Data policy is to carry the data traffic. So like if you want to influence the data traffic from like sender to receiver, receiver to the sender, if you want to influence the data traffic, for that we can create a data policy and we can apply that data policy respectively. So both the types of policies we can implement, both the types of policies we can influence, we can create and we can influence like control traffic and the data traffic as per our requirement. Now, no matter if you're talking about like control policy, data policy, no matter what type of policy we are talking about, note that all the policies we are going to create on the vManage. All the policies we will create on the vManage, and those policies that we are creating on the vManage will be sent to the vSmart controller if it's a centralized policy, and they will be sent directly to the vManage router if it's a data policy. Based on what type of deployment we want to have. So right here we had the diagram here as well. So if the policy is a centralized policy, then the centralized controller will come into the picture. And if it's a localized policy, the centralized controller will not come into the picture. And if it's a control policy, if it's a centralized control policy, the vSmart will execute the policy itself. And if it's a centralized data policy, since the data traffic is forwarded from the vManage devices, the vSmart controller will forward that. The vSmart controller will forward that policy to the vManage devices, and the vManage devices will then, based on the policy, start forwarding the data.
So localized policy is like we manually on the CLI we configure it, correct?
No, localized policies are also created on the vManage. They will just get delivered directly onto the vManage router. We already have done it, by the way. If you remember, here what we did in our topology, what we did, we configured the OSPF templates and we attached the OSPF template on the site 1. We configured the BGP template, EIGRP template. These are in fact, these are the localized control policies, by the way. So localized policies are attached to the devices with the help of the templates directly. We don't require any vSmart controller in between. Such as the routing that we have done, the routing that we have done like OSPF BGP, it comes under the control policy, localized control policy, because why localized? Because it affects a local site, it affects a local device, it affects a local branch, local site only. It doesn't affect the entire SD-WAN fabric, it just affects the local site where we are pushing the template. So that's why the localized policy and localized control policy, the policy to influence the routes that we have already covered. We already have configured OSPF, BGP, EIGRP in the service side. using the templates and all. So that comes under the localized control policy. So they are pushed by a template. Since they get attached directly to the devices, hence the name localized policy. And since the centralized policies are sent to the centralized controller, the vSmart controller, and from there, the policy either will be executed by the vSmart controller, or the policy will be delivered to the vManage device for further execution. And no matter if you're talking about centralized policy, localized policy, how the policies are delivered, we talked about like vManage will deliver the policy with the help of the netconfig, netconfig. And when the vSmart has to deliver the policies to the vManage devices, it will use the OMP messages, because between the vSmart and the vManage, the OMP is already running and all. So this is how the routes are going to be like distributed. Sorry, this is how the policies are going to be distributed in the SD-WAN fabric.
Manage device will send it to the vManage will send to the vSmart, and vSmart will send the traffic to vManage, correct? I mean, policies to vManage.
Only if it's a data policy. Only if it's a, you can take a look at here, only if it's a centralized data policy or centralized AppAware policy, then only the policy will get delivered from the vSmart to the vManage. Else the vSmart itself will execute those policies. Only if the policy is the data policy, only if the policy has to influence the data traffic, then the policy will get delivered from the vSmart to the vManage. But if it's a control policy, then the policy will be handled by the vSmart itself.
I didn't get actually. So
take a look at the arrows. Take a look at the arrows that are here in this diagram. If it's a centralized data policy and if it's a centralized AppAware routing policy, then only the policy will get delivered from the vSmart to the vManage. Else not. Else the policy will be executed by the vSmart itself. If it's a control policy, who is a centralized controller? The vSmart will execute the policy itself. And if it's a data policy, then the policy will get delivered to the vManage devices.
Okay, understood.
vManage are the data plane devices. So how to create the policies, by the way? In order to create the policy, you will have to go to the policy dashboard right here. So on the vManage, we have configuration, we have the policies. Here is the policy dashboard. And from here, we can create the centralized policy or the localized policy. So we have centralized policy option, then we have the localized policy option. We can create the centralized policy, we can create the localized policy. So click on the centralized policy, click on add policy button. And here are the things, here are the steps that you'll have to take in order to create the centralized policy. The first step is to create group of interest, the match criteria. The criteria based on which you want to match. The criteria based on which you want to match the things. Such as I have here sites, so I can match. These are different lists, such as we have access list, prefix list, route map. Here in this SD-WAN, we have these lists. There are different lists based on which we can match various things. Such as we can match the routes based on the site ID. We can match the TLOC based on the site ID. We can match the routes based on the VPN. We can match the TLOC based on the VPN. We can match the data traffic based on the VPN. We can configure, we can match the TLOC based on the color. We can match certain application traffic. We can match the packets based on the source IP, destination IP. We can match the routes. So these are called lists. These are like group of interest. These are called lists. Lists are more like the match criteria. So based on what criteria we want to match, and then configure the policies accordingly, such as VPN. So there are two VPNs. One is like Corp. I'm going to say Corp VPN, which is VPN 10, by the way. And we have, let's say, for example, the guest VPN. So I'm configuring the VPN, guest VPN, which is VPN 20. So I can create like the VPN 10, VPN 20. I can create a VPN list to match our desired VPNs. Or we can create a VPN list like all, for example, VPN. So here I can match like 10, 20-30. I can match as per the requirement. I can use comma. I can use this hyphen to mention the range. So 10, 20/30, for example. So this is called VPN list. Just like we had the access list, just like we have the prefix list, just like we have the route map. This is called the VPN list to match the things based on VPN number. We have, for example, the site list. Here we have new site list. This is like BR1. BR1 is site number 1. BR1 is basically site number 1. I'm creating like list, branch list. Site 1, site 1 is there. Now site 2, site 3 respectively. Right? So yeah, so basically I was just creating the list. So I can create these lists like branch 1, branch 2, branch 3, branch data center, and we can mention the list number like the site number 1, site number 2, site number 3, site number. You can match like spokes, for example, like 1 to 3. For example, like data center is already there, spokes and the branches, all the sites, for example. So you can create this thing called site list. This is site 1, 2, 3, and 1. So we can create this thing called site list. Site list is where we can match the things based on the site ID. So branch 1, branch 2, branch 3, site 1, site 2, site 3, then DC, then maybe like these devices, site 1, site 2, site 3, these are the spoke, and the data center is like the hub. So spokes 1, 2, 3, all the sites we can match the sites based on site ID. Color, for example, color like MPLS. What color? MPLS. Color list, we can match here our colors that we are using in our SD-WAN environment. So we are using color MPLS. We are using the color public internet, for example. We are using the color public internet. For example, we are using like the, what is this? What is that? In the data center, I guess I'm using gold. So I believe in the data center, we are using the color gold. I have set the color gold in the data center. On this router, I guess I have configured the color as gold. If I'm not wrong, I guess it's gold on that cEdge router. How can I check, by the way? I can go on the any site router, such as site 1 VH1, and I can execute the command admin Cisco @123 and show OMP and TLOC paths, for example. So yeah, it's gold, by the way. Gold, which is a public color, by the way. We can add multiple colors, like all colors, for example. So you can select multiple colors from here, such as you can add here the public internet. Here you can add MPLS. Here you can add gold, for example. You can add all these colors as per the requirement. So color list, we call it like color list. We can create the list to match our colors that we are using in the network. Similarly, we can create other TLOC list, for example. Similarly, we can create other lists as well, such as TLOC lists, such as prefix lists, such as data prefix lists. We can create different types of list, which we will do throughout the content. But the objective of the list is to match based on various criteria. Match the route, match the TLOC based on site ID, match the route, match the TLOC based on VPN, based on TLOC, whatever. Like, we can define various things right from here. So for example, in the branch 1, so we have multiple TLOCs, right? We have multiple TLOCs, okay. So for example, here we can create a new TLOC list. This is BR1 or site 1 VH1. Site 1 VH1 has the TLOC as 10.1.11.1. Color is like public internet, and encapsulation is IPsec. We have not set any preference, so we are not going to match any preference here. Then add the TLOC again, 10.1.11.1, MPLS, IPsec. We can set the preference to higher or lower value, but it is more like to match, not to set at the moment. So match. So there are two TLOCs on the site 1 VH1. I have matched both of those TLOCs of site 1 VH1. Then you can copy right from here. You can copy, and this is going to be site 1 VH2, for example. And then you can edit it as per the requirement. It is going to be just 10.1.11.2. This is going to be site 1 VH2, by the way. Same color, same encapsulation. you can create these different TLOC lists, for example. This is site 2, for example, VH1. Site 2 VH1, and you can just keep editing it as per the requirement. Site 2 VH1, Site 2 VH1, you can edit it. Site 2 VH1, you can edit it, and it's 10.1. It is 12.1. You can match the TLOCs in this TLOC list.
The preference is showing both for same.
Preference is by default 0. So we have not set any preference, so we cannot match any preference in the TLOC list. So that's why the preference is 0. For example, DC TLOC, DC TLOC, DC TLOC, it is 10.1.100.1, and the color is, by the way, gold there. So gold encapsulation IPsec, and there is no preference. So the preference is 0, no preference. It's not mandatory that you create all these things beforehand, but you can create it later on as well. As per your requirement, you can create it later on as well. But I'm just telling you, like, these are different types of lists. So we can create like various lists as per our requirement right before we create any kind of policy. So we are creating our group of interest. These are called lists. The very first thing is group of interest. Group of interest, where we create the prefix list, site list, TLOC list, VPN list, color list, SLA list. So we will create the group of interest, basically based on which we want to match our prefixes respectively. Match the prefix, match the TLOC, match the route, match the TLOC, match the data traffic respectively, for example. Once done, once you have created the required lists as per your understanding, whatever things were needed, once you have, for example, created it. Now, let's go to the next policy. We are going to create the policy next. So click on the next button right from here. And right here, we have this section, configure topology and VPN membership. It contains our control policy. It contains the things that we can influence using OMP, Overlay Management Protocol. This section, this right here, this contains our policy for various things, such as control policy, VPN membership policy, and those things. So for example, let's say we want to create a very basic hub and spoke policy, where I want to designate the data center router as the hub router, and I want to designate all these devices as the spoke devices. See how easy it is. Okay, add a topology policy. What policy? Hub and spoke policy. Name, hub, spoke. The policy number 1 is hub and spoke. You can put some description as per your requirement. You can put some description as per your requirement. You can put some description as per your requirement. Do it yourself. So, and then for what VPN? For what VPN do you want to have hub and spoke? I want to have hub and spoke for the corporate VPN, which is VPN 10. For the other VPNs, I don't care actually. For other VPNs, I do not care. For other VPNs, I don't care. I want to create a hub and spoke policy only for VPN 10. I want to create a hub and spoke policy only for VPN 10. What is the hub site? Okay. The hub site is data center. And what is the spoke site? Add. What is the spoke site? Here is the spoke site. What is the spoke site? The spoke site is BR1, BR2, BR3 spokes. Remember, we already have created the site list where we have defined data center site 100, and we have defined our spokes 1, 2, 3, and done. That's it. Done. Save. Done. This is how we can create a hub and a spoke policy. Done. Mark what device is the hub device, mark what device is the spoke device, and done. You can also control what routes, what prefixes you want to advertise. Let's forget about it. I'm just going to skip it, save the hub and spoke policy, and done. This is how we create the hub and spoke policy. I'm going to create just one policy, just one hub and spoke policy. Okay, done. Click on the next button. I don't care about the traffic rules. Click on the next button, and click on the next button. And this is the hub and spoke policy, by the way. So this was the hub and spoke policy that I created. this is the name of the policy, like, so you can give whatever name, like hub and spoke policy for the VPN 10, whatever you want to name it, like, you can name it as per the requirement, and nothing else, just save it. Just save it. Or you can preview to see what configuration will be pushed, but you can just save it. Just save it. It will save that particular policy. And done. This is how you create a hub and spoke policy. This is the amount of time it will take to create a hub and spoke policy. You have to create the lists, like a site list, VPN list, and you have to say that in VPN 10, these sites are the hub sites and these sites are the spoke sites, and done. That's it.
Why we have to do this? Like, if you have a firewall on that site, if you want to route all traffics via that firewall.
Sorry.
So why we do this one hub and spoke? Because there will be reason that there is a firewall in that site, hub site.
Same hub and spoke requirement. There was a requirement that all the traffic must pass via the hub router. So to fulfill I don't want to have the full mesh policy, too many IPsec tunnels. So we have designated some devices as the hub devices and some devices as the spoke devices. So we are going to have some sort of hub and spoke type of connectivity, so that our tunnels are limited also, so that they don't form the full mesh tunnels. Whatever could be the requirement.
Site 1 communicates with site 1 VH1, communicates with site 1 VH2. It will go via the upsite only, correct?
Site 1 VH1 will communicate with the site 1 VH2 via the LAN. There's no tunnel, by the way, between site 1 VH1 and site 1 VH2. Site 1 will communicate with the site number 2 via the data center. That is the correct statement. So once you have created the policy, you have to just activate it. Since it's a centralized policy, you can just click on these 3 dots and just activate it. You can, by the way, preview what configurations will be sent, but let's skip it. Just activate it. The policy will be applied to the reachable vSmart. Remember, it's a centralized policy, and the centralized policy is always applied via the centralized controller vSmart. So here is our vSmart controller. At the moment on this vSmart controller, show run policy, we do not have any policy, but as soon as I click on that activate button, you will notice that the policy will be sent to the vSmart controller. Remember, centralized policy means centralized control plane, vSmart. So the policy will be, once the policy is applied, then the policy will be delivered to the vSmart controller, and the vSmart controller will now have the policy.
So this policy will not be delivered to any of the vManage router.
No.
If any, so only thing is it will happen. One edge router is connecting to another edge router. That time this policy control plane will check and it will.
We'll see how it works, but this policy will not be delivered to the vManage devices. You can check on the.
Fine. I got it. Your concern. It will not be delivered on the vManage device.
Yes.
But when the vManage device communicates.
We'll talk about it. It will not happen like that. It will not happen like that. We will talk about it, what is happening in the backend, step by step. So just confirm first of all that you do not have any policy on the vManage router. Just confirm that you are not getting any policy from the vSmart controller. Show policy from vSmart. You are not getting the policy from the vSmart controller. You are not having any policy in the running configuration. So on the vEdge, the policy is not there because it's a centralized control policy, and centralized control policy does not get delivered onto the vManage devices. So the policy is only on the vSmart. The policy is there on the vSmart. Here is the vSmart. The policy has been delivered onto the vSmart, and now a few things will happen. Now the control plane operation will change. Now the route propagation thing, the control plane operation will change because of that policy which we just activated. We just activated this policy. And as soon as we do that, as soon as we configure this policy, as soon as the policy gets delivered onto the vSmart, a few things, the control plane operations will basically change. What happened actually in the backend? In the GUI, what we did, in the graphical user interface, what we did actually, we just configured what device is the hub device, what device, spoke device. We just did that and we just applied that. What is happening in the backend, by the way? How the communication, how the things are happening in the backend, by the way, how the policy is actually getting delivered. So if I take a look at the policy, if I go here, configuration, and if I go to the policy that I have just created, if I preview that policy, what is happening in the backend exactly? That when we configure that policy, you can see the route and TLOC propagation is being controlled. What routes and what TLOCs are going to be advertised to the WAN edge devices, that is now being controlled. Earlier, all the routes. Earlier, what happened? All the routes and all the TLOCs advertised to the WAN edge devices. But now, when we configure that policy, when we configure that centralized control policy, hub and spoke policy, it's kind of a route map kind of thing. So you can see the first statement says, match the routes of data center VPN 10. Match the route of the data center VPN 10, accept them, and match the TLOCs of the data center and accept them. This statement basically means that only and only data center routes of VPN 10 and data center TLOCs are going to permit it, and everything else is a reject. What is this site list DC? It is site 100. What is this site list DC? It's site 100. What is this Cork VPN? It's VPN 10. So as per this policy, what is happening? Only the data center routes and the TLOC. Only the data center route and the TLOC. Only those two things are permitted, and everything else is rejected. So match the data center routes of VPN 10, match the DC routes of VPN 10, and match the DC TLOC, and accept it, and reject everything else. So the vSmart controller is receiving all the TLOCs, all the routes from the data center, from the site 1, from the site 2, from the site 3. It receives all those routes. It receives all those TLOCs. But when this vSmart controller advertises out, when this vSmart controller advertises the OMP update, when it sends the OMP update to the spokes, site list spokes is like 1, 2, 3. When the vSmart controller advertises the TLOC and route information to site 1, site 2, and site 3, it will first apply this policy, meaning to say to the spokes, it will only advertise the data center routes and data center TLOC. One branch route and TLOC will not be advertised to other branch and other branches. One branch route and TLOC will not be advertised here. One branch route and TLOC will not be advertised here and there. So you don't even have on the branch. Earlier on the branch we were receiving like multiple TLOCs, but now on the branch we will not even have, this branch will not even have this TLOC, this TLOC, or this TLOC. So there will not be any IPsec tunnel from here. There will not be any IPsec tunnel from here. There will not be any IPsec tunnel from here. This site vEdge will only have the TLOCs and the routes. It will not even have these routes also. It will only have the routes and it will only have the TLOCs from the data center. So only this TLOC is present here, and only that route of VPN 10 is present there. So these devices can only form the IPsec tunnel. These devices can only form the IPsec tunnel with the cEdge router. Only the cEdge with the cEdge router they will be able to form the IPsec tunnel, and there will not be any direct IPsec tunnel. So we are also limiting the number of IPsec tunnels that the WAN devices can form. That is also a good thing, and the traffic will no longer go from here to here directly. The traffic must be sent to the cEdge, to the data center, and from the data center it will go here. Why? Because this data center router has given me a default route. It is not advertising. The vSmart controller is not advertising one branch route to other branches, so the reachability will not be there. Data center is giving me a default route. Data center is advertising a default route, and we have advertised that default route in the LAN network. So when you ping from, for example, you ping from here to here, following, you don't have the exact route. Following the default route, you will send the traffic to the site 1 vEdge 1. From here, following the default route, the traffic will go to the data center, and from the data center, it will go to the site to manage one, because the data center has, in fact, all the routes and all the logs. That's why the communication from the site 1 and site 2 will happen via data center. Why? Because the data center has advertised a default route. If not, communication will not happen. This is what is happening in the backend. This is what is happening in the backend actually. Only the data center TLOC and only the data center route is getting advertised to the branches. Understand the direction very well. Understand this direction. When the policy is getting applied, the policy is applied in the out direction of the site, in the out direction of the branches, in the out direction of the spokes, in the out direction of these sites, site 1 and site 2 and site 3. Whenever we talk about the centralized policy, always keep yourself at the vSmart controller. Whenever we talk about the centralized policy, always keep yourself at the vSmart controller. Remember that the centralized policies are always applied through the vSmart controller. So whenever you have to create, apply any centralized policy, always keep yourself at the vSmart controller. Place yourself at the vSmart controller. And when we say spokes out, that means when the vSmart controller out, when it advertises the routes to site 1 and site 2 and site 3, when it gives the OMP update out, when the OMP update is sent out of spoke out of the vSmart towards the site 1, site 2 and site 3, then the policy is going to be applied. And if it was if it was like a spoke in, which means that when it receives the OMP like information, when it receives the OMP updates, when it receives the OMP update from the branches from the site 1, site 2 and site 3, then the policy will be applied. This is called direction. Just like when we have to apply the ACL, we apply the ACL on the interface in the. When we say the direction is very important. Like when it comes to the centralized policy, localized policy, whatever policy, the direction is very important. Direction means like just like when we have to apply the access list. Just like when we have to apply the access list, we apply the access list on the interface in direction, out direction. In similar way, we are going to apply the policy in either in direction, out direction. But the direction, the concept of the direction is a little bit different than the ACL one. So whenever we talk about any centralized policy, all the centralized policies are always applied via the vSmart controller. So always place yourself at the vSmart controller. And when we say site out, when any centralized policy is applied for the site out, means when the updates are advertised, when the OMP updates are sent to that site, then only the policy will be applied. And when we say site in, means like when we receive the updates from, when we receive the OMP update from that site, then the policy will be applied. Direction matters a lot. That is what has happened. So when this vSmart controller is advertising the OMP routes and the OMP TLOCs to, it is out. When it is advertising the OMP routes and TLOCs to the site 1, site 2 and site 3, right at that point, it has applied the policy. Out basically means when I advertise the out. Spoke out means when I advertise the routes, when we advertise the TLOCs to the particular site, then the policy will be. This is what is happening in the backend. The policy is true. The policy is true. True basically means like the policy is now activated. And if you see the same policy, when the policy is true, you will be able to see that the same policy is available on the vSmart controller, and based on the policy, the route propagation and the TLOC propagation will be influenced. So you can preview, by the way. You can preview. You can view. View basically means show me the policy that you have created. So we have created a hub and spoke policy like that, for example, and preview is going to show you the CLI relevant commands actually. Preview will show you the CLI relevant command. You can edit it, but the only thing that you can edit here, in this case, the only thing that you can edit here most probably by the name and everything. You can't really Here is the hub and spoke policy under the topology. Under the topology, we have the hub and spoke policy. You cannot really edit it from here. You can't really edit it. You can just view. You can just copy. You really cannot edit this hub and spoke policy that you have created right here. You can't really edit it. If you actually want to edit it, then not here. If you want to edit something in this policy, just go to the very top, custom option, and from here you are going to click on the topology, and from here you will be able to edit that policy. From here you will be able to edit the policy. You can change, for example, the VPN, for what VPN we want to apply the policy, the name, for example, hub and spoke 1, for example. You can change the policy description, for example. You can change the policy name, for example. You can do the changes here. You can change the the DC site, you can change the hub site, you can change the spoke site. Those things you can do, and just click on the save button. Whenever we do the changes, we will have to apply those changes, of course. The point remains the same. The point remains the same, that whenever we have to do any changes, we can still do the changes. We can still edit the policy afterwards. Once we have created the policy, we can always edit the policy after we have configured it. Once we have attached it, we can edit the policy later on as well, as per the requirement. How long did it take? Hardly 2 minutes to create not even 2 minutes. Like, it did not take that much time to create that policy. Actually, it did not take that much time to create the policy. So once the policy is delivered, you can check those policies on the vSmart as well. You can check the policy on the vSmart by the command show run configuration, show running config policy, and here you can see the policy. And if you use the command show run apply policy, how the policy is getting applied. Show run policy, it will show you the policy, and show run apply policy. Show run apply policy, it will show you the policy that we are applying. We are applying the policy in the out direction of these spokes, for example. Again, repeating the same thing, repeating the same thing, that you have to understand the direction very well. You will have to understand the direction very well. If you do not understand the direction properly, then it will be a little bit problem. So direction, you will have to understand well. Site in, site out, the direction you must understand properly. If you are not able to understand the direction, then it's going to be a problem. Let me know, first of all, like at the moment, if you have any doubts, any questions, let me know. This is a very basic, we'll talk in more detail about it, but this is just the very basics of the policy that we have configured. This is just the very basics of the policy that we have configured. Very basic policy we have configured, a basic hub and spoke policy, which is true. True basically means the policy is activated. Also, one thing you'll have to understand, that when it comes to configuring the centralized policy, your vSmart controller must be in the template mode. The vSmart controller must be in the template mode. In order to apply these policies, your vSmart controller must be in the template mode. We already have created the CLI template for the vSmart, so it's not a problem for us. But if not, then you will have to create the template, and you will have to attach the templates respectively. Make sure that your vSmart is in the template mode. Make sure that the vSmart controller that you have, make sure that the vSmart controller is in the template mode. I did a mistake basically. One mistake I made actually when we configured the template, by the way. When we configured the template, the vSmart template was okay. But when we configured the template, when we filled the values in the template, I can see here that the value that I put actually, the value that I put for the VPN, this is the interface ETH1. This is incorrect actually. The value that I have put for the interface, it is 100.1.1.2. This value is incorrect actually. It must be 100.1.1.2, not 200.1.1.2. So I will need to correct it actually, otherwise it will not work. The problem is that one task is already going on. So let me do one thing, let me clear this pending task. I already have told you how to clear the pending task. Let me repeat it one more time. So what we need to do actually, we can, this task is going on for a very long time, and I actually want to clear this task. It's going on for a very long time. So what I can do, I can say HTTPS 192.168.10.91, which is the IP address of our vManage, and slash. Here we can use an API call. Slash data service / device / action and /status / tasks. This is the already one time we have discussed. If not, then you can refer to this document on how to clear the pending tasks. If you, let's say, for example, if let's say you pushed some template and all, and somehow the task is stuck and it's not going through, so just use an API call, HTTPS, then the IP address of your vManage, then the data service device action status task. If you enter, it will show you the pending task that is going on. And then what you need to do, then you need to clean tasks. After the tasks, you have to say / clean and question mark and the process ID. You will have to specify the process ID. Process ID PROCESS ID is equal to, and the process ID is this one. This is the process ID. So just copy and paste it here. So enter. So true. That means this task must now be, this task that we had, it's now deleted. So sometimes when we do the configuration, like the tasks, they get stuck actually. Sometimes when we do the configuration, the tasks, they get stuck for some like very long time, for example. So you can always like, you can always edit those tasks. You can always clear those tasks. You can always clear those tasks by using that API call. Using the API call, you can always clear those tasks. Refer to the documentation that I have provided to you. You can refer to the documentation on how to. So the command is going to be, the API call is going to be the IP address of the vManage, then the data service device action tasks. This command, this will show you all the pending tasks, and then you can clean the task based on the process ID that we have just got from the previous API call. Right. So for the control policies, you will have to remember that the device must be, the vSmart must be in the vManage mode. The device must be in the vManage mode. If the device is not in the vManage mode, you will not be able to apply the policies. You can apply the policies only when the device is in the, when the vSmart is in the vManage mode. It is a requirement for the centralized policy. So I'm sure somewhere it must be written, but for the centralized policy, vManage, the vSmart must be in the vManage mode. Otherwise, you will not be able to apply those centralized policies, by the way. So right here, you can see in this image, the direction that we talked about. When we talk about the centralized policy, all the centralized policies are sent from the vManage to the vSmart. vSmart receives those centralized policy, and these centralized policies are applied. These centralized control policies are applied by the vSmart controller for the site in a particular direction. So when we say site in basically means when I receive the OMP update from that site, and site out basically means when I advertise the OMP update to that site. That's what it means by in and out. That is what it means by in and out. In and out. In basically means that when I receive. In basically means when I receive OMP update from that site, then the policy will be applied. And out basically means when I advertise the OMP update to that site, then the policy will be applied. In from the site, when the OMP update comes in from the site, and when the OMP update is advertised to the site, then the policy will be applied. Direction is very important. Direction is what we have to understand. Direction is what we have to consider. If you do not configure the proper direction, then the policy will not get applied. Understand that the policy will not get applied if you have not, for example, configured the proper direction. Forget about the data policy. Just focus on the centralized policy. We have configured a very basic hub and spoke type of policy. We have configured a very basic hub and spoke type of policy. And that hub and spoke type of policy that we have configured, that hub and spoke type of policy will in fact, allow us to fine-tune the OMP sessions and all those things as per our requirement. The basic hub and spoke policy we have configured here. This hub and spoke policy that we have it will allow us to fine tune like how the OMP sessions and all those things will be established. If everything is done properly, then we should be able to see the policy on the vSmart controller. So if I take the access of the vSmart controller, and if I show you the policy one final time, so here show run policy, you have the policy with you. And as per the policy, when I advertise apply policy, as per the policy, when I advertise the OMP updates to the spoke out, when I send the OMP updates to the spoke, then I will apply that policy. As per the policy, I will only advertise. As per the policy, I will only advertise the data center TLOC and the data center routes. I will only advertise the data center TLOCs and the data center route. So if you go on the vManage router, such as for example here, you can see that only the data center TLOC is present here. Only the data center TLOC is present here. Upper one is your own TLOC, but only the data center TLOC is in fact present here. Meaning to say, show BFD session, meaning to say that this device only has the BFD session with the data center. Meaning to say, show IP routes VPN 10, you can confirm that you only have 172.16.100 subnet. You only have 172.16.100 subnet in VPN 10. So OMP routes pipe tab, you are receiving 172.16.1, 2, 3. These are your own subnet. Then 172.16.100.100.100.3. These are the subnets that you are receiving via the data center. But you don't have, what you don't have here is the site 2 routes, and you don't have the site 3 routes, by the way. So the data center router needs to advertise. The data center router needs to advertise a default route. We have already configured a default route here, and show run pipe section router EIGRP. We have to redistribute that default route. Router EIGRP and redistribute static. So this router actually has the connectivity to the internet maybe. So here we have configured the default route, and that default route I am advertising into the EIGRP domain, so that EIGRP routes that default route gets advertised everywhere on these branches. So you check there. Once you do it, you check there, you go to the site 1 VH1, and the default route must also be present now. The default route must also be present. So the default route must also, you are now receiving a default route. You are now receiving the default route from the data center, by the way. You have now started receiving the default route from the data center. You have now started receiving the default route from the data center on the site number 2 as well. On the site 2 also, you can cross check that here also you have started receiving show IP routes OMP. You can see that you have started receiving the default route from the data center. Data center router has started advertising that default route, in the OMP update to all the branches. And since the redistribution is done, since the OMP is getting redistributed into the BGP, the border gateway protocol, that default route must also be present on the LAN side, show IP route BGP. So yeah, that default route is present here. But unfortunately, the default route is not present on the site 1 router. The default route is not present on the site 1 router 1. We don't have the default route here, and we do not have the default route here as well. Here also, we don't have the default. We do not have the default route. I am receiving all the other routes, but I don't have the default route. Reason is that in this branch, site 1 and site 3, in the LAN, we are running OSPF, and OSPF does not redistribute the default route. OSPF does not redistribute the default route. In OSPF, default route is not redistributed. Learn about it. You can read about it. OSPF does not redistribute the default route. If you want to advertise the default route in OSPF, you will have to use the command default information originate. You will need to run the command default information originate rather than redistribute. OSPF, all the other routes got redistributed on the site 1 router 1. I can see all the other routes. But I don't see the default route. Default route is not redistributed into the OSPF. It's a classic OSPF behavior. So we will need to manually say here, we will need to say, for example, on the site 3, we will need to say admin, we will need to log in there, configure terminal, VPN 10, router OSPF, and default information originate. Default information originate or default information originate always, whatever. Default information originate or default information originate always command you will have to run in order to let that router originate router OSPF and default information originate. Now the router will originate the default route and advertise that default route to the site router 3. Show IP route OSPF. You now have the default route from both the places. You will have to do the same on the branch number 1 as well, but in order to do it from on the branch number 1, you will need to go to the OSPF template. You will need to go to that template that you have configured. OSPF, where is that OSPF template? You will have to go to the feature template, and since we have connected OSPF, since we have attached the OSPF template, I will edit that and I will say under the advanced command, I will say default information originate. Or you can say default information originate always. Default information originate means originate the default route only when you have the default route present in your routing table. And default information originate always. Default information originate always says that always originate the default route. Whatever suits you, whichever requirement suits you, default information originate or default information originate always, you are going to click on the update button and you will push that configuration on both of the WAN edge devices. Once you do it, then these routers will also start originating the default route and advertise it on the site 1 router. Once the template configuration push is successful, then you will also have the default route on the site number 1, router number 1. Here you will have the default route once the template configuration push is successful. Wait. Let the template config get pushed and you will notice now the default route is also present there. So data center must originate the default route. Why? Because then only the default route will be present here, basically on all the spokes. And these will, let's say from the site 1 router 1, let's say I want to do the ping to 172.16.2.1, 172.16.2.1, which is on the other side. I don't have the exact route to go to 172.16.2.1, but I have the default route. Following the default route, I will send the packet here or here. On this site 1 VH1, do I have IP route in VPN 10? Do I have the route to reach to 172.16.2.1? I don't have the exact route to reach to 172.16.2.1, but I do have a default route. And the default route is pointing towards the data center. Following the default route in this VPN 10, the traffic will be sent all the way to the data center. And on the data center, I have all the routes. On the data center, we have all the routes. On this site router, we have all the routes. On this cEdge router, by the way, we have all the routes. So the traffic will get routed from the cEdge to the branch number 2, respectively. Check now. Are you able to ping, by the way? So the ping is successful. Are you able to do the trace? 172.16.2.1, source loopback 1, and you can see that the trace went to the default gateway, and then it went to 100.1.2.1. 100.1.2.1 is right here in the data center, and then from there it went to 192.168.20.1 and 20.2. Basically, the traffic is getting forwarded from here to here. This traffic is getting forwarded from here. If you ping 3, for example, if you do the trace for 3, the traffic will go all the way to the traffic will go from here, it will go to the default gateway, from here it will go here, and from here it will go here, respectively. There is no direct communication, as you can see. There is no direct communication, as you can see. The traffic is going via the data center. And if you want to cross-check even more, you can just deactivate that policy. Why does to deactivate policy? I have to deactivate the policy. I'm not sure why it says false. This policy is activated, by the way. Not sure why it's saying false, but you have to deactivate the policy. Once you deactivate the policy, you will notice that the traffic will flow exactly the similar way. When we deactivate that policy, you will notice that the traffic will flow directly, just like it was happening earlier, from here to here, directly, from here to here, directly, without any problem. Because now you have all the routes, all the TLOCs, all the BFD sessions and everything without any problem. The traffic will flow then respectively directly to the site. But this output that we have here, this output proves basically that the traffic is in fact going, the traffic is being sent via that particular data center, right? So you can deactivate the policy if you want to. You can deactivate the policy, and once you deactivate the policy, you will notice that the traffic will flow respectively. The traffic will flow accordingly. But once you, for example, activate the policy, the traffic flow will be as expected. As we cross-checked, the traffic flow will be via the data center. However, remember, the data center must originate the default route and advertise the default route to the branches so that the branches can use that default route to send all the traffic to the DC, and from the DC, the traffic will go to the other places. This is a very basic hub and spoke policy that we have just created. This is a very basic hub and spoke policy that we have just created here. This very basic hub and spoke policy that we created will allow us to forward the traffic. It will allow us to forward the traffic as per our requirement from one vManage to other vManage via the data center, rather than forwarding it via like directly. We can forward the traffic via the data center. Remember, for that to happen, the policy we will have to configure respectively. The policy we will need to configure respectively. You could have done it via CLI as well if you wanted, but why should I use the CLI configuration when I can just use the policy configuration? I'm not going to use any CLI configurations or anything. I'm not going to do any CLI configurations or anything because I can do the things from the, directly I can do the things from the template. This is one basic example. This is one very basic example. How can we configure things? How can we configure the policy? Forget about the data policy. Just focus on the direction of the control policy. So we configured our group of interest, then we configured the control policy, and then we have applied the policy in the network, activated the policy. Centralized policy is configured on the vManage and enforced across the entire network. Remember that you also have to remember that we can apply multiple policies. We can create multiple policies. We can create the local ingress policy, centralized app route policy, centralized data policy, routing and forwarding policy, then queuing and scheduling related to the quality of service, local egress policy. We can create multiple policies. But remember that there will be an order. There will be an order in which the policy will be applied. There will be an order in which the policy is going to be applied. And the order is, first of all, local ingress policy, which is policing, admission control, call admission control, classification and marking. Then the centralized app route policy, which means SLA-based best path selection. Then centralized the data policy, means policing, admission control, classification marking, path selection, services. Then the routing and forwarding decision. Then the queuing scheduling. Then the local egress policy. This is the order of operation when the policy is basically applied on the device. If you apply multiple policy, in what order the policy will be? If you apply multiple policy, then in what order the policy is going to be executed? That in what order the policy will be executed, that order is right here. You will have to understand that the policies are executed in the same order that you see in front of you. If you apply multiple policy, remember that the policy will be executed in the same order. You will have to memorize this order actually. Throughout the lab, we will do the practice. So you will have to memorize this order. You will have to memorize this order in which the policy is getting delivered. So which policy is applied first, which policy is applied second. So you have to understand the correct order in which the policy is going to be applied. Policies are processed in a sequential manner, just like access list, just like prefix list, just like route map, no differences at all. As soon as, if you have defined multiple statements in the policy, as soon as the match occurs, the match entity is subjected to the configured action and no longer subjected to continue processing. So just like the access list, prefix list, route map, when the match occurs basically, just like we have this concept, just like we have here the access list, just like we have the prefix list, just like we have the route map, where like when the packet matches at a certain statement, the action is taken, the packet is either permitted or denied, and further no longer lookup is done. Same exact thing in the policy as well. If you have configured multiple statements, as soon as the match occurs, the match entity is subjected to the configured action that we have defined and will no longer be subject to the continuous processing. Any entity that is not matched in the sequence is subject to the default action, which is reject by default. Exactly same as the access list, exactly same as the prefix list, exactly same as the route map. At the end of every access list, at the end of every prefix list, at the end of every route map, we do have that deny statement, by the way. We do have that deny statement at the end of every access list, prefix list, and route map. So this is the same exact thing. At the end of every policy, there is a reject, there is a deny statement that is by default configured. So in case if we have multiple statements in the policy and the packet does not match with any of the statement, by default it is going to be rejected, by default it is going to be denied. Just like access list, just like prefix list, just like the route map. In a multi-vSmart deployment, if you have deployed multiple vSmarts, if you have deployed multiple vSmart controllers, each vSmart acts independently to disseminate the information to other vSmart and the vEdges. So like if you have multiple vSmarts, the policy will be activated. The vManage will give the policy to both of the vSmart, and both of the vSmarts will advertise the information to the vManage devices. This thing also we have covered, if you remember from the previous class, this thing we also have covered that if you configure multiple vSmarts, all the vSmarts will in fact run independently. They all will have the OMP session formed between them. They will have the OMP session formed in between them, and they will be able to advertise the OMP routes, TLOC routes, and the policies and everything independently to all the vManage devices. The important thing is that only one centralized policy can be activated at one time. You can create multiple policies, but only one centralized policy can be activated at once. What does it mean? That when we were creating the policy, when we were creating that centralized policy, for example, we have configured that hub and spoke policy, for example, we can create other policies as well. We can create like other policies as well as per the requirement, but understand that at one time, we can only activate. At one time, we can only activate one policy. We cannot activate more than one policy, more than one centralized policy we cannot activate. At one time, only one policy is going to be activated. You can activate only one. You can activate only one centralized policy at one time. You can create multiple policies. That is okay. That is fine. You can create multiple policies. You can create multiple centralized policy, but you cannot activate more than one centralized policies at once. So if you want to do more than one things, you want to create a hub and spoke policy, you want to filter the routes, you want to filter the TLOCs, for example. If you want to do like more than one thing, in that case, you will have to define everything. You will have to define everything in the same centralized policy, and then you can apply that centralized policy respectively on the device. You again repeating the same thing. You cannot create more. You cannot activate. You can create multiple hub and spoke policy, but you cannot, by the way, you cannot activate more than one centralized policy in the deployment. On one vSmart, on the vSmart controller, there can be absolutely one centralized policy there. There can be only one centralized policy you cannot have more than one centralized policy activated on the vSmart controller. So in our case, for example, we have configured this centralized policy. It says true here. If I create another centralized policy and I activate that policy, this will get deactivated automatically. This will get deactivated automatically. This will get deactivated automatically. So if you wanted to do more things, remember that you'll have to define all the things in the same policy, because you cannot activate more than one centralized policy. You can create multiple centralized policy, but you cannot activate more than one centralized policy. So whatever you want to do, you want to influence the data forwarding, you want to influence the route, you want to influence the TLOC, everything needs to be defined within the same policy itself. For example, if you wanted to filter some route, for example, if you wanted to filter some TLOCs, for example, if you wanted to influence the data forwarding, and you want to do all those things with the help of centralized policy, you have to define all those things. You will have to define all those things in the same policy actually. Anyway, let's not go in that much detail, because this thing will be covered in the content anyway. So in only one centralized policy can be activated at once. Make sure that it has all the needed policy that you want to activate, all the control policy, data policy, app route policy, VPN membership policy, all the policies we will have to configure in the same centralized policy, and then we can activate it. Anyway, so let's create the policies individually first, and then later on we will create a composite policy. So centralized policy configured on the vManage, enabled and enforced on the vSmart, do not get forwarded on the vManage. Control policies operate on the OMP, and OMP carries two things. It carries the route, it carries the TLOC. So we can modify, we can filter, or we can modify various attributes that are carried in the OMP updates. In the OMP, we carry the routes. In OMP, we carry the TLOCs. So with the help of the control policies, we can change the routing behavior of the entire SD-WAN. Just right now we configured a hub and spoke policy. We have configured a basic hub and spoke policy, and that hub and spoke policy basically allowed us to IP sectoral formation and the route propagation. These are some common control policies: arbitrary VPN topology, service chaining, traffic engineering, extranet VPN, service and path affinity. There are multiple control policies that we can configure. This we did. So how to create a centralized policy? Go to the policy, centralized policy, add a policy, and you can create the group of interest and the policies one by one. This we did. For example, for a certain VPN, we want to enforce hub and spoke policy, and for the other VPNs, we want to have full mesh. It's called arbitrary VPN topology. Arbitrary VPN topology basically means for certain VPN, we are having full mesh. For certain VPN, we are having hub and spoke. For example, in our case, for VPN 10, we have hub and spoke policy, and for VPN 20, we did not configure anything. So for VPN 20, it's full mesh, by the way. This is called arbitrary. Random, like for one VPN, we have full mesh. For one VPN, we have hub and spoke. There are other ways to create the same policy as well. We'll see, but there are other ways to create the same policy. So we configured a basic hub and spoke policy. Let me create the similar kind of thing in another way. So I will click on the add policy button. I will click on the next button. I will go to the configure topology and VPN membership. Click on the add topology, and I am not going to create a hub and spoke policy. Instead, I am going to go for this option called custom control. Custom control on your route and TLOC. So click on it. This is the second hub spoke. This is an alternate way to create, for example, the hub and spoke policy. So this time we went on the custom control. Custom control basically means like I want custom control on the route propagation and the TLOC propagation. Sequence type, what do we want to do? Match the route. What routes? I want to match the routes. What routes? Match the routes based on these following criteria. So what I'm going to do, I'm going to match the routes of site 100 in VPN 10. So what site? Site 100. and VPN, what VPN? VPN 10. We have matched all the routes. We have matched all the routes of site 100, VPN 10, and we are going to go to the action, and I am going to accept it. I have accepted all the routes of data center VPN 10. I am not going to set anything, just accept and click on the save button. Then I am going to add another sequence, TLOC. I am going to accept only the data center TLOC. I can create the site list from here if you have not created it already. I am going to, since I have already created it, I can do it. Otherwise, I can also write down the number from here actually, like 100. This will also work. Both is possible. Since we already have configured the site list, I'm going to use it. So here I am matching the TLOC based on site ID, and I am going to accept it. Okay. So I have configured the first rule. In the first rule, first rule is basically you can just drag and drop. You can drag up and down as per the requirement. You can, for example, you can rename it. For example, you can rename this statement. You can rename, for example, as per the requirement. You can do plenty of things from here. So what we have done here in this policy, I am accepting the data center TLOC, and I am accepting the data center routes of VPN 10, accept, and I'm going to reject everything else. Reject everything else. Save it. I have configured the policy. Next button. I do not care about the traffic rules. Next button. This is the alternate hub and spoke policy, and I'm going to apply this policy. I'm going to apply this policy, this hub and spoke policy. I'm going to apply this policy for what site? I'm going to apply this policy for branches, for site 1, site 2, and site 3, for branch 1, branch 2, and branch 3. Basically, all the spokes in out direction. Meaning to say, when the vSmart controller out advertises the route to site 1, site 2, and site 3, it will first activate that policy, and as per the policy, only data center TLOC and only the data center routes are going to be advertised, which is exactly same thing. It is exact same thing that our hub and spoke policy did earlier. I am doing exact same thing using the custom control as well. I will activate it. Activate this policy. Here you can activate this policy, and you notice that once you activate this policy, you will notice that this policy will get, the other policy will get deactivated. Once this policy gets activated, wait for this policy to get activated. Once this policy gets activated, you will notice that the other policy will get deactivated. Wait for this policy to get activated. Once this policy is activated, wait, you notice that the other policy got deactivated only. That's what it means by you can only activate one centralized policy at one time. Policy got delivered on the vSmart controller, by the way. Check it there. The policy, show run policy, by the way, show running config policy. You can see that the policy got delivered there, but this is not the hub and spoke policy. This is just the normal policy. The policy that contains the VPN list, site list, the site list, the data center site list, the spoke, the prefix list, and the policy says that match the data center TLOC and match the data center route and accept it and reject everything else. So same exact thing. Now here, if you go to any like, let's say, for example, site 1 VH1, you log in there, and you check there like show OMP and TLOC paths. You see that you only have the data center TLOC, show BFD session. You only have the show BFD session. You only have the BFD session. You only have the IPsec tunnel with the data center, and show IP routes VPN 10. You only have the data center routes. Same exact thing, no differences at all. Same exact thing that we were able to achieve, we were able to do with the simple hub and spoke policy. We can create a custom control policy as per our requirement. You need to explore the options. You need to explore the options that you get in the match and in the custom control. You need to explore the option such as block TLOCs. You need to explore what options you get here in this dashboard. Like I can match the TLOCs. What TLOCs? I can match the TLOCs based on what criteria? I can match the TLOC based on what criteria? I can match the TLOCs based on site ID. So for example, I am saying that site number 2. I have matched the TLOC of site number 2. I have matched the TLOC based on the criteria site branch number 2. And then what I did? Action reject. I blocked it. I blocked that TLOC. And default action, accept. Everything else is permit. Everything else is permit. So in this one, this basic policy, here in this policy, what I did in this basic policy, I did not save it, I guess. In this basic policy, I am going to match the TLOC of branch 2 and I am going to reject it. In this basic policy, I have matched the TLOC of branch 2 and I have rejected it, and everything else I have permitted it. Save, next, and I'm going to apply this policy. I'm going to apply this policy in inbound direction of branch number 2. What does it mean? It means that when the vSmart controller in receives the OMP update from the branch number 2, it will filter based on the criteria that we have applied. So when the branch number 2 advertises the OMP TLOC and OMP routes based on the policy that we have configured, the TLOC is going to be blocked. The TLOC is going to be blocked. The branch 2 TLOC is going to be blocked. Add, save, and activate it. Activate this policy. Where is the third policy? Here. Activate this policy. At the very end, we have the option activate this policy. So now what will happen? The policy will get delivered onto the vSmart controller, and the vSmart controller, based on the policy, when the vSmart controller receives that policy, as per the policy, wait, let the policy get delivered here. Wait, still not there. Yeah, now it's there. So as per the policy says that I am going to match the branch 2, the site number 2 TLOC. I am going to match the site 2 TLOC and I am going to reject it and I am going to permit everything else. And we have applied that policy. We have applied that policy when the OMP updates are received from the branch number 2. Meaning to say, show OMP TLOC paths. When you receive this, where is this 10.1.12? You don't have 10.1.12. You can see that you do not have 10.1.12. 10.1.12 is gone. Show OMP TLOC TLOCs 10.1.12.1. You don't have that TLOC. You do not have that TLOC. That TLOC is reg. You see right here. You open that TLOC. Show OMP TLOCs IP 10.1.12.1, and right here it says reg. Reg means rejected, invalid. Rejected, invalid. This TLOC is not installed. This TLOC is in fact not received. Both of the TLOCs. On the site 2, we have 2 TLOCs. One is like system IP color encapsulation. The other one is also system IP color encapsulation, but this is reg. Reg stands for rejected. Reg means rejected. The TLOC got rejected when the router receives it, the TLOC got rejected. As a result, this TLOC will not be advertised. As a result, this TLOC will not be advertised on any place. 10.1.11 is there, 13 is there, 100 is there, but the 12 is not there. The 12 is not there. It means there will not be show BFD session. There will not be any BFD session with that particular router. you will not even have any routes, show IP routes VPN 10 from that particular 172.16.2 routes are not there. You see, show OMP routes pipe tab. These routes 172.16.1.1, 1.2, 1.3 is there, but you see 2.1, 2.2, 2.3. 2.1, 2.2, 2.3 reg, rejected, invalid, rejected, invalid. These are rejected. Why? Because the TLOC is not reachable. Next hop reachability is the very first criteria. If you remember from the OMP best path selection, the reg, rejected. Here, reg, rejected. Where is that? Rejected, invalid, TLOC unresolved, U, TLOC unresolved. So OMP routes 172.16.2.1/32. If you open that route in detail, you will notice that right here it says reg, invalid, and unresolved TLOC. In order to go to that destination, this is the TLOC, and I actually do not know how to go there. The result, this route is not getting advertised anywhere. If you change the direction, by the way, you edit it, you edit this policy. And do one thing, change the direction, remove it and change the direction to site 1 out. Branch 1 out. You change the direction to branch 1 out. What does it mean now? It means that when the vSmart controller receives the OMP update from the branch number 2, it will accept it. But when it will advertise it to the branch number 100, it will advertise it to the branch number 3. But when it advertises out, when the OMP updates are sent to the branch number 1, then the filtering will happen. Then the branch 2 TLOCs will not be advertised to the branch number 1 only, but they will be advertised to branch number 3. They will be advertised to the branch number 100. Direction, again repeating same thing again and again. Direction in basically means when the OMP update is received from the branch, and out means when the OMP update is sent to that particular branch. Notice that when this policy is delivered, if you go to the site 1 VH1, here show OMP TLOCs, TLOC paths. You don't have that 12.1, but if you go to this site 3 VH2, for example, here, if you go here, you must have show OMP TLOC paths. For example, you must have the 12.1. So you do have a working IPsec tunnel, show BFD session. You do have an IPsec tunnel with there. You do have the IPsec tunnel with 12. You do have the IPsec tunnel with 12, and you also have show IP routes VPN 10. You do have the routes of 172.16.2. So TLOCs are not filtered in. TLOCs are not filtered inbound direction. TLOCs are not filtered in inbound direction when the TLOC is getting advertised. When the TLOC is getting advertised to the particular branch, then it is getting filtered actually. Then it is getting filtered. So you see, installed. This time it's installed. This time this particular TLOC is installed. It's fine. It's installed. It's fine basically. And if you scroll down, installed, this is the second TLOC, by the way. So both the TLOCs, you can see that they are installed. But when show OMP TLOCs, when the same TLOCs are advertised, what TLOCs are advertised to the branch 1? The branch 1, these TLOCs are getting advertised. 10.1. These are the TLOCs getting advertised to the branch number 1. Take a look at here. You can see 10.1.12.1 is not there. Only to the branch 1. Branch 1 out means when the OMP updates are given to branch 1, then things will happen accordingly. You can see that the TLOCs are getting advertised. This TLOC is getting advertised to the data center. This TLOC is getting advertised to the branch 3, but this TLOC is not getting advertised to the branch 1. It's not getting advertised to the branch 1 because this time we have applied the policy. This time we have applied the policy show run policy. This time we have applied this policy in out direction. Out direction means when we advertise the OMP update to that branch, when the updates are sent out of the vSmart to the branch number 1, then the policy will be applied. There is a clear difference between the direction in and out. The more lab you perform, the more lab you do, you will get clarity on the direction. Direction is going to be very important aspect of the policy. So make sure that you do your policy labs like quite a lot of times to get very clarity on the direction part of the policy. This is how we have configured some basic hub and spoke policy, alternate way to create hub and spoke policy, block the TLOG. The localized control policies, for example, the localized control policies will allow you to perform things such as routing with the help of the template, which we again already have done. But let's say, for example, now what we want to do, we want to filter. Let's assume that we want to filter certain routes. I want to filter certain routes, whatever routes I'm learning here, I want to filter those routes. I want to filter the routes, but I want to filter the routes only in the site number 1, local to that site. I don't want to filter it at the vSmart. I want to filter it on the site number 1. So in that case, when we want to do it, when we want to do that, in that case, what we can do, we can configure a localized control policies. I want to filter the routes. I want to filter those routes. So to do that, we want to configure some localized control policies. So I will go to the same. I will go to the this time I already have configured these control policies. Now I will go to the localized policies. In the localized policy, the same exact way, you will click on the local add policy button. Here, you are going to create your group of interest. In the group of interest, you can see that there are different criteria. We have AS path, community, data prefix, extended community, class maps, and all that thing. We have different criteria. So for example, I'm going to match my prefix. I'm going to match my desired prefixes. Like for example, I want to block. Let's assume I want to block this particular subnet. I don't want to receive this particular subnet on site number 1. I do not want to receive that particular subnet on the site number. I don't want to receive that particular subnet on the site number 1. So I have masked it in the prefix list. In that prefix list, we have masked that particular subnet. Okay, fine. Then click on the next button. No need to worry about the forwarding classes. This comes under the QoS, so we don't need to worry about it. Next, we can configure an access control list. I can create an ACL. And with the help of this ACL, I can block or permit certain routes as per our requirement. So if I go here, if I click on add IPv4 access control list policy 1, it's a route block. I want to block certain routes. So route block site number, something like that. Click on add ACL sequence. What I want to do, this is the sequence number 1. What I want to do, I want to match. What exactly do you want to match? I want to match based on source data prefix, destination data prefix, source port number, destination port number. This is like the access control list. This is like the ACL that we can create. These are the criterias. These are the criterias based on which we can do the matching, by the way. And if you take a look at these criterias, you will understand that typically this access control list that we are talking about here, it is to match the data traffic, like source data prefix, destination data prefix, then protocol, then TCP, and then once we have matched it, then we can set all these things as per the requirement. So it does not look like, doesn't look like it will work based on this. It will not work based on. It will not work based on the access control list. We wanted to block the routes. So we don't need to do it under the quality of service. We don't need to do it under the ACL. This ACL typically will be used to control the data traffic. So when we didn't talk about the localized, the data policy, there this ACL will come. We need to go to the configure route policy. I will go to the route policy, create a new route policy, give it some name, and here we can match based on various criterias. Here we can match based on various criteria that are mentioned right here. So I want to block the routes based on what I route. I want to block this route. Address, simple. Address. I can match based on address. I can match based on metric. I can match based on AS path list. I can match based on community. I can match based on the OSPF tag and different concepts. Simple. I want to match these routes and I want to block. Done. I want to match these routes and I want to block them. So this basically, by the way, if you remember, Site1 LAN here, what route is matching? 172.16.1.2. That particular route is matching here. So I'm blocking that. Okay. Save it. Another condition. Let's match another address. Let's match another address, such as let's match another address, such as a new prefix list. This is like 172.16. This is like site 1 subnet number 3. This is the third subnet that I'm going to match here, and the subnet is basically 172.16.1.3/32. This is the third route that we are matching, and what we are going to do once we match it, what I'm going to do, I'm going to accept it. And after accepting, I can do all these sorts of things, such as I can set all these sort of things, such as if it is external out, I can set the metric type, set metric, OMP, originator, OSPF tag 9999, for example. I can add a tag value. These, if you remember, if you understand the concepts of, let's say, BGP, then you know what exactly is the AS path, community, then what is that, atomic aggregator. We can do those sort of things as well. So as per this statement, I'm going to block this route, and this route I'm going to match, and I'm going to set the OSPF tag, and everything else I'm going to permit as it is. Everything else I'm going to permit as it is. So we have configured this condition. We have configured this route policy, by the way. We have configured here this route policy. This route policy is going to match Site1 LAN prefixes. It is going to reject it. It is going to match the Site1 third subnet, and it is going to set the tag 9999. And everything else I'm going to accept it. So save this policy, and yeah, done. This is the policy that we have applied. The point is, this policy does not have a direction. The localized policy that we are talking about, these localized policies, they do not have a direction, because these policies are applied directly with the help of the template. These policies, this we have created, we can't activate these policies. We cannot activate these policies. If you take a look at here, we cannot activate these policies. There's no such option to activate this policy. And the reason why we can't do it, because the localized policies that we have, the localized policies are attached with the help of template directly onto the sites. Localized policies, when we talk about attaching those localized policies are attached. Those localized policies are attached with the help of the template. These localized policies are attached with the help of templates directly to the branches. So I do not need to activate that policy, because we can't do it. We cannot activate that policy. There's no such option to activate this policy. If you want to attach this policy, it will get attached with the help of templates actually. So you will need to go, let's say I want to attach this policy on the branch 1. So I will go to the template. I will go to the template for branch 1. This is site 1, site 2 template. I will go to that. I will edit it, and at the very end, we have these additional templates. At the very end, we have these additional template. And right here, where is the option of policy? Right here, we have the policy template, and the policy that we just created, we can attach that policy template right here. This is how we attach it. This is how we attach that policy. By the way, we are just, what exactly is happening here is that we are just sending the route. We are just sending the route, this ACL, that this prefix list, this policy, to the router with the help of templates. I am just sending the policy with the help of the template. Still, we have not used it. Still, like we are just sending it. We are not using it anywhere. So I will click on the update button. Let the policy get delivered first. The policy will get delivered on the site 1 VH1 and site 1 VH2. Once the policy gets delivered on these two devices, once the policy gets delivered on site 1 VH1 and site 1 VH2, remember that we will need to use that policy somewhere. It's not like it will just get activated and everything will start working from there. No. Once this policy, for example, gets activated, once this policy gets like pushed onto the vManage devices, then we'll have to use that policy somewhere. So let's first push that policy. Next, let the policy get delivered on those two devices. Let the policy get delivered on those two devices. And once this task is done, once the policy is delivered on those two devices, then after what we need to do, once the policy gets delivered on these two devices, then after what we need to do actually, we need to use that policy somewhere. So the policy is now site 1 VH1. On the site 1 VH1, we might have, let's see if the policy is delivered or what. So admin Cisco@123 show run policy. Wait. Yeah. So see, now the policy is there. On the device, the policy is now showing. Show run policy. You can see the policy. You can see the subnets. There are two prefix lists. One is site 1 LAN, one is site 1 subnet 3. There are two prefix lists, for example. This is one prefix list and this is the second prefix list. Then we have configured the policy and whatever. So this policy now, this policy that we have just configured, this policy has no use at the moment. You can still see, if you check here, you can still see all the routes. Show IP routes, OSPF, you can still see all those routes. 1.1, 1.2, 1.3. The policy is not in effect. It is just that the policy is delivered onto that device, but it's still not in use. So in order to take a use of that policy, I will go to that OSPF template that we have configured. I have configured that OSPF template. I will edit it. And here I am going to go to the advanced option, and here policy name. Here we can apply the policy. The name of the policy is whatever name of the policy was. The policy name was, what was the policy name? Route block site 1. This is the name of the policy. So first we will push the policy and then we will use the policy wherever we want to, such as since we are talking about OSPF, once the OSPF policy, once that OSPF configurations, once those OSPF configurations are delivered, once those OSPF configurations are once those policies are delivered, then once the policy is delivered, then here what we are doing, we are actually using that particular policy under the OSPF configuration. Let the configuration get delivered. Let the configs get delivered there. Now see, this policy must now be, this policy that we just delivered, show run VPN 10. Now the policy is activated under the OSPF, and now you check the routes one more time. Show IP route OSPF. You are receiving all these routes from OSPF. You are still receiving all those routes from the OSPF, but let's just see. You see, previously when we were receiving this route, it was saying FS. F stands for installed in the fib. S means selected. But now, if you just notice here, it says I. It says I. I stands for inactive. I stands for inactive. That means the route information is available with you, but it's inactive. Inactive basically means that this route is not installed in the fib table. It is not installed in the forwarding information base. It's inactive. It is inactive. We can see that it says inactive. So if you notice, if show IP fib command, you can execute the command show IP fib VPN 10. You can see that in the VPN 10, we do not have that 172.16.1.2 route. We have just 1.1 and 1.3. And by the way, if you open show IP fib VPN 10, show IP fib, if can I open show IP route? What is that? 172.16.1.3/32. If you open that route in detail, And in the detail, where do we see that tag actually? We also set a tag on that third prefix actually. So where will we see that tag? So show IP fib, and there is only like these options, VPN 10 and this color or TLOC, and that's it. That's the only option that we have here. So do we see? I don't see any tag here directly, but as since the policy is activated on this particular route, the tagging must also be done. So show IP routes and detail, for example, or show IP routes 172.16.1.3/32. Show IP routes OSPF, if I say, what show IP routes OSPF detail. So I'm actually not seeing the tag because the option is not available here. The option is not available here. I don't see that tag value, but let me do one thing. Let's go to the vSmart and let me just on the vSmart, let's open the route, show OMP routes VPN 10 and 172.16.1.3/32. If I open that route, I don't see actually any tag actually. I don't see any tag here. The tag must also be there actually. The 9999, the tag that we have set. This is a OMP tag which we have not set, by the way. So it does not show that. The route will also have the tag value actually. The route will also have the tag value. The route that we the route on which we set the tag value, the tag will also be there on that particular device. So just like the device was able to filter, one subnet, the device will also be responsible to perform the tagging for that particular subnet. So tagging will also be there, by the way. Tagging is also going to be there. This is how we can block the routes as per our requirement. We can block the routes as per our requirement with the help of these policies. We can block the routes as per our requirement. Not only block the routes, we can also set like things in BGP, by the way. So you can go to the templates, you can go to the policy, localize the policy, add a policy, and AS path, for example, AS path, or maybe some community, extended community, or like normal community. For example, you want to say community tag, for example, like 100:100, for example. This is the community that I want to send. I want to send the community. I want to send the community like 100:100. Community is basically a tag in case of BGP. So this is the community, for example, 100:100, or maybe the AS path list I want to prepend or match AS path list, for example. This is like match the AS path list. Regular expression to match the pattern. If you know about the regular expression, then you can write down a regular expression. So match all the routes that begin with the AS number 3, for example, or all the routes whose AS path list is blank, basically. So again, for these, you must know the regular expression. But for example, we have matched a regular expression in the AS path list. We have matched the AS path list based on some regular expression. The community, for example, we can have the extended community, for example. If you know about this extended community, like route target, site of origin, and all that thing, we can match it based on the same as well. So we can do a few things regarding the BGP as well. Click on the next button. No need to worry about that. No need to worry about this ACL. Forget about it. Go to the route policy, and under the route policy, create a new route policy. Create a new route policy. This is like set attributes in, let's say, for example, BGP. I want to set some attributes in case of BGP. So match. What do you want to match? Match based on what? I want to match based on the AS path list. Basically, this is going to match all the routes originated in my own autonomous system. All the routes originated in my own autonomous system. What address? All the address. all the addresses or some specific address, like, completely your choice. Do you want to match based on community, local preference? These are the options based on which we can match actually. And once we have matched, we can accept it. Once we have accepted it, we can prepend some bogus autonomous systems like 100, 200, for example. We can add some we can prepend some bogus autonomous systems, for example, in case of border gateway protocol. We can, for example, set the aggregator. We can set the community tag, like, for example, 100:100. You need to know about the BGP committee and all that thing. We can set, for example, like the weight, for example. We can set the weight, for example. We can set the origin, for example, origin like IGP, EGP, or incomplete. So IGP, for example, or incomplete, for example. You must know about these actually. Then only you will be able to set. And then just save it. Just here, save it. So here in this condition, I am going to match all the routes originated in my autonomous system, and I'm going to set all these things. I'm going to set all these things actually, and everything else I'm just going to accept as it is. Save it and push it. Push this policy. Push this second policy. You have to push this policy on the branch number 2, because in branch number 2 we are running border gateway. So once the policy is delivered, once the policy is configured, I will push that policy in the branch number 2. Here is the branch number 2. I will edit it, and I am going to additional template, and I'm going to push the policy template that we just set. So as per this policy template, all the routes that this router learns via BGP, whose AS path list is blank, basically all the routes originated in the same autonomous system. In all those routes, this router BGP is going to set a few parameters. It is going to set a few parameters. So show run policy. Let the policy get delivered here. Let's wait. Let's wait for the policy to get delivered here. So fail to update the configuration. Additive command is not supported. Okay, no problem. I will just edit the policy one more time. It says that additive command is not supported. No problem. If it's not supported, I'm going to edit that policy. It says that additive command is not supported. So unknown command additive. So I'm going to just edit it, and I'm going to remove this additive keyword. And let's try to push it again. If you know about border gateway protocol, if you know what are those terms, what are those things actually, then of course you will be able to create the policy properly, and you will be able to push that policy with the help of the template on the appropriate site, which is in our case site number 2. Let's wait. Let's see if the policy gets delivered this time or not. It's there. It's now here. We got the policy. We got the BGP policy. And now I'm going to use this BGP policy. I'm going to use this BGP policy with the help of the templates that we have configured. So this is the template that we have configured. I'm going to edit it, and I'm going to configure the policy for that neighbor. Where is the neighbor? And I'm going to edit it, and the route policy in. Route policy in means when I receive the route from that neighbor, I am going to apply this particular policy. When I receive the route from that neighbor, I am going to apply that particular policy named as this one. So not only you have to push the policy on the branch. But also you will need to use that policy in the respective protocol such as BGP, OSPF, or whatever, So let the policy get delivered. Sending the configuration. So under the BGP, the policy must now be there. Show run VPN 10. You can see in the, so in the VPN 10, we now have that BGP policy this time. And if you check show IP BGP, if you check the show IP or show BGP, for example, show BGP and routes, for example, what route? 172.16.2.1/32. If you check these routes, this is the route, you see that the AS path is prepended. You see that it's incomplete origin. You see that the weight was adjusted. I could have changed the local preference. I could have set the tag and all as well. But you can see that our attributes got changed in the BGP as well. So things are happening as expected. Things are happening as expected. So this is one thing. This is like the localized control policies, configuring the routing, influencing the routing. Those things can be done. Those things can be done with the help of these localized control policy. And why we call them localized? Because the impact is only on the local side. We call them localized because the impact is only on the local side. It is not impact. It's not like the policy is getting activated by the vSmart and all that thing. It's not like that. You can now explore the rest of the options. You can explore now the rest of the options. The options such as like what routing you can do, how can you influence the routing based on those policies. You can explore the rest of the options if you want to, but pretty much everything else is done here. Everything else is like pretty much done here. These are called localized control policies. The control policies influence the control plane. The control policies influence the control plane. They influence the routing decision, but only for the particular site. That's why we call them like localized control policy. If you want to influence the data traffic, if you just want to influence the data traffic, then you have the localized data policy that influence the data traffic. Local managed router data policies allow the device specific behavior. Local managed router data policies cover a wide range of functionalities. Most commonly used data policies are quality of service, ACLs, traffic mirroring, for example. Localized data policies are also provisioned via the vManage with the help of templates. So for example, in the same diagram, I want to block my communication from site 1 to site 3. Okay, fine. So I will go to the policy section one more time. I will go to the localized policy. I will create a new policy. Here I'm going to match my source IP and the destination IP. I will match it here. Otherwise, I will match it later on. So click on the next button. No need to worry about the QS. Click on configure access control. Click on this configure access control list. Here, I'm going to say ACL. ACL for blocking the communication between the site 1 and site 2. Add the ACL sequence, source IP, destination IP. Source IP is, if the source IP is 172.16.1.0/24, if the source IP is from this range, and the destination IP is from 172.16.2.0/24. If the source IP is from this range and the destination IP is from this range, then do one thing. Then just drop it. Just drop it. Drop the data. If the traffic is going from here to there, and everything else, permit it. Everything else, you are going to accept it. Save this access control list policy. Next button. No need to configure the route policy. Next button. Create this policy. Save this policy. And once you have saved this policy, then you will have to again use this policy with the help of the templates. So go to the template button and we need to apply this policy on the interface because the traffic will arrive on this interface in order to go to that destination. So I will need to go to that interface template, GE2. I will need to go to that interface template. And here I am going to edit this template and I am going to apply the ACL, access control list, the ACL, ingress ACL. Ingress ACL means when the packet comes, then the ACL will be applied. I'm going to apply the ACL under this interface and click on the update button. I'm going to apply the ACL on that particular interface. Let the configuration get delivered again. Once the configurations get delivered, things will happen accordingly. Let this ACL get delivered. Remember that this template is configured on 3 devices. So for 2 it will work, but for this one it will not work. It will fail actually because we have not pushed the ACL on the branch number 2. We have not done it actually. So on there it will fail, but on rest it will be successful. Looks like it failed everywhere. Why does it fail everywhere? So click on it and ACL name is incorrect. Why it failed? So ACL name is in. It says that the ACL name that you are trying to push is incorrect. Okay, fine. Let's try it again. Template, feature template, the GE2 template, edit it, and go under that ACL option, ingress ACL, and what ACL you are trying to push. This is 3 ACL, site 1 and site 2. Cross check. Make sure that the name of the ACL is correct. Make sure that the name of the ACL is completely correct. So when we were trying to, for example, apply that ACL, it shows me that the ACL configurations were incorrect, that push was unsuccessful. The reason is that we have configured the ACL and we are directly trying to apply that access list, which is not allowed actually. Once we have configured the access control list, once we have created that ACL, we have to push that ACL first onto the devices. We will have to push that ACL on the devices and then we will use it. What we did, we just configured the policy and we just directly started using it, which is incorrect. First of all, I will need to go to the template. Once we have configured the ACL, I will go to the template, I will edit it, and I will at the very end, I will first edit it, and at the very end, I will push that ACL onto that branch. First of all, I need to push that ACL onto the branches. So create the policy, then push the policy, and then activate or then use the particular. What we did, we created the policy, and we directly started. We created the policy and we directly started using that policy, which is not allowed. You have to push the policy to the branches first. So create the policy, then push the policy, and then activate the policy. Now it says the update push is failed as well. Why? Because the policy name is not correct. Because like the policy that you are trying to remove is already called in OSPF, so we'll need to fix it as well. So it says that we cannot push that policy. We have configured the policy, but it says that we cannot push that policy. When we are trying to push the policy, we are getting the error, and the error actually is that the old policy that we are trying to remove is already being called in OSPF right here. Right here it says that under the router OSPF, you already have called that policy, so you cannot remove that policy. So the step will be, first you go to the OSPF. First you go to the feature template, then you go to the OSPF template, then you go to the OSPF template. And here under the OSPF template, you will have to remove the policy that you are calling. Under the advanced, you will have to remove that policy. You have to remove that policy first of all. Once you have removed that policy, so earlier what we did, we configured a route filtering policy. We have filtered some OSPF routes. Okay. So we created that policy, then we pushed the policy onto the site number 1, and then we actually used then actually we use that policy in OSPF. And now we created one more policy. And that policy that we created, I need to apply that on the same branch. I need to apply that policy on the same branch. So earlier we created the policy for route filtering. Now we are creating the policy for traffic. Like I want to block certain traffic. I want to block some certain traffic. So we created the policy for the same, and we are now trying to push that policy. We are trying to now push that policy on the site number 1, but the site number 1 already has a policy. So when we push the policy, the SD-WAN will try to the vManage will try to remove that policy and then push this policy. But that policy, since it's already being called in OSPF, so we first need to remove the policy from the OSPF, and then we will be able to go to the device template, and then we will be able to push that policy, and then we will be able to use that policy on the interfaces that we have. So here site 1, 2, here we are going to now attach, here we are now going to edit that, and here we are going to now at the very end attach that new policy that we are just trying to push. Remember, the way you have applied the policy is the same way you will have to remove the policy. The way you have applied the policy is the same way you will have to remove the policy, and then you will need to activate the new policy. You will need to push the new policy actually. Otherwise it will not work. Since we created a policy, we push the policy, and then we use the policy in OSPF. So first we'll need to remove the policy from OSPF, then we'll need to push a new policy, and then we will need to activate that policy there. Now, then we will be able to push the new policy on that particular branch. And once the policy push is successful, done. Now I will be able to go under the gigabit 2. Now I will be able to go under the GE2, the gigabit 2 template, and I'm going to edit it, and I'm going to ACL. I'm going to apply the ACL on the incoming direction. And the name of the policy is this. It is basically like it gets a little bit complicated because you have to remove the old policies first, and then you will have to activate the new policy. It's not like the old policy will get removed automatically. Once you have removed the old policy, then only you will be able to activate the new policy. That is the whole concept behind. And by the way, if you have used, for example, the old policy somewhere, then you will have to remove that policy, and then you will have to activate the policy again. Now this is done. So now you see, now here on the site 1 VH1, you can log in here, and you can now see show run policy. Now you can see that you do have the policy here, that I'm going to, if the source IP is this and destination IP is this for the packet, I'm going to drop it, and everything else I'm going to accept it. Okay. Then show run VPN 10. You can see that this policy is activated actually on the interface gigabit 0 by 0. So understand the concept. Understand that when again you can apply only one policy. You can apply only one policy actually. And if one policy is already activated, then you have to remove that policy, and then you will have to apply the policy, a second policy basically. So now if you try to, as per the policy, now if you try to ping 172.16.2.1 source loopback 1, the ping is unreachable. The ping is not working. But if you ping 172.16.100.1 source loopback 1, this ping must be successful. So as per the policy, when the packet arrives onto this interface, packet with this source IP and this destination IP will get blocked by the ACL, and everything else is just. So you see, show policy, you can see that show policy and access list. Do we have the ACL option? We do have actually show policy, device, we have access list, show policy, access list, and then what? Names, the ACL name, the access list, for example, associations, that where we have applied that ACL actually, on what interface, and counters. In the counters, you will see how many times it matches actually. So you will be able to observe all those things right there. And it also shows here actually in the main dashboard. Now, if you go to the monitor dashboard and if you go to the device dashboard, if I go to the device dashboard onto the device one, site one, VH1, if I go there, and here, where is that ACL logs? Right here. Right here under the ACL logs, here it shows also the logs. Anytime the packet matches with the ACL, it will also show the logs here. If you have enabled the logging, it will show the log here as well, that the packet has matched with this particular ACL, and we can filter it based on the VPN as per our requirement as well. Then last 1 hour, last 3 hours, last 6 hours, how many times the packet matched with the ACL can be cross-checked. It can be cross-checked. We can cross-check that from this ACL log option. I was never able to see these logs, by the way. Only in case of like quality of service, I was able to see the logs. But it is also possible actually. It is also possible to see the logs and everything here as per our requirement. So this is an ACL policy. This is a policy that we can configure in order to apply an access control list on the respective interfaces so that my certain traffic gets permitted and certain traffic gets blocked as per the requirement. AC. We can also do the port mirroring. Same exact thing. You just check the match criteria. You just go there, go to the configuration, go to the policies, go to the localized policy, and create the policy, and just take a look at the match criteria. Forget about the quality of service. Forget about it. Check under the access control list. Check under the ACL. What are the match criteria? Check under this access control list. Check under this access control list. Check what are the match criteria. Actually, we don't have the edit option, by the way. So I'm going to detach it and I'm going to create a new policy. So check the match criteria and check the set criteria. Set mirror list. We can set the mirror list. Like where do we want to, remote span services, remote destination IP, destination IP, source IP, and all that. So mirroring, we can do the port mirroring. We can do some sort of span services here. We can set the polisher. We can police the traffic in terms of quality of service. We can police the traffic as per our requirement as well. We can enable the counter, we can enable the logs, and all that thing. So just explore the options. What I'm trying to say is that just explore the options that you have under the localized policy. We have configured a localized policy for route filtering. We have configured the localized policy for our ACL as well. We have configured the policy as per our requirement. We have configured these policies as per our requirement. I can also enable the logging, by the way. So we have configured the policies as per our requirement. So you can configure the policy for, you can configure a localized policy to influence the route, and we can create a policy to filter the data. Both the options are in fact available. It is your understanding how much you have understood these localized policy. Do you want to? We can also not only block the routes, we can set the attributes in case of BGP, OSPF, for example. There are plenty of things that we can do. Based on how we have applied the policy, things will either work or things will not work. Simple as that. Either the ping will work or the ping will not work, simply based on how we have applied the policy respectively. That's the whole point. You see, the ping is not working. So, but the ping is working to the other locations. So this is basically an example of the localized control and localized data policy. Just the basic examples of the same. You can explore the rest of the options as per your. The important thing, the important policy that we have under this section, the very important policy, that we have under this section is the QoS, the quality of service. QoS, or quality of service. In order to improve the application quality of experience, in order to improve the application quality of experience, we can implement this app QoE. The main goal of the app QoE is to provide enhanced application experience in case of SD-WAN. So AppQoE is a set of SD-WAN features to address latency problem, packet loss on unreliable WAN links, and the bandwidth optimization. These are the three things covered. These are the three things covered. These are the three things covered under this AppQoE. The very first thing to address the latency problems and everything, is to implement the quality of service or QoS. We can implement the quality of service. We can implement the quality of service in our SD-WAN to improve the user experience of application. Like user is experiencing some latency, some drops and all while accessing some resources. So to improve the user experience, we can actually use this policy, basically QoS thing. Under the quality of service, what things are there? What is the quality of service? Quality of service is basically a set of tools. QoS is a set of tools. A set of tools to improve the user experience for certain application over certain application. Set of tools, or tools basically commands. Quality of service is just some set of tools or set of some commands to improve the user experience of certain application to other application. This quality of service, this QoS or this quality of service policy is created on the vManage, applied on the WAN-edge devices directly with the help of templates. So first of all, we will match our interesting application traffic either with the help of the ACL or with the help of a data policy. With the help of the ACL or with the help of the data policy, we are going to match our interesting traffic with the help of the same. Either we can match it with the help of the ACL or the data policy. Once we have matched our critical application traffic for which we want to, for example, apply the quality of service, we are going to place that traffic into different forwarding classes, which is equal to the class map command in the classic quality of service. We are classifying that this is telnet traffic, this is like the real-time RTP traffic or XYZ traffic. So we are going to match our interesting traffic. And we are going to place it into the respective forwarding classes. And here we are going to define the policies. For that class, that any traffic that is in the forwarding class 1, it will get this much amount of bandwidth. It will get this priority, and this is the drop policy for that particular traffic. We are going to map this forwarding class with the QoS map. We are going to create the policy. We are going to implement the quality of service for that particular forwarding class. So any packet that is in the forwarding class, for example, remote access, will get this bandwidth percentage, this priority, this drop policy, and all that, XYZ. So these forwarding classes, forget about policy shaping. No need to worry about that. We are going to map these forwarding classes with the QoS map, the quality of service map, which defines the bandwidth percentage, the buffer percentage, and everything else as per the. So let's create this policy. Let's go to this configuration, policies, localized policy, and we are going to create a new localized policy. Here I am going to create list. ASPark list, committee list, this, that. We are going to create these lists. So for example, from the list, I am going to create my class map. The class map, like the remote access, any traffic that is placed into this class is part of the queue number 1. Queuing, there are total 8 queues on every interface in the SD-WAN. Queues. the concept of queuing, the concept of queues are there. There are total 8 queues per egress interface. There are total 8 number of queues where we can place the packets as per our requirement. And we can place the packet into these queues based on either the data policy or based on that 6 tuple matching, deep packet inspection, source IP, destination IP, source port, destination port, DSCP value. We can match it based on those 6 parameters, or we can create a data policy and place the packet into the respective queues. Queue number 1, queue number 0 that we have the queue number 0, it is a special queue. It handles like all the control traffic, DTLS, TLS, BFD, routing protocol. It is not subjected to any low latency queuing policy. It is not subjected to like any policy. And the scheduling algorithm in the queue number 0 is LLQ. LLQ stands for low latency queuing, which means that this queue will always be prioritized over any other queue. Whatever bandwidth is left from this queue will be distributed among the queue number 1 to queue number 7 then respectively.
Q0 is for real-time traffic, so something is dedicated.
We can place the real-time traffic in the queue number 0 if you want to, but by default the control traffic will be there in the queue number 0.
Okay.
If idealistically speaking, we should place the real-time traffic in the queue number 0, but even if we place it in the queue number 1, 2, 3, 4, 5, 6, 7, it's fine, because we can define the bandwidth percentage and scheduling algorithm and all those things as per our requirement. The only problem is that the queue number 0, since it's the low latency queue, which means that it will always get the priority over all the other queues, and whatever bandwidth is allocated to the queue number 0, whatever is left from there, it will be allocated to like queue number 1 and queue number 2, 3, 4, 5, 6, and 7. So if idealistically speaking, like we should place our real-time traffic into the queue number 0. But even if you have not done it, if you have placed it in the queue number 1, 2, 3, 4, it still will work pretty much okay. But if you want to have that LLQ for the real-time traffic, then you must place the real-time traffic in the queue number 0 as well. Because this queue number 0 is the only queue with the low latency queuing. All the other queues, queue number 1 to queue number 7, they work on round-robin algorithm, weighted round-robin algorithm. Whatever bandwidth percentage we have defined determines the weightage, the priority of the particular queue. So we can't change it, by the way. The algorithm that will run on all the remaining queues in order to decide like which one will get preferred over which one, it is the weighted round robin. Based on the bandwidth percentage, it will be determined the queue and everything. And the drop policy, what if the queue gets full? The drop policy is either tail drop or random early detection. Random early detection or tail drop. Random early detection, red or tail drop. Red stands for like when the queue gets filled, like this percentage, like when the queue gets full up to a certain level, then random percentage of the traffic will be dropped to avoid any possible congestion. That is what we call red. Randomly drop some packet before you detect any kind of congestion. So early detection, random early detection, linear drop probability. Based on how many number of packets are there in the queue, the percentage of the drop probability will increase based on the same. Or or the tail drop. Tail drop basically means when the queue gets full, all the remaining packets will drop. If the size of the queue is like 40, like there could be like 40 packets in the queue, for example, there could be like 40 packets, let's say, for example, in the queue, and the queue is full, queue is like completely full, then all the remaining packets will basically. Here we are defining the same thing. We are defining here that the remote access traffic will be placed in the queue number 1. Then again a new class, let's say, for example, real time, I can place that in the queue number 0 or maybe queue number 2 completely on us. Maybe the file transfer, we are creating the class maps and then we are mapping it with the respective queues that we have available in our QoS concept. Click on the next button. And here we are going to create the QoS map. The very first thing is that we are going to create here the QoS or the quality of service map. In the QoS map, we are going to define this is a QoS and map. In the QS map, we are going to define, here we are going to define, you can see the queue number 0 is by default low latency queue, the drop policy is tail drop, and the control traffic comes under the queue number 0. It gets all the bandwidth percentage, buffer percentage, the optional bus capability, and you cannot change really anything here. You can't change anything. You cannot change anything except for like, putting the forwarding class into this. You can't really change anything here.
And one, in case of link congestion, okay, so Q0 traffic can starve bandwidth from other queue as well?
No. Whatever we have configured, whatever is left basically after liberating it from the other queue, that is the maximum amount of bandwidth it can consume. So you had to define it accordingly based on that. That's why I said that in case of even in case of real-time traffic, you can put it into some separate queue so that you can adjust the bandwidth percentage, buffer percentage, respectively.
Okay, so whatever bandwidth is left from Q1 to Q7, okay, that is assigned to Q0.
Correct. So if for example, if you add the queue number 1, we have configured the queue number 1, which includes our remote access traffic, by the way. I can define the bandwidth percentage. Typically, we define the same amount of buffer percentage as well, like how much bandwidth it can have it in buffer versus the bandwidth. So pretty much these are the same thing. We configure these values as the same value typically. So bandwidth percentage, buffer percentage, and you can't change the scheduling algorithm. The only thing you can define is the drop policy, tail drop, or the random early direction. That's it. Add queue number 2, where we have our real-time traffic. I'm going to allocate approximately like 25%, for example. I'm going to allocate like 25% of the link bandwidth for that, or maybe 30% of the link bandwidth, 30% of the link bandwidth for that. And the drop policy is like random early detection. And what traffic is placed into this queue is the real-time traffic. What about the file transfer? File transfer, I don't want to assign a lot, only 10%. I don't want them to, overuse my bandwidth, so 10% maximum. And you can see whatever is left goes here actually. Now my question is, try to find the answer to this question. What if I have allocated like all the bandwidth to different queues and there is nothing left in the queue number 0? There is nothing left for the queue number 0. Then what will happen? How your control plane traffic will be handled? If you have, let's say, allocated all the bandwidth to other queues and you are left with 0% of the link bandwidth for the queue number 0, then what will happen?
Does it allow to have 0?
Exactly. We'll try to find the answer to that. So
I think other queue will not work in case there is a much traffic utilization on Q0.
No. The question was reverse actually. The question was that if we have configured the QS in such a way that we have allocated all the link bandwidth to other queues and queue number 0 is left with 0% of the link bandwidth, then how the control plane traffic will work?
Correct, sir. The concept is the priority queue is 0. Whatever the bandwidth is remaining from there, it will be allocated to queue number 1 to 7.
That is not happening actually. Looks to me that it is happening in reverse actually. So we allocated like 20% of the link bandwidth to the remote access. So it went to like 80, then we allocated 30, then it went to like some things, when with 10, so it went to, it is basically getting reduced. So it's like whatever bandwidth is left from here is allocated to the queue number 0. Okay, anyway, so try to find the answer to that question. I will repeat the question. Question is that what if we have configured the quality of service in such a way that we have configured some queues, and in the queues we have allocated like 100% of the link bandwidth. First of all, is it even allowed? Second, if it is allowed, then the queue number 0 will have 0% of the link bandwidth if we go by that concept. So if there is no prioritization, if there is no QoS for the control plane traffic, then how the control plane traffic will work properly in that case? So basically queue number 0 has all the bandwidth by default. And as we reserve the bandwidth for the other queues, queue number 0 overall bandwidth is reducing, like the overall bandwidth from the queue number 0 is reducing. So what if like it goes to 0? That's the question. Anyway, so you have configured these things. Save this policy. Now you will have to define what traffic will go into the remote access class, what traffic will go into the the classes that we have configured. So here we are going to create an ACL. In that ACL, I'm going to say QoS ACL. This is the quality of service ACL. And as per this QoS ACL, I'm going to match if the destination port number, if the destination port number is 22, separated by what? Separated by space, 22, 23. 22, 23 is what? Telnet SSH, remote access. So I'm going to match it and I'm going to place it into the class. What class? The class remote access. So I am matching my traffic and I'm matching the traffic based on criteria, and then we are placing it into the class 1. Right here, we can also police the traffic. Police means, set the limit. I can also police it. I can police it at certain rate. That I can also enable the policing for the same. Do not exceed this limit. Actually, I can also police it if I want to, but I'm not going to do it at the moment. So we can do the policing for that as well. I can also enable the logging for that that rule as well if I want to. So okay, the second statement says that if the destination port number is what? If the destination port number is 20, 21, and 69, which is like FTP, TFTP, then I'm going to place it into the class file transfer. If like match a DSCP value 46, remember typically the audio video traffics are marked with the DSCP value of 46 actually. You could have matched like the protocol, you could have matched like these different things as per the requirement. The protocol, source data prefix, destination data prefix, source port number, destination port number, TCP SYN, packet length, packet loss priority, class. You can match one class and all that thing, completely up to you. I can match all the packets with the DSCP value 47, 48, 46, whatever. So we are going to match packets with all the packets with the DSCP value of 46, decimal 46, 41, AF41 or DSCP 46. They are all classified as the audio video traffic. I'm going to accept it and I'm going to place it into the class the real time. Where is that? Maybe one more. Maybe like destination port number 80 and 443. 8443, I'm going to the 8443 I'm going to accept and I'm going to place it into the class web, and I'm going to match it in the queue number 4. And everything else apart from that, everything else is just accepted as it is, class default. It is accepted as it is. This ACL concept that we have here, this ACL concept is what we are using to classify our traffic and place it into the respective class. Identify the traffic based on the source port number, destination port number, DSCP value, and XYZ conditions, and place it into the respective class. And then the policy will get activated for that particular ACL. We can also define the route policy. No need to worry on that. The policy name is like a QoS policy, for example. The name of the policy is QoS policy. And we want to implement this policy for our application traffic, IPv6 application traffic, cloud application traffic. We can enable the ACL logging. We can enable the net flow. We can do those sort of things here. But I have noticed that in the previous version, there was an issue that when we enable the ACL logging, it just fails to push the template. Let's try it in this version. Let's see how it happens. So you have saved this QoS policy. You have created this QoS policy. And in order to apply this QoS policy, first you will need to remove the old policies. And in order to remove the old policy, first you will need to remove where we have applied those old policies, such as interface gigabit 2. On the interface gigabit 2, first of all, interface gigabit 2, what we have done on the interface gigabit 2, we have applied that ACL. So first of all, we have to remove it from here. We will have to remove this ACL from here. I am not going to apply the ACL here. I have to remove that ACL that we applied earlier. We are going to remove that access control list. First of all, I'm going to remove that particular ACL. You cannot just directly do it. You can't just directly do it. You will have to remove that. You will have to remove that particular ACL first. Once you have removed that ACL, we have removed that ACL, removed it. Let the config get delivered. Once we have removed that ACL, then we are going to let it happen in the backend. Then we will go to the templates, and we are going to edit. We are going to edit this template, and instead of applying this policy now, I will apply I will send my QoS policy. I will send my quality of service or QoS policy. Update template login edit mode. Okay, still it's going on. Still completed. Yes, it's done. So,
sir, how about if on the same interface there are two types of traffic? One is a real-time traffic, and the other one is a web traffic where I want to put the QoS.
So whatever you match in the ACL will match in the policy.
But I have something different classes for each traffic, right?
Everything else will match in the class default. So whatever like traffic you want to implement the policy, just match it in the ACL, and then just implement the policy. And whatever traffic you don't want to apply any policy, just leave it as it is. It will match in the default class, and it will just be applied normally, just like in the classic quality of service.
No, my question is, sir, I have a one QoS, okay, QoS on interface 1, okay, and I have two types of traffic where my QoS statics are different. But you are saying I can have only one QoS on one interface.
Yes, you can have only one policy on one interface. So whatever thing you need to define is on the same policy. Whatever thing you need to configure, whatever policy you need to configure, you have to define in the same QoS map. In the same policy, whatever things you need to define, you'll have to define it in the same policy, and then you will have to apply that policy respectively on the managed device.
Yeah, there could be some conflict with the traffic. See,
it will not work in that. It will not work in that case. Simple. It will not work in that case. If the policy overlaps or if there is some issues with the policy, it will simply not work. You have to create the policy in such a way that nothing overlaps with anything else.
Okay.
Right. So you will have to understand the match and set criteria, and based on that, you will have to implement the policy in such a way that nothing overlaps with nothing overlaps with anything, and then you will be able to apply that policy on the devices. Else, you will not be able to do it. Now that policy is pushed. Now that policy is just delivered. The policy is just pushed on there. It's still not applied. The policy is just pushed there. You can see show run policy. The policy is just pushed there. The class maps, the ACL, the queues, everything is just pushed there. It's still not applied. So in order to apply that, we are going to go on the interface. I will go to the templates. I will go to the feature template, and I'm going to go to the GE0. This interface, this WAN interface, when the traffic goes to this out of this interface, then we want to apply that policy. So you go under that interface and edit it, and here you are going to apply that QoS map, the quality of service map, the QoS map, the quality of service map that we have configured. It's named as QoS map. I guess the name has to be completely correct. So just cross check the name. QoS and then M capital AP small. So yeah, the QoS map we have implemented on the, we are implementing the QoS map on the interface gig 0x0. So when the traffic exits out of that interface, the QoS, the quality of service, will be applied respectively. If you want to enable it for this interface, you will have to go under that interface also and apply that QoS, the quality of service map, there as well. If you want to push it if you want to apply the policy on the branch number 2, then first you will need to push that policy to the branch number 2, and then you will need to apply that policy. Wait for this to get delivered. It will get delivered only on the branch 1, not on the branch 2, by the way. So no need to worry if that fails. It will fail. Okay, no problem. No problem. We can't apply the QS map on the branch number 2 because we have not pushed the QS map on the branch number 2. On the branch number 1, however, send in the configuration to the devices. Completed. And then we will also need to edit the interface template of the GE2, Gigabit Ethernet 2, the LAN interface, this interface template. And here we will have to apply that edit. And here we will have to apply that ACL, the access control list. The ACL on the inbound direction. ACL in the inbound direction, and the name of the ACL must be proper as well. The name of the ACL must be properly configured as well. So show policy and access list names. For example, we are going to configure here. The name is QoS ACL. So QoS ACL. So what will happen now? On the inbound direction, we have applied the access control list. On the inbound direction, here on the inbound direction, we have applied the ACL. Basically means when the packet arrives from this LAN side, when the packet arrives onto the interface gig 0x2, 0x2, the ACL, based on the ACL packet will be identified and classified. It will be placed into those different classes. It will be placed into those different classes. When the packet is placed onto the exit interface, once the packet is identified, once the packet is classified, once the identification is done based on the ACL and the packet is placed into different classes, when the packet is exiting out of the interface, based on whatever priority we have configured, the traffic will be prioritized 1 over. So template push is successful on all the devices. So you can see that here on the interface, access list associations, you can see that the interface, the ACL, QoS ACL is applied on the gig 0x2 inbound direction, and the QoS map, show policy or show QoS, show policy and quality of service, the QoS, and you can see the map info, the QoS map is applied on the appropriate interface as well. How much bandwidth percentage, buffer percentage you have given, all those things are mentioned right here. So now when the traffic comes from the LAN side, from this site 1, router 1, when different types of traffic is generated, when the traffic is received, let's say, for example, telnet traffic. What is that? 172.16.2.1 source loopback 1, whatever it is, like, or 172.16.100.1 / source interface loopback 1, for example. The telnet traffic, when it sends the telnet traffic, when it sends the SSH traffic, SSH-L, then username, and then, for example, the IP address is 172.16.100.1, for example, enter. So when it sends the telnet traffic, when it sends the SSH traffic, when it sends different types of like traffic such as ping 172.16.100.1, source loopback 1, when it sends the trace, when it sends different types of traffic, the traffic will be classified on these interfaces as per the ACL. The traffic will be classified on those interfaces as per the ACL. Access list counters and everything, you can observe how many times the packet has matched with that particular ACL, and you can check the names, you can check the associations. For example, you can check the names, you can check the associations and everything. So, and then when the packet moves out of the exit interface, the QoS, the cost map will be applied, and based on the quality of service map, the prioritization will happen for one application over other application. We can do the monitoring, by the way. We can do the monitoring by going to the monitor dashboard, by going to the device dashboard, and here I can take a look at the device such as site1 VH1, and here this QoS, right here we have this QoS or quality of service. The QoS monitoring you can do right from here. You can do the QoS monitoring as per the requirement right from here. The real-time monitoring you can on the interface gigabit 0x0, we have applied the QoS map. So in kbps, in packets per second, post policy rate, post policy counter, we can implement, we can check the QoS statistics actually from here, from this dashboard that we have under the QoS. So based on like how the traffic exits out of that particular interface, how the traffic goes out of that particular interface towards the next devices. If I say like telnet SSH, if I say like telnet ping, for example, 8.8.8.8, but we have not enabled the DIA policy actually. So, I cannot ping google.com, I guess. Yeah. So like, when the traffic exits out of that interface here, it will show you chart. Here it will show you the chart, it will show you the counter and everything, like, how many times the packet have matched and everything. It shows right here the chart, the counter regarding the quality of service. Anytime the packet matches with the ACL, it will also show the ACL counters right here. It will show you the ACL counters right here. When the packet is going from here to here to here, the packet was, the ACL match has happened. So it will also show you the counters. Might not show you right away, but it eventually shows this dashboard. So the overall point is that here, we can implement this is a very basic QoS thing that we have implemented here. We can now generate different types of traffic, and we can then track like how the QoS is working based on the same. I'm activating that NAT policy again, by the way. I'm activating the NAT policy again. I'm activating the NAT policy so that the traffic exits from here, exits from here.
Surinder, I have checked, okay, it's not allowing. Means we need to define some bandwidth to Q1.
Correct. So at least some bandwidth has to be there, right? Otherwise your control traffic will not work. This is a very basic policy that we have. Applied there. This is the very basic policy, the ping, the telnet, and different things that we have here. Like, of course, it will not allow, but the objective is basically to place the packet onto this interface so that we can see it in the counters and all. So it sometimes does not show you the counter, but the counter is there. If you go to the D cloud, for example, if you visit the D cloud and you go to the monitor dashboard on the Cisco D cloud, and there if you take a look at there, it shows the counter, by the way. It shows the counter, it shows how many packets have matched with that ACL and all. It might have something to do with the version of the software that we are using. So based on that, accordingly, we will see. This is a very basic quality of service. This is a very basic QoS that we have applied here. This is the very basic quality of service. This is a very basic QoS that we have applied here. So we can apply this basic quality of service, implementing quality of service. So it can be done on queuing. Basically, this part we have done actually. We can also like do the changes, by the way, like if you, let's say, for example, at the very end we have configured the web class. At the very end we have configured the web class, for example. So configuration and the policy, the list, for example, the quality of service map, I can edit it. So we added a new, for example, add a queue. We added a new port number queue where we had our web traffic, by the way. So we can define the drop policy. We can define the bandwidth percentage as per the requirement. As per the requirement, we can define something here actually. So we can always edit it as per the requirement. So the changes will be delivered, and now the policy will be activated based on the same. Steps are like, first you will need to create like you will need to create the class maps, and class maps are mapped with the queues, by the way. Then you will have to create the cost map, QoS map. You will have to create the cost map. In the cost map, we are defining the policies actually, like for this class, this much bandwidth percentage, buffer percentage, and all that thing. And then we are going to configure, what is that? ACL. In the ACL, we are doing classification. And then we are going to apply that ACL in the inbound direction, and we are going to apply the cost map in the egress in the outbound direction. This is how we can implement quality of service, basic quality of service. You can see the options available under the quality of service. It's not like there are a lot of things, by the way. Like whatever things are available, we have explored a few options there. Once we have implemented like everything, once we have configured the routing, once we have configured the policies and everything. Now what we also want, we want to implement some security feature. We want to implement some sort of security in our SD-WAN. We want to actually make sure that the traffic basically goes as per the requirement, and also we want to make sure that the traffic is also secured. We already have talked about the security from the control plane and data plane point of view. Control plane security is provided with the help of the DTLS, TLS, and data plane security is provided by the IPsec. But if you want to implement some dedicated security features, let's say in our topology, we want to implement some dedicated security features. That is also possible to do. We can also implement those dedicated security features in our SD-WAN. Dedicated security features that typically require security appliance, such as, for example, firewall. So assuming that it is not possible, it is not possible to install a firewall on all the branches. Like we have many branches here, and it is actually not possible to deploy the firewall on all the branches because of the cost constraint. Because of the cost and all, it is not possible to deploy. It is not possible to deploy the firewall on all the branches. So we can take a few approaches. We can take a few steps. We can take a few approaches to implement the security in our SD-WAN. So what we can do, first of all, First option that we can take is to continue backhauling all the traffic to the data center. Typically in the data center, we have those security appliances installed. Security appliances such as firewall, IPS, IDS, or some other appliances that we have. So the traffic, the branches, whatever traffic they need to send, for example, they want to go to the internet and all, they will send all the traffic to the data center. Here the traffic will be inspected via the security appliance, via the firewall. And once everything is okay, then the traffic is either allowed or traffic is not allowed to go to the internet. So one option is to continue backhauling all the traffic. One option is actually to continue backhauling all the traffic to the data center. Continue backhauling all the traffic to the data center basically means that all the traffic will go all the way to the data center. Advantage is that security is simple, but disadvantage is that user experience is not going to be good. Since all the traffic is going to the data center, from there it is getting inspected via the security appliance, and then it is going to the firewall. If we are running, let's say, for example, some SaaS application or infra as a service application, since the entire traffic is going all the way to the data center, from one branch to the data center, it will introduce a lot of latency. So user experience might not be proper. That is the problem. So security is simple. Like we don't need to install a dedicated firewall on all the branches. We can just install a firewall or security appliance on the data center. We can backhaul all the traffic to the data center where it will be inspected via that appliance, and then either it will be permitted or not permitted to go to the internet. Advantage, security is simple. We don't need to manage many firewalls. We don't need to manage like many devices. But the problem is that the user experience is poor, meaning to say that if you are having some SaaS or cloud applications, then sending the traffic all the way to the data center will introduce like latency and also. But this could have been one option. Second option is we can perform DIA. We can here implement direct internet access so that the traffic that is destined to the internet, it exits locally from this device rather than going to the data center. So DIA, and then we can go for some cloud delivered firewalls, for example, cloud delivered firewalls. So I can redirect all my traffic from this branch to those cloud delivered firewalls. Then we can contact those cloud service providers. They will provide us the cloud services. They will deliver, or maybe we will deliver a firewall onto the cloud, in some AWS or Azure cloud in a virtualized environment. I will redirect all the traffic to the cloud, and from there, cloud delivered firewall, for example, the inspection will happen, and then the traffic will either be allowed or not allowed to go to those different applications. Application user experience will be improved. That's fine. But the problem is that since this is the firewall, for example, since we are going for some cloud security, since we are following the concept of cloud, since we are asking for the security from some cloud service provider, we will not have like full control. We will have limited control on what things we can secure, what things we cannot secure. So that could have been one option, but we will get limited control in this case. Else, we can install a UTM. We can still do DIA. I can still do the direct internet access, and I can install a UTM, Unified Threat Management. I can install basically some sort of a UTM, for example, device. I can install some sort of UTM device on the branch, Unified Threat Management device. Like we can install like for example some threat management device like firewall, for example, on all the branches. firewall, IPS, IDS, and all that thing into like on all the devices, on all the branches. Basically, we can install a UTM device. UTM, Unified Threat Management. Typically, basically, a firewall with IPS, IDS, and some antivirus and some other features in a single appliance. So that is typically referred to as UTM. So we can purchase and install UTM device on all the branches. And we can do DIA so that all the traffic exits locally for the internet, but first it gets inspected via that UTM device. So it improves the user experience, but it is complex to manage. It improves the user experience, but installing UTM device on all the branches, installing the UTM device, for example, on all the branches, installing the UTM device on all the branches is going to like add some additional challenges in the management. It will be complex to manage. Or we can implement security everywhere, data center, headquarter, branches, everywhere, so that the traffic flows efficiently from one point to other point. But it will be difficult to manage all the policies if we have deployed security everywhere. Security everywhere basically means like we have purchased and installed some security plans on the data center, on the headquarter, on the branches, basically everywhere. Not a problem, but the challenge will be that managing all those things, managing all those appliances, managing all those things, implementing security policies and everything will be a little bit complicated task. So we have various options. We can continue backhauling all the traffic to the data center. From there, the security is being enforced. We can go for some cloud delivered firewalls. From there, security can be enforced. We can purchase some appliances and we can install those appliances onto the devices itself, onto the branches itself. From there, security can be enforced. And all of these have their own advantages and disadvantages, respectively. What they thought that, okay, since we are going to do all that thing, why don't we do one thing? Why don't we just implement the security natively in the SD-WAN itself? Why do not we implement the security natively in the SD-WAN itself? So what they did actually, on the VS devices and on the CS devices, they added some security features natively. On the router itself, they added some security feature natively. CS devices support more security features as compared to the VS devices. And all of those features, by the way, can be managed right from here, configuration, and we can go to the security option. Under the security option here, we can add from the dashboard here, I can add a security policy for different use cases. For example, for compliances, for some devices, for some card readers and those kind of like devices, we can implement some application firewall, intrusion prevention, SSL TLS decryption. For the guest access, it is recommended to at least deploy application firewall, URL filtering, SSL TLS decryption. For direct cloud access, application firewall, intrusion preventions, AMP, DNS security, SSL TLS decryption. For DIA, it is recommended to deploy at least these much security. To improve application quality of experience, SSL TLS decryption. Or if you do not understand, then you can just click on the custom button and you can get the option to implement like all the things: intrusion prevention, URL filtering, advanced malware protection, DNS security, and SSL TLS decryption. These are the options that comes under security available in the Catalyst SD-WAN. So we have enterprise firewall application aware, IPS, URL filtering, AMP, DNS website security, SSL TLS decryption. We have various options available built in within the SD-WAN solution. For these features to run, we do not need to purchase. For these features to run, we do not need to purchase some additional security appliances. We can, for example, there are employees. Employees send the traffic for the cloud delivered applications, such as like Office 365, Salesforce, Dropbox, these SaaS applications. Employees, they also want to access to the internet. Employees, they also send the traffic to the data center here. And then when we talk about the guest users that are part of the VPN too, they are typically accessing the internet services. So we can implement a policy as per our requirement for the employee SaaS application, for the employee internet traffic. For employee SD-WAN traffic, the security is already there with the help of the IPsec. So not a lot of things needed to be done. However, we can redirect the traffic via certain firewall in order to cross-check from some rules that we can do. Apart from that, we don't need to do really anything. So for all these, like for the employee for the employee internet traffic, for the employee SaaS application traffic, we want to implement some security here. And for the guest internet traffic, for example, we also want to implement some security here. So following are the options that we can implement from the SD-WAN dashboard in order to improve the security in your SD-WAN solution. And for all these features, we do not require any additional firewall. For all these features, we do not require any like IPS IDS or any additional appliance. We don't need. For the compliances, we have some PCI compliance. We have some card readers and some different types of like hardwares. We want to basically for those like we want to implement like security for those features for those PCI compliances. For compliances, basically we want to enforce some security. So it is recommended for the compliances. It is recommended that you implement at least application firewall, intrusion prevention, and SSL TLS decryption. At least these three things. It is recommended for the compliances. It is recommended that you at least implement these three things in order to make sure that the compliances are okay. So application firewall, intrusion prevention, and SSL TLS decryption. At least these three things are recommended when it comes to implementing the security for the compliances. Then after, like if you want to implement the security for guest access, then application firewall, URL filtering, SSL, TLS decryption needs to be enabled. We can do DIA. DIA stands for direct internet access. So we can go for direct internet access and we can implement these security features. Then for the cloud access, it is recommended to at least for those cloud delivered applications, for example, Office 365, Salesforce, and all these. So it is recommended that you at least add the following security features: application firewall, intrusion prevention, advanced malware protection, DNS security, and SSL TLS decryption. For DIA, for direct internet access, it is recommended to at least implement like these following security features. For the for improving the application quality of experience, you can implement like at least SSL TLS decryption feature minimum. And if you're not able to understand what features you must implement, just go for the custom option. Just go to that custom option, and in the custom options, you will get like all the features, and you can implement these features as per your requirement. So there are like different features. There are different, like for example, features that we can implement. There are different features that we can actually implement here when it comes to SD-WAN security. These are some general features that we are going to implement for different things, such as compliances, such as secure guest access, such as direct cloud access, direct internet access, improving application user of experience. We have different features that we can implement to improve the. We have different features that we can implement to improve the application quality of experience and enhance the security in the SD-WAN traffic. So the very first feature that we have in the SD-WAN, is the firewall feature. Firewall, application aware firewall to be precise. This is like application aware firewall feature. This application aware firewall feature is available on both vEdge and CS devices. This application aware firewall, this feature is available on both vEdge and cEdge devices. This application aware firewall feature is in fact available. Now, what we do exactly in this application aware firewall feature? What exactly is the objective of this app aware firewall? So what we can do, we can here configure in this application aware firewall. It's more like zone based security. It is like zone based firewall basically. Just like in a classic firewall, in a normal ASA firewall, for example, or in typical firewall option, we have this thing called zone. So we have this thing called zone inside. We have the zone outside, basically the trusted network, the untrusted network, and then we have DMZ, demilitarized zone, for example. So just like in a traditional firewall deployment, we deploy this zone-based security. Here also in the SD-WAN, we can deploy this zone-based firewall. However, here the term zone basically refers to the VPN. So what is this basically? For example, zone 1. Zone 1 basically means like VPN 1. What is this zone 2? Zone 2 basically means like the VPN 2, for example. So we can implement the policy that when the traffic goes from the VPN 1 to VPN 1, basically when the traffic goes from the zone 1 to zone 1, or when the traffic goes from the zone 1 to zone 2, when we have performed like that extranet VPN policy, when we have configured the communication between the two VPNs, then we can define the policy that when the traffic goes from the zone 1 to zone 2, basically means VPN 1 to VPN 2, then I will apply this particular policy. We can match our traffic. We can match our traffic based on source IP, destination IP, source port, destination port, protocol number, and maybe based on the application name itself. 6-tuple matching we can do. And once we match our traffic, we can either choose to drop that traffic, either we choose to pass that traffic, or we choose to inspect that traffic and create some sort of connection table. Create the flow record, create the record on the device itself that the traffic is flowing from this device to this device. So inspect mode we can also enable. So zone-based firewall feature. Zone-based firewall feature comes. It is implemented something like that. Go to the configuration. Go to the security. Under the add security policy, I'm adding custom policy. And I can click here on the add firewall policy, create a new policy. I'm going to call it like zone-based firewall. Zone-based firewall. I'm going to call it like zone-based firewall. This is like zone-based firewall policy that we have implemented. Zone-based firewall. And then here we can define the rules. We can define the rules. What do we want to do? We can configure various rules. Click on add rule button, and here we can define these various rules. These are the 6 things that we can match based on. We can match based on the source IP, source port number, destination IP, destination port number, then protocol number, the protocol number, protocol name, protocol number, whatever. So we can match based on the protocol number, protocol name. The packet inspection basically will work here. So we can match based on that. Otherwise, we can match based on simple application list we can create. So we can match based on the application as per the requirement. So based on these options, we can match. This is the rule number 1. Rule number 1 basically says that any traffic that is going any ICMP traffic, like protocol number 1. Protocol number 1 basically means ICMP. So any ICMP traffic needs to be inspected. If I let's say for example ping somewhere from any source IP to any destination IP with any source port, destination port, whatever, if I do the ping, ICMP packet needs to be inspected. Okay, fine. Then what? Then I can say I have defined this one rule. For example, this is the one rule that we have configured. Then I'm going to create another rule. The second rule basically says that if the packet has the destination port number, if the packet has the destination port number, let's say for example 20, 21 and 69, basically FTP, TFTP. If the packet has the destination port number this, then I'm going to drop that packet, simple. I can also enable the logging if I want to, but I'm going to drop that packet, simple. And let's say for example we are going to add a rule that let's say destination port number, if it is let's say for example 53, or if it is like 80, 53 basically for example, destination port number 53, which is DNS, or 2223 for example, which is telnet SSH. So I'm going to save it and I'm going to just accept it. I'm just going to pass it as it is. Pass that traffic. I don't need to check that traffic. I'm just going to pass that traffic. So we can keep adding rules. What I'm trying to say here is that we can keep adding the rules based on various criteria. Based on these various criteria, we can create these rules. I can create these rules such as like web. For the web, we have the destination port number like 80,443. So we can create this list, for example, and then we can define that we are going to inspect that traffic. We can create the rules as per our requirement. We can match based on various criteria. You can also explore the options. We can match based on various criteria. We can match based on various criteria, and then we can choose to either inspect it, either drop it, or just pass it. There is also an option of add rules with the rule sets. We can configure some like rule sets like from here. Based on theme like source port, same criteria, same things like source port number, destination port number, this protocol number. We can match it. If the packet matches following rules, following criteria, then we can choose or we can choose a different application, and then we can decide to permit or drop as per our requirement. So same kind of thing we can also implement with the help of the add rules and rule sets. So once we have defined like what traffic you want to permit, what traffic you want to deny, what traffic you want to inspect, for example, once you have done all that, then you have to define the zones. Right here, you have to define the zones. Zones basically means like, for example, zone 10. Zone 10 basically means VPN 10. So I'm saying that when the traffic goes from zone 10 to zone 10, basically means when the traffic goes from the VPN 10 to VPN 10, then these 4 rules needs to be applied. Or maybe when the traffic goes from the zone 10 to, let's say, for example, zone 20. Zone 20 basically means like the zone 20 is basically like the VPN 20. Maybe for example, like when the traffic goes from the VPN 10 to VPN 20, then also I also want to apply those 4 rules. When the traffic goes from zone 10 to zone 10 or zone 10 to zone 20, zone 10 to zone 10, zone 10 to zone 20, when the traffic goes from this VPN 10 to VPN 10, VPN 10 to VPN 20, then we are going to apply these 4 rules. And for the rest of the traffic, I'm going to permit as it is. These rules are specifically applicable. All these rules that we have defined here, these rules are specifically applicable for zone to zone, like VPN to VPN communication. What about the traffic that is going in some other VPNs and all? For that, I'm going to just pass it. Default action pass basically means that I am going to pass the rest of the traffic. These 4 rules are only for those zones, zone 10 to zone 10, zone 10 to zone 20, which means for the VPN 10 to VPN 10, VPN 10 to VPN 20. And the rest, for example, here, whatever traffic goes in another, for example, VPN and all, whatever traffic goes in some another VPN and all, then we are going to define the default action as pass. And we are going to save this policy. This is what they call zone-based firewall. No need to worry about the intrusion prevention, no need to worry about URL filtering, no need to worry about AMP, no need to worry about DNS security, no need to worry about SSL TLS decryption. We can just implement this zone-based security policy. We can just implement this zone-based security policy for our, we can also enable the logging, like in we have the syslog server in VPN 10 listening on the port number 2055, so we can also enable the logging there. Bypass firewall policy and allow all the traffic to and from the VPN 0. So the policy that we have applied is for the VPN 10 to VPN 20, VPN 10 to VPN 10, and all the rest of the traffic is going to be passed as it is. But if you do not check this box, it basically means that we are not defined things for the direct internet access. So if you have implemented DIE on that particular branch, then you also need to check this box, which means that the policy is not going to be checked for the traffic going towards the internet. Bypass the firewall policy and allow all the internet traffic to and from the VPN. You can see here, VPN 0 zone pair firewall will take priority. So you can just mouse over it and know what exactly it is trying to say. So if you check this box, basically means like whatever traffic goes to the internet via that DIA concept is just going to be allowed. It is not subjected to the policy. Save this policy. And in order to activate this policy, we don't have the option to activate it again. Then in order to activate the policy, we again need to go to the templates. And under the template, I am going to edit the template. And at the very end, we have, from where we have applied the policy, we have here the security policy option as well. And here we are now going to choose our zone-based security. Update and let the config get delivered, let the configs get pushed onto the devices. We are implementing that security basically on branch 1, site 1, VH1, site 1, VH2. Here we are implementing that particular security. So we are pushing that template basically on those devices. So here, since we are pushing the configuration with the help of the template, here when you do like admin and Cisco @123, then when you do show run security, so wait for the policy to get delivered or simple show run. Let the policy get delivered here, right here. You see, zone-based firewall, some things are there. Let's wait for the policy to get delivered properly. We already have implemented our QS policy, so no need to worry on that. Let's wait for, it failed. Okay, so this thing is not supported. Unknown command, this destination port list, this thing is basically not supported, I thought so. So we are going to edit that policy. Some things might not be supported, so you will need to explore. So I will go to the security policy and I'm going to edit this policy. And after editing this policy, I'm going to edit it and I'm going to the list. This I'm going to edit. And instead of using the list, I'm just going to define the port number 80 and port 43. It happens sometimes, sometimes these versions, they have that issue that they cannot like push certain things. So you need it, the error will be shown right in front of you. You need to read that error and then you will need to do the changes accordingly in order to in order to fix that error. That thing was not supported. That app list that we configured was not supported. It might have something to do with the version that we are using, but that thing was not supported. So when I now push the policy, let's see if the policy gets delivered. Same exact thing is also available, by the way. Same exact thing is actually can be done. Same exact thing can actually be done on the cEdge devices as well. Same thing we have here on the VS devices, and we have the same thing that can be done on the cEdge, vEdge, all the devices we can do same kind of thing. Wait, sending configuration to the devices. Done. That's done now. So if you check now here, you must have that security policy with you. So here now you just go through and right here you can see the security policy. So just scroll down. You must have some security policy here. Policy, application policy here. You see, you can see the policy. You can see zone 10, zone 20. You can see the policy getting applied for the zone 10 to zone 10, zone 10 to zone 20. And as per the policy, the rule is ping is going to be inspected. Second rule is that this is going to be drop. The third rule is that this is going to pass. And the fourth rule is this is going to be inspected. And everything else from zone 10 to zone 10, zone 10 to zone 20 will pass. And whatever traffic like that goes from the zone to no zone, VPN 0 basically, that is going to be allowed as well. So this policy is delivered here. If this policy is now delivered here, and if I now ping, for example, from here, from this site 1, if I do the ping, for example, ping 172.16.2.1 source loopback 1, the ping must be successful. The ping must be successful as well. Let me cross check the routes. Show IP route. Okay, 3 routes are there. 172.16.3 dot. Okay, no problem. So ping 172.16.3.1 source loopback 1. The ping is successful, and I'm going to do the repeat ping. I'm doing the repeat ping. You can see that the traffic is going on, and all the ping packets are supposed to be inspected. So what will happen here? If you use the command show policy and zone-based firewall, if you implement this command show policy zone-based firewall sessions, for example, you can see that some sort of connection, some sort of filter state is established. Show policy zone-based firewall session. So some sort of connection table is maintained here. Zone-based firewall session, zone pair, zone 10 to zone 10, source IP, destination IP, whatever it is. Source IP address, destination IP address, source port number, destination port number, ICMP, source VPN, and all that. So some sort of filter state is established, which means to say that the traffic that we are sending is getting inspected. Inspected basically means like some sort of connection table is basically established here. So filter statistics, for example, you can check the filter statistics. You can see the packets matching with that particular sequence, or we can see the global statistics. If you want to see the global statistics, you can see the global statistics as well. Only these 3 commands are there. Total, how many zone-based firewall packets have been sent so far? So we are continuously sending the packet. So whatever zone-based firewall traffic has, whatever zone-based firewall traffic has been sent, and also all those statistics, basically, all those stats, all those statistics, you will be able to check with the command show policy zone-based firewall. And there are only 3 options here. One option is basically like sessions, one is global statistics, and one is like the filter statistics. It will just create a connection table to inspect. It will just show you a connection table. In that connection table, it will show you the session that is created between the devices, so that you can see, you can inspect, you can check basically like the traffic is going from what VPN to what VPN, how many packets have been sent, XYZ, whatever information is there. That kind of thing is maintained. That kind of thing can be maintained. That kind of thing can be created basically. That kind of thing can be created. That kind of thing can be maintained with the help of this zone-based firewall policy. That's it, by the way. That is it. You will not have like anything extra. You will not have like anything extra. That is it, by the way. That is it. That's all. That's all you can see in the zone-based firewall thing. Of course, your what is that? Your FTP TFTP traffic is going to drop. If you want to see that, you can go to the monitor, by the way. If you want to see the FTP TFTP traffic getting dropped, basically, if you want to see that your FTP TFTP traffic is getting dropped, then you can just go to the one device has gone unreachable. So you can go to that particular monitor, you can go to the devices, and here you can go to the particular device, which is Site1 VH1, for example. Site1 VH1, and from there you generate the FTP TFTP traffic. Go to the troubleshooting, go to the simulate flows, and from here you generate the traffic for the certain application and simulate it and see how the traffic is basically going there. You simulate and check how the traffic is basically going there. You click on the simulate button and see how the traffic is going there. Then check for that FTP TFTP, for example, and see how the packets are basically going there. The point remains the same, that in case of like a zone-based firewall policy, whatever things we have permitted will be permitted, whatever things we have dropped will be dropped, and whatever things we have done for the inspection, this kind of table will be maintained. This kind of connection table will be maintained to show you more details about that particular device, more details about the flow of the packet, I will say, like what traffic is going from what source IP, destination IP, and all that. So that kind of flow can be seen here under this zone-based firewall policy, nothing else. So again, you will decide, like, how useful the particular feature is throughout the content. You will be able to decide which of these features are more useful, which of these features are not so much useful. But eventually, this is what it is. It is how it is. It is how it works basically. It is how overall. This is how overall this works. We can implement the basic. Zone-based firewall policy in order to enable some sort of like filtering as per our requirement. This is what they call zone-based firewall. VPN zone-based firewall. This kind of policy is what they refer to as the zone-based firewall policy. And we could have done it like, we don't need this actually, like, we can do it with the help of a simple data policy as well. We can do it with the help of a simple data policy as well. Like configuration policies, I can do it with simple data policy. I can do it like we have configured all these, how many? 17 policies, 18 policies, by the way, 19 policy, by the way, we have configured. I can create like a simple data policy, add policy, and I will match my desired applications that I want to block. For example, I can go to the configure traffic rules option. I will go to the configure traffic rules option. I will configure this traffic data policy. This is like block FTP, TFTP, whatever. So I can define the same exact thing, application firewall, right here at the very top of it. I can do the exact same thing with the help of this policy that centralize the data policy, that I want to block this application. What application you want to block? I want to block the file. I want to block the file transfer. I want to block all the applications in the category of file transfer. I want to block all the application in the category of file transfer. Where is that? I want to block all the applications in the category of file transfer. Done. I could have configured more criteria for the match, such as source IP, destination IP, source port number, destination port number, protocol number, for example, packet length, packet loss priority. We can match based on these criteria, and then we can just choose the action to drop it or maybe accept it. So I could have done it like with the help of the data policy as well. Everything else is just permitted. I could have done it with the help of the data policy as well. I can create this kind of data policy, and in the data policy, I can define that I want to block this application traffic. I want to block this, for example, application traffic I want to block this FTP, TFTP, whatever, traffic, and I want to permit everything else. Then you can apply that data policy. You can apply that data policy under the site 1, site 2, and site 3 in the VPN number 10, which means like none of these branches will be able to send FTP, TFTP traffic in the VPN 10. I could have done the same exact thing with the help of this kind of security policy, but the problem is, not the problem, I will say the limitation basically is that we will not get that connection table and all that thing, so that fancy name, zone-based firewall, we don't get that, but we can redirect certain application traffic to the firewall. Firewall doesn't mean like an actual firewall. Firewall basically means like here, a device to permit or deny the traffic as per our requirement. So this thing can be done. This thing can be done as per the requirement. Zone-based firewall policy, for example, can be implemented as per our requirement in the SD-WAN. Zone they refer to as VPN, by the way. So VPNs is what they refer to as the zone. And then based on that, they are going to implement the things. Based on that, they are either going to permit or deny the traffic as per the requirement. So this is one security feature that we have. We could have done it with the help of we can deploy basic application firewall policy with the help of the data policy, by the way. We can match our branches, we can match our VPN, we can match our application, and we can define that this application traffic needs to be dropped and everything else needs to be permitted in the VPN number 10. And then we can apply that for all the branches so that they are not able to send and receive, for example, the FTP, TFTP traffic. So we could have done it like that, or we can do it with the help of this zone-based firewall policy. This policy does not require you to add anything on the device. It is just a very basic policy that is available on both vEdge and the CS devices. This policy, by the way, is applicable on both vEdge and the CS devices. We can apply this policy on both vEdge and CS devices as per our requirement. But other policies, such as, for example, if you want to implement some more robust policy, such as, for example, intrusion prevention system, such as URL filtering, such as advanced malware protection, these policies, for example, if you want to implement, first of all, these policies are in fact not available on the vEdge devices like IPS, IDS, URL filtering, AMP thread grid. These are not applicable on the vEdge devices. These are only applicable, by the way, on the cEdge devices. These policies are only available on the cEdge devices. And in order to implement these policies, well, we need here, in order to implement these policies, we need some additional resources. We need some additional image. So for example, if you want to implement intrusion prevention system, URL filtering with cloud lookup only, not on box database, you don't want to build any on box database plus AMP thread grid, then minimum 8 GB of the flash, 8 GB of the RAM, and approximately 2 cores will be required in order to implement these basic things. And supported on all these platforms that you see right here. These are all the CS devices where that thing is basically supported.
So how the communication will happen between two devices?
Will be covered later on. And if you want to, let's say, for example, implement the policies, the same policies with the help of you want to implement the same exact thing, but you also want to create some on-box database for the URL filtering and all, then you will minimum require 16 GB of the flash memory, 16 GB of the RAM, and minimum 2 cores you will require for the same, and supported on these particular platforms. Enterprise firewall policy that we just implemented, DNS web layer security policy that we just implemented, it will work with the default 4 GB RAM. But if you want to implement these features, first of all, you need CS devices with minimum resource requirement right here. And then you also need an image because these things, if you want to implement, for example, these things, these are not available natively onto the box itself. These things are not available natively on the box. What we need to do, we need to have an image. That image we need to upload actually. We need an image, and that image we will need to upload on the, for example, CS device. On the CS device, remember the architecture of the cEdge. the CS device or iOS XE based devices, basically they allow learn the iOS XE architecture if you want to. iOS XE devices basically allow that we can we can run certain applications in a virtualized, in the containerized environment. We can run applications on the cEdge devices. Basically, the CS devices, the base of the CS device, the base operating system of the CS device is Linux based. And here the iOS is running more like as an operating system. Earlier on the iOS devices, the iOS runs directly on the device and enables all the functionality of the device. But in case of iOS XE, the base is basically Linux based, and this Linux based architecture is going to this Linux based core is going to run the iOS as an application, and then it also allows that we can run other applications in a virtualized, in the hosted environment, such as, for example, like some containerized applications, such as, for example, some the security appliances, some security applications we can run like some programming tools. We can run all those things in a virtualized environment. Here, what we are going to do actually, here we are going to download the security application image from Cisco. We are going to download the security application image from Cisco, and we are going to upload that image. We are going to upload that image onto the cEdge device so that these additional security features can be implemented. That security application image is referred to as the UTD engine image. That security application image that we need to download and in fact install will allow the cEdge router to implement all those security features. Those security application image we need to download and install on the cEdge device, first of all, from the Cisco website. I already have done it, so you don't need to do it. So the very first thing is that here we will go to the maintenance, we'll go to the software repository, we'll go to the maintenance, then we'll go to the software repository, and from there we need to upload the security application image on the vManage. vManage basically will distribute the image on the appropriate CS devices whenever it's needed. So first of all, we need to go and upload the image here. And by the way, for that to work fine, you need to also make sure that the what is the version of the CS that you are running. So I will just cross check the version of the cEdge, go to the tools, SSH terminal, and take a look at the cEdge router that we have here. Since the CLI is not working from here, I can take the SSH from here itself. And you need to just check the version of the CS device. You need to check the version of the CS device that we are working on. We need to check the version of the CS device that we are working on here. So show version. The version of the CS device is basically 17.9.1. The version of the CS device that we are working on is 17.9.1. So we need to download, we need to go to the software.cisco.com and we need to download that cEdge image. We need to go to the software.cisco.com. We will go to the downloads and upgrade option right here. We will browse the product. We'll browse the router. We will, what is that router? This is I guess the 8 kV, if I'm not wrong. Is it 8 kV or 1K? This is, I believe, 8000 V. So here we are going to just go for the virtual router 8000 V, Catalyst 8000 V, and right here at the very end we have iOS XE SD-WAN software and all. And at the very end here we have UTD Snort IPS engine software. This is what we need. This image, this thing for your version actually. So if it is 17.9.3, 17.9.3, this is the file that you need. This is the file that you need to download and have it with you in order to implement those security features in the iOS XE based SD-WAN devices. Not supported on the vEdge, supported on the cEdge only. This is also one reason why they are pushing cEdges over the vEdges, because we can implement a few additional things that is what we cannot do in case of the vEdge devices. You download this image. This is a security application image, a UTD engine image for UTD engine for iOS XE version 17.9.3. This is the image that you need to download. Once you download this image, then you are going to upload that image onto the platform. Snort, by the way, Snort that it says UTD Snort IPS engine. Snort, by the way, if you take a look at Snort IPS here, right here. Snort is foremost open source intrusion prevention system. Snort is basically open source intrusion prevention system in the world. Snort IPS uses a series of rules that help define malicious network activity and those rules to find the packet that match against them and generate alerts for the user. So they have defined some rules like, okay, if you receive the data and that data has this pattern, then this data is not a data. This data is some sort of virus, some sort of like malicious packet, which you do not need to, or which you should not need to permit in the network. So it can sniff the packet basically. It can sniff the packet. It can basically check the packet. It can match the packet against the known threats, and then it can alert. It can generate some alerts in the network. So Snort, like Snort IPS, it is like it was Snort software. Snort is an open source network intrusion prevention system. So it was created funded by SourceFire. Snort is now developed by Cisco, who purchased SourceFire in 2013. It was open standard basically. So SourceFire was the tech company name who developed this basically, and then Cisco, when they purchased SourceFire, they got the Snort basically software. So it everywhere shows Cisco now, basically, for the Snort. It gives you the ability, it has the ability to perform the real-time traffic analysis and packet logging on the IP network. Snort performs protocol analysis, content searching, matching, whatever. So basically, in order to implement those IPS, IDS, those things, we need this image actually, this Snort, this engine, this image we require. Version needs to match, by the way. And if you are using not the 8 KB, if you are using, let's say, for example, 1 KB, if you are using 1000V device, Catalyst 1000V, then you need the 1000V, for example, for the Snort, for the image for 1000V as well. So you need that image, you need that utility engine image, and then you can download that image actually from the Cisco website, and then you can just upload it onto the CS device. So I'm going to basically upload it. Let's try. So we have that image, by the way, will be uploaded onto your portal as well. So then you will just exit from here. I don't need it actually. 17.9.1. Okay, correct. So I will just exit. Then I will go here. I will go to the maintenance. I will go to the software repository, and I am going to upload this image under the virtual image option. Under the virtual image, I need to upload that Snort image actually. So the Snort image I actually have. Just a second. I am just I'm just downloading it from the web actually. Yeah, it's done. So now I'm going to upload this, add a new virtual image on this particular vManage, and just browse the image. Just browse the location, click on the browse button, and just browse the location where that particular image actually is. Just browse the image where the particular, browse the location where the particular image actually is. So right here, for example, right here in my downloads, I have that image, 17 security application UTD 17.9.1 whatever. I'm just going to open it, and this is the Snort. This is UTD for 8KB. So that is the name, and I'm going to just upload this. Approximately 60 MB image. So I have uploaded that image onto the vManage. The image is now uploaded onto the vManage. App hosting, UTD, Snort. You can see security application image version 17.9.1. So the description on the vManage, it is going to run in a containerized environment, LXC. LXC stands for Linux container. So it will run in a containerized environment. This image will run in a containerized environment actually. And this is an app hosting image. Approximately the size of this image is like 60 MB. This image will run in a containerized environment. So there are different types of container technology. The container technology being used here is this LXC, this containerization technology that we are using in the container where this is being used actually, or this image is being run is this LXC. LXC stands for Linux container. LXC stands for Linux container. So we need to download this image, by the way. We need to download this image and then we need to upload that image onto the container. What else we can now do here? Now we will create a policy. Now we will create a policy for the security, for the IPS IDS. Now we are going to create some policy for the same. So now we will go to the, again, where is that? Configuration. I will go to the policies and, sorry, not the policy, security. I will go to the security, and just like we configured this zone-based security policy, I'm going to create another security policy. I will again choose the custom option because it gives me like all the options that are available, and proceed. And right here, I don't need to worry about the firewall policy anymore. So I'll just click on the next. And right here, we are going to create the intrusion prevention policy. Prevent and act against the malicious and hostile attacks by configuring the signature sets and the inspection mode. Intrusion detection and prevention policy. So right here it says that to make sure that you have proper image uploaded. Okay, that we already have. Add the intrusion policy. Create a new intrusion policy. I'm going to call it like IPS policy, intrusion prevention system policy. For what VPN? For the VPN 10, for example, we want to implement this policy. We could have selected multiple VPN. Are we going to use the detection or prevention? Are we going to use intrusion detection system, or are we going to use intrusion prevention system? IDS or IPS? Detection is just going to detect it. Like, it is just going to detect and it will let you know that the intrusion has happened, for example. Inspection mode we can choose. We can choose either the IDS or IPS as per the requirement. Intrusion detection or prevention. Detection is just going to detect the intrusion. It will generate some sort of alerts. But in case of prevention, it will just prevent the traffic flow from the device itself. So we can configure the IDS or IPS as per our requirement. So let's go for protection. Then here we have this thing called signature sets. What is a signature actually? Again, you will need to study security for the same, but just to give you a brief idea, signature is more like a pattern. Like, let's say, for example, let's say somewhere some sort of attack has happened. Let's say somewhere some sort of attack has happened. So in the attack, a particular pattern was basically used. So it is the responsibility of those security people, security personnel that we have. It is their responsibility to analyze that attack pattern and create a signature based on the same. Signature is more like signature is like to match the pattern of a particular type of data. If some data comes onto the device and the data has similar kind of, let's say, for example, pattern, similar kind of like signature, then it might be considered as, for example, an attack. That thing is basically defined right here under the signature. Signature is more like a pattern that allows us to confirm if the data is data or if the data is some sort of attack. So here we have to choose like three things are here. Here we have to choose like we have the signature set as balanced, connectivity or security. So there are teams, by the way, there are dedicated teams, like for example, when you talk about Cisco Talos intelligence group basically is responsible to analyze on regular basis, on daily basis, they are responsible. These are basically security people who are responsible to analyze different attacks, different like viruses, bombs, or different types of like malicious activities that have been done worldwide. And based on that, they are responsible to create some sort of database that reports those malicious things that have happened in the past, like 2 years, 3 years, 4 years. Basically, they are responsible to create the signatures. They are responsible to create the signatures for different types of attacks and everything that have happened in last few years. They are responsible to do some, some R&D and find out the vulnerabilities in the operating system. For example, create database based on the same. So those vulnerabilities that we have on the devices, they are rated. They are rated like based on this thing called CVSS, Common Vulnerability Scoring System. It is an open standard method of like rating the vulnerability, how severe a particular vulnerability is. That is rated with the help of the CVSS, Common Vulnerability Scoring System. If you read about CVSS, So common vulnerability and scoring system. So CVSS stands for common vulnerability and scoring system, provides a way to capture the principal characteristics of vulnerability and produce a numerical score that defines the severity of that particular vulnerability from 0 to 10. 10 being most severe. Different like techniques are there to measure the severity, whatever. So learn security, learn about these things in security. So if I choose like the signature set balanced, what does it mean? It means that when we choose the signature set as balanced, which is also the default one, it contains the rules. It contains all the rules that are published in last 2 years. All the rules that are published within last 2 years, and with the CVSS score is greater or equal 9. Balanced basically means it is going to match all the rules within last 2 years, and the categories included in this balanced signature is malware, exploit kits, for example, SQL injection, blacklisting, and all that thing. So balanced basically means like within last 2 years, all the vulnerabilities with the CVSS score of 9 or greater is going to match under the balanced signature set. Here in the balanced signature set, we have like blacklist, we have exploit kits, we have malwares, we have SQL injection, we have different options available. In the connectivity, however, it is going to match all the vulnerabilities that have the CVSS score of 10 published within last 2 years. So that is under connectivity. And security, if you choose the security, it is going to match all those vulnerabilities with the CVSS score actually of greater or equal than 8 published in last 3 years. And the categories included in the security signature set is basically malware, exploit, SQL injection, blacklist, app detect rules. All these categories are included under the security signature set. Details are given in your official book. Read it from there. But we can choose the signature sets as per the requirement. Remember that we do not have those patterns on our box. It is like being delivered by the IPS provider. Whoever is our IPS provider, if let's say, for example, Cisco is our IPS provider, so it is their responsibility to keep that signature database up to date, and it is my device's responsibility to contact that cloud service, that IPS provider, to either download it, to download that signature set onto the box itself. And then under the advanced option, we can also like whitelist, blacklist as per our requirement. We can do some whitelisting as per our requirement. We can do some sort of whitelisting as per our requirement if I want to, but done. This is how the IPS policy basically. In order to apply this policy, by the way, we require that UTD is not Indian, which runs based on the Linux container. In order to implement all of these 3 features, we need that snort. We need that UTD engine image actually. So we already have done it. We already have uploaded that image onto our vManage. So when the vManage has to implement a policy on the cEdge, and when it sees that, okay, the IPS policy is being delivered or URL filtering policy is being delivered, then it is just going to push that image onto that cEdge platform first. And so once it pushes the image, then after the policy will be activated. So automatically, when the policy is getting delivered here, when that software image, when that snort utility engine image is basically uploaded on the cEdge platform, the image is going to be hosted in a containerized environment automatically. We don't need to do it. We don't need to do anything manually. The image, here is our data plane. Here is our the data plane. And what will happen in a containerized environment, in some sort of containerized environment, Linux-based container. So the base operating system is going to be Linux-based. Here, the snort image, the SNORT, the snort IPS image basically is running in some sort of containerized environment. In Linux-based container, the snort image is basically working. Different softwares are running within the iOS XE box, within this iOS XE platform. Within this iOS XE box, different softwares are running to manage those virtualization services and all those things. So what will happen? Some sort of logical, some sort of those virtual interfaces will be created automatically. We don't need to do it. automatically some sort of virtual interfaces will be created between the data plane and that snort utility engine image that is running in a virtualized environment automatically. So when the data arrives, this is the data usually will go directly, like, via the data plane, the data will normally go directly actually from here to there. But when we have implemented that policy actually, when we have implemented that security policy, for example, if the traffic matches with that policy, then the data will go via those virtual interfaces which are created automatically. The data will go all the way to that utility engine image that is deployed in a virtualized container environment, and then from there the inspection and everything will happen. And if the data needs to pass, then the data will go like that. Some virtual port group, some basically like virtual port groups, some logical interfaces are going to be created automatically in order to support this kind of traffic. This will happen within the box automatically as soon as we implement that. Security policy, all of these things will happen automatically under the control plane. That's how the flow of the data will be there. So when the traffic, for example, is going for the particular application, for example, we have implemented the IPS IDS policy. For example, we have implemented the URL filtering. For example, when the data arrives on, for example, the cEdge router, the cEdge router is going to intercept that data. It is going to see that the traffic is going for a certain URL, and for that URL, we have configured some security policy. So the data flow will change. The data will flow now like that via the snort IPS engine. The data will flow like that in order to go to the other destination. And just in case if this snort fails, if we have implemented this policy and due to some reason, if let's say, for example, this snort fails due to some reason, whatever happens due to some reason, this snort IPS engine, let's say, for example, fails due to some reason, or reboots, for example, due to some reason. So we do have the option. We do have the option when we apply this policy. We do have the option to choose what should happen when this snort IPS engine fails due to some reason. The options are like fail close or fail open. Fail close basically means like all the IPS IDS traffic will be dropped when the snort IPS engine fails due to some reason, or maybe reboots due to certain reason. And fail open basically means like the traffic will keep processing, the traffic will keep flowing as it is without any. If the engine failure happens, then the traffic will keep going without getting inspected and everything. So that will happen like in case of fail open. Done. That's it. Once we have configured this policy, I'm going to click on the next button. Let's not talk about the URL filtering, all these things. Let's skip it and just implement this policy, by the way. Let's implement this policy first of all. I'm going to implement this policy. This is our composite security policy. And you see right here, if you want to enable the logging, you can enable the logging. You can define like where is your syslog server and what is in which VPN we have the syslog server, what is the IP, and failure mode open or close. Open basically means like if the IPS IDS engine fails due to some reason, if that utility engine fails due to some reason, then your IPS IDS traffic will keep flowing as it is without any inspection. And close basically means like drop all the IPS IDS traffic just in case if IPS IDS engine fails. Save it and apply this. In order to apply this, we need to go to the template. In the template, we are going to apply that. On the cEdge template, we are going to apply that. Where is that? Additional template. And right here, we have the security policy. Composite security policy. And right here, we have the utility engine template. By default there, we can edit it as per the requirement, or we can create a new utility template settings. Forget about it. As soon as we choose this policy, if I choose this policy, there is no such thing because this policy does not require any UTD or anything. But if you choose this security policy where we have called our IPS IDS, then we need that UTD image. That's why when we click on it, we can see this UTD container profile is automatically there. Update. But the problem, the problem is actually The problem is that, okay, so I'm going to click on the next button. But before I do that, let me see 192.168 10.91. So what I'm going to do here, I'm going to open the dashboard here, and I'm going to go to the tools, SSH terminal, and I'm going to SSH the cEdge router from here because I cannot open it from here. So I will just do the SSH from here, and let me just log in there first of all. What I'm trying to do here is to, I'm not sure if I will get the logs or not. I want to get the logs, terminal monitor. Let's see if I get the logs or what. So when I push this template, onto that cEdge router, what will happen actually? Before the policy push is there, before the policy gets delivered there, that template will, that utility engine image is going to be pushed. Take a look at here. So checking, configuring the device, generating the configuration from the template. Okay. Updating device configuration in vManage. Okay. Now, when the device comes to know, that we are going to push the IPS sending the configuration to the device. Now, before the configuration gets delivered onto this device, actually, the utility engine image is needed now. Successfully notified the device to pull the configuration. Okay, fine. So the device is now supposed to pull the configuration actually. See, utility signature package not found in the metadata. Periodic update may be disabled. Okay. Configured iOS on Linux. iOS, basically the device is now informed to run iOS. The device is now informed to configure. It is informed to run the iOS. Basically, some things are going on in the started iOS on the device. So on this device, the iOS is now started. iOS on Linux is now started, so that the containerization, in a containerized environment, those security application can run. Will take some time. Not allowed. Anyway.
Can you run show IOX command?
Show IOX command will let the process complete first. I will show you. Successfully downloaded started IOX, successfully downloaded the package for app ID UTD. So it has downloaded the image. So comment them, no. Show IOX, so app hosting, those commands we can run, we can implement here. But let this process happen once. So show IUX command, if you run right here, show IUX, for example, here you can see that IUX is now running here. So IUX is running here, and show app hosting command you can run here in order to see the details about the list of applications or things that we are running basically on the device. So for example, show app hosting list, you can see that UTD is now deployed. Show app hosting detail, for example, if you see in the show app hosting detail, for example, you can see the detailed information about that hosted application actually here. Let this process complete first. Device successfully installed the app ID UTD, so that is now installed. This device has pulled the utility engine image, the 5060 MB image that was there. That image push was basically successful. And now once it is done, now the policy will be delivered. The policy that we have Now the policy will be delivered on this. Let's wait. Will take more time. First time it takes time. You know, when you do it for the first time, it will take some time. But after when you add more policies, it doesn't take that long. So you can see that in the show app hosting detail, you can see the app ID UTD, IUX status running, Linux container, UTD is not feature. Here is the image, that was downloaded. Then the RAM, approximately you can see that 2 GB RAM it is consuming, and 861 MB disk usage is there. 7% of the CPU is being used and all that. So you can check the details about the. You can see the interfaces basically. So you will see the details about that particular hosted application image that we have. Anyway, so done. So configured, verified app UD in running state, successfully verified, config applied successfully, template attached to the device successfully. So now here on this device, show that template configuration basically. That template configuration. So SD-WAN running configuration, by the way, that SD-WAN running configuration basically will now show you that policy, the policy that we have, for example, show SD-WAN running configuration, but I can't say policy, by the way. So here, like for example, you will be able to see that policy that we have pushed actually from the device. Let me know when you see that. So yeah, right here. Some UTD command, IPS policy is there. So some sort of UTD commands, see IUX related things, IUX, app hosting, app ID, UTD, then it configured some virtual net interface card with the interfaces virtual port group 0, configured it with the IP address, virtual port group 1, configured it with some IP addresses, some additional IPs are there, which are there to have the communication from the data plane to that UTD engine image, and then the policy that we basically pushed is also. Now remember that the device must also need to download the signature database. The device must also need to download the signature database. So you have deployed the policy. The policy push is now successful. You can go to the security. Under the security, you can see that the policy is basically deployed. You can go under the where is that security maintenance security. You can go under the maintenance security, and here you can also see that where is that intrusion prevention. So we have deployed the application firewall policy on site 1 VH1, by the way, and the intrusion prevention policy we have deployed on the cEdge router, by the way, right? So that you can also check it from there actually. But the problem is you can also go to the monitor devices and you can monitor that particular cEdge router. Where is that cEdge? DC cEdge router, for example. You can particularly monitor that cEdge router, and under the monitor, we have a dedicated tab called security monitoring. Under the security monitoring, we have the intrusion prevention, for example. Under the intrusion prevention, you have the UTD states, the counter and everything. Right here, you can see the traffic counter, CPU uses, UTD health, and all those things is basically okay. You can click on the real time to see the data, whatever data is passing via that UTD image. You can see that data in real time as well. The problem is, you see the received byte, transmitted bytes. The problem is that the last update on the UTD was done like quite a few years ago. The database that we have on this device, about that IPS policy, those signature sets that we have on this device regarding those vulnerabilities are completely out of date. So the device must need to download the database for that IPS IDS as well. So things are working okay. We can see that the amount of bits, bytes received and whatever it is, but the database more than 24 hours since the last signature update. So the device is not able to download any, the device is not able to download actually any signature. Reason, because we have not gone to the administration settings, and under the administration settings, we need to provide the information right here somewhere. Where is that? Into UTD snort subscription signature right here. Here, IPS signature download interval. Do you want to download the IPS signature? Yes. Who is the provider? I can download it from the cisco.com, or if some remote servers, local database, if you have, for example, .package, I can click on Cisco, I can provide my username password, and once it's done, the device will use this credential to download the signature sets from the Cisco cloud. Or we can have like custom signatures that we can upload it from the server and all that thing, or we can upload it locally, the TXT rules and all that thing. So this is also important to understand that just because you have implemented the policy, things will work fine. Not actually. You will also need to make sure. You will also need to make sure. You will also here need to make sure that the database is completely fit and fine. You need to make sure that the database of the IPS is now completely. Anyway, you're not going to do it. Just letting you know that if you are implementing this thing, if you're implementing this UTD IPS signature, then you must also need to have these settings configured properly so that the device can download the signature sets on the box itself. Resource requirements will be there, so make sure that you also have sufficient resources, by the way. Make sure that you also have sufficient resources on the device so that the signature sets can be downloaded properly. You can also do the monitoring right from here. In the monitor, we have the security monitoring right here. Here it shows you the packet that have matched with the firewall rule, then top threats, intrusion prevention, for example, advanced malware protection, URL filtering. So if some sort of intrusion is detected or prevented, it will be shown right here basically. So you will be able to see it, by the way, in this dashboard. Let me show you, by the way. If you want to see the charts, actually, you can take a look at these charts from the D Cloud. You can visit the Cisco D Cloud. On the Cisco D Cloud, you can log in on the Cisco D Cloud, and you can go for that SD-WAN demo, by the way, that we have covered in the very first classes. And you can just take a look at the dashboard there, actually. They have deployed a SD-WAN, for example, demo on the D Cloud. So you can log into your D Cloud. You can log into the D Cloud for your with your credentials, and then you can just click on the catalog. Under the catalog, you can search the SD-WAN. You can search the SD-WAN, and then you will be able to see the in their like SD-WAN demo, the dashboard. You will see this chart properly, basically there. So I'm going to click on the instant demo right from here, and I can search the SD-WAN right from there. I can search the SD-WAN here. I can search the SD-WAN, and I can open any 20.11, 20.10, whatever, you can open any of the SD-WAN right from here. And let me just let it open for a moment. Now you can just see, if you go to the security dashboard here, you can see, for example, the advanced malware protection, firewall, signature hits, URL filtering. You can see some sort of dashboard here, basically. You can see this kind of dashboard that shows you, like, in last 24 hours, last 7 days, URL filtering has filtered how many URLs, top signature hits, for example, the firewall enforcement if you have done somewhere, some advanced malware protection. These things you can actually cross-check right here, powered by Cisco Talos. There is a dedicated dashboard basically for the security. Just make sure that your IPS signatures are up to date. Just make sure that your IPS signatures are up to date, because if those signatures are not up to date, then you will actually not be able to see like a lot of things. So make sure that IPS signatures are completely up to date. So this is one of the policies that we can implement. This is the IPS. This is intrusion prevention policy that we can, or intrusion detection policy that we can implement. It uses Snort. It stores the signature in a database format on the device, and it can generate the alerts or report to the syslog servers just in case if any intrusion, for example, happens. Powered by Cisco Talos, which is a security intelligence group responsible to analyze the different threats, vulnerabilities on regular basis, and create the signatures pattern based on the same. What else? I can also implement a URL filtering policy in order to, I'm pretty sure we can see it if let me do one thing. Let me power this machine on. I'm powering on this Linux machine. Remember that we already have set this machine earlier. We already have configured this machine actually earlier. So I'm just powering it on, and I am going to activate that policy. I'm going to activate that NAT policy, by the way. I'm going to activate that NAT policy. It's already true. NAT policy. Why I'm enabling the NAT policy? So that actually the internet can be accessed via this cEdge router. So on this Linux machine, basically, the username is test and the password is test123. On the last class, when we were talking about the QoS and all those things, in the previous classes, we already have configured this Linux machine. We already had the reachability to the internet using this Linux machine. So I'm just going to open the browser here. I'm going to open the browser here, and I'm going to check if the websites are opening or not. Even though I can see the connection state is established, so everything must be okay. But I'm just going to cross check if the internet opens or not. So if I open the Facebook, yes, it's working fine. If I open, let's say, for example, Wikipedia, it's working fine. So looks to me that the web pages are basically loading as expected. Basically, internet reachability is intact. Now I want to filter the URLs. Remember that I want to filter certain URLs. So I'm going to go to the security again, and I'm going to create that policy in the same policy itself. So I'm going to edit this policy. I'm going to edit this policy, and I'm going to create, I have already configured the intrusion prevention. Now I'm going to configure the URL filtering policy right here. In the URL filtering policy, we can create a new policy to define what we want to permit, what we want to block. URLF, URL filtering for what VPN? For the VPN 10. And what do we want to do? We want to block the websites or allow the websites based on the categories. I can allow or block the websites based on, for example, following categories. So, for example, adult websites, for example, like alcohol and tobacco, for example, like what are different, like dating websites, for example, gambling, for example, some, what is job search. I don't want anyone to search the job using our internet. So, whatever. So we are going to, we can define, we can news and media, very harmful. So we can block all these websites as per our requirement. With the social media, social network, shopping, for example, Amazon and everything, we are going to block, like, for example, these are the categories based on which we can block the websites. These are the categories based on which we can actually block the websites. Or we can block the websites based on web reputation. We can also block the websites based on web reputation, like how reputed like the website actually is. A web reputation, based on the web reputation is based on the web reputation. If the website is risky, suspicious, high risk, low risk, then I'm going to block it. So basically we can define like when should we block the particular, or we can whitelist, for example, certain URL. I can whitelist certain URL. I can create a URL list, and here we can say like allowed URLs. So I can say that, for example, www.cisco.com. This is whitelisted, for example. So I'm going to like whitelist, for example, certain URLs, or maybe I'm going to blacklist, for example, certain URLs. Denied websites. So www. By the way, you can separate multiple websites with comma. So www.facebook.com or google.com or whatever you want to block. So we can permit or deny as per our requirement as well. And when you get blocked, then you will get this message. You can customize this message as per the requirement as well. Or maybe you can be redirected to some other server where we have stored some kind of web page and all. So you can be redirected to some other server, or you can just be displayed a simple like message here. And we can also generate the alerts as per our requirement. We can also generate the alerts as per the, and then that's what we can do here. That is what we can do here under the URL filtering. Again, This URL filtering policy is also going to utilize this snort UDT engine image. It is basically there to control like the websites available via HTTP, HTTPS. Whatever websites we have permitted, they will be permitted. Whatever websites we have denied, they will be denied. We can do whitelisting, blacklisting as per our requirement. And then we can also block the websites based on, the categories. So URL inspection, first of all, allowed list, blocked list. Whatever we have allowed will be allowed. Whatever we have blocked will be lost. Then based on the categories, the permit deny will happen. And then based on the reputation, permit and deny. So block, allow, based on category, based on reputation. If you have allowed certain thing, then it will be allowed. If you have blocked certain thing, then it will be blocked. Then based on the reputation, based on the category, we are also going to permit or deny. And that is pretty much it. That's all you can do. That is all the options that we have here, by the way. You can assume, you can now think, you can decide yourself how useful these features are and how useful these features are not are. Basically, like, these features are not so much useful or they are useful. So completely up to you, you can decide. I have shown you like all the options that we get under the URL filtering. Similarly, we can also implement AMP. AMP stands for Advanced Malware Protection. AMP-TG. AMP stands for Advanced Malware Protection. We can implement it for all the VPN, or maybe we can implement it for the custom VPN such as VPN 10. AMP stands for Advanced Malware Protection. So when we download the file from some website, for example, the file might contain some malware. Let's say, for example, we have downloaded some file and they contain some malware. It could harm your infrastructure, network infrastructure. So I do not want to download any file that contains any kind of malware. We can enable that AMP, Advanced Malware Protection policy. We can AMP, Advanced Malware Protection. It can block the malwares like malicious things such as virus, worms, Trojan horse, for example. It can block those malwares from entering in your network. It basically uses some sort of antivirus engine. And using that antivirus engine, again, there are signatures for known malwares. For the known malwares, it is the responsibility of the Cisco or the other vendor's security team to create the signature pattern. And based on the signature, when we download the file, some things will happen, and based on that, it will be determined if the file is safe to download or if the file contains some sort of malware. So again, it is the responsibility of those security personnel, such as Cisco Talos. They are responsible to inspect thousands of malwares on regular basis. They create like terabytes of the data every day, and they push that onto the AMP cloud. So AMP cloud has like plenty of signatures. AMP cloud, like let's say for example, has plenty of signatures. Signature basically means patterns that can identify different types of malware. So what happens when we download some file? This same snort file processor, the snort file preprocessor on the vManage router, it identifies that the file has been downloaded, and it calculates the hash. It calculates the hash for that particular file based on this SHA-256 algorithm, and then looks up the local cache. It looks up the local database. It looks up in the local cache to find out if this hash is clean or if the hash is not clean. And if there is no match in the local database, then this hash will be sent to the AMP cloud. In the AMP cloud, in whatever region that we have selected, such as these regions, Asia Pacific or whatever region, in this cloud, the hash, the SHA-256 hash will be sent, and the AMP cloud, on there we have like thousands of, like tens of thousands of, hundreds of millions of basically like signature sets are there. The hash value will be checked from there, and then the AMP cloud will return the response that the file is clean. AMP cloud will return the response that the file is clean, and the file download will then be considered as complete. The file will be downloaded onto the device. The device will allow the file to be downloaded. That's what we can say. And the AMP cloud might also respond that no, the file is not clean. The hash that you just gave me, the hash actually includes some sort of like malware. So it means like the AMP cloud can also respond malicious. Malicious basically means that the file is not clean actually. The file is malicious, file download is basically interrupted and stopped by the UTD snort engine. And if let's say the AMP cloud does not know the state, if the AMP cloud does not know, it is the very first time that the AMP cloud has seen that particular hash value. So it doesn't know, for example, let's say if the content is clean or if the content is malicious, then what it can do, if we have enabled it, then what it can do, it can send that hash, it will send that hash to the TG, to the thread grid. It will ask basically the vManage router, it will ask the vManage router to send the file. It will ask the vManage router that, okay, I don't know, unknown, I do not know actually, I don't know, unknown, I don't know if the file is clean or malicious. Do one thing, give me the file. Give me the file. The file will run in a thread grid, in a TG, in a virtualized, in a containerized environment. The file will be run in a controlled situation, like in a virtualized environment. The file will run, and if the file is clean, then the thread grid will respond that, okay, the file is clean, or the file is like malicious. Then the thread grid will respond like the file contains some sort of malware, in some sort of sandbox environment. In some sort of sandbox environment, the file is running, and the vManage router will query. The vManage router will query the thread grid that, okay, did you get the chance to take a look at my file and confirm if the file is clean or what? So in a certain period of time, the vManage router will query the thread grid that if the file is clean, if the file is clean, if the file is clean or not. So thread grid updates. Thread grid is going to update the status of the file in the AMP cloud, and then AMP cloud will know that, okay, if the file is clean or not, and then the file will either be downloaded or not. So we can send the file for analysis into the thread grid, but for that you will require, again, for that, like what sort of file, for example, what sort of files are supported in order for sandboxing environment. So we can select the file type, we can select the thread grid region. We have to configure some API keys, which we don't have, so I can't enable the thread grid. So in order to implement, in order to add the thread grid, you need to add some API keys so that the vManage can communicate with the thread grid with the help of those APIs. You need to have some sort of like thread grid facility available. So I'm not going to have it. I'm just going to enable the basic AMP, advanced malware protection, and then that's it. Just click on the save policy. That's what we can do under the AMP, advanced malware protection. I'm not going to cover the DNS and this will cover later on, but that's it. This is what we can do here. Click on the save policy button so that the policy gets updated, so that the policy in fact gets updated onto that cEdge router. This time the UTD engine and all those things, they don't need to be downloaded. They are already there. Now the file will be, now this policy will be updated. And once the policy gets updated, then when you download some file, for example, or when you visit the websites, for example, then under the URL filtering, if you visit some malicious websites that have been blocked, you can do some sort of like, monitoring from here. You can do some sort of monitoring from this this URL filtering dashboard. By the way, from the URL filtering dashboard, you can do certain type of monitoring, or from the AMP, advanced malware protection, you can do the monitoring from the AMP as well. AMP file analysis and all that thing. You can see all those things here. We will not be able to see that we will not be able to see these kind of charts in our deployment, but if we have implemented the firewall, the packets that are inspected, the packets that are basically dropped, top signature hits in case of like IPS and all. So if some signature hits are there, that you can see the URL filtering, AMP and all that thing. You can see all those security related monitoring under the security dashboard. Right. So once the policy gets updated, once here the policy gets updated, once on this box, the policy gets updated and we download some file from the internet, for example, when we visit the websites, for example, then those things are going to be, then that policy is going to be basically checked, and based on the policy, based on the things, either the communication will be allowed or the communication will not be allowed. So you can see now here, we're not getting the exact like expected output, but you can see right here that Wikipedia, if I do the refresh, the Wikipedia still is loading, but the Facebook, if I open the Facebook, the Facebook is not opening. It's basically, it's giving some SSL error. However, we should have gotten that log message basically. That website is blocked. Basically, we should have gotten that log message. But earlier it was opening, now it is not opening. So I expect that the policy that we have deployed is working properly. That's why we are not able to open that particular page. We also get the logs, by the way, but since we are not able to take the access right from here, so it's just basically hanged. So we also get the logs anytime that the packet matches there. We also get the logs, by the way. Otherwise, you can always do the monitoring. You can always do the monitoring by going to the security dashboard, and from here you can do the monitoring. From here you can intrusion prevention and whatever. From here you can do the URL filtering and all. From here you can do the monitoring. It doesn't show you right away. It does not show you things like right away, but it does show you the things. So it will show you like in past like 7 days, how many URLs got blocked and everything. Just like we are able to see in .dcloud, you will be also able to see those things here as well. And when we download the file, we can get it under the AMP, just like we are able to see in that dcloud dashboard right here. So similar kind of thing will also be displayed in our case actually. At the moment, I cannot say that the policy is hitting basically, because policy is basically hitting, but I'm not getting the expected result. I must have gotten that secure the contact your administrator and all that thing, but we are not getting that actually. So anyway, everything else will work. Everything else, for example, will work. Everything else and everything like else will work basically. But apart from that, like when we talk about, you see if I try to open like Instagram, the Instagram is also not working. But if I try to open, let's say, for example, YouTube, the YouTube is working fine, for example. So, YouTube is working fine, for example. So the point is that the policy is working, but it is not working as, we are not able to get the log. We are not able to get those logs right here. It will show you the logs, not immediately, but it will show you the logs when the packet hits, when the cEdge exports the statistics, it will definitely show you the logs. So policy is in fact working, but we are not getting the expected results, expected like logs and all. So that's why I'm saying that it is not working as expected. It is working somehow. We are still able to open some websites, and we are not able to open certain other websites. Whatever things we have blocked actually, whatever things we have blocked, they are blocked actually. But we are not getting it like as what we are not getting the results as what we should have seen actually. So under the URL filtering, you can see under the URL filtering, you can see like under the blocked, it says nothing actually. But here we show some received bytes, transmit bytes. It shows you something, right? So I expect the policy to be working properly, just not immediately. Like it's not like, so it's not working right away basically, but it is in fact. Same AMP, advanced malware protection. You can do the monitoring of the AMP from here, URL filtering from here, intrusion prevention from here. We can do those kind of monitoring we can do right from here. So whatever things you have blocked is blocked actually. Whatever things you have blocked is in fact blocked. We will see some logs. We might see some like charts and everything we might see. So it is being referenced somewhere. So things must have worked properly. Things must have worked, like all these websites that we have blocked. All these websites that we have, for example, blocked, they must have been blocked actually. So basically, you get the idea. You got the idea like, okay, this is how it works. So you can block more and more, like, let's say, for example, you can block more and more like websites as per the requirement. You can block more and more websites as per the requirement, and things will still work. So I'm still not able to open like Amazon, Flipkart, because they are blocked under the shopping social network. We are not able to. I should have gotten that log message, by the way, here that I'm not able to see. We will check it tomorrow. I will leave the things right here and we'll check it tomorrow, like if the policy is working as expected.